So I know you're likely anxious to get into Revit right away, but before we do, let's talk about a few high-level concepts first. For starters, just what exactly is BIM? Well, as you may know, BIM stands for Building Information Modeling, and this term has been in the industry for many years now, and it was actually coined by Autodesk several years ago. And it's used to describe the basic process of creating virtual models that represent actual building facilities. Now, Revit is often highly touted as purpose-built for building information modeling, and this is certainly true, but it often leads to some confusion that somehow Revit and BIM equal the same thing. Revit and BIM are not the same thing. Revit is a tool to help us achieve BIM, and BIM is actually a process that we follow to create building model data that is essentially two things: coordinated and computable. Now, those are the two most important tenets of BIM, in my opinion. If all of the parts and pieces that make up your BIM project are fully coordinated with one another and don't require any manual updates to keep them in sync, and if you have a robust and rich data source of information that can be used both internally by the system and exported out to the project team to do meaningful computations, then you have BIM. Some of those computations might be things like energy analysis or calculating structural loads. We might want to do lighting analysis or heating and cooling. Any of those things become possible when you have a rich and robust BIM. Now, there's lots of different ways that you can achieve BIM, but Revit is an excellent tool to help us achieve it because it does many of these things that I've just described natively. Now, it's important to understand that 3D is not the only component that makes BIM BIM. Often when you hear BIM, in the same sentence, you'll hear people talking about 3D, and you can be left with the impression that in order to be BIM, you have to be in 3D, or somehow if you have 3D, then you automatically have BIM. Now, don't get me wrong, 3D is very important. If your primary goal is to perform clash detection between, say, your structure and your mechanical systems, or if you want to make sure that your stair tower fits in the overall architecture, 3D can be pretty important. If you need to do visualization and get high-quality renderings and so forth, 3D is going to be pretty important. However, 3D is not the only aspect that makes BIM special. Remember that it's BIM, and I think the I is sometimes even more compelling than the M. So think about cost estimating tasks, or specification writing, or calculating energy loads, or doing your heating and cooling analysis. All of these things require data, and that data is what we mean by the I in BIM. So when you have all of this data, instead of manually computing all the various things that we need to do to get a proper design, why not let the computer do what it does best? Compute stuff. So this is what BIM is all about. So again, let's not focus just on the modeling. Let's also think about the I. So if we've got the two of those together in a fully coordinated package, in the way that Revit gives us, then what we've got is a fully implemented BIM solution. So with that introduction in mind, let's go ahead and jump into Revit. So what's so special about Revit anyhow? Well, there are many possible answers to that question, but in this movie, I'd like to focus on one of the easiest and most immediate benefits of using Revit. Whether you're an architect, interior designer, draftsman, or contractor, you spend a lot of time looking at and working in floor plans, sections, and elevations. In Revit, work that you do in plan is immediately reflected in the elevations and sections and vice versa. In this movie, I'll show you how easy Revit makes it for us to keep our changes coordinated with a first-hand look at what I think is one of the fundamental benefits of building information modeling, the fully coordinated building model. So to illustrate this, I have several windows tiled on my screen. I've got a floor plan, an elevation, a 3D view, and even a schedule. Now what I'm going to do is click over here into my floor plan, make that the active view, and then I'll use this little magnifying glass over here to zoom in on the right-hand side of the plan. Now you'll notice I have a few doors shown over here, and I'm going to select this exterior door right here, and I want you to watch the 3D view and the elevation as I select this door. Notice how it highlights in blue here in the plan, but it also highlights in blue in the other two locations as well. That's because these are not three separate disconnected drawings. These are in fact just three different views of the same model. Now that's true of not just selecting, it also is true if I take this door and I click and hold down and I just sort of drag it a little bit. Now when I do that, notice how it moves in both the elevation and in the 3D. We do that again so you can watch it more carefully. Watch the 3D view and watch the elevation as I drag this door. Now, if I click an empty space, it deselects the door and it deselects it in all views. It's no longer selected. Now, what about the door schedule here? Well, notice that I've got door 12 here, door 9 here, door 10, door 11. I can actually click on the entries in the schedule. There's door 9, door 10, door 11, and they highlight not only in the schedule, but they actually highlight there in the plan as well. Now, back up here, I've got door number 5. Now, that's not shown in my plan because I'm currently zoomed in too close to see it. So what I'm going to do is just take my wheel on my mouse and just roll it back a few clicks so that I can zoom out and then drag my wheel over here, and there's door number 5 right there. It's sitting over here in this conference room area. So let me roll the wheel in again to zoom in on that location. Now, in addition to being able to just sort of drag the object around, there's other changes we can make as well. And sometimes we can make those changes directly in a schedule view. Doesn't really matter whether we make it in plan, elevation, section, or even schedule. So for example, if I click on door number 5 here and then come over to this drop-down field right here, you can see I have some other options available. And I can choose a different size door, and you'll see that door shrink slightly and become a little bit smaller. You'll also see the numbers here reflect that change immediately. Maybe I want to get a better look at that door from another vantage point. I'd like to actually look right at it. Well, I don't actually have a view that currently shows me that. So that's another great benefit of Revit, is that we can create views on the fly anytime we need to look at and study different aspects of the model. So what I'm going to do is click back over here in the floor plan, and then up here I'm going to choose this little section tool. This is one of my favorite Revit tools. I'll click a point here outside the conference room, and then I'll just sort of drag to the right and click again. And that's going to create a new section view for me. Now I'm going to click away from it and then double click the blue section head to open up that view. Now let me just resize this a little bit just so I can continue to see the door there in the background, and then roll my wheel so that I can continue to see the door here in the section view. Now if I select it here, of course it selects in the floor plan as well. And maybe I decide I want to change that to a double door. It's as easy as coming over here and making that selection. It turns into a double door here. It turns into a double door there in the floor plan. And once again, the schedule stays up to date as well by reflecting that new size and the changes that I indicated there. Now, when I was focusing on this conference room, I noticed here with this section that there's actually another door that needs attention. This door right here seems to be in the wrong spot. Well, if I verify that by opening up a second floor plan, I can see in fact that door is in fact in the wrong spot. And again, just dragging it right here, you're going to see it change immediately in both views. So one of the easily the best benefits of working in Revit is the changes that you make in one view are immediately applied in all other views. You won't spend your days constantly tracking down changes and repeating the same edit over and over again. A single change in the model is a single change in the model, and it will immediately be reflected in all views. And that's the power of working in a building information modeling paradigm and using the Revit software to do it. In this movie, I'm going to expose you to some of the high-level organization and hierarchy that's built into the Revit software. It's important to understand how all of the different objects and elements in the Revit platform fit into a broader structure. So we'll start at the top level and we'll kind of work our way down. So every element in Revit is part of a category. Those categories are built into the software and they come from a fixed list. Beneath those categories, we can have subgroupings, and we call those groupings families. And then those families can either be subgrouped even further into types, and then finally we have the objects themselves that we can select in our projects and our models. Now going back to the top level, that category level, those categories break down into certain sort of overall groupings that Revit understands that are very important to impart certain basic functionality into the objects. Now I like to call these groupings buckets because I don't really have a better word for them, but there's really a few major groupings. We have our model elements, we have our view-specific or annotation elements, and then we have some special case elements like the view elements and the datum elements. So let's talk first about what the difference is between, say, a model element and, on the opposite end of the spectrum, say, an annotation element. A model element is quite simply anything that represents a real thing. So if you think about the building when it's all done and you walk out with your hard hat and you actually can put your hand on it and touch it, then it was a model element. So that would include things like these walls over here, things like these doors over here, this stair and railing. Those are all model elements. They physically exist. You can put your hand on them and touch them. The behaviors of all the model elements that they share in common is you create them in any view and they show in all views. We saw examples of that in the previous movie. So if you make a change to a model element in one view, you can be very confident that it's going to change everywhere. The model elements are drawn full size, actual size, full scale. So those are some of the characteristics of model elements. On the opposite end of the spectrum, we could contrast that with many view-specific elements. And what I mean by view-specific elements is these are elements that belong specifically to the view. But specifically, I'm talking about annotation elements. Now, there's lots of different kinds of annotation elements. We have things like dimensions. We have things like this bar scale right here, this north arrow, these labels and tags. All of those things are necessary for architectural communication, but they're not real elements. Nobody paints the dimensions or the bar scale or the tags on the floor of the building. They're not actually physical objects. Furthermore, those objects only exist in the view that they're created in. So notice that I'm in a level 1 floor plan view right here, and it has several room tags, several wall tags, door tags. It has dimensions. There's lots of different annotation elements. Well, I also have a level 1 power plan. And if you look at it, you'll notice that the layout is exactly the same because it's got the same walls, the same doors, the same windows, but notice that it has very different annotation. There's only a couple dimensions. The room tags are outside the rooms, and they're in totally different locations. Now, we saw in the previous movie that if we say zoom in right here and I grab this door and I move it over here, that we're going to expect to see that change occur in all places throughout the model. And in fact, it does. The door has moved in any version of this floor plan. However, if I took this corridor tag right here and I moved it over here, and then I go back to the level 1 power plan, this room tag is unchanged because in fact, they are two different room tags because they're view specific. Now, another reason why that's the case is because annotation elements or view specific elements respond to scale. So this view is set to 1 to 100. When I change the scale, none of the model geometry will change, but all of the annotation will. So if I change it to 1 to 50, notice that all of the tags have just gotten smaller, but of course, all of the model geometry remains exactly the same. So that's those sort of major buckets, right? And the difference between model and annotation is a pretty big distinction. And keep that in mind as you work in Revit because we're going to see those behaviors again and again. And the more you understand how they behave, the more you can begin to predict things in the Revit environment. Now, another really important hierarchical concept is the concept of category family type. So I mentioned it briefly, but let me dig into it a little bit more in detail. The categories are built into the software. So there's things like walls, doors, windows, text, dimensions. These are all categories. And they just impart certain behaviors and features on all of the elements in our Revit project. Now, talking about walls is a pretty broad category. Talking about doors is a pretty broad category. If we think about a door is a hole in a wall that we can pass through, but doors come in all sorts of shapes and sizes and kinds. So right here on the screen, I have a single door and a double door. Those are pretty different from one another, even though we recognize them both as being doors. Well, the difference between this single door and this double door would be what we would call a family in Revit. So a family is a little bit more specific designation, and it defines much more specific characteristics than just the broad grouping of the category. Another example is furniture. All of these items here are furniture, but a desk is very different than a chair, which is very different than a credenza. All of them are considered furniture, they're part of the furniture category, but the desk, the chair, and the credenza are different families. Now, even within each family, you often have variations, and those are called types. So if I took this door right here and come over here to this list, you'll notice that it actually has several different variations. Now, the types describe really just different sizes. So I could drop this door to a different size, and in all ways, it's very similar to the other doors within the same family, but now it's just a slightly smaller size. So by working your way down from category to family to type, you progressively get more and more specific on the kinds of things that you can change. But one of the important characteristics to understand is that all objects at the same tier of the hierarchy share common characteristics. In other words, if you change something about this type, it would affect all other instances of that type. So this door right here, this is exactly the same type right here. If I made a change to that type, this one would be affected as well. If I made a change to the family, both of these doors would be affected, even though they're different types. And then, of course, if I made a change at the category level, it would affect all doors, including this one out here. So the hierarchy basically tells us at what level our modifications are going to take place. Are they going to affect only the object we have selected? Are they going to affect a group of objects? Or are they going to affect an entire category of objects? And we get to decide what those behaviors will be and how far-reaching our edits are made just in the choices we make and in understanding how that hierarchy in Revit functions. So as we go through the course, we'll be seeing plenty of examples of that, and we'll get plenty of opportunities to learn the specifics of why we might want to dig in and make changes at all those various levels. As you may be aware, there are a few different versions of Revit out there. In this movie, I'd like to talk about some of the differences between the various versions and also discuss the focus of this course. So the main focus of this course is architectural features, and for architecture, we actually have 3 different versions of Revit that we should talk about. So there is Revit or Autodesk Revit, which is the full product. It's included with the building design suite and includes functionality for all 3 disciplines: architecture, MEP, and structure. Then we actually have Revit Architecture. Revit Architecture includes only the architectural functionality and just a little bit of structural functionality. The only real difference between Revit and Revit Architecture is essentially in the options dialog, where you can choose which disciplines are of interest to you and turn them on and off. In the full version of Revit, you can actually disable some of the disciplines, where in Revit Architecture you don't have that feature. Now we also have Revit LT. Revit LT is the newest of the versions, and it came on the scene a few years ago, and you can think of it as a limited version of Revit Architecture. It's only focused on the architectural discipline, and it includes a subset of the functionality of the full architectural product. Now, there are also other flavors of Revit for engineering that you may or may not be aware of. We also have standalone versions of Revit MEP and Revit Structure. Now, naturally, each of these is focused on those disciplines individually. This course does not cover the structural or the engineering functionality, so if you're interested in those aspects of Revit, then you might want to check out essential training for both Revit Structure and for Revit MEP. Now I'm going to be focused on the architectural aspects of the software, and from that point of view, it really doesn't matter whether you have Autodesk Revit, Revit Architecture, or even Revit LT. If you are using Revit LT, there are a few movies which won't apply to you. So be sure to check the FAQ that's included here on the course page to see which specific movies don't apply. Now, if you haven't actually purchased a Revit product yet, then you might be interested in more detail on what's different between them. So you can go out to the Autodesk website, and there are a few comparison charts there that I'd like to show you. If you're interested in possibly going with Revit LT, there's a comparison chart here that compares Revit LT to the full version of Revit. It goes feature by feature, and it shows you which features are available and which ones are not available by comparing the two products. There's also a similar comparison chart that compares the building design suite with just plain old Revit and also with AutoCAD. So there's lots of information available on the website for Autodesk, and you can also check with your Autodesk reseller for more information and specifics on the various flavors of the products. In this movie, we're going to talk about 2 important aspects of the user interface in Revit: the recent file screen, which greets you when you first launch the product and is what I'm showing you on screen right now, and the application menu, which is in the upper left-hand corner, adorned by the Revit logo icon, and it's akin to kind of like a file menu. You can perform similar functions using both of these interface elements, and so let's just kind of look at an overview of what each one is capable of. So in the projects area at the top, we have some links here on the left. So we can use this one to open an existing file, we can use this one to create a new file, and then these items here are customizable and allow you to create new files based on predefined templates. So if I wanted to create a file from the construction template versus, say, the structural template, I could choose the various links. If the template that you want to use is not listed in one of these 4 choices, then you can simply click the new link here and browse to the template that you want. Now, next to that, over to the right, you have the most recently opened files that you've opened on your copy of Revit. So if you want to work on the same file again, you can just simply click one of the icon links over there at the right and reopen that file. Now beneath that, you have a similar structure for family files. So most of the work you're going to do is in a project file in Revit, but family files are like individual objects and elements that you'll place within your projects. And so if you want to open up a family file directly, there's links there to open to create new ones and also the recent families. On the far right-hand side, there's a resources area, and you can use that to access certain aspects of the help menu and the help system and even some getting started videos. So feel free to explore those elements. Now here with the application menu, when you open that, it has many of the commands you would expect in a typical file menu. You can create new files, you can open existing files, you can save, you can print, you can export. Many of these items here on the application menu actually have a small little arrow right here. And you can see that if I hover over it for just a second or two, it actually expands out a broader menu. So let me try that again. Let me move away, and you can see here that there's new, and I can just click it to open the new dialog, or if I hover over it, it'll give me other options. So specifically, I could create a new project or a new family or a new conceptual mass and so on. Now, if you just click the link, it will open up a dialog. In this case, opening up a dialog to let me choose an existing file that I want to open. I'll go ahead and cancel that. Now, if you don't have any of the items on the menu highlighted, on the right-hand side, it's going to actually show you a list that can be one of two things. At the moment, I have it set to show me the recent documents. So this reiterates the same items that I had here in the background in the recent file screen. Those are just the most recently opened files. Now, there's room here for a lot more than just 4. If I had opened up more than 4 files recently, they would all be listed there on the list. Now, if you're working on a project for a long period of time and you want to keep it on the list, there's actually this little pushpin icon right here, and you can click that, and it will keep that item pinned to the list, and it will not scroll off the list as you open up other files. And then finally, down here at the bottom of the applications menu, there are 2 buttons. There's the options button, which we'll talk about in a future movie, and we can also use this button right here to actually exit out of Revit when we're done work for the day. So you can create new or open existing Revit files using either the application menu or the recent file screen. The application menu has a few additional items like saving and exporting, and these are all the standard file access operations that you would expect to find in most software programs. In this movie, we're going to talk about 2 primary interface elements in the Revit user interface, the ribbon and the quick access toolbar. Now, the quick access toolbar is displaying currently, but most of the tools are grayed out, and the ribbon is also mostly unavailable. So in order to talk about these 2 interface elements, we really need to have a file open in the background. So I'm just going to click the architectural template link here and just create an empty architectural file. Now, as you can see, the interface changes when you do that, and across the top of the screen is where we find the quick access toolbar at the very top, and then beneath that, the ribbon, which is organized into tabs, starting with architecture on the left and ending with modify on the right. So let's start by talking about the ribbon a little bit. The ribbon is really the primary interface element that you have in Revit, and all of the commands that you're going to access in the software are located somewhere on the ribbon. Now, I'm on the architecture tab to start off with. You may not have exactly the same tabs that I do. It depends on which version of Revit you have installed, but if you have the suite version, you'll have systems and structure tabs as well. If you just have Revit architecture, you might not have the systems tab, for example. But you'll always have things like the insert tab, the annotate tab. So there are some common tabs that appear in all versions of Revit. Well, back here on the architecture tab, let's just take a look at the organization of the ribbon. The ribbon is organized into what we call panels. So the first panel you can see here is the build panel, and it encompasses all of the buttons and controls that would allow you to create things in your Revit model, architectural elements. So we've got walls and doors and windows all on that build panel. There's also the circulation panel and the model panel, and as you can see that each one of them groups like commands together. Now, if we scan over a little bit further, there's a panel over here called room and area, and you can notice that it's got this small little drop-down arrow next to it. Now, that doesn't occur on some of these other panels. Now, notice that this one, when I highlight it, it actually highlights in a bluish color. These don't. Well, this is actually what we call an expandable panel. So when you click that, you'll see that there's actually some other buttons stashed away underneath that expandable portion of the panel. So these are less frequently used commands, and they kind of tuck them away under this little expandable portion. So be on the lookout for those. Now, another thing you want to be on the lookout for, and I'll have to switch tabs to show you this, is, for example, if I go over here to the annotate tab, sometimes you'll have a small little icon that appears right here. Now, this is the text panel, and you'll see that when I hover over this little icon, it says text types. Now, this is called a dialog launcher, and it's called that because if you click on it, it actually launches a dialog, in this case, the type properties dialog, where you could configure things about your type properties. Now, I'm not going to change anything there. I'm just simply going to click cancel, but I just wanted you to be on the lookout for these small little dialog launcher icons, and they do occur in other locations as well. Here's one on the insert tab on the import panel. Now let's go back to the architecture tab and talk about the different kinds of buttons. Even with all these buttons and controls, really everything in the ribbon boils down to 3 basic kinds of buttons. The simplest form of button is what you see here with like the door and the window commands. When I highlight it, the button highlights, and if I click it, it just does one thing. It launches the door command. Now over here on the model tab, I have another kind of button, which is actually called a drop-down button. So here, when I highlight this model group command and click it, instead of it running a command, it actually opens up a little miniature menu. And you can see that there's several items on this menu. And then when you choose any one of these, they would behave the same way as the door or window button did. It would create a group or load a group and so on. Now over here on the wall command, you're actually going to see a combination of the 2. The top half of the button, if you click it, just runs the wall command. Now if you've gone ahead and clicked it, I'm going to just simply click this modify tool here to cancel that command without doing anything. And then I'm going to show you the second half of that button, the drop-down portion of it, which actually expands out a little miniature menu. Now I should point out that a lot of times whenever people see this little drop-down, they always click it. And there's nothing really wrong with doing that. This first item right here is exactly the same as this item here. So if you know you want to create an architectural wall, you can actually just click the top half of the button without using the drop-down. But if you use the drop-down, no big deal. It's just an extra click. Now, any of these buttons and controls that you see can be added to the QAT, or the quick access toolbar. Now, that's that toolbar that we see up there at the top of the screen. Now, there's already some buttons here. We've got open, we've got save, we've got undo and redo, but we've got a series of other commands over here as well. You can actually add any of the commands on the ribbon to that quick access toolbar by simply right-clicking them. So, for example, if I wanted to add the ceiling command to the quick access toolbar, I could choose this item, and you can see it adds that button to the toolbar. Now, you can see that I'm not going to have much room here before I run out of space if I start adding a lot of commands. So, it's actually possible to right-click anywhere on the quick access toolbar itself and choose this item here to show it below the ribbon. And it will move that QAT down underneath the ribbon, and you now have all this space over here that you can add commands to. So, if you like to use the buttons, but you don't like having to switch ribbon tabs, this can be a nice way to do that because you can add your favorite commands to the QAT and move it down here so that you have room for them all. Now, at the very end of the QAT is this little drop down, which offers you another way to customize the QAT. So, for example, one of the things you could do is come down here and choose this customize option, and you can see that this dialog allows you to actually start grouping the commands, and you can even incorporate these little separators here in between groups of commands, and they show up here in the background as these little vertical lines, which just makes it a little bit easier to kind of visually group the different commands. Now, I'm going to go ahead and cancel this, and I'm going to remove that ceiling command that I added, and then I'm going to move this quick access toolbar back up above the ribbon and just kind of reset myself. But feel free to do any of those customizations I showed you if it suits your workflow a little bit more closely. So the ribbon is your primary user interface element in Revit. All of the Revit commands are located there, and then the quick access toolbar just provides you shortcuts to many of your most frequently used commands, and you can actually customize that to suit your own needs and preferences. Much of what you do in the Revit environment is context sensitive. What I mean by that is when you're manipulating certain objects or when you're executing certain commands, the interface will actually change to reflect the context of the command or the object that you're manipulating. The 2 places where you're going to see this happen most frequently is on the ribbon and on the options bar. So let's talk about those 2 critical interface elements here in this movie. So let's start with context ribbons that will appear when you select objects. So I'm going to go to the modify tab here first, and I want to show you what the default modify tab looks like. So this is the default modify tab when there's no command active and when there are no objects selected. So we have our properties panel, our clipboard panel, geometry, all the way over to measure and create on the far right side. if I come into my model here and I select an object like this roof here, notice that the left-hand side of the Modify tab remains exactly the same, but we now get an additional mode panel on the far right, and the whole thing tints in this sort of greenish color. If I click away from that to deselect, that context portion will disappear, and the Modify tab goes back to saying just Modify. Let me select another object and show you again. Here's the door object on screen. Notice now the Modify tab says Modify Doors, and we get a couple different buttons that appear that are related to the context of the selected door. So in other words, each of those buttons on the context portion of the ribbon would pertain to the selection. So we could pick a new host for the door, for example, or we could edit that door family. And you're going to see that depending on the kind of object you select, you may get more or fewer of these context-sensitive buttons. So we get several buttons when it's a group, but maybe only one button when it's a topo surface, for example. So it will vary depending on the object and what commands are available. Now, the other place where you're going to see similar context buttons is when you're actually creating objects. So if I go to the Architecture tab and I just click the Wall tool, for example, notice that that takes me to the Modify tab. And again, the left-hand portion of the Modify tab is exactly the same as it was a moment ago, but then we get that context-sensitive portion off to the right, and it now says Modify Place Wall instead of just Modify, and we get all the draw shapes over there on the right-hand side. Now, in addition to that, when I'm in the Wall command, I'm also getting a whole collection of options available on the Options bar. Now, the Options bar is that big slot of space there directly below the ribbon. Now, if I come over here and click the Modify tool or press Escape twice and cancel completely out of the command, notice that the Options bar is now completely blank. So the space is still there, but there are no options available because I'm not doing anything. Now, sometimes when you select an object, it will put options on the Options bar. It didn't do it with the door, it didn't do it here with the roof, but in some cases you will get options that will appear on the Options bar. Like when I select this topo surface, I get the Activate Dimensions button. But more often than not, the Options bar gets populated when you're creating objects as opposed to when you select existing ones. But in either case, you really want to pay attention to what displays on that Options bar and on those context-sensitive ribbons while you're working, because all of those tools are going to be highly sensitive to what it is you're actually doing. So it's changing all the time. And so after a while, you'll get used to that. But certainly initially, when you're learning Revit, you want to pay close attention to those interface elements so that you know what features and options are available to you as you work. In this movie, we're going to talk about the Properties palette. The Properties palette is one of the primary interface elements that you use to manipulate objects both while you're creating them and then after they're created when you want to make changes to them in your model. Properties palette by default is located on the left-hand side of the screen, just below the ribbon, but it can actually be located in other parts of the screen as well. So yours might be in a different location, which is fine if that's your preference. If you don't see the Properties palette at all, then what you're going to want to do is come over here to the View tab, and using the User Interface dropdown, make sure that you put a check mark right here to display that Properties palette. So it is actually possible to hide it, but I wouldn't recommend doing that. So let's look at ways that the Properties palette will help us while we're working. The first way that you're going to interact with the Properties palette is when you're creating new objects. So for example, if I come over here to the Architecture tab and click on the Wall button, now don't worry too much about the specifics of the Wall command just yet. We're going to talk about those in a future movie. But when I look over at the Properties palette, you're going to see that there's some settings that pertain to the wall that I'm about to draw. So I'm about to draw a generic 140mm wall. And if I begin clicking points, you can see that I'm creating segments of that wall. Now let's say I wanted to change some of those settings to something else. Well, notice that the Properties palette has grayed out. So while you're drawing walls, you can't make the change. But if you want to make the change, you just simply press the Escape key one time. That will cancel the current draw action, but keep you in the Wall command. And notice now that all the property settings are available to manipulate. So I could open up the type selector here at the top and choose a different size wall, like maybe this generic 200mm wall. And then I could continue drawing, and you can see that those walls are slightly thicker than the other ones. To get all the way out of the command, you can press Escape twice, or you can just simply click this Modify tool right here, and that will cancel out and get you back to a 0 state. So that's manipulating the Properties palette while you're drawing new elements. But what about elements that already exist in your model? Well, to see their properties, you just simply select them. So for example, if I select this exterior wall over here on the left-hand side of the plan, notice that the properties is now displaying that particular wall. So that particular wall is an exterior brick on metal stud. It's set to the wall center line. It's at level 1. You can see the various properties that are associated with that object. Right here is another small drop-down menu, and it says currently walls, and in parentheses, the number 1. So what that's telling me is 2 bits of information. It's telling me the category of the selected object, which is walls, and it's telling me how many walls I have selected, currently just 1. Now, we can manipulate this existing object in the same way that we did when we were drawing new ones over here. For example, if I opened up the type selector and chose my generic 200mm wall, notice that that wall will get a little bit thinner in place right where it is. Now, assuming you wanted to not actually keep that change, you can undo it. So I can just come over here to the Quick Access toolbar and click the Undo command, or you can press Control-Z, and that will restore it to its original state. Now, remember that I had walls and it said quantity 1. Well, let me select that same wall again, hold down the Control key, and I'm going to select a second wall. Now, the Control key is how you add to your existing selection. As long as it's held down, it will add other objects. Now, we're going to talk about lots of ways to select in future movies, but for now, we'll just use that simple method. Notice the only difference on the Properties palette is the quantity right here in parentheses. It says 2. Everything else is the same. Brick on metal stud, wall centerline, level 1, because these walls share the same properties. Now, you certainly could open up the menu and make changes to that selection, but I just want you to really pay close attention to that quantity. And here's the real important reason why. I currently have 2 walls selected. But what if it said 5 walls or 8 walls or 10 walls, and I thought I only had 2? When you make a change, anything you do here is affecting the entire selection. So you really want to be cautious of that because you might be modifying objects that you're not aware of. Let me show you an example of that here in the south elevation. So if you come over here to the project browser, double click the south elevation, you're going to be looking right at an elevation view of this model. And I'm going to roll my wheel slightly to zoom in on this window. Now, if I select that window, you can see that it's a casement window. It's at level 1, and it currently has a sill height of 915mm. Let's say I wanted to move that window. Let's put it at 600mm. Well, notice nothing's happened yet. When you make a change on the Properties palette, you have to actually apply that change. Now, there's 2 ways to apply it. You can either use this Apply button right here, and that will apply the change, move the window down. Or, let's say I want to put it back to 915. Shifting your mouse away from the Properties palette will actually apply the change. Now, the program is called the shifting focus. So if I shift focus off of the Properties palette back to the drawing window, it will apply the change for me automatically. And that was actually what was happening back in the previous view, in the floor plan view, when we were applying a different type. By moving the mouse away, it was automatically applying the change. Now, as I talked about just a moment ago, if you select more than one element with the Control key, in some cases, if those elements aren't the same kind of element, you might see different things happen in the Properties palette. Now, in this case, they're both windows, so we still get quantity of 2, but you want to be cautious here because it says multiple families are selected. Now, what does that mean exactly? Well, let's say that I just went ahead and made a change here. I'm going to pick a fixed window, maybe this size right here in the middle, and you can see that that's a pretty dramatically different change from what was there a moment ago. Now, that may be your intention, but it may not. And so this is where the caution that I was giving you a moment ago is to pay attention to the quantity and what you actually have selected, because the change you make on the Properties palette is going to affect the entire selection. So let me go ahead and undo that, and I'm going to return to the level 1 floor plan. And I'm going to show you one last example of a multiple selection and what you want to be aware of here. Suppose I select a toilet. the category for that is plumbing fixture and quantity of 1. Now I can hold the control key and select a second toilet, and it's still plumbing fixtures, now quantity of 2. But what happens if I hold the control key and I select an item that's not a plumbing fixture, like this wall? Well, now the filter selection is going to change to common, telling me that these are the properties that these multiple categories share in common. And really, it's just comments. Okay, so about the only thing you could do to walls and toilets at the same time would be to add some comments to them. However, what I want to point out here is that this filter is actually a drop-down list. So by keeping the selection active on screen, all 3 elements are still selected. You can actually reach in and focus your edits on different categories within that selection. So here's the 2 plumbing fixtures, and I could make changes. Here's the 1 wall, and I could make changes. And then also, you actually have access to the floor plan itself. So without losing the selection, if you wanted to make a change to the floor plan, change its scale or its level of detail, you could switch to the floor plan itself and get access to those settings as well. So as you can see, the properties palette is a very powerful user interface element that allows you to manipulate objects not only as they're being created, but after they've been created within your model, and make changes not only to individual objects, but to large collections of objects all at once. And just really pay close attention to those subtle little nuances that appear on that properties palette, because it can make a big difference in the kinds of edits that you get. Your Revit project is a complete virtual building model that can be viewed, edited, and explored 3-dimensionally, 2-dimensionally, and in various reports and tabular lists. Each such representation of the project is referred to in Revit as a view. Views are listed and accessed from the project browser palette, which functions much like a table of contents for your project. So similar to how you have a table of contents telling you where you would locate various aspects of a book, you can use the project browser to help you locate the various views within your project. So let's start with where the project browser is located, which by default is over on the left-hand side of the screen, directly below the properties palette. Now I have the default installation. Your project browser might be located somewhere else on the screen, or it may not be displayed at all. If it's not displayed at all, you can use the tool on the View tab, the user interface tool that we looked at in the previous movie. At the very top of the project browser, you'll have a branch called Views. In parentheses next to that branch, it says the word All. Now, All is simply the name of what we call a browser organization. Now, when I select Views here, you'll notice that the properties palette actually changes to reflect the selection, just like it did in all the examples that we explored in the previous movie. So up here, it says Browser Views, and then there's the type called All. And there actually are some other types that we could choose from, but for this movie, we're going to stick with the default grouping of All, which just simply means it's going to display all of the views within your project. Some of those other types would actually filter out the list and show a limited subset of views, and in some cases, that might be appropriate. Now, beneath that, you see different branches for the different kinds of views. Now, these branches are named after your most common types of drawings that you would have in architectural production. So we have a floor plans branch, we have a ceiling plans branch, we have elevations, we have sections. Now, when you scroll down a little bit further, there's also a legends branch, schedules and quantities, sheets, families, and even Revit links down toward the bottom. Now, we're going to look at some of these other branches in future movies throughout the course, so we won't necessarily explore every single one of them here, but they all function in a similar way. You can expand open the branch, and then beneath that will be indented whatever views belong to that branch. So for example, let's say I wanted to look at the second floor plan of this model. So I locate my floor plans branch, and then expand it if it's not already expanded, and then just simply double click level 2 to open up that floor plan. Now, I'm going to use simple navigation methods in this movie, but we're going to talk about navigation in a future movie, but you can use the wheel and just zoom in and out, and you can drag with the wheel to pan if necessary. So this is a floor plan of the project from the second floor. We also have third floor plans and a roof plan and so on. There are ceiling plans, there are elevations. Now, down here, I've got 2 sections, section 1 and section 2. Now, in many cases, the views will actually have on-screen representations as well. So you can see over here that there is a section cutting all the way through the building model. And if I just kind of pause my mouse over that, it should give me a little tooltip on screen telling me what view that is. You can see that that vertically cut section there is actually section 1, which corresponds to this view right here on Project Browser. And if I do the same thing with this section, that's section 2, and you can see it listed right here on the browser. So you can open these sections in one of 2 ways. You can either double click directly on that item in the Project Browser the same way we open the floor plan, or here's that section 1 again, because we're now cutting through the building, looking at that section 2, and it intersects the section 1. And if the tooltip doesn't display on screen, you can look down at the status bar at the bottom left-hand corner of the screen. So notice at the bottom left-hand corner, I see views, section 1. That's the same information that we would have seen in the tooltip, and you can see that it points to that section 1 that we have there in the browser. You can open the section directly from the on-screen control here. So there's 2 ways you could do that. You could either double click this blue section head here, and it kind of functions like a hyperlink in a web browser, and you can see that will open that one up. Or you could actually highlight the section marker, right click, and choose go to view, and that would take me right back to section 2 there. So there's a couple different ways that you can navigate around the various views in your project, either by using the on-screen indicators or by double clicking them over here in the project browser. Notice that the level heads are also in that blue color. And if I highlight over that, it says the same thing, go to the floor plan that corresponds to this level. So if I wanted to return to my level 2 floor plan, I can double click the level head to get back there as well. All right, now let's direct our attention back over to the browser at a few other functions that we can do over there. Now, it should be fairly evident that these little minus signs here can be clicked and they become plus signs, and that will either collapse or expand that grouping. So if you have a project with lots of views and you want to make it easier to scroll through that list, you can easily collapse down the views that you're not using at the moment to make it easier to scroll. You can also search anywhere in the browser to find views. Now, in this project, it's a very simple project. There's not that many views, but in projects back in your office, you might have hundreds of views in some cases in the browser, and so it can be difficult to locate them. Just simply right-click anywhere in the browser, and you can access a search feature. And when you do that, it will display a dialog, and you can begin typing in what you want to search for. So for example, if I just type in the word section and then I click next, notice that it will go to the sections branch, then it will go to section 1, section 2, and so on. So if you type in something very specific in the search field, it'll go to maybe just a few views. And if you type in a more broad keyword, then it might actually have several views for you to filter through. Let me go ahead and close that. Now, in some cases, there are other right-click options available as well. So really, the best thing you can do is just sort of right-click on the various parts of the browser and see what comes up. Notice when I right-click here on the elevations branch, I only get search, but if I right-click on an actual view, an elevation in this case, I get lots of choices. I can open that view, I can duplicate it, I can delete it, rename it. So in some cases, the right-click menu will offer you many, many more choices. So the project browser contains all of the views that are available in your project, and we can use it to open views, navigate views, rename them, duplicate them. We can do a variety of things. So make sure that your project browser is open and in a nice, convenient location on your screen so that you have easy access to all the views in your project. If you spend a lot of time working in Revit, then you will no doubt discover that screen real estate often becomes a premium. So there's a few different ways that you can manage your interface to adjust it to your liking, and one of the things that we can do is adjust the way the palettes are organized on the screen. So this would include the properties palette and the project browser that we talked about in the last 2 movies, but it would also include other palettes that you can display as well. So if we look over here at the left-hand side of the screen, I have my properties palette above my project browser in the default configuration. This is how it would install out of the box. But with either of these, you can actually come over here to the title bar, click and hold down your mouse, and tear it away from the docked location on the screen. Now you'll see this big gray border, and when I let go, you'll see that now the project browser is a floating palette. And you can see that I can easily move that around on screen. Now, the only disadvantage of that is that it actually covers up the drawing window underneath. So the best use of tearing it off in this fashion would be if you actually have two monitors connected to your screen. So nowadays, a lot of folks have double monitors, and so if you do have that, you can actually tear off both of these palettes and put them on the second screen, and then your view window can be a nice full screen view. So that's definitely something you can do. Now, of course, you'll also notice that the properties palette is still docked on the left, and so it now fills up the entire vertical part of the space. Now, you can dock these palettes to any of the four sides of the screen. And so if I grab this floating palette and I start to move it to the edge here, notice that it wants to dock to the upper portion of the screen. Or if I drag it to this edge down here, it will want to dock to the lower portion of the screen. Now, I wouldn't necessarily recommend that with the project browser because, as you can see, it significantly reduced the size of the view window. And unless you have really long view names, all of this space over here to the right is just empty white space. So I would think that the best place for your project browser and your properties palette would be on the vertical sides of the screen or on the separate monitor. Now, some folks prefer to organize their Revit screen this way, where they have a properties palette on one side and a project browser on the other, and they benefit from both of them being the full height of the screen. So that's another configuration that's very popular. Here's another option. I'm going to pull this back off again, and this one is a little bit trickier to get used to. So you're going to want to pay very close attention to the on-screen cues when you do this next thing. So I've got my browser floating, and I'm going to start to drag it. Notice that I get this big gray box that sort of simulates the shape of the palette. If I move it over here towards where the properties is, pay attention to the shape of the gray box and notice that it's now a much longer and thinner rectangle. If I were to let go, it will actually dock on there as a very narrow window, and it puts itself next to the properties palette. Now you can always put your mouse here and adjust the width of it. So again, if you want, you can put them side by side like that. Let's peel it off again and look at another alternative. If I take this and I start to drag it, the first thing we start to see is what I just showed you, that it's going to try and dock on like this. Here's the trick. Don't pay attention to the gray box so much. The gray box is the feedback for the end result that you're going to get. You want to pay attention to where your mouse pointer is. If I look where my mouse pointer is, notice that as I move it up just underneath the title bar of properties, it's actually going to dock it on top of the properties palette. Let me tear it off again. Let me shrink this down a little bit narrower here. Now, suppose I take this and drag it down here. Okay, now it would give me below the properties palette. And then finally, if I put it right on top of the toolbar of the properties palette, you can see where my mouse is. It's on that blue bar. You can kind of see at the very bottom a little gray line that kind of has a step in it. And what that's going to do is it's actually going to put the two palettes on top of each other and tab them. So when I let go, notice that I get a tab here for properties and another tab here for project browser. And if I click, it switches between the two. So if you don't have two monitors, but you don't like having the palettes stacked on top of each other and really short, you can make them full screen height like this and tab them. The only downside is that you have to remember to click the tab to switch between the two. So it really is just a matter of preference, which one of these you choose, but there's a lot of different options that are available to you. I'm going to tear this off one more time, and I just want to reiterate, it's the mouse pointer that you want to follow. So again, if I do this right below the title bar, it stacks. Right on the title bar, it gives me a tab. So that's how you know which one you're going to get. I'm actually going to put it back down here, right underneath my properties palette where it started off. And for the remainder of the course, I'm going to leave it in its default position. But you are welcome to use any of those methods that I just showed you and move the two palettes to any configuration that suits your own personal preference. In this movie, I want to talk about an alternative way to execute commands using keyboard shortcuts. So we've already talked about in previous movies that you can go to Revit and you can click on the various buttons to execute commands, but in some cases it's going to be easier to actually just use the command from your keyboard. And many of the commands in Revit actually have keyboard shortcuts. I want to show you how you can learn where the shortcuts are. So the easiest way is to pay attention to the tooltips that appear on your mouse when you put your mouse over one of the commands on the ribbon. So for example, here's the wall command right here. Now you'll notice a behavior about tooltips in Revit is that when you first highlight the object, the tooltip just gives you the name and a brief description. When you leave it there just a little bit longer, it expands the tooltip open to a more detailed description. So let me show you that again here with the door command. See, brief description, and then it expands open. Now notice with both of these, next to the name of the command, this is door, in parentheses it says DR. And over here with wall, this is the wall button, and in parentheses it says WA. Those are the keyboard shortcuts. So in addition to using the tooltips to just help you learn about the command, the tooltips will also tell you whether there's a keyboard shortcut associated with that command. So if I move my mouse back out here into the drawing window without clicking the button, if I wanted to execute the wall command, I would just type WA. Now this is very important. Don't press the enter key. You just simply type the two letters, W and A. That's it. If you press enter, what that actually does is it repeats the last command. So whatever command you did before you were trying to run the wall command, it will run the wall command, then it will immediately cancel it and run the previous command. So in my case, if I press enter, the last command that I did was the align command. You see how it jumped me to the modify tab, and it's now highlighted the align command right here on the ribbon, and you can see that my cursor has changed to an align command. Now that will be frustrating if you're not expecting that behavior. If I type WA enter thinking I'm going to get the wall command and instead I'm getting the align command, I may be puzzled as to what's going on. So just kind of keep that in mind. I'm going to press escape key 2 times here to cancel all the way out, and I'll go back to the architecture tab again. So most of the commands here on the ribbon are going to have keyboard shortcuts, but not all of them. So as I page through these, you'll notice that roof by footprint, for example, does not have a keyboard shortcut. Now, if you create lots of roofs by footprint and you want the roof by footprint command to have a keyboard shortcut, you can actually customize your Revit environment to include a shortcut for the roof command. You would do that by going to the View tab, come over here to the User Interface dropdown, and choose the keyboard shortcut command. Now, if you look at the tooltip for the keyboard shortcut command, notice that it actually has a keyboard shortcut. So you can actually type KS to get to this dialog as well without having to go through the ribbon. And then here you'll get a complete list of all of the commands in Revit, and you'll see whether or not they already have shortcuts associated with them. Now here I've stopped at properties, and you'll notice that properties actually has 3 different shortcuts. So it's actually possible to assign more than one shortcut key to a command, and you can use whichever one you prefer. So in this case, I could type PP, I could do Control-1, or I could type VP, and they would all do essentially the same thing. What you want to be careful of is not assigning the same shortcut to 2 different commands, because in that case, Revit will only execute one of the commands, not both. So even though you've assigned a shortcut, it won't ever get to the second command. So try to make sure that you are familiar with the existing shortcuts before you assign a new one. I'm not going to actually create any here. I'm going to simply cancel out. Before I do that though, if you want, you can actually choose export here to create a text version of this list and use that as a cheat sheet for the shortcuts if you like. I tend to prefer just looking at the tooltips and learning them that way, but both methods would work. So if you prefer to use the keyboard to execute your commands and not click through the ribbon tabs as much, you absolutely can do that in Revit. Just look for the 2 keystroke that you need. Make sure you type the 2 keys without the enter key. Very important you don't use the enter key, and that will execute the same command without you having to find it on the ribbon first. In this movie, we're going to look at view navigation. View navigation is a critical part of any graphics software program, and Revit is certainly no exception. So I'm going to show you ways that we can zoom the screen to change magnification, pan to slide around or scroll the screen, and to orbit when we're looking at 3D views. So I actually have a 3D view open here right now. We can look at all 3 of those, zoom, pan, and orbit. Now the first way that I'm going to show you how to do that is to just simply use the wheel on your mouse. Now if your mouse does not have a wheel, I would highly recommend that you get one that does, because it will pay for itself in the first few minutes of its use. To zoom, you simply roll the wheel. So if I roll the wheel down, it will zoom out, and if I roll the wheel up, it will zoom in. It's that simple. Wherever your mouse is, that will become the center of the zoom. So notice here that my mouse is nearby this curb here in the parking lot, and that's what I'm zooming in and out on. If I instead move my mouse over here, don't click anything, but just sort of move the mouse in this vicinity, now it's zooming in and out on the entrance wall here in this building. So that's the easiest way to zoom in and out. To pan, you take the wheel and you press and hold it down. So you're just pushing it in, and then you can drag in any direction to pan the screen. Now there are scroll bars here on the sides of the screen, and honestly, I never use them. Okay, so they work exactly the way you'd expect them to work, but I think it's just so much easier to use your wheel there and that middle button. Now you can also use that middle button to orbit the screen. So because I'm in a 3D view here, I can spin this model around and look at it from another vantage point. To do that, I'm going to hold down the shift key, and then I'm going to drag with the wheel. And you notice that the cursor changes from this, which is a pan shape, to this, which is a orbit shape. And now you can see that I'm spinning the model around. Now this only works in a 3-dimensional view. So if I come over here and I open up, say, a level 2 floor plan, and I want to zoom in a little, that I can roll the wheel just like I did before. If I want to pan, I can do just like I did before. But if I hold the shift key down and try to orbit, it will just pan. Now, that's by far the fastest and easiest way to navigate your Revit views, is to use one of those 3 methods with the wheel. But there are other ways that you can navigate the screen as well. So staying here in this 2D view, let me show you some of the options. Over on the right-hand side of my screen, I have a small ghosted out toolbar, which is called the navigation bar. Now, if I move my mouse nearby it, notice that it starts to light up. So when you get in vicinity of that toolbar, it will become full intensity. So when you move away, it's kind of light, and then it gets full intensity. There's 2 navigation controls here. There's a steering wheel, and there's this view dropdown. And I'm going to show you this view dropdown right here. If you click the small little icon beneath it, it shows you that there are several different ways to zoom. Now, the default one is zoom in region, and you can see that by the check mark next to it. You can't actually choose it off the menu to run the command. You have to actually click the icon. So there's zoom in region. And if you watch the previous movie, we talked about keyboard shortcuts. Notice that there's a keyboard shortcut for this command as well, which is ZR. So I can do it either way. I can click the button or I can type ZR. And I'll get a little magnifying glass. And then you basically define a rectangle and it will zoom in on that rectangle. So it's pretty straightforward, but that's how you do zoom in region. Now, the next one down is zoom out 2 times. Now, a peculiar behavior of this little dropdown is if you're choosing a command off this menu that's not the current one, then it will execute the command as you choose it. So watch when I choose zoom out 2 times. It actually executes the command and makes that the button on the top of the list. Now, if I tried to pick it off the menu again, nothing would happen. If I wanted to zoom out 2 times a second time, this time I would click the icon or type the letters ZO. So you can use the keyboard shortcuts or you can use the little icons. And in fact, every one of these zoom commands has a keyboard shortcut. They all start with Z, and then it's the first letter of the next word in the name. So ZR for zoom region, ZO for zoom out, ZF is zoom to fit, ZF, and you can see that fits the screen. Now it does fit all the way out to these elevation markers here. So it didn't fit to just the building model, it fits to any geometry in the view. Zoom all to fit, I could only show you if you had more than one window open on screen. So if I take this little icon right here, which is the windows, we've got minimize, maximize, and close here. This one in the middle, restore down, that drops the window down to a floating window. And notice that I've got other windows open in the background, like an axonometric view in my level 2, and then whatever this window is here. Well, if I do the keyboard shortcut for tiling these windows, that would be WT, or I could click this icon right here, and that will tile all 3 windows on the screen. Well, now if I type ZA, it's going to zoom all of those windows to fit. So if you're ever in a situation where you have multiple windows open on the screen, you can zoom them all to fit with a single command. Now let me go back here to my level 2 floor plan. I'm going to maximize that again, zoom to fit again, and let's look at the last one, which is zoom to sheet size. Now zoom to sheet size is actually one of my favorites. What I'm going to do first is zoom in region around this general area, and then I'm going to do zoom to sheet size, which would either be choosing it here off the menu or typing ZS. Now when you do, it makes a slight adjustment to the view. This command makes the view window match the size that it will be when it prints. So it's called zoom to sheet size, but I actually like to think of it as zoom to scale. Now, if you look down at the bottom left-hand corner of my view window, you can see that the scale of this view is 1 to 50. So at 1 to 50, this door right here, which is, if I hover over it, you can see the last part of the tooltip, it's 900 millimeters by 2400 millimeters. So it's 900 millimeters wide from here to here. And if you look at your own screen and imagine about how big 900 millimeters should be when it's printed at 1 to 50, then that's about the right size. Now, I wouldn't suggest taking out your scale ruler and measuring your computer monitor because computer monitors are not as accurate as printed output. But if you did hold up a piece of printed output next to your computer monitor, it'll be really close. And so the purpose of this command is to give you a decent preview of what it's going to look like when it's printed. So if before you work in the file, before you print, if you just do a quick ZS and look at the screen, if everything kind of looks legible and okay, you can trust that it's probably going to look pretty good when it prints. If you do that ZS and everything is all muddled and muddy, maybe you want to make some adjustments. For example, if I were to change the scale here to 1 to 200, notice what happens to all the labels. They get huge, right? Now, if I do ZS, the labels look fine, but everything is overpowering on the screen. Like I really wouldn't want to print this view right now because it would be very difficult to read anything in the drawing. So this is why ZS can be such a helpful tool to help you make good decisions about what a view looks like before you commit it to paper and waste the time in the paper actually printing it out. So that's why it's one of my favorite commands. I'm going to go ahead and change this back to 1 to 50 here, and then I'll do a ZS again to confirm that this is a much better and more appropriate scale for this view. So as you can see, there's a lot of different ways that you can navigate the views, and there are some others that we haven't talked about yet, but using the wheel is by far your primary view navigation tool, and that's the one you're going to use most of the time. You roll the wheel to zoom, you drag it to pan, and in a 3D view, you can hold the shift key to orbit and spin around. You also have the drop down on the navigation bar, which gives you access to some other zoom commands, and all of them have keyboard shortcuts. And between the collection of those tools, you should be able to navigate most views and get into the areas that you need to do your work quickly. Before you'll be able to be successful in making manipulations to a Revit model, you're really going to have to master the process of selection. Now, this is not unique to Revit. Any graphics program, selection is a key skill that you have to master. And there's lots of ways that we can select objects in our Revit models. Now, the first clue we have to the methods of selection is actually right on screen when nothing is happening in your Revit project. So if you're not running any commands, you don't have anything selected, and you look down at the status bar at the lower left-hand portion of the screen, you can see that it says click to select, tab for alternates, control adds, and shift unselects. Now, in some previous movies, we've seen the click to select. That's pretty easy. You just simply go over and put your mouse over an object and click, and it will select that object. Now, what I haven't really mentioned in any of those previous movies is if you click to select a second object, it will actually deselect the first. So an important thing to know about selection in Revit is every time you click, you're actually creating a new selection set. Now, if you want to actually add to or remove from the existing selection set, that's where the control to add and shift to unselect comes in. So in this case, if I want to add another wall to this selection, I would hold my control key down, notice the small plus sign that appears next to my cursor, and then click to add that wall, and maybe click to add this wall, and maybe click to add this wall. Now, when I'm done adding walls, if I realize, oh, I didn't actually want the small wall after all, then I'll hold the shift key down. Notice now that I get a minus sign next to the cursor, and then I can click to remove that object from the selection. So click to select, hold the control key to add to it, hold the shift key to remove from it. And then if you remember a previous movie when we were talking about the properties palette, the quantity of selected items will be listed over here, and I currently have 3 walls selected. And I encourage you to always pay attention to that quantity before you move on to the next step to make sure that the quantity matches your expectation. Now, if you click an empty white space, it will clear any selection you have. So another way to think of that is you're always building a new selection when you click. So if your new selection includes 0 items because you're clicking an empty space, then it will replace your current selection with an empty selection, or in other words, it will deselect everything. Now, the other way that you can deselect is to just simply press the escape key or to click the modify tool. So all of those methods will deselect everything. Okay, so now let's talk about the tab key. When you first get ready to select an object, it actually first pre-highlights. So if I move my mouse over this wall, you're gonna see it highlighted under my cursor. Now, if I don't click and I just move my mouse away, it de-highlights. See this door here? See this wall here? Okay, so it's just highlighting the object to let me know what will be selected if I click the mouse. Now, if you put your mouse near the object you want to select and it highlights the wrong thing, the way that you get it to highlight the thing that you do want is using the tab key. So the tab will cycle through the available objects underneath your cursor. So if I press the tab here, notice that it jumps from the door to the wall. Now, it's important that you press and release tab. You just press it. Don't hold it down like we did with the control and shift. If you hold it down, you get this sort of strobe light behavior, and that's not what we want at all. So let me start again. I'm gonna highlight the door, press tab, and then if I like this selection, I can click to make the selection. So it's really important that you remember that it's basically 3 steps: highlight, tab, and then click. Sometimes it's highlight, tab, 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 click. So the amount of tabbing depends on what you're trying to select, but the tabbing is always the middle step. You highlight first, then you tab 1 or more times, and then you click. So just keep repeating yourself: highlight, tab, click. A lot of times when beginners have trouble with this because they get out of sequence and they have a hard time, don't give up on tab selection because it's way too important. So make sure you practice that and get good at it. Now let's look at another place where the tab key is really helpful, something called a chain selection. So I'm gonna highlight this wall again and press tab, and notice what it did. It actually looked down the ends of the wall, and if it found another wall touching the endpoint, it selected that wall as well. Now, this is a very specific type of thing. What Revit means by a chain is touching endpoint to endpoint. Notice that it highlighted the wall on the right because they're touching end to end, forming a corner. It did not highlight the wall on the left or the one at the bottom, which are forming T intersections. Those are not considered chains. So in order for it to highlight the object, they have to touch endpoint to endpoint. Now, in some cases, you can actually get away with a situation that looks like it's a T intersection, but it's actually an endpoint to endpoint. And I've created that over here. So notice that I've got a small wall here, and I've got another one right here. So there's actually 2 separate walls here. So even though it looks like a T intersection, there's actually 2 different walls there. So this one would respond to chain selection. So I'm going to highlight one of the walls, press tab, and notice that it finds the chain going all the way around the entire perimeter of the floor plan. It's very powerful. But watch what I can do. If I move my mouse just slightly, it'll highlight a different chain. So in some cases, if you have more than one chain available, just moving the mouse a little bit will toggle between the 2 different chains. And then when you see the one you want, you click to select. Remember that final click is critical to always make your final selection. One more tab choice here. Here's a door. Here's the wall. Here's the chain of walls. I'm going to keep going. Okay, there is a floor slab. So sometimes you have to tab, tab, tab several times to actually get to the object you want. So again, it's a really important technique that's definitely worth practicing. Now, all of those techniques are useful, but if you want to select a lot of objects, it can be awfully tedious doing it with some of those methods. So another method we have is to use window and crossing selections. Now, these are the so-called box selections. So the way these work is you don't click, you click and drag. So if I take my mouse and I click and drag to the right, I get a solid edge box. Click and drag to the left, I get a dashed edge box. This is called a window when it goes to the right. The dashed one is called a crossing. And here's how they work. A window has to completely surround an object in order to select it. So notice how I'm able to highlight just the plumbing fixtures, for example, inside this room without getting the walls. And if I let go of the mouse, it highlights those objects. Now I got the door too, but I could easily remove that with the shift key. So keep in mind that all of these methods work together and you can use them all together. It's not one or the other. They definitely work together. Now, a crossing would do anything that's touched. So it would get the plumbing fixtures, but it would also get the walls and even that floor slab. So notice that it's a much more inclusive selection with the crossing. But here's an interesting thing. You can hold the shift key and deselect with a crossing. You can hold the control key and add with a window. So there's lots of ways that you can use these techniques together. Now, a final method that I want to share with you is perhaps the most powerful of all. This is the filter method. Here, you're going to select a lot more than you need. So I'm going to select the entire right-hand side of the floor plan. When I look at my ribbon, a filter button appears over here. When I click this, it will display a dialog which will list out each category of object I currently have selected and the quantity over here in this count column. Now, let's say that I was only interested in certain kinds of objects. Maybe I only want the equipment and fixtures and I don't want any of the walls. I could deselect walls. Maybe I don't want this window. I could deselect the window. And when I click OK, it will leave all the equipment and furnishings selected, but it will deselect the walls and the windows. I realize maybe I don't want the doors. I can go right back into filter and I can take that out as well. So you can fine tune the selection by using this filter method. So that is by far one of the most frequently used and most powerful selection methods that we have in all of Revit. And so you'll find yourself using that a lot because it's a very quick way to get to just what you need, especially in a very cluttered or busy model. So there's lots of different ways you can select objects, and I highly encourage that you take the time to master each and every one, because the more of an expert you are at selection, the more comfortable and the more fluid your Revit experience will be. We have lots of settings that control the way that objects are selected in our Revit models, and while it's a slightly more advanced topic, we want to discuss it now because if you don't have these settings in their default state, then it can make it difficult to select certain elements as we move forward. So what I'm going to do right now is discuss each of the selection toggle settings that we have available to us, describe them briefly, and then in future movies, we'll look at them in more practical applications as appropriate. I'm in a level 2 floor plan here, and I've kind of created a situation where each of the selection toggles is represented. Now, this isn't necessarily always going to be the case. Now, there's a few elements here that we haven't talked about yet. We've got some grid elements over here, which we'll discuss in a future movie. We've got a Revit link model over here, which we'll discuss in a future movie. So a link model is just another Revit project that's been brought into the current project, and grids are just where the column locations are and so on. So you can also see that we've got this gray geometry here in the middle of the floor plan, and that's something called an underlay. So that kind of quite literally represents what you could do in hand drafting, where you put one sheet underneath the current sheet and use it for reference. Each of these types of objects has some special control over the way that we can select them. So you can actually isolate certain types of objects and prevent them from being selected in the model. So let's start with this linked element out here, which represents the site plan for our building. There's two places you can find the selection toggles. They're at the bottom right-hand corner of the screen, represented by several little icons, and the other place is up on the ribbon directly beneath the Modify tool, and that's actually a small drop-down on the Modify panel. Now, the very first icon here is labeled Select Links, and we can see that over here as well with Select Links. And notice that there's a check mark next to this. This means that I should be able to click directly on the linked object, and it will, in fact, select. And you can see it highlights in that sort of blue color there, and then I could make manipulations to that object. Like, for example, I could move it. Now, it's probably not desirable to have somebody move the site plan. So what I'm going to do is click my Undo tool here to reverse that, and a way that we can easily prevent that from happening accidentally is by just simply turning off that Select Links option. Now, notice when I uncheck it here, a small little red X will appear on top of that icon at the bottom right-hand corner. So it works the same way. You can either toggle it there with the little icon, or you could check or uncheck it in the dropdown. They both do the same thing. And now notice that I'm not able to select this link file no matter what I do. So the main reason to bring it up early like this is if you're trying to select an object in your model and it's not working, then what that tells you is that you have one of the selection toggles toggled off where you should have it toggled on. So the next toggle over is underlay. So for example, this gray geometry that we see here, I'm going to zoom in so that we can get a better look at it, that represents the floor plan down below. I'm actually on the second floor, but I'm seeing down below the restrooms and some of the offices on the floor plan below. Well, if I wanted to select those elements, currently I can't do that. Now, in a lot of cases, that might be desirable for underlays because you're just using it for reference. But if for some reason you did want to be able to select that geometry, then again, we can just simply toggle that feature there or here, select underlay elements, and now notice that these underlay elements highlight and are selectable. Okay, so that's the underlay elements. I'm going to toggle that back off. The next one is pinned elements. Now, a pinned element is something that you can personally do manually. Okay, so for example, this wall right now is not pinned, but if I select this grid, it is pinned. You see this little push pin here? Now, the pin is used when you want to prevent an object from accidentally being moved. So notice that even though I can select this grid, I can't currently move it. Okay, and that's because it's pinned. Now, if I unpinned it, then it can move. I'm going to undo that with Control Z. But as long as it's pinned, here's the icon right here, it can't be moved. With the selection toggle, not only will it not be movable, but it won't be selectable as well. So as you can see, each of these toggles isolates certain groups of objects and prevents them from being selected. And the main reason for doing that is to prevent accidental modifications to your model. So as projects get more complicated and more complex, you're going to want to consider the condition of these various selection toggles. Now, what we want to do for now is make sure that we can select each of these items, and then we will toggle them off as necessary in the future movies. So on your own Revit, before continuing, make sure that you can select links, you can select underlays, and you can select pinned elements. And if you've got those three checked, then we'll be good to go moving forward. This movie, we're going to look at the overall system-wide options that Revit has available to us. Now, I should point out that most of these options will probably be set by some sort of CAD or BIM manager if you work in a firm, and most of the time these settings are what I would term set it and forget it options. So once they've been configured to your liking, you rarely have to change them unless there's some change in circumstance that requires it. So these settings are not stored with each project. In other words, they're stored with the Revit environment, and so they follow from project to project. Now, I don't actually have any projects open right now, and it's not necessary to open a project to get to the options. You can access them without anything open on screen. The first option I'm going to look at is how I'm signed in. So at the top right-hand corner of the screen, you can see that there's several icons, and one of them has the sign-in option. That's right here, and you can see that that's labeled Autodesk 360. Now, if you have an Autodesk 360 account, then you can set up a username and password, and you can log in directly from the Revit software. If I switch over here to my Windows Start menu, notice that my username is just my name right here, Paul Auden. Okay, now I'm going to switch back to Revit. If I go to the application menu, we can get to the global options here at the bottom of the application menu using this button right here, options. So here in the very first tab in general, you can see the username area, and you can see that it's using that same name that I had back in Windows. Now that's just the default behavior that Revit will do, is it will use your Windows login if you haven't signed in to Autodesk 360. But notice that there is a sign in to Autodesk 360 here, and if I choose this, I'm able to put in my Autodesk 360 username and password, sign in. And what will happen is Revit will display a message here saying that my Revit username is going to be changed to match that. So when I click close here, notice that it grays out my username and it matches my Autodesk 360 username. So it's important to understand that if you've logged in to your Autodesk 360 account, it's going to use that as your username. Now normally this is not going to be that big of an issue, but it's just something to be aware of. Now where the username is actually used in Revit is when you're in a team project. Now I'm going to talk about how to open up a team project in a future movie, but if you're working in a standalone project, you don't really care what your username is. It only matters when you're working in a team of people that are accessing the same project together, and then each person has to have a unique username. And usually using a 360 username accomplishes that quite nicely. Now directly above that, we have some notifications that have to do with saving. If you're in a team project, it will remind you every so often to synchronize with your central file. If you're in a standalone project, it will remind you every so often to save your standalone project. Now both of these are set to a 30-minute increment by default, and I think that's a pretty good increment for most users, but you can actually change it to something less frequent or to something more frequent. It's actually possible to turn off the reminders as well, but I really don't recommend that. The way that the reminders work is that as you're working, if you haven't saved in that amount of time, then Revit will look for an opportunity to display a reminder. And it's usually a disruptive opportunity. In other words, as soon as you execute a command, it will display this interruption and say, yeah, but you haven't saved in a while. Now, while some users get frustrated by that interruption and are tempted to click the cancel button, I highly recommend that you don't do that. Get in the habit of clicking save the project. Revit will remember what you were doing when it's done saving, and it will take you right back to whatever it was you were doing. And this is your best defense against losing work if something bad should happen and the system should crash. So you need to be in the habit of saving often, and the save reminders are designed to help you do that. Now, there's some other settings here on this tab that we don't have to be concerned with at the moment, like work sharing frequency and so forth. We'll talk about those a little bit later. But down here, you've got your default view discipline. Now, a lot of times it will default to something like coordination, but if your discipline is something different, like architectural or structural, you probably want to choose that from the list. So I'm actually going to choose architectural here. The biggest benefit of doing that is when I create a new view, like a new floor plan or a new section or elevation, it'll be assigned to that architectural discipline ahead of time and therefore use appropriate settings. Now let's look at some of the other tabs here. Under user interface, depending on your version of Revit, you may have several checkboxes available here. Now I've got the full Revit installed here. Even though I'm architectural, I have access to the structure tab and the systems tab here in the background. So if I didn't want to see those tabs, I could actually turn them off by just unchecking it here, and it would hide that tab if I don't want to see it. I'm going to leave them turned on, but you could choose your own preferences there. Now if you don't have all those checkboxes in your Revit, don't worry, it's not going to affect any of the work that we're going to do here throughout the course. You can set the theme that you want. We talked about keyboard shortcuts in the previous movie. You can get to the customization here. There's also an option here to control what happens when you double click on an element. Now there's a lot of options here. So if I click this customize box, you can see that there's several different items that have this double click feature. Now most of them I'm okay with the default settings, except for the very first one here, the family option. What this is saying is when you double click on a family, it's going to open up the family and edit it in the family editor. Now I think most of the time that's probably not what you intend when you double click on a family. So I personally don't like that option. I would choose either edit type or do nothing. So that if I double click on a family, it's not going to try and do anything at all. I don't want to end up in the family editor when I wasn't expecting it. And we'll talk about the family editor in a later movie. So let's go ahead and click OK on that. We talked about tooltip assistance in a previous movie, but this controls those tooltips that appear on screen, whether they show just a brief amount of information, whether they show a detailed tooltip, or whether they do both. The default normal behavior is what we've witnessed, where it shows the short tooltip first, and then after a brief pause, it shows the more detailed one. But if you prefer the minimal all the time or the high all the time, you can choose that. Let me go to the graphics tab next. Now, depending on your graphic card and the settings and your hardware and so forth, you may see a message here that's asking you to get more information about your hardware. Talk it over with your IT people and see whether there's anything to be concerned about there. I will point out, however, here in the graphics mode, that there's this option here called Use Hardware Acceleration. Now, normally that's a good thing because it can help speed things up, especially in detailed 3D views. However, if you're noticing any kind of odd behavior on screen, if things are displaying kind of weird, or you seem to see visual artifacts on screen, usually the hardware acceleration is the culprit. You can customize colors if you want to change your user interface. I'm going to leave all of these set to the defaults. One last place that I'm going to look at here is on file locations. In the background, I have the recent file screen open, and we talked about in a previous movie the different default templates that are listed here. Those are all located here. If you want, you can use this icon here to add values to that list, or this one to remove values from that list. So if I had no interest in the mechanical template, I could remove it from the list. If I wanted to add an Office standard template, I could add it to the list. And what will happen is it will customize this list that you see back here and put those templates that you want to use readily available to the users when they access the system. When you've got all of the options set to your liking, you rarely will have to come back in this dialog again. This is largely a set it and forget it kind of situation. And so you set up all the options the way you want. The first time, consult your CAD and BIM manager if you have any questions. And then for the most part, you really don't have to come back here again unless something changes that warrants it. In this movie, I want to talk about using Revit template files to create your project file. Now, you're probably ready to get started and actually start creating an actual Revit project. And I should point out that Revit projects are contained in a single project file. That file is often based on a template. Now, there's some sample templates that come with the software, and these might vary depending on your jurisdiction, what country you're in, what options you've installed. And so the ones that I'm going to show you are just examples. I'm working with the default United States version of Revit, and so mine has installed both Imperial and Metric templates. I'm going to show you an example of each one. Now, you can access template files in a couple different ways. We can certainly get there using the application menu, the new command, and choose new project. That will display the new project dialog. Also, if you happen to be looking at the recent file screen, then everything that you can do on the application menu is also reiterated right here under projects. And we talked about this in a previous movie. So this new link right here would open the same dialog, and then there's a few template files listed here, which if you watch the movie on configuring your options, you know you can actually customize that list and point to any template files that you use frequently. That same list will appear right here on this small dropdown. So any template that you use on a regular basis, you really ought to add to that list. Now, what I'm going to start with is the default metric template. Now, in the US installation, I actually had to add that to my list. If you don't see that on your dropdown, you can click the browse button here and you can locate that file. Now, I've got a folder here called US metric, and you can see that there's several different metric templates available in here, and that's just the default metric one that I'm opening right now. So when I click OK, it will create a new project file based on that default metric template. Now, this is a really simple template. It's just basically a no frills, just get me started in Revit kind of template. So when you look over here in the project browser, it's got some floor plans, some ceiling plans, and a few elevations. It doesn't have any legends, any schedules, any sheets, and there are some families available naturally. All Revit projects include some families. This is a really basic starting point. Now, you can start here and you can build any project you like, and we're going to do that in a future movie, taking this file and building up our project file from it. But let me contrast this to a couple other example template files. Now, some of the template files I'm going to show you are going to be metric units, some are imperial. So I'm not really too concerned about the units per se. I'm more concerned with the actual features that you can include in a template. For example, you can add other views to your template. You can add schedules and legends to your template. You can even add default sheets. So let's look at some of those examples. I'm going to go to the application menu, go to new, and choose project again. I'm going to click browse, and I'm in the US Imperial folder right now, but I'm going to step back one step here, go to US metric, and let's open up this one here, this construction default metric. Now, if you don't have access to this file, you can watch what I'm doing here or follow along with a different file. Let me go ahead and click open, and then OK. Now, the on-screen view looks pretty much the same, but if you look over at the project browser, what you're now going to notice is there's a couple more floor plan views available. And the reason for that is if I open up one of the elevations, you can see that there's more levels available in this project. So there's a level for the bottom of the footing and for the top of the footing and the slab, level 1 and level 2. If I switch back to my default project, the one that only had the few floor plans, you can see that that one only had level 1 and level 2. So that's the difference, is that that other project started with more levels. Now we're going to talk about adding levels in a future movie. So for right now, I'm not going to worry too much about how those levels got there. Now, back over here in this project, another thing that makes this one slightly unique is that notice that there's a plus sign next to schedules and quantities. So if I expand that, what you're going to see is there's lots of schedules that are already available here on this list. So for example, there's one here called door quantities. I'm going to open that up. Now that displays an empty schedule. So you say, well, that's not very exciting. Okay, so let's go ahead and add a couple doors to this project so we can start to see how the schedule behaves. So I'm going to come up here to the floor plans, open up the level 1 floor plan, and you can't just add a door. You have to first add a wall. So let me go ahead and click the wall command. I'll just draw a little segment of wall here. Click my modify tool to cancel. Then I'll go to the door command, and you can place 2 or 3 or 4 doors. It doesn't really matter how many. It doesn't really matter where you place them. But notice that you can't place a door in empty space. It has to be hosted to a wall, and we'll talk more about that in the future. Let me zoom in with my wheel. And I'm going to go ahead and select the first door here, scroll down, that's door number 1, this one's door number 2, and that one is door number 3. Okay, so we've just placed 3 very simple doors. Now, if I scroll back down and reopen my door quantity schedule, you'll now see that there's a line item here in the schedule. And instead of showing 3 separate lines, what you're going to see here is there's a quantity of 3 in the count column. So the reason it's showing that is because all 3 of those doors were the same kind of door. And so this schedule is concerned with how many of each kind of door you have. So if I went back to level 1 floor plan and I took one of these doors and I changed it to some other type of door, and then we return to that schedule, you'll see I just get 2 line items. I have one of the one type and one of another type. And again, the specifics of the types you choose isn't really that important. It's just understanding what's different about this particular template. So the real important aspect of this template, and we've only looked at one, but there are all these different schedules which are designed to immediately give you quantities and information about your model as you're building it. So as you add walls, as you add doors, as you add other geometry, those items will automatically be populating these various schedules, giving us very useful information. Now, there are other templates available. So I'm going to make another new project. I'm going to click browse again. And this time I'm going to look at one that's here in the US Imperial folder. And again, the units aren't important to our discussion right now. So I'm just going to go ahead and open that up and click OK. This is the commercial default. And what I want to point out here is what's slightly different is these are the elevation symbols. You can see that's the west elevation, but it's got the number 2 here in A5. And if I zoom back out, and over here, this one has number 1, elevation south, in A4. So what is that referring to? Well, here are my 4 elevations, east, north, south, and west. But if I scroll down a little bit further, you'll notice that there are several sheets that are already available in this template. Right here, we can see that there's an A4 sheet for elevations that has the north and south elevation. And right here is an A5 that has the east and west elevation. And what that means is if you actually open one of these sheets, like the A4 elevations, you can see that both of those views are already displayed here on the sheet. Now, in order to see something happen there, we would go back to our level 1, for example. Let me just zoom out just a touch. And as long as I build my model in the middle of those 4 elevation symbols, it will automatically show up on that sheet in each of those elevations. So I'm going to click over here on my wall tool. And again, the specifics of the wall tool will be coming in a future movie. But let me just go ahead and click the rectangle icon here and just make a random rectangle, cancel out of the command, and I'll add a door here in the south elevation. I'm doing that just for orientation purposes. Let's go back to the sheets branch now, and I'm going to open up the A4 elevations again, and notice that that wall shows here the north elevation without a door, and then here the south elevation with the door displaying right there. So one of the advantages of setting up a template that has pre-built schedules or pre-built sheets is that you can have your project team just get started right away and start drawing, and as long as they draw right in that central area of the screen, they're already creating elements that are going to show up on views, going to show up on sheets, going to show up in schedules, and the team is able to get useful information and feedback from their project right away without having to do an enormous amount of setup. Now, a template can't solve all setup tasks. There will always be some setup that you have to do, but it can certainly shorten some of that. Now, later in this chapter, we're going to create a brand new project from scratch that's going to become a project that we're going to work with throughout the remainder of the course. We're going to do a lot of the setup in that project on our own. However, if you start with a template but as you saw here, we can shorthand some of that setup. And that's largely what's going to happen in the experience you're going to have in most of your work working in your firm, because most likely your firm has an office standard template. But by going through this movie and going through the other movies in this chapter, you can see what happens when you do it either way, either starting from scratch or starting with the template, and you can kind of compare and contrast the two experiences. But starting with the template is a highly recommended way to get started with a Revit project because it definitely helps you shorthand a lot of that setup right from the beginning. In this movie, I want to take a moment to talk about how you access a file in a multi-user environment. I'm going to just do a really quick example here just to kind of give you the process. And the main reason I'm doing it is because in most of your firms, you're going to be accessing files this way. However, for the remainder of the course, we won't be accessing files this way. Let me explain. When you want to work with multiple users in the same Revit project, we create what we call a central file. That central file is usually stored on a network server of some kind, and it's set up by either your CAD or BIM manager or some other model manager person in your office. That central file is not accessed directly by any of the users. What we do instead is we click on the central file and we create what we call a local copy. That local copy gets stored on our own local hard drive. We make our changes, and then every so often we synchronize with the central file to make updates, and then our coworkers do the same thing, and then we all get to see each other's changes. So it's a fairly powerful feature and allows multiple users to access the file at the same time, but it's very difficult for me to provide you an exercise file to work with for that. So in this movie, I'd like you to just watch and kind of understand the process and then just keep in the back of your mind that when you work in Revit in a team environment, that this is the way that you're going to need to access the files. But for the remainder of the course, you'll be able to just go right to open and click directly on a file without having to follow these steps. So let's pretend we're in an office environment. I've set up sort of a dummy network here on my system in order to simulate the process. And then we go to the open link just like we would for any project, but the difference is going to be here. I browsed out to this folder that I called My Office Network. So this would be some drive letter on your network, and you might have to log in with a password or whatever. Once you get there, when you select a central file, what'll happen is down at the bottom of the screen, you'll see a little work sharing area. And there's two options that you have available to you when you're accessing a work share project. You can either detach it from the central file, which actually turns it into a standalone project and completely severs its link to the central. Do that with caution, because if you actually do that, there's no way to put it back again. That's good if you want to basically open read only. But if you're intending to actually work on the project and save your changes, you don't want to do that. What you do instead is make sure that create new local is checked. Now, most of the time, that's what you're going to do is have that create new local button checked there. And then when I click open, what's going to happen is instead of actually opening Workshare, what it's going to do instead is create a local copy of Workshare. Now, while this is opening, if you look at the top right corner of my screen, you can actually see my Revit username right here. This is how I'm logged into Revit. So if you look here at the name of the file that Revit created, and let's just take this thing here and drop it down so we can see it a little bit better. Notice that it actually created a file called Workshare_, and then it added my username there. So that's what we mean by a local copy. So now at this point, this copy belongs only to me, and I would make my changes and perform whatever actions I want to perform. And then when I'm ready, I use this button up here, synchronize with central, and I can check whatever options that I want to check right here. And then when I'm done, I click OK. That will make my changes and synchronize them with the central file. And then if my coworkers have made any changes, I'll actually see my screen change, and I'll capture those changes that my coworkers have made as well. So other than that difference, everything that I show you here throughout the remainder of the course would be the same as it is in a standalone project or in a Workshare project. But when you open files and save files, it is slightly different. So I just wanted to point that out to you and make sure you're aware of what some of those differences are. And certainly if you're working in a team environment like that, you most likely have support personnel there that can help you with some of the more specifics. In this movie, we're going to create a new project and configure some of its basic settings, and then this project will become the basis for one of the buildings that we'll use throughout the course. Now, I'm going to use the default metric template that ships with the United States version of Revit. You might have different templates available depending on what country you're in. So if you don't have access to this default metric template that I'm going to be using here, I provided a copy with it that you can use with the exercise files instead. Now, I've created a link to that template right here called default metric. Now, just to remind you of where that is, if I go to the application menu and I go to options, in an earlier movie, we saw that we could do file locations, and I clicked the plus sign here and I added this default metric template and pointed to the folder where that exists. So I'm going to go ahead and click that link right now, and that's going to create a new empty copy of that project. Now, if you don't have access to it on your recent file screen or you haven't added that link to it, you can go to the big R, you can go to new, choose project, you can click browse here, and you can browse to the location where that template lives. And you can see here's where it is in my default installation, or as I say, I've provided a copy of it with the exercise files that you can access. Now, you'll notice at the top of the screen that the file is called project 1. So in a little while, we're going to save this project and it will actually change the name to whatever we decide to call it. Now, there's a variety of things that you might want to configure when first getting started in your project. Certainly, there's many eligible candidates. We could look at the views that are on the project browser. We could look at some of the global overall settings. That's where I'd like to focus right now. So over here on the Manage tab, there are lots of settings that are available in all projects. And many of these you're going to kind of set up one time and just sort of forget about for the life of the project. So one of the first things you might want to look at is the project information. So if I click this button right here, this will display a dialog with the project properties. And there's all sorts of little bits of information that you can fill in here. Now, don't feel like it's necessary to fill in absolutely everything here. Just fill in the things that you think would be good candidates to have in the project early on. So like, for example, you might know what the expected issue date is of the project. So I'm going to put in a date later this summer. You might want to put in the status of the project, maybe the client's name. For the project address, you can start typing it here, or there's a small little browse button which would open up a larger dialog where you could input the full project address, give your project a name. Now, I should point out that this name is not the same as the name up there. It's still going to be called project 1, so we're going to need to save as and actually give a name that either matches this one or something similar. And then finally, we can put in a project number and click OK. Now, most of that information is just there for reference to give the project some overall context, but several of those fields will actually show up in title blocks when you create sheets for your project. So for example, if I scroll down here in the project browser, right-click the Sheets branch and create a new sheet, I'm just going to accept the defaults here and click OK. If I zoom in, you can see that my client name, my project name, my issue date, those have all filled in directly in this title block. I'm going to come over here and return back to my level 1 floor plan. Now, there's other settings that you might want to consider, or at least check before you get started. One is the project units. Now, because we're working in a metric project here, it's going to default to millimeters, but perhaps you work in centimeters, perhaps you work in meters. Okay, so what you can do here is click this button next to the length unit, and you can actually choose whatever default unit you want to use for this project. You can also set the number of decimal places. Now, for now, I'm going to leave mine at the default, which is millimeters, and I'm going to let it round off to 0 decimal places. So I'm only going to use whole units. But if you want to do 1 decimal place or 2 decimal places to get a little bit more precise, you are welcome to do that. There are units for all the different types of measuring systems. So we have area and volume and so on. And I'm not going to change any of those right now, but I do want to point out this dialog to you so that if you have other preferences, you can certainly get those set right away before you get too far into your project. Another thing that you might want to look at is where the project's actually located in the real world. Now, in the project address, I filled in an address, but that doesn't actually change the location of the project. That's just for the title block. If you actually want to change the location of the project, you come over here to this project location panel and use this button right here, the location button, and that will display this dialog right here. Now, it's kind of small when it first opens. So what I'm going to do is move it here on screen and stretch it out a little bit just so that we can see it a little bit larger. And notice that the default location is here in Boston. The team that builds the Revit product for Autodesk is actually located in the Boston area, and so that's just the default in the templates to ship with the product. But you could certainly put in whatever address you want, and this can actually be a mailing address, or it can be a more generic location like I'm doing. I'm just putting in the city and state. Whatever you put in, it will use the map here and it will browse directly to that location. Now you'll see that it took me to kind of downtown Boulder, and I've got this little icon here that represents it, and it actually filled in the longitude and latitude. Now you can be as precise with this as you want. You can even drag this little icon around to another location, or as I say, you could type in a very precise project address. Now we don't have to be super precise, because the main reason of doing this is to get the weather stations correct, as you see over here, or to get the shadows and the sun correct. So if you're planning on doing green building analysis or shadow studies, then you want to at least be in the correct geographic area. That's what setting this dialog up will do for you. So I'll go ahead and click OK here with that set to the general Boulder area. So there's certainly other settings that you can configure, and you're welcome to explore and look around and see what some of those are. But for now, I'm going to kind of leave it there, and I'm going to go ahead and save the file. So again, reminding you that currently the file is called Project 1, and that's not a really great name. So I'm going to come up here to the application menu, the big R, and I'm going to come down to save. Now, because I've never actually saved this project, it will actually display the save as dialog. And what I'm going to need to do is I'll go to my desktop in my exercise files folder and decide where I want to put this file. Now I'm going to give it a name that matches the project name that we gave it in the project information, but you certainly could choose a different name if you wanted to. And then I want to click over here on this options button and configure a few options here. At the top, we've got maximum backups, and it's currently set to 20, which seems a bit excessive to me. A more reasonable default might be 3 or 2 even. What this does is every time you save the file, it'll actually keep however many backups you list here, that many copies of the file as a backup. And then if something goes wrong, you always have those files that you can open up to try and restore your work. So when I click OK here, let me show you how this is going to work. I'm going to save it. You'll see the Office Park name there replaces Project 1. And now let's say that I went to the Save As command here, and I just want to show you this just so you can see there's my Office Park file, right? Let me cancel that. Now I'm going to click the Save icon here. And this time it doesn't display a dialog, it just simply saves the file in its current state. Well, now if I choose Save As again, what you're going to see is there's actually 2 versions of the file. This is my current version of the file called Office Park, but the one that's labeled .0001, that's the first backup. And then if I save again, I'll get 02 and then 03. And then when it gets to 4, because I capped it 3 backups, it'll throw away 1 and it'll create 4. So I'll have 2, 3, and 4, and so on. So it'll always throw away the oldest version, and it will continue to create those incremented backups. And that can be really helpful if something crashes on your system and you're in danger of losing work. You can always restore one of those backups. And to restore them is as simple as just opening the file and doing a Save As, and you're back in business at whatever state that backup was in. And this piggybacks on that recommendation I made to you in an earlier movie about the save reminder. If you're letting it save backups for you, and if you're in the habit of always clicking save when the save reminder appears, both of those things are designed to help protect you in your work, so that if you do crash, you don't lose everything. You only lose maybe 10 or 20 minutes worth of work. So I highly recommend that you have some backups, and I highly recommend that you're saving often. So that gets us started. We've got our basic project in place. We started from a basic template and we've configured a few of the settings. And in the next few movies, we'll go ahead and continue setting up our project, adding levels, adding grids, and other things that will give our project context. Levels are one of the primary organizational and structural constructs in your Revit projects. They help determine where all the important heights are in your building. They can be in the positive or the negative direction, and they determine the important values in that Z direction. So it's very common to have a level at each story of the building. So I always tell people if there's a button on your elevator, you ought to have a level there. We can also use levels for other purposes as well, just any important Z height that you want to establish in your building, whether it's the bottom of your foundation or the top of an eave condition or a parapet height or something like that. So in this movie, we're going to go ahead and set up the levels in our project. I'm in a simple file that's based on the default metric template, and you can't actually work with the levels in a floor plan view. You have to actually go to a vertical view like an elevation or a section. So our default template included several elevation views, and I'm going to open up one of those. I'm going to open up the south elevation. And what you'll see is in this default template, there's simply 2 levels. There's a level 1 at 0 and a level 2 at 4,000 millimeters. When we click on either one of these levels, there's going to be a variety of small handles and controls that appear on both ends of the level. So let's look at a few of those first before we start adding and manipulating any of these levels. There's a little open circle at each end of the level. If you drag with that open circle, it will actually change the extent of the level. Now notice that it also changes the extent of the other levels as well, and that's indicated by this small lock icon right here. That lock icon actually locks the 2 endpoints together, so if I drag one, they all drag together. Now in a really tall building where you have lots of levels, that's going to be really handy in helping you keep all of the levels neat and organized and lined up with one another. There's also a little check box over here, which is currently unchecked, versus the one on the right-hand side, which is checked. If you check the box, it displays the level annotation with its name and its height, and if you uncheck the box, it will hide that annotation. There's also a small little squiggle grip right here, which allows you to add an elbow, and that will actually shift the annotation away from the height of the level. Now in this case, I'm going to just drag this back up to parallel, and it will remove that elbow, but in a few moments we'll see an example where that could come in handy. So those are the different controls that we have. Now it's also possible to change the height of an existing level. This is going to be the first floor of my building. It's going to be a 2-story building, so I do want to keep level 1 and level 2, but my level 2 is currently a little bit taller than I'd like it to be. So instead of 4,000 millimeters, I'm going to change that to 3,000. Now I could do that with the dimension right here, or with the value right here. You just simply click on the number and then type in the value you want. So I'll type in 3,000, and notice that that moves the level down. So now I've taken the 2 existing levels and configured those the way I want. Now it's time to add some additional levels. I'm going to actually add several. I'm going to add a level below level 1 that's going to represent the grade that the building sits on, and then I'm going to add 2 roof levels, a low roof and a high roof, because our building is actually going to have 2 roof conditions. So to do that, we're going to go to the architecture tab, and here on the data panel, I'm going to click the level button. Now the keyboard shortcut for level is LL. So if you prefer, you can use that instead. Now, if I accept all the defaults, what you'll notice is I'm in this kind of draw mode, and when we look at the draw panel, it's an icon that lets me draw as a line. So basically, if I click 2 points on screen, it would create a level at whatever height that I first clicked. Notice that the level is always going to be parallel to the other. So levels have to be parallel to the ground plane. They're always in the Z direction, so you can't draw a level at an angle. If you look carefully at the level head on the right-hand side, you'll notice that it's currently black. Now compare that to the 2 level heads that were already here, which are currently blue. Now we talked about this in a previous movie, that blue color kind of indicates that that's an interactive feature, that we can actually use that level head to access the floor plan that's associated with those levels. Notice that if I come over here and I click the modify tool or press double escape to cancel out of the command, it actually turns that level head blue as well. So the default behavior of the levels is to create floor plans that go along with the levels. Now, if we look at my project browser, you're going to notice that because of my version of Revit, I'm in the full suite version of Revit, I got actually 3 new floor plans. I got a level 3 floor plan here, a level 3 ceiling plan here, and I actually got a level 3 structural plan. Now, you're not required to have all 3 of these plans. You can add and remove floor plans anytime that you like. But I just wanted to point out that the default behavior is giving me all 3. Now, you can easily remove ones you don't want by just simply selecting and pressing the delete key. Now, in this case, if I delete the structural plan, it would actually remove that category as well, because that was the last plan in that category, or the last plan in that branch of the browser. So all of these branches of the browsers actually react to the views that are within them, and if you delete all of the views, then the branch goes away as well. Now, the other thing is, I kind of place this somewhat randomly. If I want to make it line up with the others, all I have to do is click these grips and drag them at the end, and notice what happens. The minute I snap it to the endpoint of the others, it automatically locks, and now these would all stretch together again. And I could do the same thing on this end, drag it till it snaps, they would lock together, and now all of these ends are locked together. And like we did a moment ago, I can actually change the height as well. Now my low roof is actually going to be at 3,800 millimeters, so I'm going to move it down there. Now notice when I do that, it gets awfully close to and is partially covering up level 2. So what I can actually do now is I can click on level 2, there's that little squiggly grip there, I can click it, and then use these control grips here to adjust that so it's more legible. Notice that the level line is still at 3,000, I've just created a jog there to move the annotation out of the way so that it's more legible. Now the last thing that I want to do with this level is I'm going to select it, and then click right on its name. So just like I was able to edit the height of the level by clicking on the temporary dimension, I'm able to change the name in the same way, and I can type in the name that I want this to have. Now when I press enter on my keyboard, watch what's going to happen. It's going to display a dialog asking me if it's okay to also rename the corresponding views. Now I pointed those out to you a moment ago over here. We have a level 3 view on the floor plan, and we have a level 3 view for the ceiling plan. So if I answer yes here, both of those level 3 views change to below roof. And at this point I look at that and I say, well, it would be kind of silly to actually have a ceiling plan for the roof, so I probably want to delete that and just keep the 2 default ceiling plans, level 1 and level 2. Now let's repeat the process, but this time I want to show you how you can determine ahead of time which floor plans it's going to create. So I'm going to go back to level, and notice here on the options bar there's a checkbox that says make plan view, and then right next to that there's this button that says plan view types. And if I click that, you're going to see all 3 plan view types are highlighted, and this is why I got all 3. So if I actually click on ceiling plan and click on structural plan, it will deselect those 2, and now when I click OK here and draw my next level, it will only create a floor plan, which is probably more appropriate for the high roof. We don't really need a ceiling plan or a structural plan for that at the moment. So I'm going to come over here, and you can actually get this thing to line up before you click, and it will save you the step of having to snap it later. So you can also follow the temporary dimensions here, and if you use them, you can actually get it set to the correct height ahead of time if you like. I'm going to start it right about 2,200 millimeters, and I'm going to pull this across until it snaps at both ends, and you can see that creates that new level at 6,000. Then I'm going to click right on the name, type in high roof, press enter, and again, when it asks me if I want to rename, I'll click yes, and this time because there was only one view, it only renamed the high roof view. Now, one last thing I want to point out is you don't have to click point to point. You can actually use this tool here instead, this pick lines tool, and I actually like doing it this way. So I'm going to come over here and I'm going to put in 150 millimeters in the offset field on the options bar. Now, when you use the pick option, it's usually a pretty good idea to do that in conjunction with an offset. I want to click my plan view types and make sure that floor plan is still selected. It will remember, but I just want to verify that. Then I'm going to come over here and highlight level 1. Now, if you can't see what's going on, go ahead and roll the wheel in a little bit so you can get a little closer. And you see how if you move slightly, you can get that dashed line to go either above or below level 1. When it's below level 1, I want to click. And the way the pick lines work is it will create an offset copy of that level at whatever distance away you set in the offset field here. I'm going to come over here to the modify tool and click it to cancel out the command. I'll select this new level 5, add an elbow, come over here and drag these until they snap to the one up above, click right on the name, and call that grade. When I get the message, I'll go ahead and rename the corresponding view and accept that. Now, if it turns out that you don't actually need a grade level floor plan, you could actually delete it, and notice that the symbol will turn black here to indicate that there's no longer an associated floor plan. This level is now simply just a datum. So that's entirely up to you whether you want to have a floor plan there or not. It's not required to have any floor plans for levels at all. So the main purpose of the levels is they establish those Z heights in your building. You need to create them in either an elevation or a section view, but you can manipulate the different heights of each of the levels. You can change their names. They can even have corresponding floor plans, which you can access from those levels and rename along with them. The levels are one of the primary datum elements within your project and one of the first things you're going to want to set up when you get started on a new project. Like levels, grids provide organization and structure to your projects. Grids serve to locate the structural columns in your project and provide key points of reference for views and sheets alike. Unlike levels, not all buildings need grids. For example, most residential projects would not have a need for grids. However, most commercial buildings do have a need for column grids. Therefore, the kind of project you're creating will often dictate the need for grids. Now, you don't have to create the grids right away, but it's a pretty good idea to create them early in the project just to help establish that form and structure. And there's a lot of similarities between creating grids and creating levels. So I'm going to go to the architecture tab, and I'm working currently in a level 1 floor plan. And over here on the datum panel, you'll see the grid button. I'll click that, and like levels before, there are some different shapes that we can use. Unlike levels, we can actually draw grids as curves in addition to straight lines. Now, for this first example, I'm going to just start with a straight line, and I'm actually going to start out here on the outside of the building off to the left. So I'm just going to click a point down here below the building, and notice that you can draw this at any angle you like, but I'm going to pull it straight up, make sure that the angle says 90 degrees vertical, and then I'm going to click again to create that grid. Now, rolling my wheel, I'll zoom in a little bit, and I want to point out that there is no bubble at the first point that I clicked. The bubble appears at the second point. So if you know that going in, then you can plan your clicks accordingly so that you get the bubbles on the side of the plan that you want them in. Now, if you don't think of that ahead of time, it's not a big deal, because as we talked about when we were discussing levels, there's this little check mark right here where you can uncheck to remove a bubble or check it to add a bubble. So you can always reverse the annotation at either end if you wanted to. Now, let me cancel out of the command for a moment, zoom in, and notice that this grid came in as grid number 1. And what I want to do is show you the way that Revit numbers grids. What I'm going to do is I'm actually going to delete this grid. I'm going to zoom back out, and I'm going to add a new grid here. So back on the datum panel, I'm going to click grid, and I want to make sure that I'm not lining up directly with this wall. I want to come in just to the inside of this wall a little bit below the building, click my first point, and then pull it straight up, make sure it's going parallel, and then click again. And notice that if you zoom in here, that grid came in as number 2, even though I deleted grid number 1. Revit remembers the previous number that you left off with, and it will just continue from that point on. So if you don't notice this and you start adding a bunch of grids, you might be in a situation where you have to go back later and renumber all those grids. Now, it's possible to renumber a grid anytime you like, but you can't have 2 grids that have the same number. So keep that in mind, that it might actually be a decent amount of work to renumber them later. So a much better solution is to pause before you do anything else, come over here and click right on the value, number 2 in this case. That will make it editable text and change it to what you want it to be. Now, if I wanted numbered grids in this direction, I might choose 1. If I want lettered grids, I might type letter A. So I'm going to put in capital A here, press enter, and now that becomes grid bubble A. I'll zoom back out, come down here below the building, make sure it's lining up with the first grid, but inside the exterior wall, pull it straight up until it snaps again, and that will create the second grid. Let me do it again over here. And notice that I now get A, B, and C. I'm going to make a couple more. Here's D, and here's E. Now, don't worry too much about the exact locations of these grids yet. We're going to fine tune all those positions in the next movie. What I want to do right now is just focus on the mechanics of building the grids. Now, that gives me the lettered grids, and then I'm going to come down here, and I'm going to create my horizontal grid running this way, and notice that it continues where we left off in the other direction. So Revit won't assume that just because you change direction, you want to change your numbering. So once again, it's up to you to notice that and come in here and change back to numbers if in fact that's what you want in this case. So I'm going to set that one back to number 1, add in grid number 2, again being careful to keep it parallel, zoom out a touch, I'll add grid 3, and then finally grid 4. Now, I've deliberately snapped them all at this end. I'm I'm going to click the modify tool to cancel out of the command. I'm going to select any one of these grids, and because they're all snapped together at this end, I can move any one of them and they'll all move together. We saw the same thing when we did levels in the previous movie. On this side, only these two are snapped together. So I could certainly manipulate those two, but it wouldn't affect grids 3 or 4. Now, if you want them to work together, you just simply need to stretch it until it snaps and attaches itself to the other one, and then they'll lock together, and then those two will move together. If for some reason you didn't want that behavior, simply unclick the lock here, and then you can drag it freely. So it's entirely up to you which behavior you want, but whenever you snap them together, they will always relock themselves. Now, if I go back to the grid tool on the architecture tab, I mentioned that we could do curved grids. So that's an option. So in some complex buildings, you might need to do that. And you can also do multi-segment grids. Now, multi-segment grids puts us in a special mode called sketch mode. Now, we're going to discuss sketch mode in great detail in a future movie, but basically the way this works is you just sort of sketch out different segments to create a custom shaped grid. And then to cancel the command to finish the mode, you click this big green checkbox right here, and that finishes the mode. And notice that this grid 6 here now has this irregular shape to it. So if you have a complex building that requires either curved or multi-segment grids, you can do both of those things and just create them however you want. In this case, I'm actually going to click on grid 5, hold the control key, click on grid 6, and I'm going to delete those two because they're not necessary for this building. Now, the last thing I want to point out is that all datum elements, and in this case, we've seen levels in the previous movie and grids in this movie, they behave in the same fashion in that they will only display in orthographic views, and they will only display when they're perpendicular to the viewing plane. So right now we're seeing the grids because we're drawing them perpendicular to this floor plan view. But notice that if you open up one of the elevations, I'm going to open the south elevation, that the lettered grids are displaying here as well. So what this tells us is that these things are actually more like a plane. So if you think of a really thin sheet of paper cutting through your building at the location of grid C, we're seeing the top edge of that sheet of paper in floor plan, and we're seeing the front edge of that sheet of paper here in the elevation. And the same would be true if you went to an east or west elevation. Now you'd be seeing the numbered grids, and you'd be seeing the edges of those planes. And notice that the levels are showing in any elevation, but when we go back to a floor plan, we don't see the levels because we're now looking right down on those levels, which is the same thing we saw a moment ago when we were here in the east elevation. We didn't see the lettered grids because we were looking right at their plane. You only see them when they're perpendicular to the viewing angle. So that's an important consideration to keep in mind. So laying out your grids is a useful early step to do early on in the project to establish the locations of where all your columns will be. You can fine-tune the positions of them anytime and make adjustments anytime. And in the next movie, we're going to look at fine-tuning the positions of those grids very precisely relative to the building geometry. But once you've established your datum elements, that's going to give form and structure to the building ongoing as you continue working on the project model. In the previous movie, we laid out grids in very general locations on screen, but naturally these positions are not very precise with respect to the overall building geometry. So a really important consideration when you're working in a project is getting things placed very precisely. There's a variety of ways you can do that in a Revit project, but one of the most common ways to do that is what I call sketch then modify. In other words, we do what we did in the previous movie where we lay things out in a very general position first, just to kind of get something on screen, and then we come back and using a variety of tools that are available to us, we can modify those positions to something very precise. So I'm going to demonstrate that here with the grids on screen and move those grids relative to the existing wall geometry. So let's start with grid line A. I'm going to select it here on screen. And we've already talked about a number of the grips and control handles that appear, such as the open circles and the locks and so forth. But notice that in addition to that, down toward the bottom of the screen, we see a couple dimensions that appear. Now I'm going to come over here to the view control bar. I'm going to click zoom in region, and I'm going to zoom in on this bottom portion of the plan. Now notice that the two dimensions that appear are measured from the inside faces of the walls to the grid line. So if we knew this distance here, we could modify this one. And if we knew this distance here, we could modify that one. Now I want this grid to appear at 50 millimeters off the inside face of the wall. In order to do that, you just simply click right on that dimension value. This is called a temporary dimension, and type in the value you want. So I'll type 50 for 50, press enter, and notice that that will move the grid line closer to the wall, and it's now at exactly 50 millimeters away from that inside face. Now if I select grid 2, it will display its own temporary dimensions, and I could repeat that step by putting in 50 over here as well. So where I previously had two grids that were placed in a very random location, now they're very precise with respect to the overall building geometry. I probably want grid line 1 to also be 50 millimeters off the inside face. Now before I do that, I'm going to go ahead and click it, but before I edit that dimension value, let me point out one other thing about these temporary dimensions. Notice that there's these two tiny little dots appearing on either side of the dimension. Those are the witness line grip controls. Now the witness line can actually be located in a variety of locations. Now when we're talking about a wall, that could be either at the face of the wall or in the center. Now to change the location of that witness line, you can either simply click the witness line grip, and notice that it will jump to one of those other faces. If I click it again, it will now jump to the center. Click it one more time, it would jump back to the inside face. The other method is to grab it and drag it to the point that you want. So either one would work just fine. Now, of course, if I really was measuring it to this outside face, I'd now have to do the math here to determine exactly how far that distance ought to be. Now, if I hover over this wall, I see that it's a 300 millimeter wall. So if I wanted that 50 millimeters from the inside face, that means that this distance would have to be 350 millimeters. Now, it's probably easier to measure it from the inside face, so moving the witness lines was probably not the best way to do it in that case, but it's important to show you that technique because in some cases you may need to do that. For example, if I zoom back out here, let's say that I wanted to measure grid line C off of grid line B. Well, to do that, if I select, notice that it's not actually displaying those witness line locations measured from B, it's actually measuring them relative to the nearby wall. Well, that means that I would have to grab this grip like I just showed you and drag it, and when it snaps to grid line B, I can let go, and then I would be able to input a value right here. Now, I actually am rethinking that, and I'd rather go 50 millimeters off of this wall right there, but maybe I want to use that technique to move grid line D. And so you can use the same techniques in different cases, regardless of which one you're manipulating. In this case, I'll go with 9500, and you can see now that I've moved grid line D relative to grid line C instead of having to do the math relative to the wall. So you can use whichever technique gets you in the position that you need it to be. Let's just go ahead and finish up a couple of these. And this final one, I'll measure off of grid line 2, like so. Now keep in mind that you've got two dimensions on either side. So sometimes folks make this error. If I now wanted to change the distance between grid line 3 and 4, and I do something like this, and I change this, notice what's going to happen. It wasn't grid line 4 that moved, it was grid line 3 again. So I'm going to do Control Z to undo that. Always keep in mind that when you're manipulating temporary dimensions, whatever you have selected is the item that's going to move. So in this case, because grid line 3 is selected, if I edit either of these dimensions, it will move either up or down depending on what number I put in. If it's grid line 4 that I want to move relative to 3, then I need to select 4 first, adjust the position of the dimension, and then input my value. Now in this case, I don't actually want to move it, but it's important to keep that in mind. So temporary dimensions are a very powerful way for you to take what's a very rough layout, almost like a virtual napkin sketch in your Revit model, and fine-tune the positions and make them very, very precise. The basic process is you sketch out a layout, and then you come back and use the temporary dimensions and make it very precise. this movie, we'll add some columns to our building layout. Revit has two different kinds of columns that we can use. There's architectural columns and there are structural columns, and we'll look at both of them in this movie. An architectural column is sort of a simple version of a column. You can use either or in your projects, but I actually like to use both. I like to use the architectural columns as the column enclosure, sort of the finished material like the drywall or whatever else might be wrapping around the structure. And then of course I use the structural column for the actual structural material, the steel or the concrete that's actually holding up the building. So I'm going to start with the architectural columns. Now both of them can be accessed from this drop-down button right here, and here is my column architectural. So I'll go ahead and choose that. You'll see a small little rectangle appear on my cursor, and that's because we're using the rectangular column family here, and it has three sizes. Now I'm going to choose the largest size, which is a 610mm square column. And you could place it anywhere on screen. So if I just placed it out there in space, I would have a completely freestanding column. But if you actually place the column at one of the intersections of the grids, take a look over at the properties palette and you'll notice that under constraints, there's a setting called moves with grids, and it's checked on right now. Now what that means is when you place these columns at a grid intersection, the position will stay associated with that grid intersection. So let me demonstrate that here. I'm going to click right at this intersection between column line 3.7 and B. I'll click the modify tool to cancel the command, and now I'm going to select column line B. Now if I drag it a little bit, notice that it takes the column with it. And the same would happen if I took 3.7 and moved it, that the column will move with it. So this is a nice handy way to keep all your columns associated with the grids, and if you later move those grids, it will adjust. Now I don't want to keep any of those changes, so I'm going to undo that. Now I could do Control Z a few times, or I could click this button a few times, but if you notice next to the undo button, there's actually a drop-down menu, and it will keep track of all the commands that you've been running throughout this Revit session. So I just did two drag operations and placed a column, and in fact I placed two columns, and I don't really need this one out here, so I'm going to drag through all four of these options and click, and notice that it will undo them all in a single step. Now, when you undo multiple commands, if you go too far, you actually have a drop down on the redo command as well that would allow you to redo the commands that you've undone. Using both undo and redo can be a quick and easy way for you to kind of reverse some of those operations. Now, let me go back to the architectural column command. It should remember that I was using a 610mm square column, and this time I'm going to place it at the intersection between grid lines A and 4. Now, when I click, I'm going to go ahead and do a zoom in window here. Notice that another interesting feature of columns becomes evident. Now, this is a feature of architectural columns. It will actually merge into the surrounding wall geometry. So if I drag over here a little bit and do it again with this intersection, and over here at this intersection, notice that it's merging in with all of these walls. Now, I'm going to go ahead and zoom back out and place the remaining columns just along the perimeter of the building. Now I'm going to skip these internal intersections here because I'm going to put structural columns in those locations. So I'm going to go ahead and click the modify tool here to cancel. So I now have my architectural columns at all of those locations. And again, keep in mind that if you were to move one of these grid lines, it will move all of the columns that are associated with that grid line. I'll do Control Z to undo that. So let's move on to structural columns next. So I'm going to come over here to the drop down and I'm going to choose structural column. Now, it is possible for us to load other families into the project file, so we could load in concrete column families, or we could load in other shapes of steel families. The default template here includes just a single steel shape listed here under universal column. So for this example, I'm just going to use that steel shape that's already loaded in the file because we're going to talk about loading families in a future movie. So this works almost the same way as the architectural column. You could place it freestanding. It also has the moves with grids feature on the properties palette. So if you click on a grid, it will associate with that grid. And then there are several additional settings here that are more structurally related. I want to show you the little gotcha that kind of gets me every time I use structural columns. Without looking at all the settings, I sometimes forget to look, and I'll click a point to locate my column, and then I'll get this warning message that appears down at the bottom of the screen. And it's telling me that none of the elements that I've created are visible in the current view. And you're left kind of wondering why and what happened. Well, let's go ahead and click the modify tool to cancel out of there. And I'm going to open up the south elevation to investigate. And what you'll see is there is my column right there. So when you're working with a structural column, it's following the rules that structural engineers use instead of the rules that architectural engineers use. And typically structural engineers like to start at the top of the building and work down. So because loads go down with gravity. So anyway, the column goes in the negative direction. So in this case, I'm going to actually delete that one. I'll go back to my floor plan. And if you want to think more architecturally about placing these columns, then what you want to do is this. Go to structural column. And again, I'm going to keep the default type here. But notice here on the options bar, you have a choice between either depth or height. So if you don't want to set it relative to depth, you want to choose height. And then in this case, I'll set the height to go up to level 2 and then begin placing my columns. Now, instead of placing the columns individually, I'm actually going to take advantage of a unique feature that structural columns have. If you look at the ribbon, notice that there's a multiple panel and it has two options, at grids and at columns. So the at columns option means that you'll be able to place a structural column at the location of any architectural columns. And that's why I place the architectural columns first. Now what I'm going to do is start over here on the left-hand side of my plan and drag a box selection surrounding my entire floor plan. Now notice when I do that, it's only highlighting the columns because this command has a built-in filter that says place a structural column at each of the locations of the architectural columns. To finish this and accept this operation, I just click this green finish checkbox right here on the ribbon, and that will place a piece of steel at each location of the structural columns. The at grids option is similar, except that it will now place a piece of steel at the intersection of column grids that you select. So I'm going to make a crossing selection this time in this location here, and notice that it will highlight any intersections that occur where I want to place a piece of steel. And once again, if I click the finish button, it will create those pieces of steel at those intersections. Now I'm going to cancel out the command and I'm going to show you one last thing. I'm going to zoom in slightly here, and structural columns obviously have an orientation. Our architectural columns, it didn't matter because they're square. But if I select these columns here, let's say along grid line B, maybe I want those to be oriented the other way. Well, the easiest way to do that in Revit is to simply tap your spacebar, and that will take those objects and it will rotate them 90 degrees, and they're now oriented the other way. So when you're ready to start adding columns in your Revit projects, you have two choices, and you could do only structural columns or you could do only architectural columns. But I like to do both because, as you can see, I think they have unique features and they both serve your model well. So I'm using my structural columns to represent the actual steel that's holding up my building, and I'm using my architectural columns as a column wrap enclosure going around those pieces of steel. This movie will add some columns to our building layout. Revit has two different kinds of columns that we can use. There's architectural columns and there are structural columns, and we'll look at both of them in this movie. An architectural column is sort of a simple version of a column. You can use either or in your projects, but I actually like to use both. I like to use the architectural columns as the column enclosure, sort of the finished material like the drywall or whatever else might be wrapping around the structure. And then of course I use the structural column for the actual structural material, the steel or the concrete that's actually holding up the building. So I'm going to start with the architectural columns. Now both of them can be accessed from this drop-down button right here, and here is my column architectural. So I'll go ahead and choose that. You'll see a small little rectangle appear on my cursor, and that's because we're using the rectangular column family here, and it has three sizes. Now I'm going to choose the largest size, which is a 610mm square column. And you could place it anywhere on screen. So if I just placed it out there in space, I would have a completely freestanding column. But if you actually place the column at one of the intersections of the grids, take a look over at the properties palette and you'll notice that under constraints, there's a setting called moves with grids, and it's checked on right now. Now what that means is when you place these columns at a grid intersection, the position will stay associated with that grid intersection. So let me demonstrate that here. I'm going to click right at this intersection between column line 3.7 and B. I'll click the modify tool to cancel the command, and now I'm going to select column line B. Now, if I drag it a little bit, notice that it takes the column with it. And the same would happen if I took 3.7 and moved it, that the column will move with it. So this is a nice handy way to keep all your columns associated with the grids. And if you later move those grids, it will adjust. Now, I don't want to keep any of those changes, so I'm going to undo that. Now, I could do Control Z a few times, or I could click this button a few times. But if you notice next to the undo button, there's actually a drop-down menu, and it will keep track of all the commands that you've been running throughout this Revit session. So I just did 2 drag operations and placed a column. And in fact, I placed 2 columns, and I don't really need this one out here. So I'm going to drag through all 4 of these options and click, and notice that it will undo them all in a single step. Now, when you undo multiple commands, if you go too far, you actually have a drop down on the redo command as well that would allow you to redo the commands that you've undone. Using both undo and redo can be a quick and easy way for you to kind of reverse some of those operations. Now, let me go back to the architectural column command. It should remember that I was using a 610 millimeter square column, and this time I'm going to place it at the intersection between grid lines A and 4. Now, when I click, I'm going to go ahead and do a zoom in window here. Notice that another interesting feature of columns becomes evident. Now, this is a feature of architectural columns. It will actually merge into the surrounding wall geometry. So if I drag over here a little bit and do it again with this intersection, and over here at this intersection, notice that it's merging in with all of these walls. Now, I'm going to go ahead and zoom back out and place the remaining columns just along the perimeter of the building. Now, I'm going to skip these internal intersections here because I'm going to put structural columns in those locations. So I'm going to go ahead and click the modify tool here to cancel. So I now have my architectural columns in all of those locations. And again, keep in mind that if you were to move one of these grid lines, it will move all of the columns that are associated with that grid line. I'll do Control Z to undo that. So let's move on to structural columns next. So I'm going to come over here to the drop down, and I'm going to choose structural column. Now, it is possible for us to load other families into the project file, so we could load in concrete column families, or we could load in other shapes of steel families. The default template here includes just a single steel shape listed here under universal column. So for this example, I'm just going to use that steel shape that's already loaded in the file because we're going to talk about loading families in a future movie. So this works almost the same way as the architectural column. You could place it freestanding. It also has the moves with grids feature on the properties palette. So if you click on a grid, it will associate with that grid. And then there are several additional settings here that are more structurally related. I want to show you the little gotcha that kind of gets me every time I use structural columns. Without looking at all the settings, I sometimes forget to look, and I'll click a point to locate my column, and then I'll get this warning message that appears down at the bottom of the screen. And it's telling me that none of the elements that I've created are visible in the current view. And you're left kind of wondering why and what happened. Well, let's go ahead and click the modify tool to cancel out of there. And I'm going to open up the south elevation to investigate. And what you'll see is there is my column right there. So when you're working with a structural column, it's following the rules that structural engineers use instead of the rules that architectural engineers use. And typically structural engineers like to start at the top of the building and work down. So because loads go down with gravity. So anyway, the column goes in the negative direction. So in this case, I'm going to actually delete that one. I'll go back to my floor plan. And if you want to think more architecturally about placing these columns, then what you want to do is this. Go to structural column. And again, I'm going to keep the default type here. But notice here on the options bar, you have a choice between either depth or height. So if you don't want to set it relative to depth, you want to choose height. And then in this case, I'll set the height to go up to level 2 and then begin placing my columns. Now, instead of placing the columns individually, I'm actually going to take advantage of a unique feature that structural columns have. If you look at the ribbon, notice that there's a multiple panel and it has 2 options, at grids and at columns. So the at columns option means that you'll be able to place a structural column at the location of any architectural columns. And that's why I place the architectural columns first. Now, what I'm going to do is start over here on the left-hand side of my plan and drag a box selection surrounding my entire floor plan. Now, notice when I do that, it's only highlighting the columns because this command has a built-in filter that says place a structural column at each of the locations of the architectural columns. To finish this and accept this operation, I just click this green finish checkbox right here on the ribbon, and that will place a piece of steel at each location of the structural columns. The at grids option is similar, except that it will now place a piece of steel at the intersection of column grids that you select. So I'm going to make a crossing selection this time in this location here, and notice that it will highlight any intersections that occur where I want to place a piece of steel. And once again, if I click the finish button, it will create those pieces of steel at those intersections. Now I'm going to cancel out the command, and I'm going to show you one last thing. I'm going to zoom in slightly here, and structural columns obviously have an orientation. Our architectural columns, it didn't matter because they're square. But if I select these columns here, let's say along grid line B, maybe I want those to be oriented the other way. Well, the easiest way to do that in Revit is to simply tap your spacebar, and that will take those objects and it will rotate them 90 degrees, and they're now oriented the other way. So when you're ready to start adding columns in your Revit projects, you have 2 choices, and you could do only structural columns or you could do only architectural columns. But I like to do both because, as you can see, I think they have unique features and they both serve your model well. So I'm using my structural columns to represent the actual steel that's holding up my building, and I'm using my architectural columns as a column wrap enclosure going around those pieces of steel. Walls are perhaps the most basic building component in any project. Certainly they'll be one of the first objects you need to master when learning Revit. Walls have many settings that you can configure while you're drawing them and even after they've been created. So in this movie, we're going to look at some of the basic settings of walls and get comfortable with their use. Now I have an empty file open here and it has a few levels in here, and we're going to start off in this first floor level 1 plan and just draw a few basic walls and kind of get comfortable with the command. So on the architecture tab, we have the wall command right here, and I can click it with the icon or I can type WA, which is the keyboard shortcut. Now, sometimes you'll see tooltips that appear on screen, like the one that I see right now says click to enter the start point. After a while, that tooltip will go away, but if you look at the bottom left-hand corner of the screen on the status bar, the tip will remain down there. So those little prompts are going to help you knowing what Revit expects you to do. So naturally, when we draw walls, we're going to need to click a few points on screen. And usually it's just 2 points, like drawing a line. So if I click the first point and then I start to move the mouse, the tip might change depending on what I'm doing next. Now, it favors directional behavior first. So you can see that if I'm moving in a horizontal direction, the prompt actually says that I'm moving horizontally. If I move in a vertical direction, it says that I'm moving vertically. But if I kind of go off angle, then I get a different prompt that tells me to enter the wall's endpoint. Now, that's actually what it's looking for. So whether you go horizontal, vertical, or at some angle, it's a second click that we need to do to place that second point. So I can just simply click a point like so to draw the first wall. Now you'll notice that it's continuing in the wall command, and the wall that I'm drawing now is connected back to the endpoint of the first wall. That's called chain in Revit. And you can see that there's a checkbox right here that controls that chain behavior. So as long as that's checked on, you're going to be drawing walls as a chain. In other words, walls that are connected endpoint to endpoint. Now, to get out of the wall command, you can do it one of 2 ways. You can press the escape key 2 times, or you can click the modify tool. If I click the modify tool over here on the ribbon, it cancels all the way out of the command in a single step. If I go back into the wall command, draw a few walls, and I press escape instead, the first time I press escape, it remains in the wall command, but it simply breaks the chain that I noted to you a moment ago. So that would allow me to stay in the command and create a new chain of walls. If I press escape 2 times, then it cancels all the way out of the command. So those are a couple different ways that you can both get into the command and out of the command. Now let's look at some of the settings that we can configure when we're in the wall command. So I'm going to go back to the wall command or type WA again. And let's focus on the ribbon now. On the modify ribbon, it says modify place wall. And on the far right-hand side, we have the draw panel. And you can see that there are several shapes that we can draw with the wall command. Now, all the ones we've drawn so far were just the default shape, which is just a simple straight line. But you can draw rectangles, which would allow you to pick two opposite corners and create a rectangular shape. You can do inscribed or circumscribed polygons, which just determine whether you're drawing to the midpoint of the side or whether you're drawing to a vertex. When you choose one of the polygon options, look at the options bar, because the options bar will have a property here to set how many sides the polygon is going to be. So it defaults to a 6-sided polygon, but you could change the number of sides to any quantity you like and draw a pentagon or a square or a hexagon just by simply changing the number of sides. And that would work for both types of polygons. When you draw a circle, you're going from the center point to the radius. And if I cancel out of this command, I'll do the modify tool for that. What you're going to notice is that actually draws two separate walls. So really what a circle does with the wall command is it actually creates two arcs that are touching one another. Let's go back in. And you can also see that there are several types of arcs that we can draw. Now this first one right here is the start end radius arc. And I always like to show this because it works a little differently than some of the other CAD programs out there, particularly AutoCAD, which is very popular. In AutoCAD, you would draw along the curve, but in Revit, you actually draw the start point and then the end point, and then notice that you're actually creating the radius of this arc. So if you're used to using another CAD program, then you really want to pay attention to the prompts that appear when you're doing this the first time and practice it a little bit. Right now, I've got the chain turned on, so I'm starting right here, and you can draw arcs in chain just like you could draw straight lines in chain. So again, it's the endpoint that I want to create next. And if you look at the status bar, it says enter arc wall endpoint. So we can see that very clearly. That's what it's asking for. And then when I click that, if I kind of move away so that it's not trying to snap to anything, you can kind of see that it's drawing the radius. Now watch what happens here when I get it to be tangent, right? So it's always looking for relationships that make sense. So by snapping tangent right here, we can actually draw some nice smooth curves that are joined with one another and flow together. I'm gonna go ahead and cancel out of there. Now I want to take all these doodles that I've drawn and get rid of them. So I'm just going to do a crossing selection here and make sure that I've only selected walls. Now I can see that very clearly right here because it says walls, and in my case I have 27 walls. If you make a bigger selection, something like this, it's going to say common here and it's going to say multi-select here. That tells you that you have more than walls selected. So in that case, you want to click the filter command. You want to uncheck anything that's not a wall. So in this case, views and elevations, click OK, and then we're going to press the delete key. And that kind of resets us to where we began. Now what I'm going to do is draw a few new walls, but I'm going to focus on some of the properties on the properties palette this time. So I'm going to stick with the straight line, and I'm just going to draw a small segment of wall right here. I'm going to press escape one time to break the chain. Now, if you look over at the properties palette, you can see that there's a base constraint and a top constraint. That wall that I just created had a base constraint of level 1 and a top constraint unconnected. Now, what unconnected means is that you can actually put in the height numerically for the wall. So you can see here that my unconnected height is currently 8,000 millimeters, but if I wanted it to be 7,000 millimeters, I could put that in and I could draw a new segment. Press escape again. Now, there's another way you can set the height of the wall. What we could do is we could actually set a top constraint. Now, in this file, I actually have levels 1 through 4. So the first wall I'm going to draw, I'm going to go from level 1 to level 2. I'll press escape once. Then I'm going to do another one from level 1 to level 3. I'll press escape once. And then finally, the last one from level 1 to level 4. And then I'll double escape this time to cancel all the way out. So I now have 5 segments of wall here, and I want to look right at those walls. Now, you could double click this small triangle here, which is the south elevation, or if you prefer, you can just double click it here on the project browser to open that up. Now you can see the levels are indicated here, and they're each 3,000 millimeters apart. You zoom in slightly so you can see those numbers. These are the walls that were unconnected that we drew first. So this is unconnected at 8,000. This one's unconnected at 7,000. They have no relationship to the levels. But these, you can see, are attached to the levels, these three here, the corresponding levels. Now, when you do it attached to a level, it's not a one-time operation. It's actually an ongoing constraint. So what that means is if I take this level and I were to move it, it's going to continue to change the height of the wall that's attached to it. Notice that the two unconnected walls were unchanged. So you do have both options. You can set your walls at an unconnected fixed height that doesn't change, or you can associate them with the levels. Associating with the levels can be pretty powerful in a lot of cases because if the design changes and you need to change the heights of the levels, then it will adjust those walls. So there's lots more that we can do with walls, but that gives you the basics of both drawing the walls in plan views and then setting some of the height parameters, and you can see those in elevation. Now I should point out that you can't actually draw walls in elevation. If you try and click the command, nothing will happen. So you have to draw walls in either a floor plan or in a 3D view. Now I encourage you to go ahead and experiment a little bit more in this file before continuing, but those are some of the basics of working with the wall command. So in this movie, I'm going to dig a little bit deeper into some of the settings that we have available with our walls. I'm going to start off by talking about how you can actually display more detail within the walls themselves. So what I have on screen here is just a simple wall, and I'm in a floor plan called Detail Levels. Now, if you look at the bottom of this view window, bottom left-hand corner, there's the View Control Bar. Now, there's a scale pop-up first, and then right next to that, there's a little open white square. And if I click that, that's actually a little pop-up menu. And there's 3 items there: Fine, Medium, and Coarse. If you set the display level of the view to either Medium or Fine, then it will display any internal layers within the wall structure. Now, in Coarse, it only shows the outline of the wall. So for example, if I choose Medium, notice that this wall that I have displayed on screen is actually a pretty complex wall. Within its internal structure, it's got several components which Revit calls layers. So starting here on the left side, there's a brick layer, then an air gap, some insulation, a concrete masonry unit, some furring, and finally a piece of drywall. Now, all of those layers display when we change the level of detail, and all of those layers are settings that are shared by all instances of this wall type. So we'll look at that in a little bit more detail shortly. When we select the wall, if we look over at the properties palette, there are some properties that pertain to just this wall that I have selected. Now, we saw some of those in the previous movie. We talked about the base constraint and the top constraint and the unconnected height, for example. We didn't talk about the location line yet, so that's what I want to talk about right now. That's an instance level setting, and it affects each wall you have selected. So what do I mean by that? Well, let's go over to this view here called location lines. And what I've done in this view is I've actually got the same wall, but as you can see, I've layered some text and some drafting elements on top of it to kind of label the parts and pieces. So what I've done first is I've highlighted in orange here what we call the core of the wall. So with all those internal layers displayed, we can see that each one has a different material. Well, at least one of those layers has to be the core of the wall. Every wall has a core. Now, you don't actually have to have anything more than the core, but you can, of course, as you can see. Now, in this case, the concrete masonry units is the core, and the easiest way to think about that is the core is just the part of the wall that actually holds the wall up. So in this case, the concrete masonry units are the structural component of this wall. On the right-hand side, we have interior finishes, the furring and the drywall, and on the left-hand side, we have the exterior finishes, the brick veneer. Now, you can measure 6 different points on the wall and use those as the location line. You can see them labeled here. So we can use the outermost face on the interior edge, or the outermost face on the exterior edge, or the center line of the wall itself, halfway between those. And then we have the same 3 points relative to the core. We can have the interior face of the core, the exterior face of the core, or the center line of the core. So if I select this wall, you can see all of those listed right here. And so with a wall like this, you can kind of get a sense of how those work. Well, let's see those in action. So I'm going to come over here to this view called Wall Types. And what you can see is I have this small box drawn on screen. Now I'm going to use my zoom in region and just kind of zoom in on that box. This is the wall that we were just talking about, but let's focus on these 4 walls instead. And I want you to pay attention to these dimensions here as I make some of these changes. So this wall is currently set, all of them are currently set to wall center line. So I'm going to leave the top wall set to wall center line. You can see it right there. But then I'm going to change the other 3 to different settings. So this one I'm going to choose core center line. This one I'm going to choose finish face exterior. And this one I'm going to choose core face interior. Now it doesn't really matter which ones you choose as long as you choose different ones for each one. Now the only real effect of that change that you can see at the moment is that the little grip points that determine the endpoints of the walls have shifted to those new locations. So you can see here we're at the core face interior, here we're at the finish face, here we're down the center line of the core. Notice that the dimensions are unchanged. So it actually shifted within the wall itself, but it didn't move the wall. There's really two places where you care what the location line is. If I zoom in a little bit closer, what you're going to notice is these walls are backwards. They're reversed. The brick is on the inside of the building and the drywall's on the outside of the building, which doesn't make a whole lot of sense. So I'm going to come over here and on the navigation bar here, I'm going to choose previous zoom to back out again, select one of these walls, and notice that there's a small flip grip right here. If I click that, this wall, see where its grips are? This is the one that we set to finish face exterior. Watch what happens when I click this flip. Notice that the location line stays put and the entire wall flipped around that location line. So it actually had a pretty dramatic impact on the overall shape of the building in this case because it moved the wall. Notice the dimension has changed. Now this wall, because it's using centerline, would be unchanged if I flipped it. So notice that this dimension did not change. So you can see the impact of having different location lines. Now the other way you can flip the wall instead of clicking the flip grip is to actually tap the spacebar, and that will do the same thing. So if I flip all of these to get to the brick to the outside, you can see the effect that has. Now the other place where you'll see the impact of the location line is if you change the thickness of the wall. That's also an instance property because we can come over here to this drop down, the type selector drop down, and we can just choose a different kind of wall. So let's say I chose this generic 140mm masonry wall. Well, that wall gets significantly thinner, but notice that it maintained its location line. So all of the thickness was removed essentially from the outside of the building. If I undo that and show it to you again, right, here's where the grips are, and then I change the thickness, you can see that all the thickness came from the bottom basically. So those are some of the instance properties and some of the impact that they have, and specifically the location line and how important that can be if you're either changing the thickness of the wall or if you're changing the orientation. But what about type properties? Well, we already kind of hinted at that all this composition within these walls is determined at the type level. So let's see that in a little bit more detail. I'm going to zoom in here just a touch, just to get in a little bit closer, and I'm going to select one of these walls, it doesn't matter which one, and I'm going to choose this button here on the properties palette to edit type. Now when you choose edit type, it allows you to see the settings that apply to all instances of this wall. So we're now actually modifying the definition of exterior brick on CMU, and any change you make is going to affect all of them whether they're selected or not. Right here we have structure, and then we have this edit button. I'm going to click that, and you'll see this table appear that lists out all of those layers that we've been talking about throughout the movie. Let's widen this dialog so that we can read it a little bit better. We can stretch this out so that these are more legible. Here's the core boundary, and notice that both of those are 0. So they have no thickness, they just define where the boundary ends and where the finishes begin. Now, it's actually possible for you to remove all of these layers if you wanted to. However, notice that the structure layer cannot be deleted, okay? So you have to have at least one layer within the core, that's required. But everything else could be deleted if you wanted to. I could insert new layers in the core, so your core can actually contain more than one layer, it just can't have fewer than one. Let's just do something that's going to be fairly obvious here. I'm going to come up here and remove the brick and the air gap. Now, that's kind of a silly change to make because you wouldn't typically just have a wall with exposed insulation, but what I want you to see is the impact of that change on not only the wall that's selected, but on the other 3 instances as well. So you'll notice that that brick and that air gap gets removed everywhere. And that's really the point of what we mean by a type level modification. Now, I should point out that we did everything here with walls, but the same concept applies to everything in Revit. So nearly every element in Revit has both instance and type properties. And so if you understand the concept of what it means to edit at those 2 levels, that's going to apply across the entire Revit software package. In this movie, we're going to talk about snapping behavior. Revit has 2 basic kinds of snapping behavior. We have increment snapping behavior and we have object snapping behavior. I'm going to demonstrate both of those for you here in this movie. So I'm going to use the wall command to demonstrate this. The first thing I want to do is zoom out a little bit. So I'm going to use the keyboard shortcut ZO, which will zoom out 2 times. Then I'm going to run the wall command, either by clicking the tool on the architecture tab or typing WA for the keyboard shortcut. Now, it doesn't matter where you click the first point. I'm going to click anywhere. And what you'll see is a 0 coordinate will appear on screen. So the first thing you want to know about the way that Revit locates geometry in space is everything is always relative. So if you just pick a random point in space, it's always going to call that 0 because there's nothing else nearby for it to relate to. Now, what I want to do is start moving my mouse slowly. And what you're going to notice here is that it doesn't move in a smooth, fluid way. It kind of skips and jumps, as you can see. And if you look carefully, you can kind of notice that it's jumping in increments of 1,000. So that's what we mean by the increment snap behavior. When I'm zoomed out really far like this, Revit's going to use that 1,000 increment. And if I click, even though I didn't put in any number, use any dimension, I can be confident that that wall is exactly 9,000 millimeters long. If I turn the corner and go in another direction, you can see it's snapping in that direction and so on. Now I'm going to zoom in a little bit. And I'll do that with my zoom in region. And let's zoom in about like so. And now what I want you to see is that the increment has actually gotten a little bit finer. So since I've zoomed in, Revit is going to give me sort of a more precise snapping behavior. But you'll notice here that it's still snapping in a regular increment. This time it's 100 millimeters. And again, I could click and that wall is exactly 6,200 millimeters. This one is exactly 2,100 millimeters and so on. Now I'll zoom in again with the wheel this time. And at some point, you're going to see that increment change. And now it's to the nearest 10 millimeters. And then if I continue to zoom in, at some point, it might get even finer down to the actual millimeter. So let me escape out of there. I'm going to do ZF to zoom to fit. And let's see where that setting is controlled. Now I'm going to go to the Manage tab, and I'm going to click here on the Snaps button. Right here at the top is where that increment is actually controlled. So you can see that it started at 1,000, then it went to 100, then to 20, and then finally to 5. Okay. Now you could actually add your own increments in here if you wanted. If you didn't want to go from 20 to 5, if you wanted to go from 20 to 10, then to 5, you could just type in 10. Now you don't even have to put them in order because if you OK, and then you go back in there, Revit will resort them for you. So now what would happen is I'd have to be zoomed in pretty close to see that new increment, but now it would start to use that new increment when I zoomed in to an appropriate level. And at some point I'll start to see it. So feel free to add other increments if you wish. I'm going to zoom back out a little bit here. I'll just roll my wheel. And I do want to point out one other thing about the snaps. Regardless of what the increments are set to, if your cursor gets nearby some existing geometry, Revit will always favor the existing geometry over the increment snap. So if I start out here, I'm getting the 0, I'm getting the snapping behavior, but as soon as I get nearby some other wall, you notice how it latches onto that wall with a small dashed line. So it will always favor existing geometry over whatever your snap increment is set to because it's going to assume that that's a more important relationship. You can see here that it's actually down to 0.3 millimeters in this case. So it's a much more precise value. Okay, let's go back to Manage. Let's click on Snaps again, and let's look at the next part of the dialog. If you look at the middle section where it says Object Snaps, you can see that all of the standard object snaps that you would expect in any CAD program are here in Revit as well. So we can snap to endpoints, midpoints, intersections, perpendicular, tangent. And we saw some examples of this already. But notice that they're all turned on. It is possible to turn on and off different ones. So if there's certain snaps that you don't want, you can do that. And then I really want you to look at the letters in parentheses because just like our commands, our object snaps also have keyboard shortcuts. So they're pretty easy to remember because every one of them starts with the letter S, and then it's just the first letter of the snap. So SE for endpoint, and SM for midpoint, and so on. So let's go ahead and click OK here and try those out. So I'm going to go back to Architecture and click the Wall tool and start moving my mouse around near existing geometry. I'll get a little square for endpoint. I'll get a small triangle for midpoint. Let's see, let's do this. and then we'll get a little X there for an intersection. So you can start to see when it's going to find those different snap points and then click. Now, if for some reason it's trying to give you a snap that you don't want, like here it's giving me endpoint, and I really wanted the midpoint, let's say, that's where those keyboard shortcuts come in. So I could type SM, and now if I highlight this wall, anywhere on this wall, it'll snap to the midpoint. Anywhere on this wall, it'll snap to the midpoint. And then after I click that, it'll go back to looking for everything. Okay, so think of that as a one-time override. So the snapping behavior is both the increment snaps and the object snaps, and they're both designed to help you get a great deal of precision and accuracy without you having to work really hard to do it. So they're really handy features and something that's basically there all the time working in the background as you work within your Revit projects. In this movie, we're going to begin laying out a small 2-bedroom condominium unit, and we're going to put into practice many of the techniques that we've talked about with working with walls. So I've already created the outline of the 2-bedroom unit, and we're going to focus our attention on the left-hand side of the plan and lay out the 2 bedrooms first. Now, a technique that we're going to rely heavily on in this movie is what I termed sketch then modify in some of the previous movies. And what I mean by that is we often go into Revit, we just lay out our geometry in rough locations first to kind of get ourselves started, and then we come back and modify those locations. So let me show you what I mean. I'm going to go to the architecture tab and click the wall tool. I'm going to use an appropriate type for interior construction. So I've got an interior 123mm partition type right here. And if we click edit type and then edit structure, you can see that it just has a simple metal stud layer for the core and then drywall on either side. So we cancel out of there 2 times. Now, I'm also going to just use a simple wall center line, location line. I think for interior partitions, that makes a lot of sense to just use the center line. And the base constraint, I'm going to leave at level 1, and I'm going to let it go up to the height of level 2. So basically, I'm going to accept all these defaults here on the properties palette. If you put your mouse near one of the exterior walls, it will highlight that wall, and it will even show you a small dimension, which you can actually use to help you locate it. So I'm not really too concerned exactly where I put this first wall. I'm just going to click my start point and start moving my mouse down into the plan. Now notice that I can move at any angle that I want, and notice that there's 2 dimensions there. We have the angular dimension and the linear dimension. Now if you look at them carefully, what you'll see is that the linear dimension is actually a little bit bolder than the angular dimension. So when you see a bold dimension in Revit, what that means is that's what we call a listening dimension. In other words, if you pull your mouse in the direction you want to go, in this case I want to pull it straight down, and then you type in a value, that value will go directly into the listening dimension. So just by typing on the keyboard, it automatically goes into that location. So if I press enter here, I've now created a wall that's 3,000 millimeters long. So you could certainly do that for laying out all the walls, but what I want you to see is actually it's really not necessary to be that precise as you're laying things out. In fact, what we're going to do instead is something much more fluid and quick. I'm just simply going to sketch the rough outline I want. So I want a space across the top here, and I want to give it a small bathroom area, so that's going to be 1 bedroom. Then I want another bedroom down in this location. That bedroom's going to have a small closet here in the corner. And then over here, there's going to be a walk-in closet for the main bedroom and then another small bathroom right here. So notice how I was able to very quickly just sort of sketch in the walls in the approximate locations where I wanted them without worrying too much about how big everything is. Now, I'm going to click the modify tool to cancel out of the wall command. And now let's go to the modify part. So that was the sketch part, sketch then modify. Now we're going to go to the modify part. So you start by selecting some object that you want to modify. And in this case, I want to take the wall here on the right-hand side of the bathroom and I want to move it over a little bit. Now, defining a small dining room area over here. Notice that 2 temporary dimensions appear. So I'm going to use this one to modify the size of that space. And all I have to do is click right on that temporary dimension number that will activate it, and I can type in the value I want. In this case, I'm going to use 2,700 millimeters. When I press enter, the wall will actually move to make that space the size that I asked for. Now, here's a common mistake that a lot of folks make. They want to set the size of the bathroom next. So I'll come over here and put in my value, 1525, and press enter, and what happened? Well, the same wall just moves right back where it came from. You always have to remember that when you're doing temporary dimensions, the object you have selected is the one that's going to move. So this one, I wanted at 2,700. I need it to stay where it is, which means I now need to change my selection. And so I'll switch to this wall and put in my 1525. Now, in this case, because of the template that we started with, the temporary dimensions are actually giving us nice, convenient witness line locations. In other words, those witness lines are right here at the faces of the walls, which makes it very easy for us to set the sizes of these rooms. But that's not actually always the case. That's a setting that we can configure in our files. Now, remember, I did point out to you in a previous movie that you can actually click these small grips and move these witness lines to either the face or the center of the walls. So you can always do that, but I think it's better to have the setting configured the way you want first. So what I've done here is I've got another file open in the background just to kind of discuss what those settings are. The witness lines can either go to the centers of the walls or the faces of the walls, and they can actually go either to the center lines of openings or to the edges or the opening itself. So where do those settings get configured? If you go to your Manage tab and click the Additional Settings dropdown, there's a command called Temporary Dimensions. Now, this particular file has them set at the center lines of the wall and the centers of the doors and windows, which I don't really care for. My preference is the faces of the walls and the openings for doors and windows. Now, that's actually the setting that we're seeing back in our other file, so there's really nothing for us to change there, but I do think it's important for you to always check that setting before you do a lot of work, because it'd be a real shame if you spent a lot of time moving witness lines and not realizing that you could just set a preference and be done with it. So let me switch back to my Locating Walls file here. If I go to Manage, click Additional Settings, Temporary Dimensions, you can see that it is in fact set to faces and openings, so that's the settings we want. So let's continue modifying the locations of the walls here. Now I'm going to take this wall and move it, and what you're going to see here is that all of these walls that are connected to it will adjust with it. So you see how when this wall moves around, it will adjust everything else. And this is why this technique is so powerful. So let me click this dimension here, and I'll set the size of this bedroom to 3,000. Then I'll move down to this wall here. Remember to always change your selection so that you're moving the correct thing. And I'll set this distance to 2,400. Then I'll select this little small wall here for this closet here. I'm going to use this dimension instead because I know how big I want the closet, and I'll make that 2,200. And then I want the closet to be 750 in the other direction, so I'll use this dimension here. And then finally, I need to set the locations of these two. This closet's going to be 1,500, and this bathroom's going to be 1,525. So as you can see, you can start with a very simple sketch layout where you very quickly lay out the walls in approximate locations, and then you come back using the temporary dimensions to fine-tune those positions to very precise locations so that you get a very accurate floor plan without expending a great deal of effort. In this movie, I'm going to continue working on the layout of my 2-bedroom condominium, and I'm going to focus on several modify tools that we have available to us. Now, tools like move, copy, trim, extend, offset, these are staple commands in any CAD program, and Revit is certainly no exception. So to access these tools, we're going to go to the Modify tab, and you're going to find all of these commands on the Modify panel. So let's start with the basic move command. So that command is right here, and the shortcut for it is MV. Now, what I'm actually going to do here is pause over the tooltip for a moment, and I'm going to let it play. What you'll see is that each of the tooltips for these modify commands actually run little small animations. So if you just take a few moments and let the animation run, it gives you a little bit of insight into how that command actually works, and it can be really helpful to learn each of these commands. So I highly recommend that you do that. So I can click the button, or notice the shortcut for it is MV, and if you click the command first, what will happen is Revit will then prompt you for a selection because I don't have anything selected. So I would have to select some object, and then in order to complete selection, I have to indicate that to Revit either by right-clicking or pressing enter. So now I'll press enter. The next step is to decide what point you want to start the move at, and then where you want it to end up. So you're basically picking the object up, you're going to walk with it, and you're going to put it down. Now, you can do this in a variety of ways, but let's say that I wanted to move this wall the exact amount of the distance of this closet. So I could use my object snap here and use that as my start point, and then I could slide over here and use the object snap again and use that as my end point. And notice that even though I'm picking points down here by the closet, what it's actually doing is moving the selected wall by that amount. So that's certainly one way that you could use the move command. Now, when I look at that, I realize, well, that probably wasn't what I wanted. I moved it a little bit too far. So I'm going to keep the wall selected and show you the other way that you can deal with selection when it comes to these modify tools. And I'm going to stay with the move command, and because the wall is already selected, notice that when I click the move command this time, it doesn't prompt me for a selection. It just immediately goes to start point, new point. Now, you don't have to snap points on screen. What you can actually do is just click any random point on screen, start moving in the direction that you want to move, in this case horizontally to the left, and then type in how far you want to go. So maybe I want to go 750 millimeters. So I'll type that in and press enter, and then it will move the object that amount. So whether you click the points or type the values in, it really doesn't make a difference. The point is that with the move command, you're picking the object up at a start point and you're putting it down to a new point. Now the copy command works exactly the same way. So if I click the copy command, I've already got an object selected. Again, pick my start point for the copy and then my new point for the copy. And instead of moving the original this time, it moves a copy. So now I've created this wall, but I don't really want it here. I really want it down in the lower portion of the plan. Now I could use the move command for that if I wanted to, but notice that if you try and move it, what's going to happen is that it's actually going to stay attached at that end. So I'm going to undo that. So if I select it again, if you don't want it to stay attached at that end, then what you can actually do is check this little box right here to disjoin it. So when I click my start point now and my new point, I'll just do this randomly. Notice that it moves the wall and it disconnects it at the other end. So you always have that option. So it's really important that you pay attention to the options bar when you're using these commands, because there's always little useful settings in there that if you miss them can make your job a little bit harder. Now another way that you could manipulate this wall is to simply use the grips at the end. So I'm just going to take this little control handle here at the end and I'm going to drag it down until it intersects the other wall, and you'll see that those two walls will actually join up together. You can fine tune the length of it at this end as well if you like, using the same technique. Okay, so that's move and copy. The next thing I'd like to look at is the trim command. Now it's actually trim and extend at the same time, and there's a few varieties of this command, but the one that I'm going to look at here is the trim and extend to corner. Now the way this command works is it makes corner conditions. So if I demonstrate right here, basically take this wall and then click this wall, what you'll see is it creates a corner between those two walls, but of course it trimmed off the part to the right. If I realize I don't want to do that and actually want to put it back the way it was, then I can do this, and now it'll extend and fill in that gap that was removed. So it's both a trim and an extend command. Now let's use it over here in this location. We're going to enter the condo right here, and I want a small coat closet in this location. So to do that, I'm going to select this wall and then this wall, and you'll see a small little pair of dashed lines show me what it's going to look like when I click, and it will extend those two walls to join up with one another and create a corner. Now, how does it know whether to trim or extend? Well, if you pay attention to the prompts at your status bar and watch the little dashed lines on screen, you get all the clues you need. So for example, if I select right here, and then here, notice that it trimmed that part off. Now, how did it know to do that? Well, when I click my first object, it says to click on the part you want to keep for your second object. So if I put that back again, and then I'll click this one, how does it know whether to trim to this side or this side? Well, if I click here, it will do that way, undo. And if I click here, it will go that way, undo. So always pay attention to the side you're clicking on, and that will determine whether it does a trim or an extend. Now I want to create a small corridor over here and then join up these two walls. So this time I'm going to use the offset command for this. Now offset's a kind of copy command, and it just creates a copy at some distance away. It's very similar to copy. You could use the copy for this as well. What you want to do is on the options bar, you want to indicate how much you want to offset. So I'm going to put in 1500 millimeters here, and then you highlight an object that you want to actually copy and offset. Now if you look carefully, you'll see that there's a small dashed green line set some distance away, that 1500 millimeters. You want to pay attention to whether it's going up or down. So if you move your mouse slightly, it'll actually go up. So I want to make sure it's going down, and then I'll click, and it will create that copied wall at the 15 millimeter offset. Now I'll go back to trim extend, select this one, and be careful, don't pick the top half, because if you do, you'll get that. What I want to do is pick the bottom half. That's the part I want to keep, and now I'll get this. Now I want my living room larger and my kitchen smaller, so let me cancel the command with the modify tool, and let me select this wall, and I can move the wall using the move command, but there's two things that I want to point out. First of all, if we go to move, notice that disjoin is still active. So if you were to actually move this wall, it will disconnect itself from the other wall. So let me do Control Z to undo that. Keep in mind that whatever options you check on the options bar, it's going to remember that for the next time you use the command, so just pay attention to that. The other challenge with move is that I would have to know exactly how far I want to move this wall to end up with the desired size for either the living room or the kitchen. Now that might require some math that is at a level of precision that could be prone to error. So I actually prefer not to do this with the move command in this case. What I'm going to do instead is just what we did in the previous movie. I'm going to use temporary dimensions. Now I'm going to pan this view slightly here so I can get at this temporary dimension, and I'm going to click on it, and then I can just type in exactly the size that I want, 3750 in this case, and that will keep the two walls connected. I won't have to worry about that disjoin with the move command. So sometimes it can be a little bit better to use one of the other techniques that we've already discussed. Now let me go to architecture and add in a few more walls. I need a small pantry right here, and I need a utility room in this location, and I'll worry about fine-tuning the sizes of those a little bit later. But now what I want to do is break out this segment of the wall right here. You can see it's one continuous wall, and we have a tool for that. If I go to the modify tab and I click the split element tool, I can use this tool to basically break out a segment of that wall in between. Now, if you just click a point, what you actually get, let me cancel out of there, is two separate walls. I'm going to undo that. That's fine. If you split it first into two separate walls, then you could do trim on both sides to clean it up. But it's actually a little bit faster if you remember to do this. Go to split element and look at the options bar. There's a delete inner segment checkbox. It's the only option available here for this command. So if I check that, now I can very precisely start my split from here, end my split from there, and it will trim out the segment in between. And as I say, if you forget to do that, no big deal. You can always use the trim command to clean it up. But using that feature is usually just a little bit quicker. So as you can see, we have a variety of the common modify tools that you would expect to find in any CAD program, and using those, we can complement our existing temporary dimension approach and very quickly complete the layout of our floor plan. In this movie, we'll add doors and windows to our two-bedroom condominium. I've got a completed version of the wall layout on screen, and I'm going to start adding doors and windows using the tools here on the ribbon. So I'll start with the door command. Shortcut for that is DR if you prefer. And if I open up the type selector, I actually have three families loaded in this file. Now, the M single flush was already here with the template, and I could certainly choose from among its types. I've also preloaded in the M door interior single flush wood panel, which is a slightly different version of a single flush door than the one that was in the template. And I've also got a bifold two-panel door here. So I'm going to show you how I loaded these in just a few moments. But let me go ahead and start with this M door interior single flush wood panel, and I'm going to choose the 900 by 2400 millimeter size to place the entrance to the condo. So the entrance to the condo is right here on the small angled wall. And notice that, of course, we've talked about this before, but you can't place a door just in free space. The door always has to be placed on a wall. So when I move my mouse on the wall, the door will start to appear. We call this hosting in Revit. So a door requires a wall host. And if you look actually at the status bar, the message down there, it says click on a wall to place a door. So it kind of tells you that you must click on a wall. Now, if I move my mouse subtly in or out of the plan, you can see it will flip the door either to the inside or to the outside. So I'm going to have the door swing in, and then using that small little temporary dimension that appears, you can see that I'm 200 millimeters off the corner. So I like that. I'm going to go ahead and click to place that first door. Now, if you move your mouse at the last second when you place it, this is a temporary dimension, and you can always click right in there and type in 200 to make sure that it's in the location you want. Now I'm going to change the size to a slightly smaller door. I'm going to do an 850 millimeter wide door, and I'm going to place the rest of the single swing doors that I want. So I want one here going into this bedroom, and notice that when I kind of move my mouse up so that it's swinging into the bedroom, that there's actually a dimension on either side, and it will try and center itself. So I kind of like that. I want it to be centered in that room, so I'll go ahead and click there. And then in this case, it's still centering, but of course it's flipping the wrong way in the room here. Now I don't really like it being centered necessarily in this case, so I'm going to move over slightly, and notice that it's snapping in 100 millimeter increments. This is tied back to that snap behavior that we talked about in an earlier movie. So that works with doors just as well as it does with walls. But what I want to do here is look again at the status bar and notice that it says in parentheses that you can use the space bar to flip the instance left or right. So if I just tap my space bar, it'll flip that door to a more comfortable position so that we can actually enter the room. I'll go ahead and click to place it. I'll place another one here at the center of this wall, place another one here 100 millimeters off the corner in this closet, place one right here 200 millimeters off the corner there, tap my space bar to flip it, and that's the remainder of the single flush doors that I want to place. Now I'll come over here to my type selector and I'll change to the bifold 2-panel door, and I'm going to choose the 915 by 2032 millimeter size, and I'm going to place one right here, and right here. Now let me cancel out of there for a minute, and you'll notice that I was a little sloppy about the one that I placed here and that it's flipping inside the closet instead of outside. Just zoom in slightly there to show you. I wanted to do that to show you that it's easy to modify these afterwards. So don't feel like you have to undo or erase or start over. Now it did center in the space, which is fine. Okay, so I can accept that. But notice that it's got these two little flip grips right here, and I can easily use that flip grip to change it after I place it. You can actually also tap the space bar, and it will flip through 4 possible conditions. So using whatever technique you like, you can go ahead and adjust the position of that bifold door to make sure that it's in the correct location. Same thing is true with each of these. You can edit the temporary dimensions and position those to your liking. So I'll put this one at 200 millimeters. So once we've placed those doors, I need a larger door here, maybe a sliding door for the closet, and I want a double door here going out to the patio. So let me show you how I preloaded those doors that were already here in the file. If you go to the door command, you can come over here on the ribbon and there's a load family button. When you click that, it will display the load family dialog and it will take you to your default library. Now in my case, it went to the Imperial library by default. So I'm going to click this up one level folder here to jump back a step. And then I'll notice that I have a metric library here. And in the metric library, I have a doors folder. Now there's some doors loose in that folder. And then there's also some subfolders. So I'm going to go into this residential subfolder here. I'm going to take this one, this double exterior glass door, and then I'm going to hold down my control key and select this one right here, the double sliding 2-panel door. That means that it's going to actually load both of these families when I click open. And then these families use something called a type catalog. Now a type catalog is used when there's lots of types to choose from and you may not necessarily want to load all of them. So what you can do in this table here is find the sizes that you're interested in. So for the interior double sliding door, I'm going to choose maybe the last 3 sizes here. So I'm just going to click and drag through those. And then for the exterior door, I'll do the same thing and click and drag through those. Now when I click OK, what you're going to see is that on the type selector, it will only have loaded those 3 sizes I asked for instead of the entire list. Now you certainly could do the entire list if you wanted to, but that usually increases file size. And if you're not going to use those other sizes, then it's a good idea not to do that. So anyway, let me choose the largest size here, and I'll go ahead and place this door centered in that space right there. And then let me choose the sliding door, and I'll choose the intermediate size here, and I'll center it on the closet like so. Cancel out of the command. Now, once you know how to add doors, you know how to add windows. They're added in exactly the same way, including all of the positioning steps that we did and loading the families, everything that we've just looked at. So I'm going to click the window tool. And when I open up the type selector here, I find that there's only one window loaded and it's a fixed window, which is probably not the best choice for a condominium. So I'm going to go directly to the load family button that we just looked at. Again, I'm going to go up one step to my metric library, scroll down and find my Windows folder, and then choose a more appropriate type. So in this case, I'll choose a double casement window with trim, click open, and then that loads 3 types in this case. So I'm going to choose this size right here, the 1220 by 1220 millimeter, and I'll place one in this bedroom, place one in this bedroom, and maybe one in the kitchen right here. So adding doors and windows is a simple matter of making sure that the families that you need are loaded into the file, and then you just simply need to click on a wall to place them. Remember that the tricks that we use with temporary dimensions work equally well with doors and windows. And also remember that you can use your spacebar or the flip grips to reorient the doors and windows as necessary. Now, there's lots of other elements that you can add to floor plans other than just walls, doors, and windows. So in this movie, we're going to look at the component tool, and we use the component tool to add a variety of categories. If they added a dedicated button for every category in Revit, then the ribbon would be just filled with icons. So what they've done is to kind of shorthand that is they've actually added just a single component button, which is kind of a catch-all and allows for the placement of several different categories. Let's start by actually clicking the component tool, and the shortcut is CM, as you can see. And let's open up the type selector, and what you're going to see is it's a rather eclectic list here. We have a desk, a parking space, and a tree family loaded. There's also a couple random items down here for supports. Now, none of those are really items that I need right now, but as you can see, it's a broad list of categories. So what I want to do is go right over here to load family, like we talked about in the previous movie with doors and windows, and then from the library, I can load in some appropriate categories. Now, what I want to do is bring in some equipment for the mechanical room here, some stuff in the kitchen, and some fixtures in the toilet rooms. So let's start with a furnace. Now I'm going to back up to my metric library, go into the metric folder, then scroll down and find my mechanical folder, architectural, airside components, and then find the furnaces. In that folder, there's a single furnace item. So I'll go ahead and select that family and click open. Unlike the doors and windows, this is what I call a freestanding family. Notice that I can place this family anywhere that I want. It doesn't require me to place it on a wall host, for example. Similarly to the doors and windows, you can use your spacebar, but in this case, instead of flipping the family, it will actually rotate it. And by default, it rotates in 90-degree increments. But if you take your mouse and you place it over something that's at a different angle first, and then tap your spacebar, it'll match that orientation. So we can do that in 90-degree increments as well. And then if you wanted to reset that orientation, you could just move back out into empty space and tap the spacebar one more time. Now I want to orient it horizontally like this, and then I want to come over here and kind of get myself in this lower portion of the mechanical room and allow a little bit of space around it, and then I'll click to place that furnace. Okay, so it's as simple as that. You load family, find the component you want, set the orientation, and then click to place it. So let's go to load family again and find some more stuff. So I'm going to go back up one folder, go to metric, and then this time I'm going to go to the specialty equipment folder. In there, I have several subfolders, and I will use the domestic folder next. And then in here, there are several items that we might want to load. So using your shift and your control keys, you can actually load more than one family at the same time. So I'm going to load a dryer, I'm going to load a range, a refrigerator, and a washer. Now I'm going to start with just those 4 items, but if you want, you could also do a microwave or an exhaust hood or a dishwasher. It's entirely up to you. But I'll do those 4 items. I'll click open, and that will load in all 4 of those families. Now it looks as though it put the refrigerator here on my type selector, so we'll place that one first. And if you open up the type selector, you can actually see that in some cases there are different sizes. So right now it's got the smallest refrigerator on my cursor currently. So maybe I want to do a slightly larger one. So I'll go to the 660 by 760, and I'll come over here and kind of zoom in a little in the kitchen and maybe place it lined up with that wall there. You see how it's trying to line up, but set it away from the wall just a little bit. Now it went 100 millimeters, which is a little bit far away from the wall. I'll change that to 50. So notice how in previous movies we talked about temporary dimensions. They work the same way here with other components as well. Let's pan slightly, change to the range. I'll choose the larger size range, tap the spacebar a couple times to orbit it around. And in this case, I'll let it snap right to the wall and place it right about there halfway on the wall. Then I'll add the washer and dryer. And you see how those will try and snap to one another. You can always fine tune the placements of these things later. Let me zoom back out a little bit. And I need to add a toilet fixture in each of these toilet rooms. So I'm going to go to component one more time, click load family again in my metric folder, scroll down, find the plumbing folder, then architectural, and then fixtures, and then find the water closets. Now here you're going to notice that there's actually two different domestic toilets. There's a 2D version and a 3D version. In large projects where you have dozens, if not hundreds, of fixtures, it might be advantageous to actually choose a 2D version because it will reduce the file size and help boost performance. In this case, we're doing a very small condominium layout. I doubt that there would be any noticeable difference between the two, so I'm actually going to choose the 3D version of the toilet in this case. Now, when I open it up and you look here in the plan, notice that even though we loaded a 3D version, it actually does a two-dimensional symbol when you're in plan, so it does that automatically. I'll show you what it looks like in 3D in just a few moments. Let me tap the spacebar to orient it around, snap it to this wall, spin it around here, snap it to this wall, and then I'll click the modify tool to cancel. Now I'm going to do zoom to fit, and that's the basic elements that we wanted to add here. And I promised you a look at the 3D, so let's see how we can do that. So to see this model and how it's shaping up in 3D, you can come up here to your quick access toolbar, and you're looking for a small little icon that looks like a tiny birdhouse. This is called the default 3D view icon. Now when you click this, it will create an axonometric view of the model, and if you look over here on the project browser, you'll notice that there's a 3D views branch, and when I expand that, the name of that default 3D view has curly brackets around it. So I often refer to this as curly bracket 3D, but that's the default 3D view. Now in the previous movie, we talked about orbiting in 3D. There are two ways you can actually do that. The way that we talked about previously was to hold the shift key down in the middle wheel button and just drag, and that will orbit around. But you can actually drag the view cube as well. So just sort of click and drag on the cube, and it will orbit around. If you drag this little turntable at the bottom, it will also orbit it in 3D, but it won't change the height. So that's just a slightly more controlled way to orbit it around. So using whichever method you prefer, what I'm going to actually do is tip down so that I can see into those toilet rooms, and then I'll roll my wheel to zoom in, and you can see that it does create an actual 3D toilet, even though in the plan view we were seeing a flat two-dimensional symbol for it. If I come over here to these other portions of the plan, you can see my furnace right there, and if I spin around this way and zoom in, you can see my washer, dryer, and my range. So when you're ready to begin adding other kinds of fixtures and components to your Revit projects, it's as simple as clicking the component tool, loading family, and then browsing to the components you want and placing them in. The out-of-the-box library that ships with Revit includes lots of components in several different categories. We saw several examples of this in the previous movie. I've since added a few additional items like a hot water heater, a couple countertops here in the kitchen, and these closet shelves and poles in the closet. So feel free to explore those a little bit on your own. What happens if you need a component that's not actually available in the out-of-the-box library? Well, there's lots of places online that you can go to find content, and the one that's maintained by Autodesk is actually called Autodesk Seek. Now we can get to Autodesk Seek directly from the software. So to do that, we can go to the Insert tab, and there's a search field available right here. So if I simply click in the search field and type in a keyword for the kind of item I'm looking for, it will run a search in Autodesk Seek and display the results for me in my web browser. So I'm going to type in tub and see if we can find some bathtubs out on Autodesk Seek. Now, Autodesk Seek includes both content provided by Autodesk and content from product manufacturers. So if we look over in the column at the left, we can see that the content source for the search results that appear here includes 238 items from manufacturers and 11 generic items. The generic items are the ones from Autodesk. So to simplify this list a little bit, I'm going to just limit it to the generic items for now, but if you want to explore what's available from manufacturers, feel free to do so on your own. Now you can see that there's some specialty tubs here at the top, and then there's a few various simple tubs here, some 2D, some 3D. Some of them are wall hosted, which is fine, but I think in this case I'd rather have something that's freestanding. So I'm going to go with this one right here that's simply called bathtub, and I'm going to click that link to open up that page. Now what you'll see here is that there's 4 different items in 4 different versions of Revit. Notice that they're all older versions. So it usually takes a while for the content on Seek to catch up with the current release, and they do this to keep it more compatible with more versions of Revit. So I usually recommend loading the latest version that your software can read. So in our case, that'll be this 2011 version right here, and then I'll select that, and then up here at the top, I'm going to click the download button. Now, if you haven't logged into Autodesk Seek, it will ask you to log in now. So you'll need to log in, and you can use your standard Autodesk login for that. Then you get the option down here to either open or save the file, and this might vary depending on your browser. Okay, so you'll get some sort of message about opening the file. Now, because it's an older version, like 2011, in this case, it's going to display a dialog asking me if it's okay to upgrade that model. So I certainly do want to do that. So I'll choose upgrade the model, and that'll just take a few moments while it upgrades the family to the latest release. Now I'm actually inside that family. I'm in the family editor. Now I don't really want to get into the family editor at this time. We're going to talk about it in detail in a later chapter. For right now, all I want to do is take this file that I have on screen and load it into my project. Now I can do that over here with this button, and actually this one, load into project and close, will simultaneously push it over to my project and then close the family file. So let's do that. And then you'll see that we get this bathtub now on my cursor. Now the default size is a little bit small, so I'm going to come over here to the type selector, and I'm going to choose a better size. Now, if I scroll through this list here, you can see that the sizes are in imperial units, which will sometimes happen when you download content from various websites like Seek. So I'm just going to choose a size that should fit into the available space that I have, and this 60 by 30 inch public ought to do the trick. Now, this is a freestanding tub because I didn't choose the wall-hosted version, which means I could really place it anywhere I want. I can use the same tricks that we talked about in the previous movie by tapping the spacebar a couple times to rotate it around, and then it should fit nicely right into the corner of the room right there. Let me go ahead and put another one over in the corner of the room right here, and you can see how it highlights the walls and kind of snaps nicely into place. So I'll just go ahead and cancel out of the command, and if you want, you can search for additional items on Seek and place additional components in the model using the same process, but that's the basic steps that are involved in going out to Seek, searching for content that would not otherwise be available to you in your default libraries. To add a little finishing touch to our 2-bedroom condo unit, in this movie I want to talk about wall joints. Now specifically, if I zoom in over here on the right-hand side of the plan, we have a few areas that could use some attention. The entrance way to the unit has this block wall right here, but as you can see, the stud walls are actually taking precedence over the block wall. Now that's an easy thing to fix using the Edit Wall Joints tool. Another place where we're going to use the Wall Joints tool is to take these really sharp corners here and kind of blunt those down. So let's take a look at both examples. To get to the Edit Wall Joints tool, you go to the Modify tab, which I already have active, and then here on the Geometry panel, you can click this button right here for wall joints. This will prompt you to select an intersection, and you just simply highlight any wall intersection. You'll see it'll put this little square over the intersection. So when you find the one that you want to modify, you just click and it will focus in on that intersection. Now, it's actually possible to select more than one intersection using your control key, but for the modification that we want to make here, we won't be able to do that modification with multiple selections. So it's better to select them one at a time in this example. Now, if you look at the options bar, what you can see is there's two buttons, next and previous, and then there's some radio buttons here for the different conditions. So we can choose between either but or miter. Now miter really wouldn't give us what we want in this case, because as you can see, it would be a sort of unnatural condition. So we want to stick with a but condition, but we just want it to reverse which wall is dominant over the other. So to do that, you just simply click the next button, and you can see that it will just toggle through different solutions until you find the one that you want. So when you find the one you want, you just come over here and select the next wall, click next again, that takes care of that. And then if you were all done with wall joins, you click the modify tool to cancel out. It's very important that you remember to click the modify tool to cancel out, because otherwise you're still in that mode and you might go select somewhere else and still be editing wall joins. Now it turns out we have two more that we want to do, these two sharp corners here. So let's go back into the command. I'll click right there, and Revit will recognize that we have a non-90 degree angle, and it will offer this third choice right here, square off. So if I choose that, that's exactly what it's going to do, is it's going to blunt that sharp corner. Now if you go to next, it can blunt it this way or that way. So you choose the one that you prefer, and then switch the focus to a different intersection, square that one off, choose the one that you prefer, and then when you're done, click the modify tool to finish the command. So those are two really simple examples of where the edit wall joins tool can be really handy. The last place that you will sometimes use the edit wall joins tool is to actually disallow the join. So in some cases, like in commercial buildings where you have a wall butting into a curtain wall, it can be useful to disallow the join. We don't really have that condition here, so I'm simply going to cancel out of there. But use the edit wall joins command to fine tune the connection between any of your joined walls. In this movie, I want to share with you the concept of constraints. Revit offers us many ways to build constraints into our model. And a constraint is just simply taking your design intent and building it right into the model geometry. So it allows you to lock in the behavior you want. And I like to say it's kind of like adding smarts to the model. So let me show you a few examples. I'm going to zoom in a region over here on this break room. Maybe I want this door to have a particular distance off of this column, even as things change in the model. So let me start by selecting the door. And what you'll see is that some temporary dimensions appear. They're not in the place that I want them in. They're actually measuring to the other nearby window instead. So all I have to do is grab this small little grip right here and start to drag it. And I'm going to let go when I've highlighted the face of this column. That will move that witness line over to that location. Now, looking at the number, I want to change that as well. So instead of the number that displays there, I just want to make it a nice round 600. Now, if I simply deselect the door, the dimension will go away because that's what temporary dimensions do. But if I reselect the door in the current work session, Revit will remember that I moved that witness line. But the trouble is, if I close the project and reopen, it won't remember. So what we want to do next is, there's a small little icon floating right beneath the temporary dimension, and it says make this temporary dimension permanent. If you click that, that's exactly what it does. You now have a permanent dimension that remains even if you deselect the door. Now I'm going to select that dimension, and I want to go a step further, and I want to lock in that value. And I can do that by just toggling the small little padlock that appears right beneath the dimension, like so. So now, if this column were to move, and the way that I move the column is to actually drag the column grid, notice that the door will move along with it. So let me undo that to put the column back again. So that's a really simple example of doing a length constraint. In the office next door, this window looks to be a little off center. So maybe I want to get it centered in this office. I could do that with dimensions as well, but this time, instead of starting with a temporary dimension, I'll just go right to creating a permanent dimension. So on the annotate tab, we can get the aligned dimension tool, and you can also find it here on the quick access toolbar, or you can type DI for the keyboard shortcut. Now, when I highlight the wall, it's going to highlight the face. So I'm going to press the tab key to get the center of that wall, highlight this other wall, press the tab key to get the center of that wall, and click. And that gives me the distance across the office. And then if I highlight near the window, notice that it will see the center line of the window, and I'll click again to add that as a witness line. I'm going to move this dimension up above the plan here and click an empty space to place the dimension. It's very important that you always remember to click an empty white space to place that permanent dimension. Now you can see that the two values are not currently equal. There's a small equality toggle right here, and all I have to do is click that, and you'll see the window move over, and it will now make them equal. And if I cancel out of this command with the modify tool, grab this wall right here and slide it over a little bit, notice that it keeps that window centered in the office. So when you apply these constraints, it's not a one-time modification. That constraint is a live rule that is now applied to your model until you turn it off. Now let me pan slightly and zoom out a little bit, and notice that there's another window down here which is not lined up with anything. Maybe I want that window to be lined up with the one in the office. So this time I'm going to use my align command. The align command asks you to select a reference first, so that's going to be the center of this existing window, and then to select second, some object that you want to move into alignment with that reference. So I'll pick the other window. And after you click the second point, it will offer you the opportunity to lock that alignment. So I'm going to close the small padlock, and now those two windows are locked together. And what I've effectively created here is a nested relationship. So I've got the equality here controlling the position of this window, but then when I move that wall that's controlling it, notice that this window also moves with it. So I've kind of nested together those two relationships. Now here we did equality for just a single object to center a single window in the room, but I'm going to pan over to this side of the plan, zoom out slightly, and notice I have 4 offices over here, and they're all different sizes. Well, you can do an equality that has multiple segments. You're not limited to just 2 items. You can have as many as you want. So I'm going to go back to my aligned dimension command. I certainly could use my tab key to tab into the centers of these walls again, but I don't actually want the center of the wall and the exterior because it's a different thickness than the ones in the interior. So notice here on the options bar that we actually have a drop down where you can choose different options for the dimensions without having to tab. So this time I'm going to choose the center of the core. And that means that I'll be able to click directly on this wall, this one, and this one, and get the centers of those cores. And then if you look carefully at the exterior wall, the center of the core of the exterior is closer to the inside face rather than the outside. And that really gives me the relationship that I want, so that when I click an empty space here to place my dimension and toggle on the equality, now those rooms are all truly equal to one another. Let me cancel the command with the modify tool. Maybe you don't want to actually see the EQ. So you can actually select this dimension that you just created, and over here on properties, modify it to show you the values instead. And now it will display the actual numerical values. Now doing that doesn't change the constraint. If you select any one of these walls and move it slightly, you're going to notice that all the other walls are going to move the same amount and the dimensions are going to be maintained. Now when I did that, I kind of put a wall in the middle of this window, so that's warning me down in the corner that I might not want that. So let me just do Control Z to undo that. Now let's look at one last constraint that we can do. Notice this door down here, I have a dimension, and actually I have a dimension for all of these doors, and I'm going to select this one at the bottom, which is currently set to 150. And what I want to do is set that 150 as my standard typical jam size. So we can do that with something called a global parameter. So when you select the dimension, if you look up on the modify ribbon, you'll have the label dimension panel here, and this small icon allows me to create a new parameter. And I'll call this typical door jam, and click OK. Now I'm going to select this dimension, and with my control key, these other 2 dimensions. And right now they're all different values. But if I come up here and choose the label dropdown, you will now see typical door jamb is an option. And when I apply that, notice that it moves all of the doors to make them all 150. Furthermore, next to any one of them, you have the small little pencil icon. And when you click it, it will display the global parameters dialog. And I could come in here and put in a new value for the typical door jamb, such as 200. And when I click apply, notice that all 4 doors will shift. So now you have global control over this relationship, this distance across the entire project. Any dimension that's labeled with the typical door jamb will have that behavior. Now, as the project progresses and people work on it, eventually at some point, they might make modifications, like maybe somebody comes in and deletes this dimension. They don't want to see that dimension. The question Revit will ask is, well, do you still want the equal relationship? Because the two are really separate. You've got the dimension itself and then you've got the equality. Well, if you say unconstrained, it will remove the equality relationship. But if you simply click OK, it will keep the equality even though it deleted the dimension. And again, you can verify that by just dragging one of the walls. And what you'll see is the other walls are still moving. So let me undo that. How do I get to see where all these relationships are then if it's not obvious looking on the screen? Well, if you look down at the view control bar on the right, you've got a small toggle here called reveal constraints. And when I click that, it will put a red border around the screen and tell me I'm in the reveal constraints mode. And now all of the constraints that are visible in this view will appear in this reddish color. And notice that there's my equality relationship even though the dimension is not there. And notice over on the right-hand side of the plan, there was another alignment here that was not visible. And there's another locked dimension right here that was not visible in the view. If you want to remove a constraint, you can do so right here in this display mode. You either delete the constraint by selecting it and just pressing delete, or you can select it and just toggle the lock icon. Either one will do the same thing and it will remove that relationship. When you toggle the reveal mode back off, everything goes back to the normal display and any relationships that you didn't remove are still applied. So the constraints give you lots of different ways to build your design intent directly into the model. I like to think of it as adding smarts, and whether or not it's equality smarts or a fixed distance or some sort of an alignment that you want to maintain, all of these rules will be maintained across the project as you continue to modify your model. It's pretty common to need to access files that were created in other CAD programs in your Revit projects from time to time. The most popular of these is, of course, AutoCAD with its DWG format. One of the most useful ways to access a CAD file is to actually link it into your Revit project. When you link it in, it maintains a connection back to the original file, so if that file should have to change, then you just simply reload the link to capture those changes. So let's go over to the Insert tab, and I'll click on the Link CAD button. Now, the files that are supported are DWG, DXF, DGN, and even SketchUp files. So I'm going to leave this set to DWG, and I'm going to select this AutoCAD floor plan file right here. Let's talk about some of the settings that we might want to configure when bringing this file in. The first thing we might want to do is decide what to do about the colors. So CAD files are in colors, and you can see it in the preview window over on the right. If you preserve the colors, they're in those bright primary colors there. They might not look so well on a white background. So if you want to keep it in color, I recommend choosing invert instead. Now, black and white is also an option. So if you're going to print the file along with your Revit file, you might want to choose black and white. Now, you can decide to bring in just the visible layers or specify even, but in this case, I think all layers is what I want to choose. Revit usually does a pretty good job of automatically figuring out the units in the file. That's what auto detect will do, but if for some reason that doesn't work, you can choose a specific unit. I'm going to leave this checked to correct the lines that are slightly off axis. That works pretty well for correcting any discrepancies that might occur and round off errors. Sometimes with really large files, you want to actually uncheck that, and you'll have to do some experimentation to see in which cases that would be. For positioning, we have lots of options. Origin to origin is the default, and for this example, I think that'll work just fine. If you don't like where the file comes in using origin to origin, you can just simply move it after it's been placed. So I'll choose origin to origin. But before we click open, I want to talk about this current view only checkbox over on the left. If you leave this unchecked, even though that CAD file is 2D line work, it will be treated in the Revit project as model geometry, like model lines. And so any view that you go to, 2D, 3D, it will show that line work. If you check this box, then it will only appear in the current view. It'll treat it like view-specific elements in Revit, and it will only appear here in the level 1 floor plan because that's the view that I'm working in. So in this case, I'm going to choose current view only to force it only to display in the current floor plan. I'm inverting the colors, bringing in all the layers, auto-detecting the units, and bringing it in at origin to origin. Let me click open and see what we get. Notice that it came in kind of in the middle of the screen. The Revit origin is right about here, and so you can see that the lower left-hand corner of the building was where the origin was. Seems to be perfectly logical. If for some reason, though, you wanted to move it, there are 2 selection options that you have to make sure are enabled before you'll be able to select this file. So if you move your mouse around and it doesn't highlight and you're not able to select it, then it could be one of 2 things that are causing that. If you look down at the lower right-hand corner of your screen, there's a series of selection toggle icons. And this one allows you to select links, and this one allows you to select pinned elements. Now, those same selection toggles are available on this drop down here beneath the Modify tool, select links, and select pinned elements. Now, links, of course, is what we have right here. This is a linked CAD file. So if you uncheck this, you would no longer be able to select this link. And that could be nice to do sometimes if you want to make sure that people don't accidentally move it, for example. Now, pinned kind of serves the same purpose. And if I uncheck that, I also won't be able to select it. And the reason for that is, I'm going to turn it back on. When we brought this file in origin to origin, Revit automatically pins it. So again, the idea being that because it's coming in at the origin, you probably want to leave it right there. And all pinned means is you can't move it. So notice that if I try and drag this, it won't let me move it. So if I did need to move it, I would unpin it before moving. And I'll undo that to put it back, and then I'll repin it. So if you want to be able to select this, just make sure that both select links and select pinned elements are enabled. Okay, I'm going to zoom in on this file. And what I want to do is actually trace over it. There's no command in Revit that's going to automatically convert your CAD file into Revit geometry. So your next best thing is to just sort of trace over. Now I'm going to go to the Architecture tab, click the Wall command, and I'm going to choose a generic 300mm wall. Whether or not it's pinned or not selectable or not selectable doesn't matter. You'll still be able to snap to the geometry in the file. You can snap to the edges, the intersections, the endpoints, whatever geometry is in there. Notice that if you put your mouse between 2 parallel lines, Revit will actually sense the 2 parallel lines and allow you to snap right down the middle of them. And that makes tracing this CAD file really easy to do. Now I'm going to go ahead and press escape one time, change to a different size wall, maybe this interior 79mm partition, and I'm going to draw a few more of these. Press escape again, zoom in so I can get a better look here. And notice that I'm not trying to snap these together. And I'm doing that on purpose because I want to clean this up with an extend command. Now I'm going to take this wall and just sort of manually extend that up. And then I want to show you the trim and extend multiple elements command. So the way this command works is you select a single element, and you can pick it anywhere, edge or center, doesn't matter. But I'm going to select that wall as my boundary edge. Then any wall that I click will automatically extend or trim to that edge. If you want to reset the boundary, you just click an empty white space and then pick a new boundary and keep going. When I click this boundary, I can also use a crossing selection like so and select multiple elements at the same time. The boundary is still active, which means that I could click an additional object and keep going. And once again, if I'm done with that boundary, I'll click an empty space to reset it. Pick a new boundary, extend these 2, and then if I want to trim this one back again, just click the part you want to keep. So I'm going to keep the lower portion and trim the rest away. I'll go to Architecture, click the Door command, choose an appropriate size door, maybe something that's a little bit smaller, and start placing it in the locations where it needs to go. Tap the space bar to flip it, And you can see that tracing over the CAD file will move fairly quickly. You can sort of see that the Revit geometry is starting to cover up the color geometry underneath. And that's the reason that I like to bring the CAD file in color. It just makes it easier for me to tell where the CAD is and where the Revit is. However, if you go to some other view, like a 3D view, spin around, there's all your Revit geometry, but notice there's no CAD geometry here. That's because we checked that box to say current view only. I'm gonna go back to the level 1 floor plan, and let's say that the owner of this file has made changes. And so now they've saved those changes and they've informed me that there's been an update. In order to reload a link, you go to the Insert tab and click the Manage Links button. Click on the CAD Formats tab, select your link, and if they just saved over the original file, you just simply reload it. However, in this case, when they sent me the new file, they changed the name. So instead, what I'll do is I'll select the file and I'll choose Reload From. I'm gonna pick this one right here, AutoCAD Floor Plan Updated, and I'll click Open, and then OK. And you'll notice on the left-hand side that the wall has moved over. So if I zoom in a little bit here, notice that the Revit geometry does not automatically update. So this is important to understand that the CAD file did update underneath, but you're still gonna need to manage your Revit geometry separately. So I can just simply move that from endpoint to endpoint like so to keep my Revit geometry up to date with the underlying CAD file. So linking in a CAD file can be a great way to coordinate efforts from a team that's comprised of Revit users and CAD users. And then by refreshing the links when changes are made, you can update your Revit geometry accordingly. In this movie, I want to look at another very common scenario for importing CAD files into your Revit projects. And that scenario is when you're working with a civil engineer and you want to create topography from their imported files. Now, there isn't a dedicated Revit package for civil engineering. So civil engineers are most likely going to be using AutoCAD or some version of AutoCAD or some version of MicroStation, which means that the files they're going to be sending you are going to be either DWGs or DGNs. Now, the example that I'm going to work with is a DWG, but the process should work largely the same with a DGN. So the first step is going to be to link the CAD file like we did in the previous movie. So I'm going to go to Link CAD. I'm going to select the site plan here. And once again, I want to single click it so that I can see the settings down at the bottom. Now, for the most part, I'm going to accept all the same defaults that I used in the previous movie. I'm going to invert the colors, bring in all the layers, auto detect the units, correct lines through off axis, and work with origin. The only thing that I want to change this time is I don't want to use current view only. This is really important because my intention is to use this CAD file to create 3D topographic geometry in Revit. And I can't do that if I flatten it out to a 2D view specific item. So with it unchecked, it will actually preserve the 3D nature of this file. So let me go ahead and click open here. It'll take a moment or two while it loads, and then you'll see the CAD file appear on screen. Now, we're zoomed in kind of close here, and if I actually start to roll my wheel back here, you can see that this file is very, very large. So in some cases, you're going to get these very, very large files here. And our original file was just zoomed in this very small area right here. Okay, so what do I want to do with this file? What I actually want to do with it, first of all, is try and understand it a little bit. So let me zoom back in a little bit in that open area there in the middle. And you can see that we've got a series of contour lines. Some of them are very close together, some are far apart. But I can tell that there's two different colors, this dark one here and this lighter one here. So what I want to know is what layer those contour lines are on. So to do that, I'm going to select the CAD file, and that will highlight the entire thing. And then on the ribbon, a query button will appear, and I'll click that. Now, notice that I'm able to move my mouse around inside the CAD file now, and it will actually highlight the lines and edges within that file. So I'm going to click on one of these dark lines, and what I'm interested in is what the name of that layer is. And you might want to jot that down somewhere. And then once you've got the name of that layer, you can click OK, and you can do it again on the lighter color layer. And you can certainly repeat that for as many layers as you need. But in this case, I'm really only interested in the minor and major contours because those are the only layers that I want to actually generate 3D geometry from. So I'm going to ignore any of the other layers here, and I'll click the Modify tool to cancel out of the query command. The next thing that I want to do is look at creating topography. Now, I'm currently in the level 1 floor plan. So what I'm actually going to do is switch over here to the site plan. I'm going to do zoom to fit because the topography object is actually hidden in the level 1 floor plan. If I want to actually see what I'm doing, it'll be better if I work in the site plan view. So now I'm going to go to the Masking and Site tab, and there's a command here called Topo Surface. Now, when you click that, it'll temporarily gray out the drawing window, and what you'll see is that you're in this mode where you can place points. So a topo surface has a series of points that are set at different heights, and it creates this sort of free-form surface based on those points. Now, I certainly could come in here and input an elevation, and then go in and start clicking points, and I'll just show you what this might look like if I do a couple points out here, and start creating a surface from those points. Now, if your surface is very simple, that's a real easy way to do this. But as you can see from this file that I've brought in, first of all, it's very, very large. And secondly, if I was trying to place all those points manually, it would take an exceedingly long time. So what I'm going to do is go to my Modify tool. I'm going to window all these points that I just created, and I'm going to delete them. Instead, what I'm going to do is instead of using the Place Point tool, I'm going to use the tool next to it, which allows me to create points from an import instance. In other words, from my CAD file. So I'm going to go ahead and select this Import Instance option, and then I'm going to click anywhere on my CAD file. Now, the reason that I wanted to query and write down the layers earlier is because what it does is it displays all of the layers in that CAD file. I'm going to click Check None to clear all of the checkboxes, and then looking at the notes that I jotted down, I'm going to check only the 2 layers that I'm interested in. And when I click OK, it does take a few minutes for it to generate the points, but it's significantly less time than it would take if I had done those points manually. Let me zoom in and show you what I mean. Let's zoom in on an area here and just look at the sheer number of points that were created from those layers. All of those points have been created and given an appropriate elevation based on the imported CAD file. So most of the work has been done for me automatically, and all I need to do is click this green Finish checkbox right here to finish and create the surface. Now what I'm going to do is click my default 3D view icon. That's going to take me out to 3D, and you can see that the surface is here and the CAD file is here, but right now the CAD file is a little distracting. It's kind of in the way. So what I'm going to do is select it, and there's an icon down here that kind of looks like sunglasses. And if I click that, it allows me to temporarily hide whatever I have selected. So I'm going to choose Hide Element off that pop-up, and it'll put me in this temporary hide isolate mode, but now you can see the topo surface isolated all by itself. The next thing I'm going to do is go to this little cube icon right here and choose Shaded, and that will make it a little bit easier to see rather than the hidden line. And then finally, I'll hold the Shift key down and start to orbit this thing and show you what it's created. Now, if I zoom in a little bit, you can kind of see where we get little dips and valleys, and the surface is following the shape of those contour lines. Now, it's fairly subtle because of the vast expanse of this surface, but if you were to look at it head on, you can start to see that it does definitely have a slope to it. So there's clearly a height differential between the lowest point of the topo surface and the highest point. And then you could use this to start building your building model on top of. So topo surface gives you kind of a ground plane upon which your building can sit, and you can create it manually point by point, but a much faster way to create it is if you have a good survey file from a civil engineer that has contour lines set at the correct Z heights, and then the topo surface will just simply read those Z heights and create all the points for you automatically. There's lots of ways you can potentially use CAD data in your Revit projects. And in this movie, I'd like to look at another scenario where we will import a detail file that's been created in CAD and use it within our Revit project. Now, most firms have libraries of standard details that they've been accumulating over the years, and it might have taken some time to generate these, and they get reused over and over again. Now, you certainly could redraw all these details natively in Revit, but it would take some time. So an alternative is to actually just import the AutoCAD files directly and print them right along with your project set. For those truly typical details, you can get away with doing that. So I'd like to go through that process here, and I'm also going to do it slightly differently than we did in the last two movies in that I'm going to use the import CAD this time instead of the link CAD, just to kind of compare and contrast some of the differences. The first thing is I need to know where I'm going to put this detail. Now, if I look at my project browser, I've got some floor plans and some elevations and so forth, but I don't really have a suitable view in order to place this CAD detail in. So Revit actually provides us a view type specifically for this purpose. I'm going to go to the View tab, and it's called a drafting view. Now, a drafting view is unique in the sense that it's just a blank sheet of paper that's not at all connected to the model. In other words, you won't see the model at all. It's disconnected from that. You can use a drafting view for diagrams, for details, of course, or for sketches, anything that doesn't need to be connected to the model. So I'm going to call this AutoCAD imports, and it's suggesting a scale of 1 to 10, and I'll go ahead and accept that and click OK. So that puts me in this blank sheet of paper, and as you can see, it doesn't display any part of the model. The next step is to go to the Insert tab, and previously we did Link CAD, and you certainly could use Link CAD for details, and some CAD and BIM managers actually insist on that. But I do want to show you the alternative just so you have both tools at your disposal, and I'm going to click the Import CAD in this example. Now I'm going to single click the detail file at the top of the list here, and then consult the settings down at the bottom just like we've done in the last few movies. I'm going to change the settings a little bit this time. Instead of using Invert or Preserve this time, I'm going to force all the colors to black and white. I am going to choose all the layers and auto-detect the units again, and go ahead and correct lines to the rough axis. I think those are all good basic settings in most cases. Notice that current view only is grayed out in this case because I'm bringing the detail into a 2D drafting view anyway, so there is no model, so we really couldn't choose the option to have it be model geometry. As far as positioning goes, and particularly with the detail, I don't really have any idea where the origin of this file is. So you could certainly try origin and move it if you wanted to, but what I'm going to do is actually place it manually, and I'm going to put my cursor at the center. So if I choose manual center, when I click open here, what you're going to see is my cursor is kind of in the center, roughly between a bounding box that would sort of surround this detail. And that's just going to make it really easy for me to just click anywhere to place it. So sometimes that can be easier than placing it at origin and having to zoom and find it and move it into position. Let me go ahead and zoom in region on this detail and take a look. So you can see that the detail is here, but if we zoom in a little bit closer and investigate, it's a little bit lifeless. You can see that all of the lines in this detail are the same line weight, and they're all kind of just thin. It doesn't have any punch to it, right? So let me zoom back out a little bit and give myself some room over here. And I want to talk about how we can actually control that. You are no doubt aware that most CAD files are organized on layers, and those layers are assigned to colors. And those colors typically correspond to line weights. So when you print an AutoCAD drawing, they print out at print time and get line weights assigned to each of those colors, and therefore the drawing gets a little bit more punch. Well, none of that information got interpreted here when we brought it over into Revit, but we can actually make it do that using this small little icon right here. So on the import panel, there's this little dialog launcher icon. It's a little difficult to find if you're not looking for it, but if I click it, it will display a dialog that lists out 255 entries corresponding to the AutoCAD color index in AutoCAD, and then over here, the corresponding line weight that we want to use in Revit. Now, I should point out that down here at the bottom of the screen, there's a little note that says these values only apply to layers whose line weight is set to default. In other words, layers that don't have a line weight assigned to them, it will use the color index to determine those line weights. If, however, you have a CAD file that has a line weight assigned, then Revit will just use that line weight. It'll ignore the color. So that's kind of important to understand. But in this particular detail, everything's assigned to colors. Now, I could go through here and I could start manually typing the line weights I want for some of these values, but that would be sort of tedious. And in order to do that effectively, I would need to open up the file in CAD and click on each of the layers and figure out what colors they are. What I've done is I've created a collection of settings already and saved it. So you can see over here that there's two buttons, Save As and Load, and we can actually take any settings that we create and turn them into an external file. Now, it's asking me if I want to preserve the typing that I was just doing right there, and I'm going to say no. And then I'm going to browse to my exercise files, and I've called this file detail line weights, and it's just a simple TXT file. And when I open that up, what it will do is it will replace all of the settings that are in here. And if you start to scroll through this list, you can see in some cases, like number 31 is assigned to pen weight 3, and number 194 is pen weight 6, and so on. So it's assigned different line weights to the colors based on how they're set up in that CAD file. Now, it won't change the one that's already here, but if I import that exact same file a second time, I'm going to leave all the same settings, click open, place it right here, you can already start to see that if I zoom in, that it's now using line weights to each of the colors that were in that CAD file. And so it gives this file a little bit more punch and a little bit more readability. So we could just come over here, delete this instance of the file, and then this is the one that we could drag onto a sheet and print out with our document set. So if you have some legacy details or other drawings, diagrams, code requirements, things like that that are already drawn in CAD and you want to reuse those in Revit, you can either link or import them in, but just remember to use this import line weights setting first in order to make sure that they preserve whatever line weight settings match your office standards. Now, I have also provided a reset file here, so if you want to reset all the line weights back to 1, you're welcome to load that up before you continue. Let's wrap up our look at importing and linking CAD files with a few tips and a few issues that you might want to be aware of when working with imported or linked CAD files. Now, what I have here on screen is an imported CAD file. It's just a detail. What I want to do is dig a little bit more into the query command. Now, we have talked about the query command before, and you may recall that if you select the link or imported CAD file, that the query button will appear here on the ribbon. I'm going to click that, and then I can reach into the CAD file and select any object that I want to get information about it. So I'll select this hollow metal frame element right here. And what we focused on before was just simply what layer that item was on. But I alluded in previous movies that if you brought in all of the layers from your CAD file, that you could actually change your mind later and you could either hide or remove some of those layers. And that's what I'd like to talk about right now. So this A detail bold layer, let's say for some reason I didn't want to see that anymore. Well, there's two options here. We could delete it or we could hide it in the view. I'm going to do hide in view first. So when I do that, it turns out that that was the only object that was on that layer, so it's maybe not that dramatic. So let's do it again with these leader lines right here. Those are on a layer called A and O note. And if I click hide in view there, you can see that's a much more dramatic result because it actually hid all of the text and leaders. Now, let me click the modify tool to cancel. And if that's the result that I wanted, then I would be done. But let's say that I look at this and I go, hey, what happened to the hollow metal frame? And I'm pretty sure that it was there before, so I want to kind of bring that back again. How do you bring back a layer that you've previously hidden in the view? Well, you go to the View tab, and you're looking for the Visibility Graphics command. Notice that the shortcut for that is VG, and most users will tend to favor the shortcut in that case, so you just type VG. CAD files are on the Import Categories tab, and what you'll see is any CAD file that you have in your project will be listed here with its name, and then beneath that, it will have all of the various layers that are in that file. And as we can see, A detail bold and A and O note are both unchecked. So if we wanted to restore one or more of these layers, we could check it and click apply, and you'll see it return there, or we could check it and click OK, and you'll see it return there. So it's very easy to bring that layer back again. Now, another thing you can do in VG is you can actually select the layer, click override, and change the line weight, the color, or the line pattern. Now, I'll let you experiment with that on your own. I'm not going to make any of those changes. I'll just cancel out of there. Okay, so that's how you could actually hide a layer in a view, and I think in most cases, that's probably the safest thing to do. However, if we go back to query again, and I'll select that same hollow metal frame again, you can also choose delete. Now, when I do that, it will remove the layer. It looks the same as it did before. I'll click the modify tool to cancel. But what happens if I go to VG this time? Now notice that layer is gone completely. It's not just simply unchecked. It's actually been removed from the file. Okay, so obviously that's a little bit more permanent. So in this case, I'll do Control Z to undo that and bring it back. So I tend to think that hiding it is probably sufficient in most cases, but if you're trying to reduce file size, then doing delete might actually be helpful. Now, this file has actually been embedded. If I go to the Insert tab, it used the Import CAD button. Now, most CAD or BIM managers would probably tell you that you should never use Import CAD. You should always use Link CAD. And for the most part, that's true, and that's a best practice sort of recommendation. However, I tend to think that there are certain cases when it might be okay to import CAD as long as you do it properly. So let me explain what I mean here. So really, what's the reason why we don't want to import CAD? Well, in general, it tends to increase file size, and it's fine if you only have one or two of these, but if you have dozens and dozens of these CAD files brought into your Revit project, it can actually start to affect performance. The linked files tend to perform a little bit better. They tend to be a little bit smaller. So that's one of the reasons. But the other reason that most CAD and BIM managers don't like import CAD is because when I select this CAD file and I go to the Modify tab, users sometimes discover that there's an explode button over here, and it's often way too tempting for people to resist. So if I click explode, what exactly happens? Well, at first it actually seems kind of attractive because what it did was it actually broke this detail apart into a bunch of separate entities. And these are text entities, and these are line entities right here. And so it kind of seems like, hey, that's kind of a nice thing, and I can actually manipulate this stuff. Well, there is a downside, as you might expect. When you explode a CAD file, it tends to bloat your file with all sorts of unnecessary line styles, text types, render materials, etc. So let me show you what I mean. If I click on one of these lines here, notice that it created a line style for itself called A Detail Find. If I open up this drop-down list, it not only did the A Detail Find, but every layer that was in that CAD file created its own line style. Now that may or may not be a bad thing, but it's certainly going to be difficult to enforce Office standards if you suddenly get all of these different line styles coming from different source files that don't match your standard. The same is true with the text types. When I click there, you'll notice that the name of this text type is AutoCAD Detail Arial Narrow, which is probably not an Office standard name, and it might be very similar in settings to an existing type, and so we'll have some notes that are using one type and others that are using another, and it'll be difficult to enforce consistency. A little more troubling is if I go to the Manage tab and click the Materials button, that will display the Materials browser, and then if I scroll down, you're going to see that several materials, starting with the word render material, have been created, and they all have these numbers after them. Now, those numbers are the actual RGB values of the layer colors that previously were in the CAD file. And even though they're all using this sort of generic gray render material, they've got that color assigned based on that RGB value. Now, these render materials are not very useful at all, but they just contribute to overall file size and bloat. So let's say that you can't avoid it, that you've identified a need that you need to explode a CAD file. What do you do to avoid all that bloat? Well, the best practice way to do it is to actually create a temporary Revit project first. Load the detail into that temporary file and explode it there. Then you can select the lines, and you can go to the line styles, and you can choose actual Revit line styles like thin lines, or I can choose thick lines, and choose ones that match my Office standards. I can select text, and I can choose ones that actually match my Office standards. Once I've gone in and I've configured and reassigned all of the different parts and pieces to the correct settings that match my standards, I can select all of those elements, copy them to the clipboard, and paste them into my project. When I do it that way, it will only bring over the geometry, and it will leave behind all those extra types and styles and settings that I don't want to have. So it takes a little bit more effort to do it that way, but it's considered a much cleaner way to do it. So if you absolutely have to explode a CAD file, then that's considered the best practice way to do it. This movie, we're going to talk about groups. Groups provide a way of taking a collection of geometry and packaging them up together and giving them a name, and then we can reuse that instance in several places throughout our model. If we make a change to one instance of the group, that change will propagate to all of the instances. So it's a very powerful way to manage any repetitive or sort of typical elements. So I have a version of our two-bedroom condo unit here to illustrate this purpose, and you might expect that in a condominium building that we might have several instances of this particular layout. And so it's a good example for us to use the group feature. Now to get started, the first thing we need to do is just simply select the objects that we want to group. So I'm going to make a window selection around all of the geometry here in this view. When I do that, up on the ribbon, I will see a Create Group button, and the shortcut for that is GP. So I'll select that. And what will happen is that I'm actually going to get a dialog here with two entries. What's going to happen is Revit's going to create two groups. It's going to create a model group, which contains all the model geometry, so the walls, the doors, the fixtures. That will be in the model group. It's also going to create an attached detail group, which is going to contain these room tags and these door tags. You can't have a single group containing both model geometry and detail geometry. They have to be separate. But we'll talk about how they vary in a moment. So I'm going to call this two-bedroom unit. And for the annotation group, I'm just going to call that tags. And I'll click OK. So what'll happen is there'll be this dash box that appears around the entire group. If I deselect, it will deselect all of the geometry, and then I kind of move here, you can kind of see that highlighted dash box, and then if I move next to the tags, notice that a separate dash box appears. So if I click there, that's the attached detail group, which contains only the tags, and this is the model group, which contains only the model geometry. So let's see how we can utilize this group. Another place where we can see the groups is to scroll down here on the project browser, and there's actually a groups branch on the browser. So if I expand that, you can see there's two sub-entries, detail and model. I'll expand model, and then you'll see our two-bedroom unit listed there. Notice that I can expand it one step further, and indented beneath that is floor plan tags. So that's the attached detail group, and it's showing us here hierarchically that it's associated with that two-bedroom unit. Now, if I take one of these, I can actually insert one directly from the browser, and I can do that by just dragging and dropping right out of the browser, or you can actually right-click here and say Create Instance. And that would do the same thing. Now, when you do that, it will put it on your cursor, and you can place it wherever you want it to go. Now, notice that the insertion point of this group is right in the dead center at the moment here. So let me cancel out of the command with the escape key and select either instance of the group. You can actually change where that insertion point is with this small little icon here, which shows X and Y. And if I grab the little dot between those two and start to drag it, I can move this insertion point anywhere I like. And I'm going to kind of move it up here to the top left-hand corner of the group itself. Now, notice if I select the other instance, it's already moved there as well. And now if I drag in another copy of this group, notice that this time I'm inserting it from that upper left-hand corner. So that's just a handy way to give you a more convenient way to place this group. Okay, so what does a group do for us? Well, I now have three instances of the model group, but only one of them shows the attached detail. So let's look at what we can do here. I'm going to select the model group itself first. Up on the ribbon, you'll get some context buttons, and one of those is to edit the group. So let's do that. That will change the screen and kind of tint the background with this light yellow color, and it will display this sort of floating toolbar right here. And you can use that to manipulate the group. Well, what I'm going to do is do something very simple here. I'm going to actually select this window and then use this command right here to create a similar window. So create another window with the same settings, and I'll place that second window here in the bedroom. I'll click the modify tool to cancel. And at the moment, we don't see that window in either of the other two instances. But when I click this finish button right here to finish the group, and the shortcut for that is FG, you can see that it applies that change to all instances of the group. Now imagine a large condominium complex or a large hotel building where you made a change to one of your units and then click finish. That change would propagate across the entire project. So it's a very, very powerful feature. Now let's go a little deeper into the attached detail groups and see what that does for us. At the moment, you can see that this one here on the left is showing all of the individual tags. Well, it turns out that you can select any of the other instances of the model group, and then on the ribbon, there's a button called Attach Detail Groups. And when I click that, it will display any detail groups that we have. In this case, there's just the one. I'll check it, and I'll click OK. And it will add an attached detail group to the second instance of the group. And more importantly, it's very smart about how it adds it. If I zoom in over here in the entry area, notice that this is door 1, this is door 6, and this is door 14. Let me zoom out and come over here. And notice how the doors over here have sequenced accordingly, but they've maintained unique numbers. And in fact, if I select this group, zoom in, add an attached detail group, it will continue to do that. So each instance of the group will have its own unique designations for the doors and for the rooms, but it's preserving the same room names. So it's very smart about how it manages that data. Okay, so what if you decided that you wanted to create a variation? Well, I could select one of these instances of the group here, and in this respect, they're going to behave a lot like families and types. We've seen in previous movies that we could edit either the instance properties of an object or the type properties of an object. And I've mentioned that you can actually make duplicate types, although we haven't really done that too much yet. Let me show you how that works here. I'm going to select this instance and use the edit type button here, the same as I would with families and types. Well, there's no properties that we can manipulate, but up here at the top, we have the option to duplicate and rename. So what I'm going to do is choose duplicate, and I'm going to just give a designation over here, one window. Now what I mean by that is, I'm going to click OK, and I'm going to go back into this group, edit it, and I'm going to remove that window I added. And I just use one window to remind me of that. Finish it. Notice that that change does not apply to these two instances. However, now if I select either instance of the group, I could go to this dropdown and I now have two different choices, and I could easily swap out one group instance with another. So now imagine how powerful that would be if you had different types of 2-bedroom units, or you wanted to change a 2-bedroom to a 1-bedroom, or in a hotel situation where you wanted to change a queen suite with a king suite. Using that feature allows you to be able to do this. So the group tool is a way where you can manage any kind of repetitive portions of your design. You combine them together into a group, you give them a good descriptive name, and then anytime you make changes to that instance of the group, those changes will apply across the project. Once you have a group of something like your 2-bedroom condo, it only takes a little bit more effort to turn that into an entire floor plan layout. So in this movie, we're going to take the mirror command and actually duplicate our group a few times to create the layout of the overall condominium building. So I've got one instance of my group right here. I'm going to select it. And up on my modify tab, I have two mirror commands. I have the mirror pick axis and the mirror draw axis. So let's look at each one. I'll start with mirror pick axis. With mirror pick axis, you select an existing object in the model and use that as the axis of reflection. So in this case, the upper wall here in the floor plan will do the trick quite nicely. So I'll select that wall, and it will create a mirrored copy of the group up above the first. And as you can see, it's flipped up in that location. As you can also see, we're getting a warning down in the lower right-hand corner indicating that we have two walls that are overlapping one another. Now, generally speaking, having two walls overlapping one another is considered a bad idea. So it's definitely something we're going to want to address. However, the kind of warning that we're seeing down there, notice it doesn't have any buttons or any OKs or cancel or anything like that. Revit terms that an ignorable warning. In other words, it's just basically a message, kind of a just so you know sort of thing, letting you know that there's something you might not be aware of. And if I click anywhere on screen, it'll actually just dismiss that warning. Now, that doesn't mean that the problem doesn't still exist. It's just basically my saying, yeah, okay, I'll take care of it later. Well, let's go ahead and zoom in and investigate that problem a little bit more carefully. So I'm going to use zoom in region, and I'll zoom in on this location right here. Now, when you zoom in, you can actually see that that wall doesn't really display very well right now. And that's because there's two walls in the same place and they're kind of conflicting with each other. I'm going to put my mouse right over the offending wall, and that highlights one of the instances of the groups. I'll press the tab key. That'll highlight the second group. I'll press tab a second time. This time, it's going to actually reach right into the group and highlight the offending wall. I'm going to click to select it, and notice this small little icon that appears on the wall labeled group member. You can click this icon to exclude that instance of the wall from the group. Now, to show you what that actually did, I'm going to select the group itself, and I'm just going to move it slightly here to kind of pull it away from its neighbor. Now, this will generate a different kind of warning. This warning actually cannot be ignored, so this one's a little bit more serious. Well, the only options we have here is to cancel or to click this button here to fix groups. I don't want to fix groups because I was just demonstrating to you what we've done. Do you see the ghosted in wall right here? We have literally removed that instance of the wall from the group. Now, when you pull them apart like this, it kind of breaks all sorts of things, and so that's why this error message is appearing. So I'm just simply going to click cancel here to snap it back where it was and not make that change. But I wanted you to see that when you do exclude member, you are literally removing that member from one of the instances of the group. It's kind of like an override. Now, let me do zoom to fit, ZF, and let's select both of the model groups this time using my control key, and now I'm going to mirror them over to the right. This time, I'm going to use the mirror draw axis command. Okay. Now with this command, we don't have an object to pick. We have to draw the axis of reflection. And the reason I'm doing that is because in this portion of the plan here, we're going to have corridors and stair towers and things like that. And I don't have that geometry drawn yet. So I'm simply going to pick any point about right here, and I'm going to pull my cursor straight up in a vertical direction and then click again. And that will become the imaginary axis of reflection. And as you can see, it will mirror everything over to the other side. Now, if I want to indicate exactly how big this gap is here, I can zoom in a little bit on that area. And typically we would do that with temporary dimensions. But as you can see, there's no temporary dimensions displaying. Well, one of my favorite tools in Revit is this activate dimensions button right here on the options bar. When I click that, Revit will actually do just that. It will activate the temporary dimensions and turn them on in lots of locations. Now, the ones up here I'm going to ignore. This is the one that I care about right down here at the bottom. So I'm going to click right on that temporary dimension, and I'm going to type in 3000. And that will pull those two instances a little bit closer together and make a 3000 millimeter gap in the middle there. Now, later I can come in and draw in some additional walls and add the stairs and the elevators, but that gives us an overall layout of 4 units on this floor plate. All that remains for me to do now is select the 3 copied groups and give them tags by clicking the attach detail groups button, checking the box, and clicking OK. So once you have a group, mirroring and copying it around to create a floor layout is a pretty easy thing to do. Whenever you have a situation where you have 2 groups overlapping each other, just remember that you can tab in and isolate the individual offending object and remove that from the group. It functions as an override to just that instance of the group, and it can really make the difference between the graphical display of the overall floor plan. In this movie, we'll look at the process of linking in a Revit project. There's lots of scenarios where you might want to link in a project. Perhaps you're working on a project that has multiple buildings on the same site. Perhaps you're working in a multidiscipline situation where you have an architectural model or structural model and mechanical model, and you want to coordinate the efforts between those trades. Whatever the scenario might be, linking in a Revit project is a very simple process, and it will maintain a link back to the original file. So if the original file changes, you'll simply be able to reload those changes directly in that link instance without having to re-import it. So I'm in a level 1 floor plan, and usually linking in a floor plan is a good choice. And I'll come over here to the Insert tab, and I'll click on the Link Revit button. Now for this example, I'm going to do a really simple scenario. So I've got this little simple building here called Shed. And it's just a small outbuilding, and I'm going to link that into my current file. Now there are a few different positioning options available here on this dropdown. We've got origin is our default option, and then we also have have center to center and by shared coordinates as well. Now, origin is usually a pretty good choice if you know that the two buildings share a common origin. Like, for example, if you're linking an architectural model to a structural model and an MEP model, then they probably share the same origin, and origin would line them up perfectly with one another. In this case, because I'm linking in a shed building to my office building, the chances that they share the same origin is probably pretty slim, but you can go ahead and try origin to origin anyway and see what results you get, and then you can always move the file. Shared coordinates is a more advanced option, and we'll look at that in a later movie. So let me go ahead and click open here, and you can see that origin didn't give me a great result. They kind of put the shed building right on top of the office building. Now, somebody on the project team knows where the correct location of this building model should be with respect to the office building. So maybe they're looking at the survey and they figure out the exact distance that it needs to move horizontally and vertically, and then maybe there's rotation involved. Well, in this example, I'm just going to do that kind of manually. Okay, so I'm just going to kind of grab this model, drag it over here. Let's say that the outbuilding is over in this location, and then just to make it a little more interesting, let's click the rotate command, click up start angle, and then a new angle about 30 degrees, and just rotate it. Let's pretend that that is the position and orientation of this shed building. Obviously, in a real project, you do that a little bit more precisely. So I'm going to take a look at that in 3D, and I can orbit around, and you can see that I've got the two buildings here positioned relative to one another. Now I'm in the office building, so here I can touch all the individual objects, the walls and the roofs and so forth, and then here you can see that it highlights and selects as a single object, as you would expect a link to do. And that's pretty similar to what we saw when we did CAD links earlier on. Now, if you're having any difficulty selecting the link, I want you to recall something we talked about in one of the earlier chapters about selection. Recall that down at the bottom of your screen, there's a series of selection toggles here, and those same selection toggles can be found here on the drop down beneath the modify tool. In order to be able to select and move the link, you must be able to select it with this checkbox here. So make sure that select links is checked and enabled, or that this little icon here does not have the little red X on it. And if you don't have that, if you toggle that off, then you won't actually be able to select this link file at all. So that's kind of important to make sure that if you want to be able to select and move that link, that you've got that feature turned on. So where is this link going to show up other than on screen? Well, there's actually a branch for it on Project Browser. So if I scroll down, you'll see that at the very bottom of the Project Browser, there is a Revit links branch. I'm going to expand that, and then you'll see that the shed file is listed there, and it's got this little blue arrow next to it to indicate that that's currently loaded. Now, if I right click on the shed, there's some options on the right click menu. And what you'll notice here is we can reload it, we can unload it, we can change its location and so forth. And then right here, it says open and unload. Now, why does it say and unload? Well, it turns out that you can have both files open as long as it's on two different computers, but you can't have both files open on the same computer. So if a person is working in the office building and another person is working in the shed, and as long as they're working on two different computers or specifically in two different copies of Revit, then it's okay. But if I try and open both files in the same copy of Revit, it won't allow me. So that's why it says unload here. So in order to open the shed and make changes to it, I have to unload it from the office building, or I would have to come up here to the application menu and close the office building first and then open up the shed. So I could do it either way, but in this case, it's gonna be a little quicker to do open and unload. It will warn me that I can't undo this, and that's fine. I'll click OK. And now I'm actually in the shed model. Now what I want to do here is just make a really simple change that'll be noticeable and obvious when we load it back into the other project. So I'm going to select one of these windows here, and I'm going to copy it, and I'm going to select this door here and change it to a double door. So I now have a larger door. I've copied the window. If I go to the switch windows here on the quick access toolbar, you can see that the Link Revit project is still active. And if I switch back over there, notice that the shed is no longer displayed. And that's because if I scroll down here, you'll notice that there's a big red X next to the shed file. So the link is still here. It's just currently unloaded. And that's what it meant when we said open and unload. But if I come back over here and return to the shed, and I'm just going to select this thing and close it, it'll ask me if I want to save it, and I have to say yes to save those changes. Back here in my office building, what I want to do now is simply right-click the shed here and choose Reload. Because I've closed it, it'll allow me to do that, and you can see it gets the little blue arrow next to it, and when it reloads, it now reflects the changes. I've got the three windows here, and I've got the double door. So bringing the link file into Revit allows you to break up the project into logical pieces like separate buildings or separate disciplines and have different teams working on each piece, and then every so often you can reload the changes that folks have been making as they're saving those changes and use that to coordinate your efforts with those other files. In this movie, we're going to look at the process to position a link file very precisely relative to its host model, and we're going to do that specifically using the rotate command and or the align command. So I want to actually show you two different methods that we can use to do this. So the file that I have here on screen has a copy of our office building down here in the corner, and we're zoomed out pretty far, and you can see that we've got this other thing floating up here, and that's actually a linked Revit model, and we talked about how we could establish a link in the previous movie. Now, it's not very clear exactly what this linked Revit model represents, and that's because I'm in level 1 floor plan. So on the project browser, let's go to the site plan instead, and when we do that, you'll see a little bit more clearly what that linked Revit model is. It's actually the site information for this building. So I have a topo surface out around here, there's some roads, a parking lot, and a property line and some trees. So the building should actually be in this general location over here. Now, what we're going to do is actually take this linked site file, and we're going to move it down to where the building is and then position it relative to the correct orientation for the building. Now we can do that using either the move and rotate commands or using the align command. And I'm going to show you both methods. In order to achieve that, I want to point out two things here in the file as it currently stands. If I zoom in over here at the end of this small sidewalk, you can see that there's this little green line right here. That's what we're going to use as the alignment reference. So in the site file, I simply drew this line as a reference point that we could use to help us with the moving and rotating. I'm going to do previous pan zoom here. Then I'm going to zoom in on the building, and I want to position that green line relative to the front door, which is right about here. Now we can't really see the front door right now. So to make it easier to work with this file, what I want to do is change the display mode here from hidden line, which is the default and usually preferable. I want to temporarily set it to wireframe. When I do that, you can see that the door now displays, and it makes it much easier for us to see and to snap to what we need. So let me do the previous zoom here again. And then to get started, I'm simply going to select the link file and then manually drag it close by. Now, it's always a good idea to do that first because it will save us a little bit of extra zooming and panning, because now I can zoom in on this general location, and it's a little bit easier for me to see what's going on as I start to position this thing. Now, the first method I want to show you is the rotate method. So if I keep the object selected and then click the rotate tool, what you're going to see is this line appearing on your cursor here, and it's emanating from this little blue dot. That blue dot is the center of rotation, and if you were to actually zoom out here, you would see that that's kind of in the center of that dash box that goes all the way around the selected file. In other words, if you just put a box around whatever you have selected, Revit just arbitrarily picks the center point of that as the point of rotation. Now, you could certainly come in here to the options bar and just type in a number. So for example, if I wanted to rotate that thing 20 degrees, notice that it will do just that, and it will rotate around that arbitrary point that we saw over there. Now, there's two problems with that. One, one is that point is fairly arbitrary, so it's not a very good point for us to rotate around. And the second is 20 degrees was really just a guess. So I suppose you could go in and try and calculate how much of a rotation we need and put it in exactly, but there's going to be an easier way to do that. So what we're going to do is return to the rotate command, and the first thing I want to do is move that arbitrary rotation point. Now to do that, you can click this button right here to place the center of rotation. You can tap the space bar, or you could actually just click that little dot there. That will give you a cursor that allows you to place the center of rotation. And I'm going to roll my wheel to zoom in just a little bit, and I want to place that center of rotation right there. There's a tiny little vertical line there, and I want to place it right at the midpoint of that vertical line. So that center of rotation is now right at the intersection between the long green line and that little short green line right there. Now I can move this starting angle anywhere I want, and I want the starting angle to go along this green line that I've drawn. And I'll click to set that as the start angle. And notice that Revit confirms that by representing that as 0 degrees. Now I can start to move the mouse, and I could rotate any amount that I want. But notice that when I get close to horizontal, it actually snaps exactly to the horizontal angle. And whatever number of degrees that is, Revit just figures it out and it snaps to that. So all I have to do is click, and now I've rotated that green line perfectly horizontal. Okay, you can see it right there. And then the final step would be to just go to the move command, pick up a midpoint, and then pick up a second midpoint over here. Now notice it's not letting me go off at a diagonal. That's because this constrain option is currently turned on. If you uncheck that, then you can move freely in any direction you want, and you can pick up the endpoint right there. Now that's one way that we could orient our site plan to match the orientation of the building. I'm going to undo that 2 times to get it back to the random rotation. The other way that I could orient it is using the align command. Now we've looked at the align command in a previous movie, but I'm going to look at it again here. If we go to modify and choose align, the first click is the object that we want to use as an alignment reference. So in this case, I'm going to use the front edge of this roof element right here, just something parallel to that front door. Then that highlights that edge, and then it says to click the object that I want to move and rotate into alignment. And that's going to be my green line right here in the link file. And when I click that, it will simultaneously move and rotate the site plan to position it in the proper orientation. Now, I do still have to make a move, so you might argue that this really isn't any quicker or easier than the rotate method, but it is just another alternative. And I'll do move endpoint to endpoint. And you can choose whatever method you prefer, whether you like the rotate method better or the align method better. Now I'm going to zoom out a little bit. I'm going to come down here and change back to hidden line. And what you'll notice is that we still have a problem. When I change back to hidden line, the building disappears. Now the reason for that is actually quite simple. If we scroll down here on the project browser and open up one of the elevations, I'm going to open the south elevation. You can see that the building is down here and the site file is way up here. So the site file has been inserted much too high for the building. Now we could select it and use our move command again to move it down, or we could actually just use our align command again for that. If I zoom in over here, you can see that there is a level here called project level. That's sort of like the 0 level for that site file. And that really ought to correspond here with the grade level of our project. Now that's really easy to do with the align command again. So I'm going to go back to the align command, and I'm going to highlight the grade level as my reference, zoom out, and then I'm going to click this project level in the link file as the object to move into alignment. And that will move the link file down to the correct height. And now you can see it's sitting under the building where it belongs. And if I go back to the site plan, we're now seeing the building sitting on the site. And if I go to the 3D view, it looks like this. And so that completes the moving and positioning of our site model with respect to our building. So whenever you link in a building, if the two files don't share a common origin, you'll have to do some moving, rotating, and positioning in order to get it in the correct location. But as you can see, it's very simple to do with basic commands like move, rotate, and align. In this movie, we're going to look at establishing shared coordinates. Shared coordinates is a process that you can use to set up a relationship between two files that will be maintained, and so that those two files will know how to link to one another on an ongoing basis. So it can be really helpful when you have multiple buildings on campus, or when the linking situation is actually complex and you want to make sure that you maintain those relationships as the project progresses. It can also be really useful when the same building is inserted more than one time on a project site. So I have a fairly simple example that I want to illustrate here. I've got my office building open, and the site file is brought in as a link file, and it's been positioned, and that we talked about that in the previous movie. And I also have this small little outbuilding sitting over here, and that's been linked in, and they're positioned where I want them to be. But now what I want to do is preserve those locations and make it possible for the other files to link their file in the same locations. So here's how we're going to go about doing that. I'm going to select the site file first. If you look over at the properties palette, you'll see that it says that it's a linked Revit model, and then there's a couple properties. And the one that I want to focus on is the shared site option right here. And you can see that it currently says that it is not shared. So if I click that, that's a button, and it will display a share coordinates dialog. Now there's actually two options. You can publish coordinates or you can acquire coordinates. Now, for our purposes, the result will be fairly similar, but in my view, the coordinates should always originate from the site file. So in this case, since the site file is the link, what I actually want to do is acquire the coordinates from the link file into the current host file. So what I'm going to do here is choose the acquire option. If I had the site file open and the building was linked into it, then I would publish from the site file to the building. In this case, because I'm in the building and I want to get the coordinates from the site file, I'm going to choose acquire. Now, that's all I really need to do. I could click reconcile here and finish the process. But what you'll notice here is that information, basically the relationship between these two files, that bit of information, is got to be recorded somewhere. So that information is stored in something that Revit calls a position, a saved position, or named site. And the default name for that site is called internal. Now that's a fairly generic name, and I personally prefer to actually rename that. So we can do that by clicking this change button right here, and that will display a dialog where I have some buttons over here where I could either duplicate or rename that internal position. I'm going to choose rename and simply call this building location. So something a little bit more descriptive than internal. And I'll click OK. I'll click OK again, and then finally reconcile. Now what you'll see is over here on properties, the shared site is now listed as building location. I'm going to repeat that process with the shed building. So I'm going to select it, and it's also not shared. And I'm going to click the change button here, repeat the rename step again, and call this shed location. Then I'll click OK. OK one more time. Now, at this point, I've established the two locations, the building and the shed location, and they're both coming from the site model. Now I need to save everything to make it permanent. So if I come up here and I click the save icon on the quick access toolbar, what you're going to see is a location dialog will display, and it will tell me that I've changed the current position within the file called building site. Okay, so what do I want to do? It's imperative that you click save here. If you choose any of the other options, then you basically undo what we've done. So I'm going to click save, and it's actually going to change that linked Revit file. Then it's going to ask the same question again for the shed building, and I have to click save again. So at this point, I've now saved all three files. I've saved my office building and the two links. Now, what did we just do? Well, you may recall from a previous movie that we can't have the link and the host file open in the same session of Revit. We can have them open in two different Revits, but we can't have them in the same session of Revit. So what I'm going to do is go to the application menu and choose close. So that will close my current file. Now, I want to open up the building site file. So I'm going to click the open link here, and I'm going to select the building site file and click open. Now at the moment, neither of the buildings appear here. Now what I'm going to do is go to the 3D view where it'll be a little bit easier to see what we're doing. I'll spin this around and zoom in just a touch. I'm going to go to the insert menu, click link Revit. I'm going to select the office building file, And then this time, I want to link it by shared coordinates. When you click shared coordinates and click open, the building site will know exactly where to go. Now, I am getting a message that's displaying telling me that it can't load the shed file, and that's fine. We're going to load that one separately. So I'll go ahead and click close there. And notice that the office building has come in exactly the correct location. So if I repeat the process again and choose the shed this time, also by shared coordinates, click open, notice that it will also come in exactly the correct location. And in fact, if I opened the shed building and did link by shared coordinates, I would be able to link the other two files in there as well, and they would come in exactly the correct location. So now that we've shared the coordinates between all these files, they all know exactly where to go with respect to one another. So it doesn't matter which file we're working in any of the files, we can link by shared coordinates, and the file will always come in the correct location. An important part of working with links is learning how to manage them effectively. Perhaps the location of the link has become disrupted, or maybe you want to point the link to a new location or a different file, or maybe you just want to check the status of all the links in your project. It all starts in the Manage Links dialog. So to explore the Manage Links dialog, let's open a new project. So I'm going to go to open. I've got a file here called Manage Links. Now, when I first open this project, it will alert me that one of my links has actually become disrupted. So it'll give me two choices. I can open the Manage Links dialog to correct the problem, or I could just simply ignore it. Well, since we want to talk about Manage Links in this movie, I think clicking Open Manage Links would be the right choice here. When the Manage Links dialog displays on the Revit tab, you're going to see each of the Revit links that are currently in this file. Now, the building site link is fine. As you can see, it's currently loaded and it's finding it at this location here. But it's the shed file where we're having a problem. If you just simply click somewhere in one of these fields, you can't get to any of the buttons. What you have to actually do is select the name of the file here in the link name, and that activates all the buttons here. So what I want to do is, because it's not found, this location has become disrupted, I'm going to click Reload From, and I happen to have a copy of that shed directly in the Chapter 5 folder, and I'll just open that up. And then click OK, and you'll see the shed file will appear. So sometimes it's as simple as that. Just change the path to the file, and that will update the link. Now, to get back to Manage Links, I can go to the Insert tab, click Manage Links, and what else can we do in this dialog? Well, we've already talked about the status column. You can see they're now both loaded. But what about this reference type column? There are two choices, overlay and attachment. So what attachment is it creates a nested relationship, where overlay only goes one level deep. So right now, both of our links are set to overlay, which just means that if either of those links had links of their own, they would be ignored. But if you use attach, then it will actually pull in those nested links as well. So I have a file that has some nested links that I'm going to swap this one out with. So I'm going to select the building site and choose Reload From, and I'm going to choose this file here called Alt Site and load that one in. Then I'm going to change the reference type to attachment, and let's click OK. And you're going to see a second outbuilding appear over here. Now, if I select the main parent file, you see it highlights the whole thing, including the outbuilding. But if I press my tab key here, I'm able to reach in and get that nested linked file directly. So that's what will happen with an attachment link. So let's go back to Manage Links. And the other path over here is the path type. Now, it defaults to relative, but you can also change it to absolute. So with relative, it just records the file name and any part of the path that it has to record. With absolute, it goes all the way back to the drive letter. Now, usually relative is a little bit nicer because it doesn't need to record the entire path, and you don't have to worry about what happens if all the users on the project don't have the same drive mappings. So generally speaking, relative path is usually the preferred way to go. Now, if you have IFCs or CAD formats or DWFs, you can manage all of these different kinds of links here in this dialog. So notice here in CAD formats, there is a link to a CAD file, and all the same options apply here, reload, unload, and so on. So I'm going to OK out of here. Now, the other place we can get to Manage Links is on the project browser. So if we scroll down in the project browser, locate the Revit Links branch. If you right-click it, here's Manage Links, and it's the same dialog. If you expand the branch, it will show you icons for each of the link files. And we've already discussed in a previous movie the blue arrow, which indicates that this file is loaded. If I right-click it, I can reload, unload, open it, and unload it. Various options that are available in the Manage Links dialog. Notice the attachment reference type now shows with this little plus sign here, and I can expand it out, and it's got a slightly different icon, and you can see the nested attached link in there. So learning how to manage your links effectively is an important aspect of working with links. So whether you need to change the paths or point to a different file or just identify where some of the problems might occur, Manage Links is your one-stop shop for managing all of the links in your Revit project. In this movie, I'd like to take a moment to talk about file formats and backward compatibility. It's very important that you understand that Revit is not backward compatible. What I have here on screen is an article from the help file, and the most important part of this article is this sentence right here that says that Revit is not backward compatible. It's very important that you understand that and what the ramifications of that are to your projects. So what this means is that if you're working with other team members using Revit, everybody needs to be on the same version of Revit. It doesn't matter whether they're on Revit Architecture, Revit MEP, or Revit Structure. That's not what we mean by the same version. What we mean by the same version is 2016 or 2015 or 2014. So if you start a project, one of the very first conversations you want to have with the extended project team is what version of the software is everybody on, and then you can make decisions about whether or not you want to stick with an older version or have everybody upgrade. But if you open a file that was created in a previous version, Revit will happily open the file, and what you'll see is a dialog will display on screen, and it will show you the version that the file was previously saved in, and it will tell you what version it is upgrading it to. Now, there will be a cancel button in that dialog that you can click to cancel out if you realize you're upgrading it accidentally. If you don't do that and you save the file, it becomes irreversible. So that file will be permanently upgraded to the new version, and you won't be able to go back. And so naturally, you can imagine that that might be frustrating for various team members if they haven't upgraded to the new version of the software. Now, you'll get a similar dialog if you upgrade a file that has a link associated with it. So we've just talked about links here in this chapter. If I link to a file of an old version, what will happen is every time I open that file, Revit will temporarily upgrade that linked file, and it will take time for it to do that. And then if I save over that upgraded file, it'll no longer be accessible to the original author who created it in the previous version. So it's just really important that everybody get on the same page and that you're always using the same version of Revit, and that will avoid any headaches that you have with people working in incompatible versions. The theme of the movies in this chapter will be sketch-based objects. What I mean by sketch-based objects is any object in Revit that we have to create a two-dimensional sketch in order to indicate the shape and overall form of the object. There are certain objects that Revit just can't automatically assume the shape and form for you. When you draw walls and doors and windows, you really only need a click or two and Revit can do the rest. But when you want to draw elements like floors and roofs and stairs and railings, these objects require a little bit more input from you in terms of what the shape and the overall form is. So in this movie, we're going to start our exploration of sketch-based objects with a look at the floor element. So I'll start here on my first floor plan, and we're going to go to the Architecture tab, and I can click on the Floor button. Now, if you use the drop-down, it's just this first option right here, Floor Architectural. Now, that takes me into sketch mode. How do I know I'm in sketch mode? Well, there's a couple clues on screen. The drawing window will gray out, and the ribbon will change to this green tinted color. Now, in addition to that, there'll be a mode panel, and it will have a big red X and a big green checkbox. And those buttons are important because those are the only two ways out of sketch mode. If you press escape, it doesn't work. If you click the modify tool, it doesn't work. The only way to get out of sketch mode is to click the red X if you've changed your mind and you want to cancel, and the green check mark if you want to finish. Now, sometimes folks will wander off onto other ribbon tabs. I don't recommend doing that. Notice that most of the tools are grayed out anyway, and you can't really do anything in those locations. So the best thing to do when you're in sketch mode is just stay on the modify tab. All of the tools you need are right here. Now, when you're creating floors, it's often the easiest to create them from existing wall geometry, and all of the defaults are already set up that way. So if we look over here in the draw panel, we're drawing boundary lines. That's the default, and that's going to be the shape of our floor that we're going to sketch out 2D. Then we've got this pick walls option right here. Now, we certainly certainly could use lines and rectangles and circles, but with pick walls, I'll be able to use the existing walls in my model to build my floor from. So that's a really handy feature. And then finally, we've got this checkbox right here, which says extend into wall core. Now that's really helpful as well, because it will actually sense the core of the wall and it will put the sketch line there. So I can illustrate that if we just zoom in a little bit, maybe right here, and then I'm going to click to create my first sketch line on this wall. And notice when I click that wall, it put the sketch line at the face of the core. Now I can actually put it on the exterior face or the interior face, and you could use this flip grip right here to change it at any time. So I want to make sure it's on the exterior face of the wall. I'll do my previous zoom, and let me continue clicking exterior walls all the way around the plan. Now here at the front, this is actually in two pieces. So there's a wall here and another wall here. And you could click both and let them touch end to end. But what I actually prefer to do is go to my trim and extend command and then just trim up this last corner like so. A floor sketch has to be an enclosed sketch. So you have to make sure that all of your corners are touching one another and they're all nice, clean intersections. When you've got the sketch finished, you can come up here and click the green finish checkbox to finish the edit mode. Now, when you do that, you'll get a message from Revit asking you if you want the walls that are underneath this floor to attach to the floor itself. Now, sometimes that's a good thing to do. And we're going to do that with the next floor that we build. But actually, in this case, I'm going to answer no. And I'll be able to show you why we answered no when we cut a section in a few moments. So for now, we'll just kind of postpone that and continue on. Now, notice that the floor slab is still selected. You can see it highlighted all the way across the plan here. And if you wanted to make any changes to it, there's actually an edit boundary button here on the ribbon. So I could click that. That would take me right back into sketch mode, and I could make whatever modifications I wanted to make. So if there was a change that I needed to make to the shape of the floor, I could do that. Now in this case, I don't actually want to keep that change. So to cancel the mode, again, you don't press escape or undo or anything like that. You click the big red X here, and it will confirm that you want to cancel, and you'll say yes. All right, so now let's move up to the second floor and create another floor slab up there. So I'm going to go to level 2 floor plan, and here we only have the second floor on this left-hand portion of the plan. And what I'm going to do is go back to architecture, click the floor button again, accept all the same defaults, boundary line, pick walls, extend into core, and I'm going to start clicking these exterior walls here on the second floor. Now I'm only going to do the ones on the left. Right over here in this location is a double volume space looking down into the reception area. So I don't want to put a floor there. So what I'll do instead is use my trim extend to corner. I'm going to pick this line right here and then make sure I'm picking the left side of the line up above so that it will trim up and create a nice rectangle there. Now, if I zoom in over here at the top of the plan, naturally, if these stairs are meant to take me up to the second floor, I'm going to need to make a modification to the shape of this floor in order to achieve that. So what I'm going to do here is this time, because I don't have any walls to pick here, I'll just draw those with simple line segments. So I'm going to start right here at the end of the stair, draw a line to there, and then another one running vertically along here, click the modify tool to cancel, and then I'll go to trim and extend and clean it up. Remember with trim and extend, you always pick the side you want to keep. Trim that up here, and then I'll click finish again. Now this time I'll get that same message again about the walls that go up to the underside of this floor. Now here we're talking about the office walls, for example, on the first floor. So this time I'm going to say yes so we can see a difference. Now I'll get a second message which will ask me about the perimeter, and I'm going to say yes for that one as well. Now to show you what both of those yeses did, let me zoom out and cut a section through my building. Sections are really handy to help you understand what's going on with the structure of your model. So you draw a section by just clicking 2 points on screen. So I'm going to start over here near grid line 3, click a point, and then draw it straight across horizontally and click another point like so. You'll get a dash box here indicating the extents of the section. I'm going to click away from it to deselect it, and then I'm going to double click on the blue section head in order to open it up. Now, to understand what we've got here a little bit more clearly, I'm going to change the detail level to medium so that we display the internal components within the walls. And then I'll come over here and zoom in this location right here. Now, the first question asked about if we wanted the walls that went up to this floor to attach to their bottom. So this wall we answered yes, and as you can see, it's attaching to and cleaning up with the floor over here. This one we said no, and hopefully now you can understand why we said that, because that would have chopped this wall down to here, and we'd have this unnatural kind of notch right there. So that wouldn't have been desirable. The second question asked if we wanted to join the floor slab with the perimeter walls, and there we said yes, and you can see what that's done. The floor slab penetrates in and through the core, and then the wall has carved out a small pocket to receive it. Now, if you don't like the way this floor is overlapping this wall, we actually have a tool that can fix that. We can go to the modify tab, click this join geometry command, you select the perimeter wall here, and then you select the floor there. Now you may need to do that in other locations as well, but that will clean up that condition. Now, one last thing I want to point out about the way that we built these floors. When you use the pick lines feature, you're actually creating a relationship between the wall and the floor. And what I mean by that is if I were to take this wall here and actually move it out here, notice that the two floor slabs stay connected to that wall and extend along with it. So by simply moving the wall, we're actually modifying the sketch of the floor as well. That's a very powerful feature. So Revit's always looking for opportunities to build relationships between the different parts and pieces of your models. So that's a look at our first sketch-based object. Creating floor slabs is as simple as going into a floor plan and drawing out the shape that you want that slab to be. When you click finish, Revit creates the 3D geometry for it. We use the pick walls feature here to make the sketching easier, but you can actually draw floor slabs using any of the normal sketch tools. Revit offers a few ways that we can create roofs. In this movie, we're going to look at perhaps the simplest form, which is the footprint roof. A footprint roof is almost identical to creating floors that we talked about in the previous movie. You go into a sketch mode, you sketch out the shape of the roof, and then when you finish, it creates the 3D form for you, complete with any sloping that you decide to enable. So in this file, I actually have two roofs. On the left-hand side, I'm going to have a roof that's a little bit higher up, and then a lower roof on the right-hand side. So I actually have two floor plans for that. So I'm going to start with the high roof. So I'll go to the high roof floor plan to get started here. Then on the architecture tab, I'll click the roof button. Now the default is roof by footprint, but if you use the drop-down, it's the first item right here, roof by footprint. So you can access it either way. That takes me to sketch mode, which looks very much like the sketch mode that we saw in the previous movie when drawing floors. The ribbon tints in a color, and the drawing window grays out in sort of a halftone gray. It's really important that you remember to stay on the modify, create footprint roof tab. All the tools you need are right there. Don't go clicking off onto the other tabs until you're done with this mode. So it's really important that when you're in a mode like sketch mode that you stay there and finish your work before continuing. Now I'm going to make just a few modifications here. On the ribbon, I'm going to accept the defaults, which is boundary line and pick walls, because that's the most convenient way to do the sketch. On the options bar, I want to check this defines slope checkbox. That will make sloping edges for my roof instead of flat edges. And then the overhang defaults to 450 millimeters, and I'm going to increase that just a little bit to 600. Now right here, the default roof is using a 400 millimeter roof thickness. Well, I'm going to switch to a slightly thinner roof, 125 millimeters, but I'm going to stick with generic for now. Later in the design, you can actually swap out the type that you're using to something more detailed, but for now I'm going to stick with generic. Now, when I highlight one of the walls on screen, you should notice a dash line appearing actually next to the highlighted wall. That's represented by the overhang that we asked for. So when I click, it will actually create that sketch line at the 600 millimeters away. Now you'll notice that there's a small triangle that appears, and that triangle has a label next to it, and it's currently 30 degrees. That's how much that edge is going to slope. So the way to think about this edge is it's like a hinge, and it's hinging up to form a sloping plane for your roof at 30 degrees. Now I'm going to lower that slope to about 18.5 for this example. Okay. Now when I go to the next edge, it will default back to the 30 degrees. So that 30 degree slope is kind of a default. So let's do it this way. Let me go ahead and create 4 edges on the 4 sides of the main portion of the building. Now you'll notice that they don't touch one another, and that's because there's another wall over here and there's this notch taken out over here. So what I'm going to do next is I want to cancel out of the draw mode. Now this is really important. If I try to select any of these edges, I can't do it. What I'll actually be doing is creating new edges. So it's really important that you click the modify tool when you're done placing edges. Notice that turns off the boundary line and pick walls options. Now you can select these edges. So what I want to do here is select all 3 of the 30-degree edges, come over here to the properties palette, and I can change their slope altogether in one step, 18.5. Now it's not required that you make them all the same. You can actually have every edge a different slope if you want to. It would make for a rather interesting roof, but in some cases it might be appropriate to actually have different slopes on different edges. But in this example, I'm going to keep it pretty simple and make them all the same. Then I'm going to go to trim and extend to clean up, because if I try to finish the roof right now, I'll get an error message from Revit, because in order to complete a footprint roof, you have to have an enclosed shape. And so it's highlighting all the places where the shape is not enclosed. So what I'm going to do is click the continue button here in the warning, and then go to trim and extend to corner, clean up those 2 corners, cancel out of the command with the modify tool, and then I'll click finish edit mode, and this time it won't complain. Now, if I deselect the roof, you can see here in the roof plan that I have a nice hip roof, okay? Now, a better way to see that is to go to the 3D view. So when I go to the 3D view, hold down my shift key and orbit with the wheel, you can see the hip roof that I created, and it's pretty shallow because I lowered the slope down to 18.5. You could always adjust that. At this point, I could actually select the roof, and right here on the properties palette, I could adjust the slope and change it if I want to. Now, if you don't want a hip roof in this case, if you look at it and you decide you'd rather have a different shape, like maybe a gable roof, that's easy to achieve as well. So I'm going to select the roof, and then up on the ribbon, I'm going to click the edit footprint button, and this takes me right back to sketch mode, and notice that I'm able to work on the sketch even in 3D view. So I'm going to select this edge, hold down the control key, and select this edge. So with those 2 edges selected, I can come up here to the options bar and uncheck define slope. That removes the little triangles, and when I click finish, I now have a gable roof instead of a hip roof. So it's very easy to change your mind and make modifications to the sketch directly in either the plan view or in 3D. Now let's go a little bit further with that. Suppose we want this gable to actually follow the shape of the building a little bit more closely instead of having this large overhang. So I can edit footprint again, and this time what I'm going to do is go back to the pick walls tool. Notice that will turn on the boundary line tool for me, okay? And then I'm going to accept the overhang at 600 millimeters, but I'm going to turn off define slope, and then I'm going to pick this wall and this wall. And notice that that will actually clean up the sketch for me and automatically trim the corners. Now, if for some reason it doesn't do that, just go to trim and extend to corner and clean it up manually. When I click finish, I now have a gable roof still, but it takes a notch out of the corner that more closely matches the shape of the building. So it's pretty easy to create your roof and then iterate it through different possibilities to suit your different design needs and experiment with different shapes. Now, I want to create the roof on the lower portion of the building, so I'm going to go to the low roof floor plan to do that. Go to my footprint roof command again. I'm going to accept the same overhang, turn on define slope, and create my first edge on the back wall here. Now, again, it defaults to that 30 degrees. Now, I want to make this a shed roof, and I want to keep it relatively shallow. So I'm going to change that slope and change it down to 9.5 degrees. Then I'm going to turn off define slope and create this edge and this edge. So now for the final edge, I want it to actually go right up against this wall right here. So what I want to do is take the overhang and set that to 0. Now, the trouble is that when I select this wall here, Revit is going to put it on the inside face of the wall. And unfortunately, even though there's a flip grip here, it's actually going to flip the entire sketch. That's really not going to work so well for me. So what I'm going to do instead is click my modify tool, and I'm going to delete that sketch line that I just created. And instead of using pick walls, I'm going to use pick lines instead. So this is a similar concept to pick walls, except that it's a little bit more general. It will let you pick any edge. So I could pick a grid line or something off the stair or the face of this wall. So make sure its offset is still set to 0. I'm going to pick the face of this wall. That's going to overlap, and so I'm going to have to clean it up. I'll use my trim and extend corner in both directions, and then I'll finish the roof. So sometimes you have to use a different tool to get there. Let's take a look at it in 3D and spin it around. And as you can see, that created a shed roof. So using the footprint roof, we can easily sketch out the shape of the roof that we want in a floor plan, define which edges are sloping, and when we finish, Revit will resolve the 3D geometry for us, complete with all these slope defining edges to create a variety of different traditionally shaped roofs. In this movie, we'll add ceilings to our model. Ceilings are a pretty simple object to add, and that's because there's a really handy automatic ceiling creation tool that we have that will automatically see the boundary walls that surround a room and create a ceiling in there. But in situations where that's not appropriate, we can also sketch our ceiling. So the first thing I want to do when talking about ceilings is show you the most common mistake that folks make when they start to add the ceilings. So I'm here in a level 1 floor plan, and I go to Architecture tab and click my ceiling button, and then I see this handy little automatic ceiling tool over here, and I say, yeah, that's great. And I come over here and I click a point in this room, and nothing happens. And there's a warning message that appears down here, and it's basically saying you can't see the element that you just created. And the reason for that is we're looking at a floor plan, and so we're cutting at about 1200 millimeters and looking down, and the ceiling is well above our head. So what I'm going to do here is undo that ceiling, cancel out the command, and then come over here to my project browser and expand ceiling plans and open up my level 1 ceiling plan. So the level 1 ceiling plan is cut at a more appropriate height for ceilings, and it's reflected ceiling, so it's actually seeing what's above rather than what's below. So once you've done that, then you're ready to actually start adding ceilings. So let's go back to the ceiling button, and this time let's pay a little closer attention to some of the options that we have available. Now on the ribbon, we have the 2 choices. We have automatic ceiling and sketch ceiling. So we're going to start with automatic. Over here on the properties palette, there are some ceiling types already built into the template that we started with. So we have 2 acoustical ceiling tile grids here, 2 different sizes, and then just a simple plain ceiling. So why don't we start with the 600 by 1200 millimeter acoustical ceiling tile grid, and I'll add that to all of my offices. I've got an office here, here, and here. I've got 2 over here, and then this one here is slightly problematic, as you can see, because when I highlight the boundary, it's actually flowing down into the conference space as well. So don't click that one just yet. What I'm going to do is cancel with the modify tool, and the solution to that problem is quite simple. This wall right here stops at the column instead of going all the way to this wall. So what we can do is go to modify, go to the trim and extend command, select the exterior wall as our boundary edge, and then just extend this wall. Now you really won't see any change here, but if you go back to architecture, click your ceiling button again, now you can see that that's an enclosed space. So if you ever run into that in your own projects, it's a really easy fix. Just make sure that everything is kind of airtight, if you will. All right, let's change to a different shape ceiling, maybe the 600 by 600, and then let's look at another setting, the height offset from level. So by default, it's coming in at 2600 millimeters, which is a decent height for the offices, but maybe I want it to be a little bit taller in the conference room. So I can just change the height anytime I like. So let's go with 28 there, and I'll pick the point there in the conference room. Now perhaps the break room is a little bit shorter, so I'll go with 2400, and I'll use the same 2x2 and place that one there. Now we also have a plain ceiling, which is basically just a drywall ceiling. I'll stick with 2400 for that one and place that in the 2 restrooms. Now it's not immediately evident that anything happened there, so if you want to prove to yourself that you actually did create a ceiling there, what you can do is cut a section right here, cancel out, double click the section head, open it up, and there's the 2 plain ceilings that we added in the toilet rooms. Here's the one in the break room and the 2 in the offices. So let me go ahead and close this section. So that's the ceilings that we can do with the automatic tool. Now out here in the lobby area, this is a double volume space on the right, and then here's a balcony up above. So we want to put a ceiling underneath that balcony only. So that one, unfortunately, if we try and do it with auto ceiling, it's going to flow into the whole space. So there's where we're going to look at the sketch ceiling option. Now this displays all the familiar sketch tools that if you watch the last 2 movies, you've already seen, and it works exactly the same way as it did when creating floors and roofs. So we can choose whatever tool we want, lines or any of the other shapes. In this case, I'm going to start with pick walls because I find that nice and convenient, and I'll make my first sketch line with this wall, and then this one, and this one up at the top. Now, if I zoom in a little bit here, you can see there's a line out here for the balcony. That's the line I want to use, but that's not a wall, so it won't select it with the pick wall. So I'm going to switch to pick lines instead, and then I can highlight that wall. Now, I also need a small little line going across here. Now, you could draw it with a line, or you could do pick again. It's up to you, but draw that small little line, and then obviously we have some cleanup to do. So I'll just use trim and extended corner, take my small line, trim it to there. You got to pick it carefully here. Remember, pick the side you want to keep. So inside right here, and then to there. You can see it creates that little notch, then here to here, then here to here, and then finally these two at the top. Cancel out and finish, and that will create the ceiling plane. Now, I still had the plane ceiling selected, which is fine if that's the ceiling type that you want, but with it still selected, you can actually change it to any other type. So if I wanted to use the 2x2 instead, you can also change the height of it. So if I want to raise it up to 2600, so you can make whatever changes you like while that ceiling plane is selected. Now, if you take a look at the orientation of these 600 by 1200 grids, and let's zoom in over here on these two offices to talk about that, they match the orientation of the room. Now, that's fine. It's a good assumption for Revit to make, but let's say that you didn't want that. Maybe you want them to go in another direction. Maybe you want to shift them in some way. Well, if you move your mouse around on these grids, you'll notice that the actual grid lines themselves will select, and you can click on them, and that activates some of our modify tools, such as move and rotate. So if I go to the move command, I can actually move this tile, and I'm going to move it half a tile, so it's a 600 millimeter tile, so let me type 300 here, and notice that the effect is that it actually shifts the entire pattern. So you can select whatever line is convenient, but know that you're going to move the whole pattern. The same is true with rotate. Let me change the center of the rotation to an intersection right there. Let me start the rotation along the line, and then let me rotate it 90 degrees. And you see that that will rotate the entire grid pattern. So it makes it really convenient for you to start off by placing these with the automatic ceiling, but then adjust the patterns to fit the design of the room. Now, the real question is, how do you know how much you want to shift and rotate by just looking at the grid? Probably what you need is to get some light fixtures in here so that you can make better decisions. So let me zoom back out again, and let's focus over here on these offices. And let's add a few light fixtures in here. So you add light fixtures just using the component tool that we've already talked about in a previous movie. Now, if you open up the list and scroll through, you're not going to find any light fixtures currently loaded in this file. So we're going to have to come over here to load family and load in some light fixtures. So in my metric library, in my lighting folder, architectural, and then internal, you can see there's a whole collection of light fixtures here. And you're welcome to load in whichever ones you like. Well, in this case, I'm going to load in a Troffer rectangular light here, just a simple office style light fixture. And notice that it won't let me place it. So similar to doors and windows, this particular light fixture is actually a hosted element, and it requires specifically a ceiling host. So if you're out here, it won't place, but here it will see the ceiling and it will allow you to place it. Now, what I usually do is I kind of place it randomly, and then I cancel the command. And the reason I do that is it's easier to get it precisely lined up with the grid using the align command. So I'm going to grab one of the edges of the grid and align that to the edge of the light, and then another edge of the grid and the edge of the light. Okay, so I get the first one positioned correctly first, then I'll select it and copy it. So I'll copy from this corner, maybe to right here, and then I'll select both of these and go from this corner to right here. Now, you can select these and copy them to other rooms if you like here and here. But it's pretty obvious that the light fixtures don't really sit correctly in the rooms. In fact, they're going right through the walls. So that's where, now that we can see that, we can go back and use the techniques I showed you a moment ago to kind of shift the grid to a more appropriate spacing. So I'm going to select this grid line right here, go to the move command, pick any base point, and I'm going to move half a tile. So it's a 1200 millimeter grid, so I'll type 600. And then same thing in the other direction, and move it half a tile, 300. And now it's centered a little better. Now I'd have to repeat that for these, 300 and 300. But in the other direction, I can use the align command. So I can align this grid to this one, and this grid to this one. And so as you can see, once you kind of get in the flow, it'll move pretty quickly. So all of your similar spaces, you can get them lined up and oriented with one another in a pretty convenient way. So when you're placing ceilings, automatic ceiling is by far the quickest and easiest thing to use. But in cases where you have a more complex ceiling, you can always switch over to a sketch mode. If you've got a grid pattern assigned to that ceiling, you can move and adjust it just simply using move and rotate. And placing light fixtures are useful to help you make decisions about exactly what orientation you want those grid patterns to have. When you want to create traditional form roofs like gables and hips and shed roofs, the footprint roof is the easiest way to do that. But we also have an extrusion roof, and that can be useful for things like barrel vaults or curvy freeform roofs and so on. And so in this movie, I'd like to look at an extrusion roof, and I'm going to build a small little roof awning over a patio that we have on the top side of this building here. So to rotate the building around, I'm going to actually use the view cube. If you come over to the view cube, you'll notice that there's all these little hotspots that highlight when you move your mouse around on here. So I'm just going to access this corner right here and click it, and that will spin the model around to match that orientation. Now, if you want to then zoom in and orbit, you can fine tune, but the view cube can be nice to kind of just roughly spin you around to that orientation to get you started. Now, let's say that we wanted to put like a little awning roof right here. Now, the best way to do that is going to actually be work in elevation. So this is the west side of the building. So I'm going to double click the west elevation, and now we're looking right at that plane there that we saw in 3D. Let's go ahead and zoom in just a touch. And the first thing that we need to do with an extrusion roof is set what Revit calls the work plane. So I'm going to come over here to the architecture tab, click the drop down next to roof, and choose roof by extrusion. And that's what it's going to ask me to do. That first question is going to be establish the work plane. Now, the work plane is quite simply the plane that you're going to draw the sketch on. So like other objects that we created in this chapter, this is going to be a sketch-based object, and we're going to have to sketch the shape of this roof, but we need to do that on some 2D plane. Now, I'm going to use the default option here to pick a plane, and that's because it's going to be real easy for me to actually select the face of the wall that I'm looking at and use that as the work plane. Then Revit will ask me what level I want to associate the roof to, and it really doesn't matter what you choose here, but since level 2 is my highest level, I'll go ahead and accept that default. That puts me in sketch mode, and we can work with many of the similar tools that we've already seen. I'm going to reduce the thickness of this roof to the generic 125 millimeter roof. And then here's the most important difference between this sketch mode and the other ones that we've looked at so far. In this sketch, you're creating an open shape, not a closed shape. So let me show you. I'm going to do something kind of curvy here. So I'm going to do start end radius, and I'll start maybe right about there, go at a slight diagonal like so, and then a really shallow curve like this with the radius. Now I can continue adding points if I want to. So maybe I want to do another small curve like so, and snap it tangent, and however you want to do that, I'm going to just do those two shapes. But notice that I didn't wrap back around and close it on itself. This just determines basically the plane of that roof. And when I click finish here, it's going to apply this type that I chose, and notice that it gives that roof a thickness based on that 125 millimeters. Now it looks a little odd here. It seems like something's a little wrong. So let's go back to 3D and see what happened. By default, when you create an extrusion roof, it will use the depth of the building geometry for the depth of that extrusion. So it extruded right inside the building, pretty much the opposite of what I'd like. So it's really easy to fix this. Notice that there's some control handles at either end. So what I'm going to do is take this control handle and drag it out over the patio to about where I want it to be. Now you can kind of orbit and make sure, that looks pretty good. Now I usually like to, if you look here and see what that did, you can see that the numbers are somewhat random down to decimal points. Let's stretch this one here as well, outside the building. So I want to clean that up and kind of round those off to more rational numbers. So in this direction, maybe I'll just do a nice even 3000. And when I apply that, it'll shorten it slightly. And then in this direction, I could do the same thing, round it off to 550. But what I'm going to do instead there's a gap right here. So what I'm going to do instead is make the face of that match the face of the wall. And I can do that right here in 3D with my align command. So I'm going to select the face of the wall as my alignment reference. And then I can touch the edge of the roof and it will snap back and snap itself right to the face of the wall. So now when I click on here, you can see that those numbers are very rational numbers and it makes a little bit more sense. I just have a nice 3,000 millimeter roof there. So the extrusion roof is how you can create any of these sort of freeform or undulating shapes. It's a very easy tool to use. Just work in elevation, you sketch out the shape you want, and when you click finish, it gives you that nice extruded shape. In this movie, we're going to look at the attach walls feature. The attach walls feature allows us to attach our walls to other geometry. So in this case, you can see that the walls don't go all the way up to the roof, and using attach walls, we'll be able to achieve that. Now, you could select individual walls and do them one at a time by simply selecting a wall, use this attach top and base command right here on the ribbon, but it's going to be a little bit nicer if you actually select multiple walls at the same time. So I'm just going to click an empty space to deselect. I'm going to highlight one of these walls, press the tab key, and that will highlight a chain. Now, a lot of times, folks, when they're making a chain, will say, yep, that's what I want, and they'll kind of move their mouse away, and then nothing happens. So you have to remember it's highlight, tab, click. So again, I'm going to highlight this wall, press tab, and then make sure you're getting the right chain here. It can actually flow along the low part of the building, but in this case, it looks like I got what I need, and then click. And that's going to select all of those walls. It's always a good idea to also verify over here the quantity. So it says I've got 7 walls. That sounds about right, but if the quantity was very different than what you expected, then you might want to look at this in some other views and investigate what the disparity was. With all those walls selected, I come over here and I click the attach top and base button. And then on the options bar, there's 2 choices. Attach wall at the top or the base. So in this case, we clearly want to attach the top because we want to go up to the roof. So I'm going to leave that default selected there. And then you just click anywhere on the roof to indicate that that's the object you want to attach to. And you'll notice those walls will go up and attach to the underside of the roof. Now I'm going to deselect them and I'm going to orbit slightly just to really show you what that did there. As you can see, it's a really nice effect. Now let's repeat it over here. Press tab. Now this is what I was talking about with the chain. You notice how it's actually wrapping around and selecting lots of walls. If you did accept this chain and tried to attach, you're going to get an error message because it's going to warn you that all of these walls over here are already attached to another roof, and it's going to ask you if you want to detach those targets or if you want to, cancel or okay. Now it's actually possible for me to just click OK here. It will ignore the ones that didn't attach to this roof, but if I undo that, it might be a little bit nicer to avoid the ambiguity there and just use my control key and select the 3 walls. So this way there won't be an error because I'm only selecting the 3 that I need, and then I can click attach top and base and pick that wall. So it's just a different approach to the same issue. Now let's take a look at this in section. I have this section here at lobby, and I'm going to zoom in nice and close here under the eave condition, and notice that not only did the wall go up to the roof, but it actually cut at the right angle. So if you select the roof and actually come over here to the properties palette and change the slope, so I'm currently at 18.5 degrees. Let's say that I went to 24 degrees and made it a little bit steeper. Notice that the wall will remain attached and will continue to match the angle of the roof. Furthermore, the roof itself can actually be offset from the level. So if I take the roof and I actually move it up from the level, let's move it up about 1,000 millimeters. And when I apply that, you're going to see that the roof moves up, and notice that the walls continue to attach. Now this is kind of important to understand because if you select the wall still says that its top constraint is the high roof, which is down here, but clearly it's going taller than that. Now, the only clue that you get on the properties palette that is occurring is if you scroll down here, there's this item here that's grayed out that says the top is attached, and that's checked on. Now, it's grayed out because it's basically a read-only setting, so unfortunately you can't uncheck it. The way that you would detach this wall from the roof is to use this detach button right here, and then you would just click the roof and it would remove it. Now, you may recall in a previous movie that when we were creating floor slabs, it asked us if we wanted the geometry that went up to that level to attach to the underside of the floor. Well, actually, this is exactly the same command that we're talking about here. So these walls right here are attached to the underside of this floor. So it's not just roofs that you can attach geometry to. You can attach to ceilings, to floors, to roofs, and even other walls. So the attach command is quite versatile. So if I select this wall, notice that its top is attached as well, and it's actually attached to this floor. So the attach top and base command is a really convenient way to make the wall geometry match whatever other horizontal planes are in the vicinity, such as roofs and floors, and even in some cases walls. In this movie, I want to talk about the shape editing tools, which allow us to start with a flat roof and then sculpt it to have a slope applied by a series of points. So it's a very different approach to the roofs that we've seen so far. And in order to use this technique, there's a lot of parts and pieces that have to fit together. So let's try and go through this systematically. So here in this file, I actually have a few different examples to kind of help us understand what some of the criteria are that are required. Over here on the left, I have this simple hip roof. Now that's just a footprint roof. And as you can see, when I select it, there's a single button that appears here to edit the footprint. Now this roof right here is also a simple footprint roof. And as you can see, it's totally flat right now. And when I select it, in addition to edit footprint, I also get this shape editing panel, and it's got several different buttons on it. So what's the difference? If they're both footprint roofs, why the shape editing tools only appear for the flat one and not the slope one? Well, that's just the first piece of the puzzle that has to fit in order for you to use this technique. So you have to start with a roof that's completely flat. So what I mean by that is if you edit the footprint, none of these edges can use the define slope feature. So that's step 1. So once you have a completely flat roof, then you can select it and you can begin using the shape editing tools to sculpt it. Now, to understand what I mean by that, let me just quickly do an example by adding a point. Okay, so I'm going to click add point right here, and that'll take me into a kind of sketch mode, and you'll see that the outline of the roof highlights in this dash green line. Now I'm going to click a point anywhere on the surface of that roof, and that'll come in a blue color. So the stuff that I add is going to be in this blue color, and the stuff that Revit created is going to be in the green, so you can think of it that way. Now, there's a modify sub-element tool right here, and you use this tool to change the Z height of any of the points that exist on the roof, and you can use this tool on either the blue stuff or the green stuff. So I'm going to select this blue point, click right here on the temporary dimension, and I'll maybe just put in 300. Okay, now that'll add a very subtle change in elevation. Let's go ahead and repeat it again, add another point maybe right here, modify sub-element, select that point, and perhaps do negative 300. Now, it'll warn me that I'm slightly off, but that's really not a concern in this case. I'm going to click my modify tool, click anywhere to cancel that, and you can kind of see that I've got this sort of warped and twisted roof. Now, where we're really going to see that is if we open up the section. So I have this section 1 right here, and if we zoom in on this roof, you can see that it's kind of got this slightly twisted form going on here. Now, if that's the roof that I actually intended, then it's fine. I could stick with that. But what I want you to see here is that there's actually some layers inside this roof, similar to the layers that are inside the wall. So once you've sculpted a roof using the shape editing tool, a final piece of the puzzle that you can entertain or consider is that it's actually possible to customize the roof type and make one of the layers variable. Now, why would you do that? Well, let's return to the 3D and do something a little bit more rational. So I'm back in 3D and I'm going to select the roof and I'm going to click this reset shape button. Now, let me use a different tool on the shape editing panel. Let me use this split line tool. Now, basically, this is just a line instead of a point. So you're going to get 2 points and a line connecting them. And it's just a little bit easier to kind of control where those points end up. Now, to change the height, I still need to go to modify sub-elements, which I will do. And you could either modify the height of the blue points you've just added or the existing green points that were already here. So what I'm actually going to do is select the green dash line, edit that, and move that up to 300 millimeters. And then I'm going to select this green dash line and do the same. And if we go back to our section, what that actually does is it makes that blue line that I drew down the middle a low point. So it becomes a valley in the roof, and we've just sort of lifted up the two outside edges. So again, if you wanted the roof to taper like this, you could leave it alone. But the next step that we could entertain doing, and in many cases would be appropriate, is to actually taper the rigid insulation component. Because often a flat roof is actually a flat structure, and then they just build up the rigid insulation on top to provide drainage. So I've got this roof selected, and then I'm going to come over here and click Edit Type on the Properties palette. Now, it's usually a pretty good idea to duplicate the type first, so I'll do that, and I'm going to just add a suffix on here, tapered, just to remind me that this is the one that has the taper applied to it. I'll edit the structure. You can widen this box a little bit if you want to see it a little better. And I've got 3 layers: the metal deck, the rigid insulation, and the roof membrane. Notice that there's a variable column over here. You can check one component to make it variable. So notice if you check a different one, it will uncheck the first one. So the component that I want variable is the rigid insulation. So I'm going to check that box, click OK, and then OK again. And now you can see the result on the roof. Now I move these points up pretty dramatically, 300 millimeters, just to illustrate what this would do. You don't need to make them that tall. You could actually do something much more subtle to get the sloping you need for drainage. But you can see the ultimate effect on the roof is that by having that one variable component, any layer beneath that component will stay flat, and any layer above that component will follow the shape of the roof. So using these shape editing tools, we can begin to sculpt the roof using a collection of lines and points, and it's just a different approach to applying sloping and positive drainage to a flat roof. In this movie, we're going to talk about slope arrows. Slope arrows offer an alternative way to create slope in your roof elements, and they also work equally well in floors and ceilings. Now, typically the most useful place to use a slope arrow is when the slope does not actually run perpendicular to the edge of the roof. Now, you may recall that when we worked with sloping roofs, and I'm just going to select this roof and do Edit Footprint, that we were able to select one or more edges and turn on Define Slope. And essentially what that does is it makes this edge a hinge, and then the roof plane will react accordingly. But a way to think about that is that the slope actually runs either along the hinge or perpendicular to the hinge, depending on how you want to think about that. Now, let me click the Cancel here to discard that sketch. Well, what if the slope didn't run along that edge? Perhaps it wants to run along the diagonal of this footprint here. Well, let me do Edit Footprint, and to achieve that, that's where we need to use a slope arrow. So I'm going to choose the slope arrow button right here, and your first point of the slope arrow has to touch the sketch. It could be here, or right at the corner, but it has to touch the sketch. So I'm going to go from corner to corner. And then with that arrow selected, you look over at the properties palette and you can define what slope properties it has. So there's 2 ways you can define the slope, either the height of the tail or the slope. So I'm going to use the height of the tail option, and I'm going to accept the default for the level at tail, that's this end, and that's at 0. And then it's going to go up from there, defaults to 3,000 millimeters. That's pretty tall. Let me reduce that to about half of that. Let me do 1,500 millimeters. And then I'm going to click Finish. And what you're going to see is that it's going to tilt that roof up along its diagonal. Now, it might be easier to see if we just kind of orbit a little bit here. You can kind of see what that's done. Now, if you look at it from edge on, that's still a flat roof. It just happens to slope along the diagonal. Let's look at another example here. Let me select this one, edit the footprint. And in this case, I'm going to need a guideline. So I'm just going to draw a temporary sketch line along the diagonal here. And I'm going to need to remember to delete that when I'm done because the sketch will fail if I try and keep it. I'm going to go to slope arrow, and I'm going to start at this corner again, but this time I'm going to go just to this midpoint. I'm going to keep that selected, put in maybe 2,000 millimeters this time, keep it selected again, go to mirror, and mirror it around that temporary sketch line. Now, if I try and finish right now, it will fail because I've got that extra line, so I need to click continue here, and I have to select that line and delete it. Now, what this illustrates is that the slope arrow can end anywhere, but the tail has to touch the sketch. So if you pulled the tail away from the sketch and tried to finish, you'll get an error message. Okay, so I'm going to cancel that. So it has to touch the sketch, but the head does not. The head can be anywhere. Let's click finish and see what that gave us. And now we get a ridge, but that ridge runs along the diagonal and it slopes down to the 2 opposite corners. So those are both roofs that would be really impossible or very difficult to achieve using the slope defining edges. So those are some examples of where the slope arrow can really be helpful. Now here I have something a little bit more traditional. I've built these 2 crickets here on this small sort of relatively flat roof. But what I'm going to do so you can see those a little more clearly is I'm going to select this wall right here, and then down here on the view control bar, I'll click the temporary hide isolate icon. It looks like sunglasses, and I'm going to temporarily hide that wall. You can see that puts me in temporary hide isolate mode. Now I'm going to select this roof, edit its footprint, and you can see that this one is a little bit more complicated. There's a slope defining edge here, and then there's these slope arrows here. Now if I took the slope arrow and I delete it, notice that there is a sketch line underneath. That's important because the slope arrow can't define the edge. So I'm going to undo to bring that back. Now let me repeat what I've done here on this side so you can see how I did it. All I did was go to my split element command, and I split that edge at a couple points. I'm going to select that segment in the middle and turn off defines slope. So that's important because you don't want the slope arrow and the define slope to try and compete with each other. Then I'll draw a slope arrow from this endpoint here to this midpoint right there. And then I'll draw a second one from the endpoint to the midpoint as well. Cancel the command, hold my control key and select both slope arrows, and then come over here and decide how much slope I want it to have. I'm going to do a very subtle slope there, and that's just going to be 150 millimeters. I'll click finish. So that bumps up a very small cricket there on that other side. Now, if I zoom back out over here, I have a floor slab, and I just want to show you that if I edit boundary here, that you do have slope arrow available in floor slabs as well. And you can add a slope arrow, and then you can define what slope you want it to have. And then when you finish, it will actually slope that floor slab as well. So this technique is not limited to just roofs, but slope arrows give us an opportunity to create more complex sloping conditions that would either be difficult to achieve or impossible to achieve using some of the other sloping methods that we have. In this movie, we're going to look at some of the opening objects that are available to us in Revit. An opening object is a void object or like a negative object, and it actually cuts away from the solid objects that we have. So we can use voids to cut holes in other objects for a variety of purposes. Now, if you look at the architecture tab on the opening panel, there are actually 5 different types of openings that we create. Now, we won't go through all 5 of them. I'm going to focus on just 2 in this movie. I'm going to look at the shaft opening and the dormer opening, but you're welcome to experiment with the others as well. So for the first example, the shaft example, I'm looking at a section through a 3-story building here, and I'm going to zoom in slightly right here around the elevator shaft. And you can see I have an elevator object here, and at the moment, we've got a floor here, and we've got a floor here, and another one down here, and they're going right through the elevator shaft, so it would make it very difficult for that elevator to pass through there. Now, we really have 2 options on how we could deal with that situation. You could select the floor, edit its boundary. Because I'm in section, it would prompt me to open a more appropriate view like a floor plan, so I could open the level 2 floor plan. Once I get in there, I could zoom in on the area in question, draw a shape to represent the hole that I want to cut in the floor, and when I click finish, I'll say no to that question for now. and return to the section, you'll notice that it did in fact cut a hole there. Trouble is, it only did it for that floor. It didn't do it for these other two. So I would have to repeat that 3 times. Now what I'm going to do is just come over here to my drop down for undo and undo all of those steps. And let's look at the alternative, which is the shaft opening. So creating the shaft opening is similar. It's still a sketch-based object, but what's nice about the shaft opening is you can make it any height that you need and it will cut through everything in its path. So let's get started in the first floor plan. So I'm going to come over here to the level 1 floor plan, zoom in on the elevator, and then let's click the shaft tool. That puts me in sketch mode, and we could use any of the tools that we've used before. And in this case, I'm just going to draw a simple rectangle, and I'm going to start from this corner right here on the outside of the masonry wall and snap to this corner here. Now notice that Revit will actually offer to lock the sketch, so you can close all of these padlocks. Now the advantage of doing that is, if any of those edges move as the design changes, my shaft will adjust automatically. The disadvantage is that in some cases, it can throw an error message if it tries to move something and the constraint becomes unsatisfied. So just be aware that it might generate an error and you might want to be aware of that. But in this case, I think it's pretty safe to do, and I'll go ahead and finish that sketch. Now, when the shaft is selected, it kind of appears solid. Let's double click this section head right here to open up the section, zoom out slightly and see what that gives us. So notice that the shaft actually has a height to it. And at the moment, it looks like it's just tall enough to cut through all 3 of the floor slabs. So it's actually doing pretty much what we need. But notice that over here on the properties palette, you can make adjustments if you need to. So there's a base constraint, there's a top constraint, and an unconnected height. Now currently it's set to unconnected and it just arbitrarily picked a height of 6,096 millimeters. What I'd like to do here instead is make that go up to level 3 without an offset. That's a really subtle variation, but notice it got a little bit taller. But by tying it to level 3, if the heights of the levels ever change, it will keep the shaft at that height as well. When you deselect it, just click anywhere, you'll notice that it now cuts through all of the floor slabs in its way. And with a single sketch and a single object, we were able to cut through all 3 floor slabs. So that's a shaft opening, and it's very useful for any kind of vertical circulation or air shafts, mechanical ducts, those kinds of things. All right, let's look at another example. I have another file open here in the background called dormers. You can see here that I have a dormer at the top of this roof. And what I'm going to do is complete the dormer geometry and then create a dormer opening. If I were to select these objects right here, the roof and the 3 walls, and hide those, you'll notice that the roof is solid underneath. Okay, so I'm going to reset the temporary height. So the first thing that I want to do is take this roof and connect it to this one. And there's a really easy way to do that. You go to the modify tab and there's a command here called join unjoin roofs. So I'm going to select that and it will prompt me to select an edge or the end of the roof that I wish to join, right? You can see that prompt on the tooltip and also down at the status bar in the lower left-hand corner of the screen. So that means one of these edges back here. Then it will prompt me to select a face of another roof that I want to join too. So like this face right here will do the trick. And notice that it will extend the roof out and make it connect to that one. The next thing that I want to do is begin creating the dormer opening. So now I'm going to go back to architecture and click on the dormer tool. This will prompt me to select the roof that's going to be cut by the dormer. That's going to be this one. And that will put me into sketch mode. And then there's a single button here to pick existing roof and wall edges. So this makes it really easy to create this opening. I can click this roof and that will create this little V-shaped sketch right there. And then I can click on each of the walls that make up this dormer shape. Now, if I click my modify tool to cancel and kind of orbit slightly, you'll see that this one ended up on the inside face of the wall instead of the outside face. But fortunately, there's a flip grip here and I can adjust that. And then I can use my trim and extend to clean up the shape. And then when I'm done and I click finish, that will complete the opening. Now, if I select this roof and isolate it, you can see that there's now a hole cut right through that roof there. And notice that the top edge is flat and the leading edge is vertical. Now, another way to see that is to come over here and open up the section. And if we zoom in right here, you can see the cut through there and the walls kind of go past and the roof goes past, and that gives you your dormer opening. So those are 2 really simple examples of opening objects that we have available to us. You're welcome to try the other opening objects as well. They will use similar prompts and they will do similar things and allow you to cut through various geometry. But the really neat thing about these opening objects is that you can create the object and then modify it at any time and it will adjust the opening accordingly. So you don't have to constantly rebuild your elements in order to achieve those effects. In this movie, we're going to begin working with stairs. Revit contains 2 kinds of stairs, stair by sketch and stair by component. So in this movie, we'll start with the stair by sketch and we'll look at the stair by component in a later movie. So I'm in a floor plan here, specifically level 2 floor plan, and I'm going to create the stair that goes from level 2 to level 3. So I'm going to come over here to my zoom command and I'm going to zoom in down here on this space. This is labeled the south stair, and we're going to create the stair in this general location right here. Up on the architecture tab on the circulation panel, I can click the drop down next to the stair button and I'm going to choose stair by sketch. Now, Stair by Sketch has a few different buttons that we can look at, and you can see them over here on the drop panel. There's a run, boundary, and riser. Now, run is typically the button that you're going to want to use, and it's lit up by default. And if I let the tooltip display, you can kind of see what this tool will do for us. With a simple 2 clicks, it will create an entire run of stairs, including 2 green lines, which represent the boundary edges of the stair, a blue line down the center, which represents the path of the stair, and then a series of black lines, which represent the individual risers themselves. So with 2 clicks, you get quite a bit of information established. Now, let's look at how it actually decides how to create and position all of those elements. If you look over at the properties palette, you can see that my stair type is called 190mm max riser, 250mm going. So we're going to stick with that type. We're also setting our constraints here from level 2 to level 3. So we're working on the level 2 floor plan, and we're going to go up to the 3rd floor. Now, Revit will take that height between those 2 levels, and it will use it to calculate the desired number of risers. And you can see that currently that is set to 16. And the actual riser height is calculating out as 187.5 millimeters. Now, that's just below our 190 maximum. Now, to see that, let's click the Edit Type button here. And at the very top of this dialog, you can see some calculation rules. And you'll see that there's a minimum tread depth of 250 and a maximum riser height of 190. So the way this works is you can actually change the desired number of risers. But if I try and put in a number that forces the actual riser height to be greater than 190, I'll get this error message which won't allow it. So I'm going to close that. However, I could put in a number greater than what was there. And when I enter that, notice that it just calculates the actual riser height to be a little bit smaller, and it allows for that. So this is the maximum riser height, but there really isn't a minimum one. You're just going to have to choose that on your own. So let's go with 18 risers. Now, I also want to increase the tread depth just a little bit. So I'm going to go with 275. Now, for the width of the stair, set that to 1200 if it's not set that way already. Revit remembers whatever the last width you used was. So the last time I drew a stair, I drew it at 1200, but it will often default to a number slightly smaller than that. So once I have the settings established that I prefer, I'm going to come over here into this space and start drawing the stair. Now, first thing you'll notice is it's trying to snap to nearly everything in sight. So don't really pay too much attention to that, and don't try and get it in exactly the correct location. What I'm going to do is just kind of click in the empty space right here for my first point, and that will get me started. And then I can always move the stair into position later. I usually find that a little bit easier. Now I'm going to start moving down from that point I clicked, and there's a light gray message beneath my cursor. And when that message says 9 risers created, 9 remaining, that means I've used up half of my stair. And that's when you want to click to create your second point. Okay, so we want to use up half of the risers. We're going to create a U-shaped stair, and so we're going to have half on each run. Now, you're only creating the runs. So with a U-shaped stair, we're gonna have 2 runs. Revit will create the landing and anything else that's required. So I'm gonna move over here and just make sure that I'm lining up with the first run, click to establish that point. Then I'm gonna start moving back up in the opposite direction. And when I've exhausted all of the remaining risers, I will click again and create the second run. Now you'll notice that Revit, in addition to creating the run, also creates a landing for us. And the message at the bottom now says that 18 risers were created and 0 are remaining. Okay, so that's what we're after. Now notice what we were able to do with just 4 simple clicks of the mouse. We got this very detailed sketch here. Now, the next thing I wanna do is start moving it into position and fine tuning it. So I'm gonna actually use a window selection and select the entire sketch. I'll go to my move command, I'll snap to the endpoint right here, and I wanna move it to the endpoint right there. Now, sometimes your move is forced in either horizontal or vertical direction only. That's controlled by this constrain checkbox. So if your checkbox is checked, you want to uncheck that now so that you have free motion and you can move and snap to this endpoint. Now there's a small gap right here between the wall and the stair. I'm going to use my measure tool right here and pick the stair and then go to the face of the small wall, and you can see that that's 100 millimeters. I want to match that same distance on this side. Now the way I'm going to do that is to do another window selection, but this time I only want to select the run on the right side and the side of that landing. Okay, so make sure that you've highlighted all of those pieces on the right. Then instead of using the move command, which would require me to do the calculation to figure out how far to move, and I might not get it quite so accurately, I'm going to use this tool here on the options bar called Activate Dimensions. That's going to activate all of the dimensions on the screen, and then I'll be able to manipulate those like any other temporary dimension. So I'll click this one right here, type in 100, and now I've moved that second run over so that it matches the one on the left. Now you can do additional fine tuning if you like. For example, maybe I want to increase the size of the landing. So I'll select this line right here, drag this witness line grip to here, and then I'll click in the dimension and maybe increase that to 1500. So feel free to do any of those kinds of modifications that you like. So one last thing I want to do is configure the railing that I want to use. So over here on the ribbon on the far right, there's a railing button. And by default, you'll always get a railing when you create a stair, and we can use this dialog to configure what we want that railing to be. Now, if you don't want a railing, you can actually choose none, or you could just wait until the stair's created and delete the railing it gives you. But in this case, I'm going to choose 900 millimeter pipe, and I want to set that railing relative to the stringers. Then I'm going to click OK. And then finally, I'll click the Finish Edit Mode button, the big green checkbox, to complete the stair. Now, a warning will appear down here about a non-continuous rail. We can safely ignore that warning by just clicking anywhere to dismiss it. We'll be talking about railings in a future movie, and so we'll discuss the non-continuous rail message at that time. So we now have the stair, and you can see it here in the plan, but I'm going to open up this section view right here. Now, you can right-click it right here and choose Go to View, or you can double-click it on the project browser. And then, of course, you can see that the stair starts here at level 2 and goes up to level 3. Now, we need another stair here to go from the first to the second floor, and so to do that, I'll go back down to the level 1 floor plan. The space that I have available here on level 1 is a little bit larger, so I can actually get away with a straight run stair in this case. Now, I'm going to build this stair using the same sketch-based stair. So if I go to the drop-down, choose Stair by Sketch, what you're going to notice is that it sets all the same settings. We're in run, level 1 to level 2, and if I come down here and scroll down, it did remember my width of 1200, but it did not change the number of risers or the actual tread depth. So just verify those settings. So in this case, I'm going to do 18 risers again, and I'm going to set this to 275 again. So once I have those settings established, I'll click my start point, and this time I'm going to pull straight up. So I'm just going to use the entire set of risers in a single run. I'll select it. I'll activate my dimensions. Click this right here, make it 100. And then this right here, maybe I'll change that to 1800. Check my railing. It still remembers 900 millimeter pipe. It still remembers the stringer, so that's okay. Let's finish. And then once again, let's reopen the section to see the result. You can see that it went a little bit far over here, so I can actually just move it back using the move command like so. So as you can see, creating a sketch-based stair is really just a few clicks, and like other sketch-based objects that we've seen, when you finish the sketch, it creates the full 3D object for you, in this case the stair complete with its railings. In this movie, we're going to look at railing objects. Now, most of the time, the railings that you have in your models will get created as a consequence of creating stairs, and that's certainly true for any railing that has to follow a stair, but there's plenty of situations where you'll need to draw a railing manually, such as guardrail conditions or other kinds of handrails. So I have such a situation here in this file. I'm in the second floor plan, and if I zoom in over in this general location, what you'll see is I have this open to below space, and I have this floor right here, and at the edge of the floor, it would really be nice to have some sort of guardrail. We're going to draw that guardrail right now just using the railing command. If I go to the architecture tab and click the drop down next to railing, you can see there's 2 options here. Now, if you have a stair that doesn't have a railing, you can use this option to place a railing on that stair, and then it will follow the slope. But in this case, because we're creating a guardrail, we just want to sketch the path. So I'm going to click that choice right there. Now that takes me into sketch mode, and the railing sketch is a little unique in the sense that it can either be an open or a closed shape. So if we had a balcony going all the way around this open space, we could draw like a rectangular shape, and it would make the railing go all the way around. But in our case, because we only need it on 2 sides, we can do an open sketch as well. Now you certainly could sketch it line by line, but in this case, this is another place where I think pick lines will be really helpful. So I'm going to click the pick lines option. And I certainly could click directly on the edge of the floor slab, but I actually want to give it just a little bit of an offset. So if you look over here on the options bar, you'll notice that there's an offset field, and I'm just going to put in maybe 50 millimeters, just a slight offset there. Now let me zoom in a little closer so you can see the effect of that. If I highlight this line, notice that there's a small dash line that appears at that 50 millimeters away. So I'm just going to highlight that and click so that it goes up, and then this one so that it goes to the left. Now notice that Revit will do a nice job of cleaning up that corner, but if I go to the previous zoom and zoom in down here, it went a little bit too long. Well, this is easy to fix with this little grip right here. What I'm going to do is just sort of back it up away from the wall, and then that will display a temporary dimension, and I'll just click in there and I'm going to make that 100. So let me zoom back out again. So that's all there is to my sketch, just these 2 simple lines. The last thing you want to do is come over here to the type selector and make sure you're creating the kind of railing that you want. So I'm going to choose the 900 millimeter pipe, and then I'll click the Finish Edit Mode, and that will complete the railing. Now, we can see it here in plan, but it might be nicer to actually look right at it. We could use a section, we could use an interior elevation, but I think in this case, it might be nice to create a 3D view. So instead of using the default 3D view, which would actually display the entire model and the roof and the walls and everything would be in the way, what I'm going to do instead here is create a camera. So a camera is just a perspective view, and we can place it anywhere that we need to. So I'm going to choose camera, and all you do is 2 clicks here. So the first click is where you want to stand. So I'm going to stand way over here in the corner, and the second click is where you want to look. So I'm going to make sure I drag past the railing, even beyond the outside of the building a little bit, and then click to set my camera. And then you can see that this is the railing that we created right here, and it's showing it to us in this nice perspective view. So creating guardrails or any other freestanding railings is as simple as sketching out the path you want, choosing the type of railing, and when you finish, you'll get the desired railing. In this movie, I'm going to look at the component-based stairs. The component-based stairs are created from a collection of interconnected components. And this makes editing them simple because if you edit one component, it usually has an impact on any of the others that are connected to it. Now, another nice benefit of working with component-based stairs is you can work on them in either 2D or 3D, and you can even do it at the same time because it's more of a 3D sketch mode. So I'd like to demonstrate that benefit of using them by working in 2 views. So I've got level 1 floor plan already open, and I've got this second view over here on my project browser called 3D Stair. Now, this is a cutaway 3D view of the stair lobby, and I'm going to come over to the View tab, click the Tile Windows button here on the Windows panel, And then using my wheel mouse, I'll just pan and zoom a little bit in each view so that we can get a better look at the area that we're going to work in. So let's go to architecture, click the stair dropdown and choose stair by component. Now, it's always good to check all the settings first to make sure that you're building the stair that you want. First of all, on the components panel here, it defaults to run. The nice thing about the run tool is that when you draw your runs, it automatically creates any supports and landings that are needed. However, it is possible to create those elements separately if necessary. Now, I'm going to stick with a straight run, but you can also do spiral or U-shaped stairs if required. Over here, I've got choices for different types that I can use for the stair. I'm going to stick with the default one, which has a 190mm max riser and a 250mm tread. Now, the base level will default to level 1 and the top level to level 2. It'll take those two levels, do the math based on the 190 riser, and end up at a desired number of risers of 16. It's possible to increase this number. I'm going to make it 18, but you can't decrease it. If you decrease it, you would get a warning because when it does the math, it would actually generate a riser that's larger than 190, and this rule here is telling us that 190 is the maximum. Now, I also want to increase the tread just a little bit, so I'm going to make that 275 in this case. Now let's look at the options bar, and we've got a setting here for the location line. So some of these are self-explanatory, like run center. If I just click a point here in the plan and start drawing, you can see that it's drawing right down the center of the run. The other options are run left or right, and you might need to zoom in to see that a little bit better. But notice that that's the inside edge of the support, and we also have support left or right, which is the outside edge of the support. So let me zoom back out a little bit, and I'm going to move to the right until I've created 9 risers with 9 remaining, and then I will click to place that first run. You will notice that the run will appear in both plan and 3D simultaneously. So again, that's one of the nice benefits of working with this component-based stair. The numbers are a little small here, but if you zoom in a little, you'll also see that it says 1 at the left side and 9 at the right side, so it's indicating to us the actual riser numbers that have been created. Now, let me give myself some room down here, and I want to create the second run. So I'm going to line up with the first one, give myself plenty of room, click my point, and then move back to the left, and it will say 9 risers created, 0 remaining, and then I'll click, and that will create the remainder of the stair. The last thing I want to check before I see what this looks like is the railing. So I'll click over here on the railing button. We've got some different choices available. So I'm going to make sure that I'm choosing the 900mm pipe railing, and I want to put it on the stringer. I'll click OK, and then finally I will finish it. Now, when I do, the stair will appear in 3D with a railing on either side, and I'm going to get a message warning me that the rail is not continuous. Now, if I zoom in here in the 3D view, you can kind of see what it's complaining about. Right here, it's a little disjointed, and over here, maybe it's not so nice. Now, this is an ignorable warning. You can click anywhere, and it will go away. So if you don't want to deal with that warning right now, you can totally ignore it. However, let's go ahead and deal with that. I'm going to select the stair and click the Edit Stairs button here on the ribbon. To deal with that railing, what we need to do is just allow a little bit more room for it to turn the corner. Now, to do that, I'm going to select the landing component. Notice the landing component has several grip points on it. I can take the small triangle drag control here, and I can start dragging it over to the left. Now, it'll snap to certain dimensions, but the distance I want it to go is actually 300, and it's not snapping to that. But that dimension is bold. And whenever a dimension appears in bold, you can start typing, and it'll go right into that dimension. We call this a listening dimension, so it's listening for input. So I'm going to type in 300, press enter, and that will extend that little portion of the landing. I'm going to do the same thing down here, start dragging. This time I want 450. It's not giving it to me, so I'll start typing 450, press enter, and it will extend out that portion of the landing. I should now have enough room on the landing so that if I click finish, that my railing should be able to wrap around nicely without generating a warning. So that was an easy way to fix that particular problem. Now, I want to edit the stair further and talk a little bit more about some of the other options available here. The first thing I want to look at is when I place the second run, I just sort of eyeballed where I wanted it to go. So I don't really have any idea what this distance is in here. Now, when I click this run, it doesn't give me a temporary dimension for that location. So all I'm going to do is just use a permanent dimension because that'll be the easiest way to designate where I want the dimension to be referenced from. So I'm going to use my dimension tool here, or type DI, highlight this inner edge, and I want to make sure it says runs. That's really important. And then the same thing down here. I want to make sure it also says runs. If it says supports, press your tab key until it says run. And then I'll go ahead and click an empty space to place the dimension. Press escape to get out of the dimension command, select the run, that activates that new dimension, and I'll type in the distance that I want that to be. And in this case, I'm going to do 200mm. So I'll just simply type in 200 and press enter. So that makes the distance between those two runs more precise. The next thing I want to look at is if you select either of the runs, at the end of the run, you'll see 2 control handles, one that's shaped like a triangle and the other is like a small blue dot. I'm going to take that small blue dot and drag it a little bit to the right, 2 risers. And notice that it will actually remove those risers from the stair. So if you were to actually look carefully at the stair, it's not kind of floating off the floor. So if you wanted to build like a platform that went up to the stair, kind of like a floor riser situation, you might choose to do that. But what I'm going to do is do Control Z to undo that. Instead, what I want to look at is the triangular control. The triangular control allows you to add and remove treads as well. But notice that whatever you add, it removes from the other side or vice versa. So if I drag to the right, it's removing risers from the top run and adding them to the bottom. Or what I'm going to do is drag to the left and add 2 risers to the top run, and it will remove those 2 risers from the bottom. Now you can verify that by looking at the riser numbers. It says 1 here, 11 here, and then 12 and 18 there. So I still have 18 risers. I've just redistributed them along the stair. Also notice in 3D that the landing actually moved up. It has to because all the components stay connected together. And that's one of the big advantages of working with a component-based stair. Let me go ahead and click finish here. We'll take a look at it in our 3D view. It's looking pretty good, except for one small problem. We're entering in here and wrapping around and coming out here, but we actually want to get to this balcony, and that balcony is on the opposite side. So that's really easy to fix. All you have to do is select the stair, and then here in the plan view, there's this small little flip control, and if I click that, it will flip the direction of the stair, and now the top run is the upper run, and the bottom run, the shorter run, is where we enter the stair, and that's the lower run now, and you can see that the stair is correctly oriented. So all that remains is for us to position the stair in the correct location. Now to help us do that, I want to turn on an underlay of the second floor. You can do that by making sure that nothing is selected in the plan view, go over to the properties palette for the floor plan, and scroll down and locate the underlay feature. It's currently set to none. All I'm going to do is change that to level 2 and apply that, and you'll see this ghosted in gray line appear here for level 2. I'll select the stair, go to my move command, snap right to the endpoint at the end of the stair, move it over here. If it's only moving horizontally or vertically, make sure you turn off constrain. Okay, I've got constrain unchecked, but you won't be able to move in both directions if you don't turn that off. I'll go ahead and move it right there, and that puts the stair into position, and you can check it in both your 2D and your 3D views. So the component-based stair allows you to assemble a stair from a collection of interconnected components, and when you manipulate any one of those components, it has an impact on the other connected pieces. So it's a very powerful way to build your stair and interact with it in both 2D and 3D. Railings have many user configurable settings, and they have a feature that allows them to have customizable top and handrails. Those top and handrails can have built-in extension parameters that will automatically extend the handrails either below or above the bottoms and tops of the stair runs. And this can help us build a railing type that complies with local building codes. So in this movie, we're going to look at the process to set up railing extensions. Now, it's a fairly complex process, so I've decided to create a very simple exercise file for this purpose, but we're still going to have several steps that we're going to have to go through, so we have to be somewhat methodical about the approach. So the first thing that I want to do is I'm going to take the two railings that I have, and they're currently the same. They're 900 millimeter pipe on both sides of the stair, and I'm going to create two different types. One on the left side of the stair, which is going to have a return that goes back to the wall, and one on the right side of the stair that's going to have a return that comes back to the railing post. So I'll select this one, edit its type, and duplicate it, and I'm just going to add the word wall return on the end, and click OK. Then I'll select this one, edit its type, duplicate it, and add post return to the end of the name, and click OK. So that's the first step, and by far the easiest. Now, in a lot of Revit types, that's really all we would need to do, and then we can modify each type. But the problem we have in this case is what we actually want to modify, if we go back to edit type, is we actually want to modify the parameters of the top rail or the handrails. And you can see that the top rail is set to another type, which is currently called 40 millimeters. Now, if I open up the drop-down list, there are some other choices in there, but the list of choices is the same regardless of which one of these rails I choose. So what I actually need to do is create a new type for that list. Now, I can't do it here in this dialog. So where I have to do that is actually on the project browser. So I'm going to scroll down in the project browser and expand families, and then I'll locate the railings branch and expand it, and then I'm looking for the top rail type branch and expand it, and then finally there is circular 40 millimeter. I'm going to right click it and choose duplicate. That'll create 40 millimeter 2, and I'll rename that with the right click and remove the 2 and call it post return. So now I'm going to work on this one first then, and I'm going to select it, go to edit type, and I now want to assign that new type that I just created called post return to that railing. Now click OK, and still nothing happens. So you can see there's a great deal of setup before you even get any payoff. Okay, so at least now we have a type and it's assigned to the correct subsettings. Now what we need to do is actually modify this post return and tell it to do a return. So we can do that right here by right clicking it and going to type properties. When that dialog displays, there's a number of settings that are in here, and what we want to do is, let's move this out of the way so that we can see the drawing window in the background. We want to focus on the extension at beginning and bottom. So the extension style is currently set to none. The length is currently set to 0. So there's a few things we can do here. For the length, I'm going to put in 300. Now let's just try that and see what happens. When I click apply, watch what happens. Notice that the top rail here has extended out 300 millimeters. Now this one did not extend out because I've created this brand new type here, and that's the only place that applies. So that's why it was important that we make that separate type. Now, if I look at extension style, there's actually 3 options there: wall, floor, and post. So let's try post style and click apply, and you'll see that not only does it extend out the 300 millimeters, but it wraps back around to the post. There's also this checkbox here to add a tread depth, and when I choose that, it'll extend it out a little further to match 1 tread depth. Now, if you want, you could switch from post to floor, and it would return down to the floor. Now, even though wall is an option there, it won't actually show anything in this case. So what I'm going to do is set it back to post, OK out of there, and to do the wall return, I'm going to go to the other railing now. Now, this is the top rail, and you can actually tab in to select it. So that's another way that you could get to that edit type there. But it's not actually the top rail that I want to use to do a wall return. It's actually the handrail type. So what I'm going to do is come over here, and you'll notice that there's already a pipe wall mount type on the list here. So I'm going to right click it and show you the type properties. So here on the type properties, let's move this over here. You can see that the profile that it's using is just a circular 30 millimeter profile. So it's just a round railing. But down here under extension, beginning and bottom, they don't have any of the settings, but it's the same settings that we were just looking at for the top rail. So in other words, I could put in an extension amount, maybe 300 millimeters. I could add a tread depth, and this time I could actually do a wall return. Now, if I click OK there, nothing's going to happen because I've modified that type, but I'm not actually using it yet in the railing. So what I'm going to do is come over here and select this railing, edit its type, and then come down here to handrail 1 and change the type to pipe wall mount. Now, if I click apply, still nothing happens. So this is where this can be very frustrating because there's so many steps to get this right. Well, notice that right above that it says position, and it currently says none. So that's the little tricky part right here. Unless you actually assign this somewhere, either left or right or both, then it doesn't show up. Now, I'm not sure if I want left or right. I'll just take a guess. I'll click apply, and if it gives me what I want, then I'm fine. If not, then I would just change it to right and click OK. But that seems to have done the trick. And notice that it does the extension here. It's returning back into the wall. And furthermore, you can actually see that that particular railing also has these little angled supports there. Let's click OK, and that completes the configuration of those extensions. So as you can see, there's quite a bit of steps to get this set up properly. But once it's set up, it's actually a very powerful tool that allows you to build in whatever code requirements the jurisdiction you work in has directly into your railing types and have them respond accordingly. In this movie, we're going to begin working with stairs. Revit contains 2 kinds of stairs, stair by sketch and stair by component. So in this movie, we'll start with the stair by sketch, and we'll look at the stair by component in a later movie. So I'm in a floor plan here, specifically level 2 floor plan, and I'm going to create the stair that goes from level 2 to level 3. So I'm going to come over here to my zoom command, and I'm going to zoom in down here on this space. This is labeled the south stair, and we're going to create the stair in this general location right here. Up on the architecture tab on the circulation panel, I can click the drop down next to the stair button, and I'm going to choose stair by sketch. Now, Stair by Sketch has a few different buttons that we can look at, and you can see them over here on the drop panel. There's a run, boundary, and riser. Now, run is typically the button that you're going to want to use, and it's lit up by default. And if I let the tooltip display, you can kind of see what this tool will do for us. With a simple 2 clicks, it will create an entire run of stairs, including 2 green lines, which represent the boundary edges of the stair, a blue line down the center, which represents the path of the stair, and then a series of black lines, which represent the individual risers themselves. So with 2 clicks, you get quite a bit of information established. Now, let's look at how it actually decides how to create and position all of those elements. If you look over at the properties palette, you can see that my stair type is called 190 millimeter max riser, 250 millimeter going. So we're going to stick with that type. We're also setting our constraints here from level 2 to level 3. So we're working on the level 2 floor plan, and we're going to go up to the 3rd floor. Now, Revit will take that height between those 2 levels, and it will use it to calculate the desired number of risers. And you can see that currently that is set to 16. And the actual riser height is calculating out as 187.5 millimeters. Now, that's just below our 190 maximum. Now, to see that, let's click the Edit Type button here. And at the very top of this dialog, you can see some calculation rules. And you'll see that there's a minimum tread depth of 250 and a maximum riser height of 190. So the way this works is you can actually change the desired number of risers. But if I try and put in a number that forces the actual riser height to be greater than 190, I'll get this error message which won't allow it. So I'm going to close that. However, I could put in a number greater than what was there. And when I enter that, notice that it just calculates the actual riser height to be a little bit smaller, and it allows for that. So this is the maximum riser height, but there really isn't a minimum one. You're just going to have to choose that on your own. So let's go with 18 risers. Now, I also want to increase the tread depth just a little bit. So I'm going to go with 275. Now, for the width of the stair, set that to 1200 if it's not set that way already. Revit remembers whatever the last width you used was. So the last time I drew a stair, I drew it to 1200, but it will often default to a number slightly smaller than that. So once I have the settings established that I prefer, I'm going to come over here into this space and start drawing the stair. Now, first thing you'll notice is it's trying to snap to nearly everything in sight. So don't really pay too much attention to that, and don't try and get it in exactly the correct location. What I'm going to do is just kind of click in the empty space right here for my first point, and that will get me started. And then I can always move the stair into position later. I usually find that a little bit easier. Now I'm going to start moving down from that point I clicked, and there's a light gray message beneath my cursor. And when that message says 9 risers created, 9 remaining, that means I've used up half of my stair. And that's when you want to click to create your second point. Okay, so we want to use up half of the risers. We're going to create a U-shaped stair, and so we're going to have half on each run. Now, you're only creating the runs. So with a U-shaped stair, we're going to have 2 runs. Revit will create the landing and anything else that's required. So I'm going to move over here and just make sure that I'm lining up with the first run, click to establish that point. Then I'm going to start moving back up in the opposite direction. And when I've exhausted all of the remaining risers, I will click again and create the second run. Now you'll notice that Revit, in addition to creating the run, also creates a landing for us. And the message at the bottom now says that 18 risers were created and 0 are remaining. Okay, so that's what we're after. Now notice what we were able to do with just 4 simple clicks of the mouse. We got this very detailed sketch here. Now, the next thing I want to do is start moving it into position and fine tuning it. So I'm going to actually use a window selection and select the entire sketch. I'll go to my move command. I'll snap to the endpoint right here, and I want to move it to the endpoint right there. Now, sometimes your move is forced in either horizontal or vertical direction only. That's controlled by this constrain checkbox. So if your checkbox is checked, you want to uncheck that now so that you have free motion and you can move and snap to this endpoint. Now there's a small gap right here between the wall and the stair. I'm going to use my measure tool right here and pick the stair and then go to the face of the small wall, and you can see that that's 100 millimeters. I want to match that same distance on this side. Now the way I'm going to do that is to do another window selection, but this time I only want to select the run on the right side and the side of that landing. Okay, so make sure that you've highlighted all of those pieces on the right. Then instead of using the move command, which would require me to do the calculation to figure out how far to move, and I might not get it quite so accurately, I'm going to use this tool here on the options bar called Activate Dimensions. That's going to activate all of the dimensions on the screen, and then I'll be able to manipulate those like any other temporary dimension. So I'll click this one right here, type in 100, and now I've moved that second run over so that it matches the one on the left. Now you can do additional fine tuning if you like. For example, maybe I want to increase the size of the landing. So I'll select this line right here, drag this witness line grip to here, and then I'll click in the dimension and maybe increase that to 1500. So feel free to do any of those kinds of modifications that you like. So one last thing I want to do is configure the railing that I want to use. So over here on the ribbon on the far right, there's a railing button. And by default, you'll always get a railing when you create a stair. And we can use this dialog to configure what we want that railing to be. Now, if you don't want a railing, you can actually choose none, or you could just wait until the stair's created and delete the railing it gives you. But in this case, I'm going to choose 900 millimeter pipe, and I want to set that railing relative to the stringers. Then I'm going to click OK. And then finally, I'll click the Finish Edit Mode button, the big green checkbox, to complete the stair. Now, a warning will appear down here about a non-continuous rail. We can safely ignore that warning by just clicking anywhere to dismiss it. We'll be talking about railings in a future movie, and so we'll discuss the non-continuous rail message at that time. So we now have the stair, and you can see it here in the plan, but I'm going to open up this section view right here. Now, you can right-click it right here and choose Go to View, or you can double-click it on the project browser. And then, of course, you can see that the stair starts here at level 2 and goes up to level 3. Now, we need another stair here to go from the first to the second floor, and so to do that, I'll go back down to the level 1 floor plan. The space that I have available here on level 1 is a little bit larger, so I can actually get away with a straight run stair in this case. Now, I'm going to build the stair using the same sketch-based stair. So if I go to the drop-down, choose Stair by Sketch, what you're going to notice is that it sets all the same settings. We're in run, level 1 to level 2, and if I come down here and scroll down, it did remember my width of 1200, but it did not change the number of risers or the actual tread depth. So just verify those settings. So in this case, I'm going to do 18 risers again, and I'm going to set this to 275 again. So once I have those settings established, I'll click my start point, and this time I'm going to pull straight up. So I'm just going to use the entire set of risers in a single run. I'll select it. I'll activate my dimensions. Click this right here, make it 100. And then this right here, maybe I'll change that to 1800. Check my railing. It still remembers 900 millimeter pipe. It still remembers the stringer, so that's okay. Let's finish. And then once again, let's reopen the section to see the result. You can see that it went a little bit far over here, so I can actually just move it back using the move command like so. So as you can see, creating a sketch-based stair is really just a few clicks, and like other sketch-based objects that we've seen, when you finish the sketch, it creates the full 3D object for you, in this case the stair complete with its railings. In this movie, we're going to look at railing objects. Now, most of the time, the railings that you have in your models will get created as a consequence of creating stairs, and that's certainly true for any railing that has to follow a stair, but there's plenty of situations where you'll need to draw a railing manually, such as guardrail conditions or other kinds of handrails. So I have such a situation here in this file. I'm in the second floor plan, and if I zoom in over in this general location, what you'll see is I have this open to below space, and I have this floor right here, and at the edge of the floor, it would really be nice to have some sort of guardrail. We're going to draw that guardrail right now just using the railing command. If I go to the architecture tab and click the drop down next to railing, you can see there's 2 options here. Now, if you have a stair that doesn't have a railing, you can use this option to place a railing on that stair, and then it will follow the slope. But in this case, because we're creating a guardrail, we just want to sketch the path. So I'm going to click that choice right there. Now that takes me into sketch mode, and the railing sketch is a little unique in the sense that it can either be an open or a closed shape. So if we had a balcony going all the way around this open space, we could draw like a rectangular shape, and it would make the railing go all the way around. But in our case, because we only need it on 2 sides, we can do an open sketch as well. Now you certainly could sketch it line by line, but in this case, this is another place where I think pick lines will be really helpful. So I'm going to click the pick lines option. And I certainly could click directly on the edge of the floor slab, but I actually want to give it just a little bit of an offset. So if you look over here on the options bar, you'll notice that there's an offset field, and I'm just going to put in maybe 50 millimeters, just a slight offset there. Now let me zoom in a little closer so you can see the effect of that. If I highlight this line, notice that there's a small dash line that appears at that 50 millimeters away. So I'm just going to highlight that and click so that it goes up, and then this one so that it goes to the left. Now notice that Revit will do a nice job of cleaning up that corner, but if I go to the previous zoom and zoom in down here, it went a little bit too long. Well, this is easy to fix with this little grip right here. What I'm going to do is just sort of back it up away from the wall, and then that will display a temporary dimension, and I'll just click in there and I'm going to make that 100. So let me zoom back out again. So that's all there is to my sketch, just these 2 simple lines. The last thing you want to do is come over here to the type selector and make sure you're creating the kind of railing that you want. So I'm going to choose the 900 millimeter pipe, and then I'll click the Finish Edit Mode. and that will complete the railing. Now, we can see it here in plan, but it might be nicer to actually look right at it. We could use a section, we could use an interior elevation, but I think in this case, it might be nice to create a 3D view. So instead of using the default 3D view, which would actually display the entire model and the roof and the walls and everything would be in the way, what I'm going to do instead here is create a camera. So a camera is just a perspective view, and we can place it anywhere that we need to. So I'm going to choose camera, and all you do is 2 clicks here. So the first click is where you want to stand. So I'm going to stand way over here in the corner, and the second click is where you want to look. So I'm going to make sure I drag past the railing, even beyond the outside of the building a little bit, and then click to set my camera. And then you can see that this is the railing that we created right here, and it's showing it to us in this nice perspective view. So creating guardrails or any other freestanding railings is as simple as sketching out the path you want, choosing the type of railing, and when you finish, you'll get the desired railing. In this movie, I'm going to look at the component-based stairs. The component-based stairs are created from a collection of interconnected components. And this makes editing them simple because if you edit one component, it usually has an impact on any of the others that are connected to it. Now, another nice benefit of working with the component-based stairs is you can work on them in either 2D or 3D, and you can even do it at the same time because it's more of a 3D sketch mode. So I'd like to demonstrate that benefit of using them by working in 2 views. So I've got level 1 floor plan already open, and I've got this second view over here on my project browser called 3D Stair. Now, this is a cutaway 3D view of the stair lobby, and I'm going to come over to the View tab, click the Tile Windows button here on the Windows panel, and then using my wheel mouse, I'll just pan and zoom a little bit in each view so that we can get a better look at the area that we're going to work in. So let's go to Architecture, click the Stair dropdown, and choose Stair by Component. Now, it's always a good idea to check all the settings first to make sure that you're building the stair that you want. First of all, on the Components panel here, it defaults to Run. The nice thing about the Run tool is that when you draw your runs, it automatically creates any supports and landings that are needed. However, it is possible to create those elements separately if necessary. Now, I'm going to stick with a straight run, but you can also do spiral or U-shaped stairs if required. Over here, I've got choices for different types that I can use for the stair. I'm going to stick with the default one, which has a 190mm max riser and a 250mm tread. Now, the base level will default to level 1 and the top level to level 2. It'll take those 2 levels, do the math based on the 190 riser, and end up at a desired number of risers of 16. It's possible to increase this number. I'm going to make it 18, but you can't decrease it. If you decrease it, you would get a warning because when it does the math, it would actually generate a riser that's larger than 190, and this rule here is telling us that 190 is the maximum. Now, I also want to increase the tread just a little bit, so I'm going to make that 275 in this case. Now let's look at the options bar, and we've got a setting here for the location line. So some of these are self-explanatory, like run center. If I just click a point here in the plan and start drawing, you can see that it's drawing right down the center of the run. The other options are run left or right, and you might need to zoom in to see that a little bit better, but notice that that's the inside edge of the support, and we also have support left or right, which is the outside edge of the support. So let me zoom back out a little bit, and I'm going to move to the right until I've created 9 risers with 9 remaining, and then I will click to place that first run. You will notice that the run will appear in both plan and 3D simultaneously. So again, that's one of the nice benefits of working with this component-based stair. The numbers are a little small here, but if you zoom in a little, you'll also see that it says 1 at the left side and 9 at the right side, so it's indicating to us the actual riser numbers that have been created. Now, let me give myself some room down here, and I want to create the second run. So I'm going to line up with the first one, give myself plenty of room, click my point, and then move back to the left, and it will say 9 risers created, 0 remaining, and then I'll click, and that will create the remainder of the stair. The last thing I want to check before I see what this looks like is the railing. So I'll click over here on the railing button. We've got some different choices available. So I'm going to make sure that I'm choosing the 900mm pipe railing, and I want to put it on the stringer. I'll click OK, and then finally I will finish it. Now, when I do, the stair will appear in 3D with a railing on either side, and I'm going to get a message warning me that the rail is not continuous. Now, if I zoom in here in the 3D view, you can kind of see what it's complaining about. Right here, it's a little disjointed, and over here, maybe it's not so nice. Now, this is an ignorable warning. You can click anywhere, and it will go away. So if you don't want to deal with that warning right now, you can totally ignore it. However, let's go ahead and deal with that. I'm going to select the stair and click the Edit Stairs button here on the ribbon. To deal with that railing, what we need to do is just allow a little bit more room for it to turn the corner. Now, to do that, I'm going to select the landing component. Notice the landing component has several grip points on it. I can take the small triangle drag control here, and I can start dragging it over to the left. Now, it'll snap to certain dimensions, but the distance I want it to go is actually 300, and it's not snapping to that. But that dimension is bold. And whenever a dimension appears in bold, you can start typing, and it'll go right into that dimension. We call this a listening dimension, so it's listening for input. So I'm going to type in 300, press enter, and that will extend that little portion of the landing. I'm going to do the same thing down here, start dragging. This time I want 450. It's not giving it to me, so I'll start typing 450, press enter, and it will extend out that portion of the landing. I should now have enough room on the landing so that if I click finish, that my railing should be able to wrap around nicely without generating a warning. So that was an easy way to fix that particular problem. Now, I want to edit the stair further and talk a little bit more about some of the other options available here. The first thing I want to look at is when I place the second run, I just sort of eyeballed where I wanted it to go. So I don't really have any idea what this distance is in here. Now, when I click this run, it doesn't give me a temporary dimension for that location. So all I'm going to do is just use a permanent dimension because that'll be the easiest way to designate where I want the dimension to be referenced from. So I'm going to use my dimension tool here, or type DI, highlight this inner edge, and I want to make sure it says runs. That's really important. And then the same thing down here. I want to make sure it also says runs. If it says supports, press your tab key until it says run. And then I'll go ahead and click an empty space to place the dimension. Press escape to get out of the dimension command, select the run, that activates that new dimension, and I'll type in the distance that I want that to be. And in this case, I'm going to do 200 millimeters. So I'll just simply type in 200 and press enter. So that makes the distance between those two runs more precise. The next thing I want to look at is if you select either of the runs, at the end of the run, you'll see 2 control handles, one that's shaped like a triangle and the other is like a small blue dot. I'm going to take that small blue dot and drag it a little bit to the right, 2 risers. And notice that it will actually remove those risers from the stair. So if you were to actually look carefully at the stair, it's not kind of floating off the floor. So if you wanted to build like a platform that went up to the stair, kind of like a floor riser situation, you might choose to do that. But what I'm going to do is do Control Z to undo that. Instead, what I want to look at is the triangular control. The triangular control allows you to add and remove treads as well. But notice that whatever you add, it removes from the other side or vice versa. So if I drag to the right, it's removing risers from the top run and adding them to the bottom. Or what I'm going to do is drag to the left and add 2 risers to the top run, and it will remove those 2 risers from the bottom. Now you can verify that by looking at the riser numbers. It says 1 here, 11 here, and then 12 and 18 there. So I still have 18 risers. I've just redistributed them along the stair. Also notice in 3D that the landing actually moved up. It has to because all the components stay connected together. And that's one of the big advantages of working with a component-based stair. Let me go ahead and click finish here. We'll take a look at it in our 3D view. It's looking pretty good, except for one small problem. We're entering in here and wrapping around and coming out here, but we actually want to get to this balcony, and that balcony is on the opposite side. So that's really easy to fix. All you have to do is select the stair, and then here in the plan view, there's this small little flip control, and if I click that, it will flip the direction of the stair And now the top run is the upper run, and the bottom run, the shorter run, is where we enter the stair, and that's the lower run now. And you can see that the stair is correctly oriented. So all that remains is for us to position the stair in the correct location. Now to help us do that, I want to turn on an underlay of the second floor. You can do that by making sure that nothing is selected in the plan view. Go over to the properties palette for the floor plan and scroll down and locate the underlay feature. It's currently set to none. All I'm going to do is change that to level 2 and apply that, and you'll see this ghosted in gray line appear here for level 2. I'll select the stair, go to my move command, snap right to the endpoint at the end of the stair, move it over here. If it's only moving horizontally or vertically, make sure you turn off constrain. Okay, I've got constrain unchecked, but you won't be able to move in both directions if you don't turn that off. I'll go ahead and move it right there, and that puts the stair into position, and you can check it in both your 2D and your 3D views. So the component-based stair allows you to assemble a stair from a collection of interconnected components, and when you manipulate any one of those components, it has an impact on the other connected pieces. So it's a very powerful way to build your stair and interact with it in both 2D and 3D. Railings have many user configurable settings, and they have a feature that allows them to have customizable top and handrails. Those top and handrails can have built-in extension parameters that will automatically extend the handrails either below or above the bottoms and tops of the stair runs. And this can help us build a railing type that complies with local building codes. So in this movie, we're going to look at the process to set up railing extensions. Now, it's a fairly complex process, so I've decided to create a very simple exercise file for this purpose, but we're still going to have several steps that we're going to have to go through, so we have to be somewhat methodical about the approach. So the first thing that I want to do is I'm going to take the two railings that I have, and they're currently the same. They're 900mm pipe on both sides of the stair, and I'm going to create two different types. One on the left side of the stair, which is going to have a return that goes back to the wall, and one on the right side of the stair that's going to have a return that comes back to the railing post. So I'll select this one, edit its type, and duplicate it, and I'm just going to add the word wall return on the end, and click OK. Then I'll select this one, edit its type, duplicate it, and add post return to the end of the name, and click OK. So that's the first step, and by far the easiest. Now, in a lot of Revit types, that's really all we would need to do, and then we can modify each type. But the problem we have in this case is what we actually want to modify, if we go back to edit type, is we actually want to modify the parameters of the top rail or the handrails. And you can see that the top rail is set to another type, which is currently called 40mm. Now, if I open up the drop-down list, there are some other choices in there, but the list of choices is the same regardless of which one of these rails I choose. So what I actually need to do is create a new type for that list. Now, I can't do it here in this dialog. So where I have to do that is actually on the project browser. So I'm going to scroll down in the project browser and expand families, and then I'll locate the railings branch and expand it. And then I'm looking for the top rail type branch and expand it. And then finally, there is circular 40mm. I'm going to right click it and choose duplicate. That'll create 40mm 2, and I'll rename that with the right click and remove the 2 and call it post return. So now I'm going to work on this one first then, and I'm going to select it, go to edit type, and I now want to assign that new type that I just created called post return to that railing. Now click OK, and still nothing happens. So you can see there's a great deal of setup before you even get any payoff. Okay, so at least now we have a type and it's assigned to the correct subsettings. Now what we need to do is actually modify this post return and tell it to do a return. So we can do that right here by right clicking it and going to type properties. When that dialog displays, there's a number of settings that are in here, and what we want to do is, let's move this out of the way so that we can see the drawing window in the background. We want to focus on the extension at beginning and bottom. So the extension style is currently set to none. The length is currently set to 0. So there's a few things we can do here. For the length, I'm going to put in 300. Now let's just try that and see what happens. When I click apply, watch what happens. Notice that the top rail here has extended out 300mm. Now this one did not extend out because I've created this brand new type here, and that's the only place that applies. So that's why it was important that we make that separate type. Now, if I look at extension style, there's actually 3 options there: wall, floor, and post. So let's try post style and click apply, and you'll see that not only does it extend out the 300mm, but it wraps back around to the post. There's also this checkbox here to add a tread depth, and when I choose that, it'll extend it out a little further to match 1 tread depth. Now, if you want, you could switch from post to floor, and it would return down to the floor. Now, even though wall is an option there, it won't actually show anything in this case. So what I'm going to do is set it back to post, OK out of there, and to do the wall return, I'm going to go to the other railing now. Now, this is the top rail, and you can actually tab in to select it. So that's another way that you could get to that edit type there. But it's not actually the top rail that I want to use to do a wall return. It's actually the handrail type. So what I'm going to do is come over here, and you'll notice that there's already a pipe wall mount type on the list here. So I'm going to right click it and show you the type properties. So here on the type properties, let's move this over here. You can see that the profile that it's using is just a circular 30mm profile. So it's just a round railing. But down here under extension, beginning and bottom, they don't have any of the settings, but it's the same settings that we were just looking at for the top rail. So in other words, I could put in an extension amount, maybe 300mm. I could add a tread depth, and this time I could actually do a wall return. Now, if I click OK there, nothing's going to happen because I've modified that type, but I'm not actually using it yet in the railing. So what I'm going to do is come over here and select this railing, edit its type, and then come down here to handrail 1 and change the type to pipe wall mount. Now, if I click apply, still nothing happens. So this is where this can be very frustrating because there's so many steps to get this right. Well, notice that right above that it says position, and it currently says none. So that's the little tricky part right here. Unless you actually assign this somewhere, either left or right or both, then it doesn't show up. Now, I'm not sure if I want left or right. I'll just take a guess. I'll click apply, and if it gives me what I want, then I'm fine. If not, then I would just change it to right and click OK. But that seems to have done the trick. And notice that it does the extension here. It's returning back into the wall. And furthermore, you can actually see that that particular railing also has these little angled supports there. Let's click OK, and that completes the configuration of those extensions. So as you can see, there's quite a bit of steps to get this set up properly. But once it's set up, it's actually a very powerful tool that allows you to build in whatever code requirements the jurisdiction you work in has directly into your railing types and have them respond accordingly. In this movie, we're going to create our own custom wall type. Now, before we get into the details of doing that, let's talk briefly about types and families in particular. Would you be surprised to find out that every wall that we've created so far in all of the movies in this course have been the same family? That family is the basic wall family. Now, that might surprise you a little bit because we've used brick walls, we've used stud walls, we've used concrete walls, and they don't at all seem like they're the same. Well, when we talk about those variations between brick and stud and concrete, we're not actually talking about a variation in family. What we're really talking about is a variation in type. So what family are all of those walls? Well, they're all a wall family that Revit calls the basic wall family. And the basic wall family, furthermore, is a kind of family that Revit refers to as a system family. Now, a system family is a family that's built into the system and that you and I cannot change or modify in any way. Walls are system families, floors, roofs, stairs, these are all system families. Now, again, that might surprise you because you might be saying, well, wait a minute, we've customized walls, we were editing floors and roofs, what are you talking about? Well, in all those cases, when we were making changes to those items, what we were actually changing were the types, not the families. So what it means to be a wall, what it means to be a roof or a stair, that's built into Revit and part of a system family. So when it comes time for us to customize, we're actually creating and modifying types. So to do that, we're going to come over here and I'm going to zoom in on this toilet room area. And in this movie, we're going to focus on a basic wall type. And then in the subsequent movies in this chapter, we'll look at the other two wall families, which are the curtain wall family and the stacked wall family. So why don't we take a look at this wall right here between the plumbing fixtures in the two toilet rooms. Right now, it's a little bit thin to be a plumbing wall. So what I want to do is create a new custom type for that wall. Now, the way you do that is you come over here to properties and you click edit type. Now, don't get too anxious and jump right into edit structure and start making changes. Like for example, suppose I took layer 3 here and made it 200 millimeters and click OK. Notice the impact of that change is not applied to just the wall that I had selected, but it actually applies throughout the model because we had several instances of that type. Now, I know we've discussed that before, but it's worth repeating. So I'm going to undo that. And what we want to do is always remember that when we select the object, if our intention is to create a new type, then the first thing we should do is duplicate. So I'm going to duplicate that type and give it a name. Now, you can follow your office standard naming convention if you like. I've just called mine plumbing wall. The name isn't terribly important as long as it's descriptive and it makes sense. Now I'm going to click edit structure. Now what I want to do in this dialog is make a few adjustments. The first thing is let's widen the dialog so that we can actually read what's in each of these columns. The next thing I want to do is click this little preview button over here so that we can actually see a little illustration of what the wall structure looks like. Now, this is a basic stud wall, so it's a pretty simple structure. In the core, there is a structural layer set to a material called metal stud, and it's 90 millimeters. And then on either side of that, we have two finished layers that are assigned to gypsum wallboard. Now, we've talked about the difference between core and finish in a previous movie, and you may recall that every wall has to have a core, and it has to have at least one layer in that core, but it can have more than that. You also may recall that we're not required to have finishes. We could actually delete those finished layers if we wanted to, but we certainly can have one or more finished layers. Now, what I want to do, all the changes I want to make to this wall, I want to do within the core. So I actually want to increase the size of the core, add another stud, and then add an air gap between those two studs. So I'm going to come down here and click this insert button twice. Now, initially, you won't see any change in the preview because over here, you can see that the thicknesses are still set to 0. Now, let's talk about each of the columns in this dialog. The function column accesses a pre-built list of 6 predefined functions. Now, if I click in one of those fields, a small dropdown appears, and if I expand that dropdown, I will see those 6 functions. The first 5 are numbered from 1 to 5 in square brackets. Structure has the highest priority, finish 2 has the lowest priority. So the lower the number, the higher the priority. What this means is when this wall intersects another wall, the structure layers will try to join up with one another and they will pass through any non-structure layers. And the finished layers will be passed through by all the other layers as they try to join up with other finished layers. Now, in addition to the function, the material also comes into play when we're establishing wall joints. When two walls join together, the functions determine how the layers cross through one another, but if you want a nice clean joint with no seams, both the function and the material have to be the same. So we'll see that when we're finished here back in the drawing window. So what I'm going to do here is I'm going to make this layer 3 that I have now, this new layer 3, I'm going to leave that set to structure. The function for layer 4, I'm actually going to change to thermal air layer because that's just going to be the gap within my wall for the plumbing. Now over here in the material column, I want layer 3 to essentially be a copy of layer 5. So what I can do is select the name of the material next to layer 5, do Control C on my keyboard to copy it, come up here and select the word by category and do Control V on my clipboard to paste it. Now that's just a shortcut way to use the same material over again. I can do the same thing in the thickness column, Control C and Control V. Now, when I click elsewhere, it'll actually adjust the preview to reflect the fact that I now have these 2 stud layers. Now, my thermal air layer, layer 4, is currently a 0 thickness, so we need to adjust that and give it some more thickness. And we also need to assign it to a material. Now, we can do this in either order. Let's click right here where it says by category and notice that a small browse button becomes available. I'm going to click that browse button and that's going to load up my material browser. Now in this case, the material I want is right at the top of the list, so I could just simply click OK and it would assign that air material directly to that layer. But let's take a minute or two to talk about what we see here in this material browser before doing that. All of the materials in this list are items that are part of this current file that we can choose from. Now, if I look at a material here, say this brick common, and you look over on the graphics tab, you're going to see the properties of that material. If you look at this material in a shaded view, it will assign this reddish color to it. If you look at it in elevation or beyond in section, in other words, not cut through it, it will apply this brick pattern to the surface. If you cut through this brick in floor plan or in section, it will use this crosshatch. So all of these properties are assigned in elevations, sections, floor plans, and 3D views. If you do a rendering of this material, then it will use the settings here on the appearance tab, which include a little photograph of bricks. If you want to calculate any load carrying capabilities of this brick, you can input physical properties. Now, there aren't really any physical properties in this particular brick material, but there could be if it was a load carrying material, such as something like concrete. So if I wanted to see if I had any load carrying materials like concrete, I could come over here to the search field at the top and start typing the word concrete. That will shorten the list to just the materials that contain that keyword. And perhaps if I select this concrete cast in situ here, you can see that this does have some basic physical properties. And you can expand each of these and start to see the properties that might be pertinent for your structural engineer. Finally, on the thermal tab are properties that determine what the thermal properties of this material are and help determine the R value of the wall assembly. So I'm going to go back to the graphics tab. I'm going to click this X here to clear the search, and then I'm simply going to select the air material. Now the air material, it doesn't have many of those settings. It doesn't have any patterns. It doesn't have color. There's no render material. It doesn't have physical properties, but it does have some thermal properties. Okay, back to the graphics tab, select air, and I'm going to click OK. And that assigns that air material to our new layer. All that remains for me to do now is to give that layer a thickness. So I want it to be at least as thick as the stud, so maybe I'll go a little thicker than that and put in 100 millimeters. And notice that the preview window will adjust to reflect that change. At the far right-hand column, you can see that there's a structural material checkbox. Now you can only check one layer at a time here. So whatever layer you check, that's the layer that will be considered structural by your structural engineer. Now, if you look up here at the top of the window, notice that there's a resistance value and a thermal mass that have been calculated. That's a consequence of the materials that have been assigned to those layers in conjunction with the thicknesses. So Revit looks at the thermal settings that I just showed you in the material browser, compares those with the thicknesses, does the calculation, and then comes up with these resistance and thermal mass values. So that can be really handy when you're doing, say, green building analysis or thermal load calculations or other analysis in your Revit project. So I'm going to click OK here. I'm going to click OK again, and then we're going to see that wall there between the plumbing grow in thickness, and notice that it only affected that wall this time because we did duplicate. Now, we're not seeing any of those layers at the moment. Well, we talked about this in a previous movie. Let's zoom in right here, and in order to see those internal layers, I just need to come over here and set the level of detail to either medium or fine. And this is where we can see the result of having both the same function and material. Notice that this stud layer is cleaning up with this stud layer, as is this one, and we're getting a seam here at the air gap. So it's displaying pretty much exactly the way that we would want it to display, and all those layers are joining up correctly. So creating your own custom basic wall type is just a simple matter of starting with a wall type that's close to the one that you want to create, duplicating it, and then modifying the layer structure to suit the structure of the wall you're trying to create. As we've already discussed, walls are system family, and system family just means that it's built into the Revit system and it has fixed parameters that we can't modify. Now, there are three wall families: the basic wall, the stacked wall, and the curtain wall. We looked at the basic wall in a previous movie, and as you recall, it's a basic wall just simply because it's the same material throughout its construction. If you cut it in plan or in section, you'd see the same layers and the same construction throughout. A stacked wall is slightly more complex because while it's got the same material along its length, what you'd see in plan, it actually varies along the height. And the reason it varies along the height is because you simply stack two or more basic walls on top of one another to create one. So in this movie, we're going to create our own custom stacked wall and look at the properties and understand how it's put together, and we'll address curtain walls in a later movie. So I've provided a very simple exercise file for this purpose, and most of the work is actually going to take place on the project browser. So I'm going to scroll down on the project browser to the families branch. I'm going to expand that, and then scroll down some more, find the walls branch, expand it. You will see the three wall families that we've been talking about, and if I expand the stacked wall, you will note that there is already a stacked wall type in this file. Now, that's required because every family has to have at least one type. But before we start to modify that, let's go to basic walls, scroll down a little bit, and I've provided, to simplify things, custom wall types that we're going to use to build our stack wall. So let's take a look at each one of these. I've named them all with a prefix of RET for Revit Essential Training, and this just sort of emulates what a lot of firms like to do, where they like to use the initials of the firm name in the names of their custom types and families so that all the users know which ones have been customized. That's a pretty standard best practice. I'm going to right-click the first one and go to Type Properties. Let me change the preview window here to a floor plan so we can see the composition of this wall. And as you can see, it's got a concrete block core, it's got drywall on the inside face, insulation, air gap, and brick on the outside face. And if you want to click Edit Structure, you can see all of those layers here. Now, I'm not going to change anything. We'll just cancel out of there. We'll look at the type properties of the next one. And this one just has two wipes of brick in its core, an air gap and an exterior brick finish layer, and no finish layer on the inside. Let me cancel that. And then finally, the brick foundation is just a simple one-layer wall that just has a single layer of concrete. So what we're going to do is create a stacked wall that starts with the foundation, then does the brick and block, and ends with the parapet. So to do that, we're going to come down here, and we're going to right-click this existing stacked wall type and choose Type Properties. Now here, we want to remember to click the duplicate button before we get started. Otherwise, we'll be modifying the existing one that's already here in the file, which may or may not be what you want. And I'm just simply going to call this RET Exterior Shell. Now, this is a simpler type dialog. There's only one big edit button, and we're going to click that. And what you'll see here is there are currently two walls stacked on top of each other. This one down here at the bottom, and then another one up here at the top. So I'm going to change each of those and then add a third layer. So I'm going to take the one at the bottom, click the little drop down, scroll down. There's all my basic wall types, and I'll choose the concrete foundation wall. Then I'll go to the one above that, scroll down, and choose my RET brick on block, and then finally click the insert button and change the top one to RET brick parapet. Now, initially, when you look at the preview, it doesn't look so nice, so we obviously have some adjustments to make. And the first adjustment I'd like to look at is the height. Now, notice that two of the walls have a fixed height, and the third one is variable. One of your stacked wall types will have to be variable, but then all the others will have a fixed height. We can make another layer variable simply by selecting it and clicking the variable button. Notice that that would then assign a fixed height to the other layers. Now, I think in this case, it makes more sense to leave layer 2 the variable layer. So as a consequence, we're going to take layer 1 and give our parapet a fixed height. Let's try maybe 1200 millimeters, and we're going to take our foundation and give it a fixed height, maybe 1500 millimeters. So that establishes the heights, and you can see that the preview already is starting to look better. Now, you can see up here and certainly down here that the walls are skewed from one another. So let's start up here at the top, and notice that there is a navigation bar in this preview window, and we can zoom in on this top portion and kind of get a better look. Now, the offset column is what we can use to kind of shift the walls with respect to one another. But before you start trying to move the offsets, it's not a bad idea to see if changing the location line will help correct some of the problems. So in this case, I'm going to try a location line of core face exterior, and notice how that actually does correct the top portion of the wall. So when we flush the two exterior faces of the core, all the rest of it takes care of itself. Now, if I scroll down to the bottom portion of the wall, it did not fix that portion, so I will need to go to an offset there. Now, I've previously calculated what that offset should be, and 165 gives us a pretty nice result. If you just click somewhere else in another field, it will shift it over and apply that result. And so I'm allowing the brick to overlap slightly for maybe a small drip edge there. Now, naturally, you can try different offsets and do a little trial and error, or you can go back out to the drawing and do a measurement if you need to. Anyway, that completes the configuration of this stack wall type. Let's click OK, and then OK again. And all that remains for us to do now is to actually apply it to the walls here in the model. So I'm going to highlight one of the walls, press tab, and click to do a chain selection. Come over here to the type selector, scroll down, and there under stacked wall, you'll now see your RET exterior shell. And when I apply it to these walls, as you can see, it's now applied that stacked wall type here. Now, if I zoom in just a little bit, the brick hatch will start to display. You can see we've got the foundation wall in the lower portion and the parapet cap up at the top. So a stacked wall just allows you to create a more complex wall assembly by simply taking two or more basic walls and literally stacking them on top of one another. The last thing that you should know about a stacked wall is if at any time you decide you no longer want the wall assembly to be a single continuous thing, you can actually right-click on it and choose break up. When you do that, you now have three separate basic walls that are still stacked on top of each other, but they're separately selectable as basic walls, and you can treat them as such. In this movie, I'm going to introduce you to our third wall family, the curtain wall. Now, the curtain wall is the most complex of the three wall families. It can vary both along its length and along its height, and it can have complex grid patterns embedded directly into the curtain wall design. Now, there's a few different ways we can work with the curtain wall. We can actually set up complex curtain wall types that set up a repetition that will occur along the length and height of the curtain wall, and we can even do a series of curtain wall grids and mullions manually to create custom designs. In this movie, I'm going to look at the type-based curtain wall designs, the built-in ones that are in the template that we started with, and then in future movies, we'll take a look at some of the other options. To get started here, I'm going to draw a small piece of curtain wall, and I'm going to do that just in this floor plan with the wall command. Now, keep in mind that a curtain wall is an actual wall object, so when you come over here to the type selector, you've got all your basic walls at the top, and then somewhere down here, you're going to see the curtain wall family. And then beneath that, you'll see the different types of that curtain wall family. Now, there's a curtain wall, which is a really generic one, exterior glazing, and storefront. I'm going to use storefront because of the three that are included in this template, it's the one that's the most complex, or it has the most amount of features in it. Now, I'm going to just draw that off to the side over here, and maybe I'll draw that about 4,500 millimeters. I just, kind of make a small random length there. Let me click the modify tool, and I'll start off by zooming in on that in the floor plan. Now, what you're going to see is that there's a repetition in bay spacing here in the curtain wall. Now, if you move your mouse near the curtain wall, it will actually highlight with a dashed line down the middle of it, and it has these sort of two dashed lines at the end. That's the curtain wall itself. But if you move your mouse near some of these bold elements here and start to tab, you can actually reach into the curtain wall and select those elements. So there's panels, there's mullions running vertically, and then this vertical line that you see here, that's actually a curtain wall grid. So all of those parts and pieces are things that we can configure within the curtain wall, and they have an impact on the overall design. Now, let's take a look at this in our 3D view. I'm just going to open up the default 3D view here, and let me just orbit around and look at it from the other side here. Okay, so you can see that there's the curtain wall again with that dash cage kind of around it. That's the entire curtain wall. But if you use your tab key, you can reach in and touch the individual mullions or the individual panels, like so. So again, keep in mind that it's very important how you select a curtain wall, whether or not you want to manipulate the curtain wall itself or some of the internal subcomponents. Now, let's look a little bit more at the behavior of this. So I'm going to select the curtain wall itself, and you'll see that you get two small little grip dots here at the bottom ends, and then you get these little triangular grips here at the top. If I take one of these little triangular grips, you notice that you have a small bay at the top and a tall bay down below. If I start to drag this, notice that that bay at the top is getting larger, and at some point, it will actually introduce a new bay. So there's a spacing built into this curtain wall design that says what the bay size ought to be, and then any leftover is just applied at the top. Now contrast that to the behavior that we're seeing running linearly. When I start to drag in this direction, it doesn't matter how long I make it. Notice that I'm always getting an equal number of bays. Now right now I have 5 bays, and if I drag it enough, I may very well end up with 6 bays. I still have 5 there. And now I have 6. So at some point, it decides when to add a new bay, but it always keeps all the bays equally spaced. So let's look at the type properties of this curtain wall to understand how that's being achieved. So with it selected, I'm going to come over here and click Edit Type, just like we've done with many other types here in Revit. So let's talk about the vertical and horizontal grid. Now the vertical grid are the bay lines that are running vertically, but that actually determines those horizontal bays. And you'll notice that the layout parameter that's being used there is maximum spacing, and that's currently set to 1524. So that's what we witnessed when we were dragging it linearly, and at some point, it added a new bay and then adjusted the size of all the bays. So the bays can't get larger than 1524, but they all have to be equal when you're using a maximum spacing. The same is true if you change that to a minimum spacing. It's just that it would go for the minimum number before it added another bay. Now in the horizontal direction, you'll see that it's using a fixed distance of 2400. So that's what we witnessed when we started stretching it vertically, and we got a bay and then another full-size bay and then a little bit of leftover at the top. So because this is a fixed distance, anything beyond a multiple of 24, it's going to just add the leftover at the end. Okay. Now in both of these cases, it's actually possible to check these boxes and adjust for the thickness of the mullion. So currently, it's actually going to the center lines of the mullions when it determines these two spacings. But if you want to ignore the thickness of the mullion and have it determine the size of the panel, then you can check those boxes. Now about those mullions, if we scroll down a little bit, we've got settings for both vertical and horizontal mullions. And at the moment, all 6 conditions are set to the same mullion, but each of these is a drop-down list where you could actually choose from other types of mullions and apply them either vertically, horizontally, or around the 4 edges. Now, the final setting I want to point out is up here where it says automatically embed. Now, notice that there's a checkbox in there, and that's currently turned on. So let me cancel out of here. I'm going to delete this curtain wall, and I'm going to go back to my level 1 floor plan. And the drawing is over here somewhere. So let me just zoom out and find it. And I want to focus here on this stair area. And I want to show you what the automatically embed feature does. So I'm going to go back to the wall command, make sure storefront is selected. And I'm going to actually draw this new storefront curtain wall directly on top of my existing exterior wall at the stair here. So I'm going to click right here and maybe drag to about here. I'm just watching my temporary dimension there. Maybe 5,200 millimeters seems pretty good. And notice what it did. Do you see how it actually cut right into the wall? The automatically embed feature is basically making the curtain wall behave like a door or a window. So let's take a look at that in 3D. Go ahead and zoom out here. You can see it right there. Now, just like we saw before, I can select it. I can even drag it up and make it taller, right? And it will add that extra bay. And if I want to manipulate this maybe a little bit more carefully, I can go to the north elevation and focus in on that bay. And what you see there is when I highlight the wall, it's literally cutting a hole in a wall all the way around, just like a door or a window would. Now, maybe I want to make this a little bit taller to let the maximum amount of light in the stair, but I'm a little concerned with that corner condition right there. Well, any wall we can do this next feature to. I'm going to do it to a curtain wall, but we could do it just as easily to a basic wall as well. So I've selected the curtain wall. And again, make sure you're clicking where you've got that dash line going all the way around. And then I'm going to click this edit profile button. That's going to put me in sketch mode, but the sketch that I'm modifying is actually the shape of the curtain wall's elevation. I'm going to go to pick lines, come over here to the offset field and decide how far away from that diagonal line I want to be. So maybe about 1,200 millimeters. I'm going to highlight the edge of the eave of the roof and click. And that will create a diagonal line that's parallel offset from the existing roof. I'll cancel there, go to trim and extend to corner, trim this up, and then when I click finish, notice how it'll actually remove that corner of the curtain wall. Now I did a really simple thing there with a straight line, but you can do curves or really any shape you want and start sculpting the shape of that curtain wall. And you can see that the mullions and the other grid lines and everything kind of adjust to match that new shape. So a curtain wall is a more complex wall assembly. It's an assembly of parts, mullions, grids, and panels, and we'll look at those in detail in a future movie. But you have all those components together in a type-based curtain wall, and you just simply draw the wall, and so it will give you that standard repetition both along the length and the height of the curtain wall. This movie, we're going to continue our exploration of the curtain wall, and I'm going to build a custom design. So what we saw in the previous movie is that if you do a curtain wall type, you can configure a set spacing in both the horizontal and vertical dimension, but what you can't do is actually do any kind of variation. So like even if you want to do something as simple as an ABA rhythm, you can't do that in the curtain wall type. So the way that you do that is actually create a really generic curtain wall and then come in and place the grids and mullions manually. So I want to show you that process here. I'm going to create a custom entrance for the building. So I'm going to zoom in right over here in this location, and I've removed the door so that we can just work in this clean area right here. Now I'm going to go to the architecture tab and click on the wall tool, or you can type WA. It remembers that I previously used the storefront, but for this example, I'm actually going to use the generic curtain wall. So I'm just going to choose curtain wall there off the list, and I'll start maybe right about here, maybe 300 or 400 millimeters off the edge. And I want to go to about 4,500 and then click. Now, I'll run into a little snag when I do that. Notice that I get a warning down at the bottom and it says that the highlighted walls overlap, and it generally thinks that that's a bad idea. Now, in most cases, having 2 walls overlap one another is considered a bad idea. Let's go ahead and click the modify tool and cancel out of there. So the reason for this situation is that this generic curtain wall that we've just created here, if we go to edit type, does not have the automatically embed feature turned on. Now, you may recall from the previous movie that the storefront design did have that turned on. Now, I've already dismissed the warning, but what the warning told me was that I can manually embed this curtain wall into the other one with a tool here on the Modify tab. So if I use this Cut Geometry tool, it's going to allow me to select the masonry wall and then pick the curtain wall, and then it will embed it for me manually. So even if you don't have the automatic embed feature turned on, you can always manually embed it using the Cut Geometry tool. Now, the next step is to take this really generic curtain wall, which currently is just a giant pane of glass, and it's probably easier to see that in a south elevation view. And then let's go ahead and zoom in on that curtain wall. So it's just this giant pane of glass here, and it's going to be easier to subdivide it here when we're looking right at it. And what I want to do now is start breaking that up into bays. Now, because it doesn't have any bays of its own predefined, I'm free to go to the Architecture tab and use this Curtain Grid tool right here and start laying out the bays that I want to have. So I'm going to click Curtain Grid, and the way this works is if you highlight one of the edges of the curtain wall, it will create a bay for you. So what I'm going to do is kind of create 4 of these all the way around. I just sort of place them randomly for the moment. Then I'm going to come in and add 3 more right down here in the middle, and then I'll click Modify to cancel out. Now, like we've done in so many other places in Revit, it's the sketch then modify methodology. So I've sort of sketched in where I want those grid lines to occur, and now I'm going to come back and modify them. Now, I could certainly do that with temporary dimensions like we've done in the past. So I can select the grid line. Okay, make sure you're selecting the grid line itself. It'll say modify curtain wall grids here, and then I could edit the temporary dimension and put in a value such as 600. That works perfectly fine. I can do it again in this direction. Let's use 600 again. Works perfectly fine. What I prefer to do, however, is use permanent dimensions for this, because I think it's a little bit easier to control, and then I always have the permanent dimension available if I want to make modifications later. So I'm going to go to the dimension tool, and I find it's always best to start on one of the internal grids. If you start on the exterior, it sometimes doesn't allow you to select what we need to select. So always start here on one of these internal grids, and I'm going to go ahead and select each one. Then I'll add in the 2 external bays. And recall that you just need to place that dimension somewhere in white space. So it's kind of empty down here, so I'll just kind of click down here and place it in that location. Now you can see from the numbers that appear that it's all very random. Let me cancel out of there. But now watch what happens when I select one of the grid lines. In addition to the temporary dimension that appears, the 2 dimensions on either side on the permanent dimension have actually activated as temporaries as well. And so I can click in there and put in whatever value I want. So I'm going to go with 450. And then be careful. A lot of times people forget and they come over here and they say, okay, I want that 900. And what did it do? It just moved the same grid back again. So remember to always select what you want to move. So that means I need to work from one side of the grid over to the other and just keep changing the selection. So I'll change this to 900. Then I'll switch selection to this, change that to 900. Go to this one, also 900, and then finally this one, which is also 900, and that will make that final bay 450. Now this is a very simple design. I have 2 equal bays top and bottom, 2 equal bays side to side, and then a bunch of equal bays in the middle. But even as simple as this design is, this is not something I could do in the curtain wall type. If you select this and you go to edit type, remember that your vertical grid and horizontal grid, you only get 1 spacing in each direction. So unless you want completely equal spacing in both directions, you can't use the type properties. You have to do it this way. Now I want to put a doorway here so we can get in the building. And obviously I have some grid lines in the way. So another feature of the grid lines is if you select them, up on the ribbon, you'll get an add and remove segments button. So if I click that button, it's going to allow me to touch the segments that I want to remove. And so I'm going to click both of those, and when I kind of click away from it, you see how it's actually removed that grid line? And as a consequence, this panel right here, I'm pressing tab to get into there, that panel right there has become a continuous panel. Let me deselect that. I'm also going to remove this grid line right here. So add and remove segments. I'll click right there. That removes it. I'll just click away to deselect, come over here, highlight, tab, and keep tabbing until the big bay selects, and now that entire bay is selected. Now, by default, all of the other bays are just using the standard system panel called Glaze. You can see it over there on the Properties palette. This one's using it as well. And that just makes it look like a big plane of glass. But coming over here to the Properties palette, we can change it to really anything we want. Now, I could use Glaze. I can make it solid. You can actually even load wall families into that bay. But what I've done is preloaded in a special panel here called Door, Curtain Wall, Storefront, Double. So it's a specially designed curtain wall family that is used to represent a door. So I'm going to select that, and you're going to see that door family kind of fill in that big void right there. So if I deselect it and click away, you can see that I've now applied a door in that location. Now, what I'm going to do here is tab in again and highlight this one, tab in, control click, one more time, control click, and one more time, control click. So I now have 4 curtain wall panels selected across the bottom, and I'm going to come over here and change those to a solid panel. Now we really can't tell the difference in this view because it's in hidden line. So why don't we go to 3D? I'm going to zoom in on this entryway, and then I'm going to hold my shift key and orbit slightly to kind of give me a better vantage point. Now here in hidden line, you can see that the glass is transparent, but that those bays down the bottom are not. If I change this to shaded view, it will be a lot easier to see that. So you can see the glass is transparent, and then we have these sort of spandrel panels down here at the bottom. Now, all I need to do is add some mullions. Now I could go back to the elevation view to do that, or I could actually do it right here in the 3D view. So I'm going to orbit a little bit more, just so I can look more head on at this, and then I'm going to use the mullion tool right here on the ribbon. Now, there are some different mullion types available here on the dropdown, and you could certainly choose other types. I'm going to stick with the 50 by 150 millimeter default mullion for all of these. Now, there's 3 options here: grid line segment, or all grid lines, which would actually do everything. But in that case, it would put mullions across underneath the door, which I don't want. So I'm going to just use grid line for these, and I'm going to click on each of these locations. This one I'm having a hard time, so I'm going to tip the view this way. There it is. Then I'll tip back again, and then let me do grid line segment here, here, and here, here, and here. So those are all my mullions, and if you zoom in, you can see that the mullions have direction. So you can actually customize that as well. Now, it's a little difficult to see here in this view, so why don't I go back to the south elevation for a moment, and you can see it a little bit more clearly here. You see these little toggle mullion joint icons? Those will allow me to toggle the joint from horizontal to vertical. And so you could do that anywhere you want to start customizing the design. Another thing you can do is actually right click on one of these, go to this option here to select all of the mullions on the grid line, and then you can either right click again and say make continuous, or you can just use this button right here. And that will actually toggle all of those joints all the way across. So feel free to continue fine tuning and adjusting those different joint conditions. Try loading in other panels and mullions if you like. You can even select a mullion, go to the edit type, go to duplicate, and create your own mullion size if you prefer. So you can see that in situations where creating a curtain wall type doesn't give you what you need because you're limited by the spacings of just one grid spacing in each direction, you can easily set up a curtain wall where you lay out the grids manually, and by using a couple clever strategies like some dimensions and some careful planning, you can create a very robust curtain wall design in really not that much time and effort at all. This movie, we're going to take a look at sweeps and reveals. Sweeps and reveals allow us to take 3D geometry and move it along the length or the height of the wall. A sweep will add to the mass of the wall, and a reveal will carve away from it. We can add both of these at the type level, in which case you would modify the wall type and it would apply to all instances of that type, or we can add them individually wall by wall. So I'll look at both examples here in this movie. So I'm going to select one of these exterior walls, and I'm going to start with a type-based wall sweep. Now to set that up, we're going to click the Edit Type button here, and that will bring up the type properties, and then I'm going to click the Edit Structure button. Now previously we've been in here and we've been working with the layer structure. Down here at the bottom, you can see a series of buttons that are all grayed out, and we've got a sweeps button and a reveals button. Well, how do we get to those buttons? Well, the little clue is right here. It says Section Preview Only. So in order to use these buttons, you have to first turn on the preview. Let me just adjust this so it's on the screen here. And then make sure that this is not a floor plan. Make sure that it's a section. So notice that when this says section, these two buttons will light up. Now, the basic steps of adding either a sweep or reveal are nearly the same. So for the first example, I'm going to do a sweep, but you could do exactly the same thing for a reveal. You'll get a list of sweeps that are already in here. At the moment, I don't have any. So I'll click the Add button here, and that will add my first sweep. Now, it's always a good idea to kind of make sure that you can see the preview here in the background, because as you work, you'll be able to click the Apply button. So with the default sweep, it's just a simple rectangle that appears down at the bottom of the wall. If I open up this profile dropdown, you can see that there's only one other choice available. Now, a profile is a simple 2D family that just defines a shape, and then that shape is going to be used by the sweep to push material all the way along the length of the wall. Well, fortunately, there's a Load Profile button here, so we don't have to cancel all the way out to go load a profile. So let me go to my metric library. There's a profiles folder, and then in here is a walls folder. So I'm going to pick this wall sweep brick soldier course profile and open that up. Now, when I open up the profile list, that will have actually loaded in 3 different profiles. So I'm going to choose the soldier course 2 bricks profile. Now, next to that is material. And if I click in there, I've got my browse button, and that takes me to the material browser. Now, if I come up here and I type the word soldier, you're going to see that nothing appears. So I'm going to cancel that search, and I'm going to take my existing brick common material here and duplicate it. And then once it's duplicated, I'll rename that to soldier course. Now, at the moment, it's just a copy of brick with a standard brick pattern. What I want to do is click on that pattern there, and I'm going to choose this 75mm vertical pattern instead. And that's going to give it vertical lines, so it looks more like a soldier course. Now, that'll be fine for any of the hidden line or shaded views. But if I also want it to look like a soldier course in rendering, I need to go to the Appearance tab as well. Now, over here at the top, there's a little icon that says Replace this asset. These images that you see here are considered assets. So when I click that, that will load up the asset browser. Now here, I can type soldier, and when I do, it will find a soldier course asset that we can use. And if you highlight it, there's this small little icon right here that will replace the current asset with a soldier course pattern. I'll close the asset browser, make sure that this is selected, click OK, and now it's applied that new brick soldier course to my profile. Now, the distance is how far up the wall it goes. Now, it's currently measured from the base, but it could also be measured from the top. So I'm just going to click in here and decide how far up the wall I want this to go. Maybe 3,000 millimeters. Let's click apply and see what that does. So you can see now that it stretches it out to the shape of that soldier course and it moves it up. And as you can see, I've got to shift it in a little bit. So that's where this offset field comes from. A positive number will move it away from the wall, and a negative number will push it into the wall. So let's try -90. And that kind of pushes it into the wall, and that looks like it did the trick. So let's go ahead and do one last thing. Let's check this box, which makes it cuttable. In other words, if a door or a window intersects this soldier course, it will actually cut through it. And in fact, if we want to see that, we might want to lower it just a little bit. So why don't I try 2,000 here and click apply. Let's click OK, and then OK again. And because this is a type level modification, what you're going to see is that soldier course is occurring on every instance of this wall, all the way around the entire model. Because I just made it cuttable, you can see that the doors and windows are actually cutting through it. Now, the only place that you might want to adjust is that soldier actually appears up on this small wall up here. So to fix that, you could just simply select this wall, edit type, duplicate, and remove the sweep. And I'll leave that to you as an exercise. Now, both sweeps and reveals can be added individually wall by wall as well. So instead of going to edit type this time, what you would do is come over to architecture and click this drop down here. This would give you access to the wall sweep and the wall reveal command. Well, since we've already done a sweep at the type level, let's do a reveal here at the instance level. So I'm going to choose that. And I'm not going to actually make any changes to the reveal, but if you wanted to, you could go to edit type, you could choose a different profile, setback, what have you. I'm going to accept all the defaults. And I'm simply going to click on one of the existing walls to place that reveal. You're actually able to click on more than one wall and create a multi-segment reveal. And I could spin around and click this way. And then when you're done, you can simply click this restart reveal and it will complete that one. Let's zoom in on it. And you can see that that is actually carved away from the brick and made sort of a void. Now, it's actually possible to place these horizontally or vertically. So if I wanted, I could create one vertically here. Let's do restart. Maybe try one here, restart, maybe try another one here, and so on. So feel free to keep working on this and experimenting with adding sweeps and reveals to further refine the design of the exterior skin of the building. The nice thing is that both sweeps and reveals use essentially the same methodology and they use the same profiles, shapes, and materials. So it's pretty easy to flip from one to the other using the same techniques. In this movie, I want to talk about model lines. Now, model lines is a tool that's available here on the architecture tab, and we also have another tool here on the annotate tab called detail lines on the annotate tab. It's currently grayed out at the moment because I'm in a 3D view, but in both cases, those objects are lines. In other words, they're two-dimensional shapes, but the difference is that a model line, as its name implies, actually is considered part of the model by Revit, so it actually shows in all views. A detail line, by contrast, only shows in the view that you draw it in. So you're going to use them for different purposes. A detail line would be used just to annotate the drawing or maybe add some detail that you only want to see in a specific area, but a model line you can actually use to start representing real things in the model that you just simply don't want to model in full-blown 3D. Now, the example that I want to focus on for this movie is control joints in a brick wall. Now, there's plenty of other uses for model lines, but this is a really easy one to kind of talk about the concept. To get started, I want to kind of contrast the model line approach that I'm going to show you to what you might be tempted to use based on what we talked about in the previous movie. In the previous movie, we looked at sweeps and reveals, and you may recall that reveals actually cut away from the surface of the wall. Now I have two reveals here on screen in this 3D view. I've got one right over here that's actually the full width of a brick, and that's a useful place to use a reveal because it's nice to represent some sort of architectural detailing. So in this case, maybe we're actually trying to show some different brickwork on the surface of the wall. So that would be an appropriate use of a reveal. But over here next to it, I have this much smaller reveal, which is meant to just represent a control joint. And even here in this 3D view, you can kind of see what the problem is. It's slightly overpowering. It should be more subtle than that. A control joint is not necessarily an architectural detail that you want to emphasize. If I come over here to an elevation to kind of make the point a little bit clearer, let me double click this reveals view. Here's an elevation of that same wall. The control joint reveal is on the left, and then the brick detailing reveal is on the right. Now I'm going to type ZS, which is zoom to scale, and pan over here. And maybe this kind of illustrates where the problem is. Notice that the brick joint appears really bold compared to the surrounding hatch pattern of the brick. And the reason for that is if you actually zoom in really close on there, you're going to find that there's actually two lines there. Now, we're zoomed in really close and we can see that, but when you're zoomed at scale, you can't really see that because those two lines are so close together, they kind of blend into one. So graphically, I don't think using a reveal for those really small details is very helpful. And then there's another reason that you might not want to do it, and that's file size and performance. The file might start to get bogged down if you start loading up your model with all sorts of actual three-dimensional control joints. And so you have to ask yourself, is that a detail that's worth modeling, or is that something I can get away with just representing in some other way? The alternative, I think, is to use a model line. So I've got an elevation here called model lines, and it's just the other side of that building. And I'm going to zoom in just a little closer so we can see this brick wall. And let's go ahead and add some model lines to the surface of this wall to represent those control joints. So I've got my model line tool right here. And similar to what we saw when we did extrusion roofs, the model line needs a work plane for you to draw on. So what surface do you want to draw these lines on? Remember, they're actually 2D, but they're going to show in 3D views. So I'm going to use the pick a plane option, and I'll just pick the surface of the wall here. And then I can just start drawing. Now, there is a list of line styles available to us that we can choose from. I'm going to start with the default one that's simply called lines, and it actually comes in a green color, so we'll be able to see it stand out a little bit better. Now, if you look over the draw panel, you can draw any shape you want. Now, since this is a control joint, I probably want to just stick with a straight line. So I'll just click the line tool right there, and then I'm just going to find a joint on my brick wall and just draw straight up. And then I'll click the modify tool. And again, because I use the default line style, it comes in this greenish color. We could actually go to the manage tab, additional settings, and line styles. And in this dialog, you could actually create a new line style called control joints if you want. You could set the line weight and the color of that line style if you're going to want to use this technique. For now, I'm just going to stick with that default green one, but you're welcome to go ahead and do that and create a custom line style if that's your preference. Now, let me show you the model lines 3D view. And notice that that line appears here in 3D as well. So that's really the big thing with model lines, is that you can draw them in any view that's convenient, but they're going to show everywhere. And so again, this is just a simple thin line, so it's much less overpowering than actually cutting a reveal into that wall. And I think it's a perfectly effective way to represent something like a control joint. Or another place where I'll use model lines a lot is to draw like louvers or other details that just don't make sense to model out in full 3D. Now we can just simply take this line, and I'll do that back in the elevation, and we can just copy it along the wall. So if I just go to my copy command, pick a point here, snap to another location, and continue, and I can put my control joints along the wall at regular intervals. So I presented as an alternative to using things like reveals. Part of being successful in working in Revit is knowing when to model things and how to model things, but also knowing when not to model things. So I think smaller architectural details like control joints and really flashing and things like that, I don't think make sense to model. So this gives you a good alternative way to represent those items. As you work through your projects in Revit, you will find many times where you wish to change the way various items display on screen and in your final output. There are various tools available in the software to make such changes, both globally across the entire project and in more specific and isolated ways. So each of the movies in this chapter will start with a much more global approach, and then with each movie we'll get progressively more specific and kind of drill down to very isolated and sort of special case overrides that we can apply. So I'm going to begin in this movie with a command called Object Styles, and this is sort of our global control panel for all of the graphical settings in the software. Now I'm looking at a section view right now, and what I want to do is zoom in over here in the joint condition between this exterior wall, the floor, and the ceiling, and kind of talk about one of the issues that might prompt you to go into Object Styles. So as you can see, the outline of the wall is a little bit bolder than the outline of either the floor slab or the ceiling plane. Now there's various ways we could adjust that, and it's sometimes tempting to sort of dive right in and select the floor and look for some way to modify it. But what I want you to do is resist the urge to immediately go in and start attacking a problem at a specific object. I want you to kind of back up and assess the problem first and think about, first of all, is it something that is more broad reaching, and can I solve it in a more global way? And so what I mean by that is if I kind of zoom out here and we look around, what we actually see is that all the floors are kind of displaying that way. And then over here we get this little thing, and that's actually a small wall, that's like a small little soffit wall here to close off the ceiling. And we start to see that this is a broader problem. Now if we opened up another section, like perhaps this transverse section, and we zoom in, we see that the problem is not isolated to just a longitudinal section, it actually occurs everywhere. So this is a job for Object Styles. So let's talk about where we can get that command and what we can do with it. So I'm going to go over here to the Manage tab, and on the Settings panel, we have lots of different settings we can configure, and the Object Styles command is right here. Now this will display a multi-tab dialog with a list of all of the categories in Revit. Now it's organized into model objects, annotation objects, and so on. So we're going to focus on model objects because that's what we're seeing here in these various section views. And as you can see, if you scroll through this list here, all the various model categories are listed here. So there also is a filter list here at the top where you can actually deselect certain disciplines if you want to, and that will actually shorten the list and remove certain categories from the list. Now we're going to focus on the architectural discipline because that's where we'll find the ceilings and the floors and the walls. So make sure that you keep at least architectural check, but if you want to uncheck some of the other disciplines, you're welcome to do that. So let me go ahead and select ceilings here, and then let's talk about the settings that are actually in here. There's a line weight column, and that line weight column branches into two subcolumns, projection and cut. And what we can see is that ceilings has both the projection and the cut at the moment set to a pen weight 1. Now, if I click in either of those fields and I open up that little drop-down list, what you're going to see is there's 1 through 16. So they get progressively bolder as you go. So most of the time, you're going to see pen weights maybe 1 through 5. On occasion, you might see a 6 used for most of the settings. It would be rare to see something higher than a 6 or a 7, perhaps maybe on the borders of a title block, but that's about it. You would almost never see a 10 or 12 or 16, but they're available. Okay, and those are just very, very fat lines. But if we kind of scroll through the list here, you can see that most of the projection settings are either 1 or 2, and then the cut settings, occasionally we'll see a 3, and if I continue to scroll down here and I locate walls, we can see that's at 3. Notice the topography is at 6. So when we cut through topography, and you can actually see it right here in the background, there's a really bold line there when we cut through the ground plane. So that's appropriate for topography because we really want our building to feel grounded. We want it to sit on something substantial. So putting a nice heavy pen weight there makes a certain amount of sense. But what I want to do in this case is I want to take a cue from the walls. We can see here in the background, the walls had a certain level of boldness when we zoomed in, and I want to match that with the floor and the ceiling. So what I'm going to do is come over here and locate the floor and ceiling categories. Here's the floors, and I'll just simply change this to a pen weight 3. I'm changing that in the cut column because we're in a section view and we're actually cutting through those elements. The projection is when you're seeing it off in the distance. So we're not actually seeing the floors or the ceilings off in the distance at the moment. And then let me find the ceiling again and do the same thing there and change that to pen weight 3. Now, line color is fairly obvious, right? You can change the color of the edges of those objects if you want to. The line pattern is whether it's a solid line or dash line. And if you look here, you can see that there's lots of choices. We're going to leave those settings alone. Let's click OK. And let me zoom back in on this joint here. And as you can see now, the pen weights match for the ceiling, for the floor, and for the wall. And if I reopen that transverse section and zoom in, you're going to see that the same is true here. So when you apply a change at the object style level, it's actually going to apply across the entire project. So it's really important to get object styles to your liking first, because that is actually going to solve most of the problems because they apply globally. Now, often firms have office standards, so there's a pretty good chance that the object styles have already been configured in your firm template by some CAD or BIM manager that works in your firm. But if that's not the case, then you can spend a little time in there going through and kind of configuring them to your liking first before you consider doing any of the overrides that we're going to talk about in the next several movies. In this movie, we're going to take a look at the Visibility Graphic Overrides dialog. Now, this dialog is used quite frequently when we work in Revit. It gives us lots of control over the objects and how they display in various views. And there's a lot of similarities between it and the object styles that we saw in the previous movie, but the main difference is where object styles is global to the entire project. So if you make a change in there, it affects every view everywhere. The Visibility Graphics command is limited to the current view only. I'm currently looking at a first floor plan, and what I'm going to do is I'm actually going to open up a second floor plan, level 2, and then I'm going to come over here to the View tab and click the Tile Windows icon, or you can type WT for window tile. Now, I'm seeing the two floor plans next to one another. I'm going to click back over here into the first floor plan, and then I'm going to go to the Visibility Graphics dialog. Now, you can get to it here on the Graphics panel of the View tab, or you can type VG. Notice that that's the shortcut. Now, often folks folks actually refer to this as the VG dialog, and most of the time typing VG is the fastest way to get in here, so just sort of keep that in mind. Now, when you first look at this command, at first blush, it looks very similar to the object styles dialog. We have the model categories and annotation categories and the other tabs across the top. We have a list of all the categories. We have the filter list over here. So there's some similarities, but then when you kind of dig into all the settings that are available here, you see that there's a lot more that we can do in visibility graphics. The most obvious is here in the first column. It's actually the visibility column. So let's do something fairly obvious here. I'm going to scroll down just a touch. I'm going to select the doors category because that'll be very noticeable, and I'm going to uncheck this box right here. Now I'm working in the level 1 floor plan, and you can confirm that at the top because it says visibility graphic overrides for floor plan level 1. So it's kind of letting you know that these are overrides just for the level 1 floor plan. Let's click the apply button down here. Notice that all the doors over in this view disappear. If I take the dialog and I move it out of the way, notice that in the level 2 floor plan, which I also have open, all the doors are still displayed. So that kind of illustrates what I mean by this being a view-specific modification. So keep that in mind as we go forward, that everything that we're doing in the VG dialog applies only to the current view that you're in. All right, now I can't think of too many times when I want to hide the doors, so I'm going to go ahead and bring those back again and click apply. In fact, I'm going to click OK, and I'm going to maximize the first floor plan again so that we can see it full screen. And then let's go back into visibility graphics or type VG. So what else can we do in here? Well, if you look over at the other columns, there is a big column here called projection and surface. Now we talked about projection in the previous movie. This is stuff that you're seeing beyond or off in a distance in the view. And what we can customize here is the line styles that they're using, any patterns that are being applied, or even the transparency of those objects. And then we have a cut column. This is stuff that you're actually slicing through. That would occur in floor plans when you're like slicing through the walls and the doors in the floor plan, or in sections. And again, we can customize the lines or the patterns. So if you select a category, last time we looked at the ceilings category, notice that when I select that category, I'll see an override button next to each of those items. And you could click any of those override buttons, and then it would give you options that you could change there. So there's quite a bit of customization that you can do in this dialog. Then there's a halftone column and even a detail level column. So let's look at a practical example. Why would I use VG? So I'm going to cancel out there for a moment, and you'll notice that in this particular floor plan, I'm seeing, walls, doors, and windows. I'm also seeing furniture. I'm seeing some electrical fixtures. Perhaps I wanted to, this floor plan maybe is a little busy. Perhaps I wanted to create another floor plan that only showed furniture, maybe another one that was my electrical plan. So what I can actually do is I can start with this level 1 floor plan and I can duplicate it. Now you can see that I can do that because I've already got two here. I've got one called level 1 dimensions and I've got another one just called level 1. So how did that happen? Well, the easiest way to duplicate a plan is to just simply right click it. So I'm going to right click on level 1. And then up here we get the duplicate view flyout. And there's actually three options. Let's talk about the first two, duplicate and duplicate with detailing. I think it's easiest to understand the difference if we just choose them and see. Okay, so here's duplicate. And notice that I get a much cleaner copy of the level 1 floor plan. It doesn't have any of the dimensions. It doesn't have any of the door or room tags. It doesn't have any text or other kinds of annotation. So when you duplicate, it's just a copy of the model geometry. So here in VG, it would only include the stuff on the model categories tab. Okay, cancel out of there. If I right click level 1 again and choose duplicate with detailing, well, as you might expect, that's going to include all of the dimensions, all of the tags, and so on. Now, in some cases, you might get this little warning here. I'm really not sure why duplicating the detail needs to tell me about my rail not being continuous, but sometimes Revit decides that it needs to tell you that. So I'm just going to ignore that one right now because we're not really too concerned with the handrail at the moment. Now, over here, you can see that it created level 1 copy 1 and level 1 copy 2. Okay. Now, remember that copy 1 is the one that didn't have any detailing. Copy 2 is the one that does. So the way that you're going to deal with model elements in your copied views is going to be significantly different than the way that you're going to deal with your annotation elements in copied views. I'm going to take this level 1 copy 1. Let's go ahead and open that up, double click it. That's the one that doesn't have any of the annotation. So let's say that this is going to be my furniture plan. And maybe in the furniture plan, I'm not interested in seeing any of these electrical fixtures. So what I'm going to do first is right click this and rename it. And instead of copy 1, I'll call it level 1 furniture. So I'm going to click over here in the floor plan to make that active, and then I'll type VG. So now what I want to do is locate the electrical fixtures. So I'll just simply scroll down here, find the electrical fixtures category, and uncheck it. Now there may be some electrical equipment in this view as well, so if you want, you can turn that category off also, and then when you click OK, all of those items will disappear, but the furniture will remain. Now let me go to the copy 2 now and repeat the process. I'll rename that. I'll just call this level 1 power. And let's double click to open it up. And then in this view, maybe I don't want to see any of the furniture. So we could go to VG again and just find the furniture category and uncheck it. Or actually there's a shortcut if you want to. You can select one of the elements that belong to that category. That'll take you to the modify tab. You can see it says modify furniture. And then there's this light bulb icon here. And you've got this hide category. And that's the same exact thing as going to VG and unchecking the category. So I'm going to choose hide category. And notice that that hides all of the furniture. Now, just to confirm that, let's go to VG, scroll down. And notice that the furniture box is unchecked. So whether you go into VG and uncheck it or use the light bulb, entirely up to you. It does the same thing. So now I've got these two different views that show two different kinds of information. Now that's dealing with the model categories. Now what about the annotation categories? Could I select door tags, for example, and hide the category? Well, you could, but I don't recommend it. When it comes to annotation, it's actually better if it's either there or it's not. When it comes to model, you want to hide and show. The reason for that is we want to remember that a change to the model changes everywhere. If I go over here and on the right side of this plan and grab this door and just sort of move it like that, if I go to any of the other floor plans, that door is moved. However, if I come over here to this power plan and I take the door tag and I move it, and then I go back to the original level 1 floor plan, notice that that door tag didn't move. Those are two separate tags. So the way that annotation works is decidedly different than the way that model works. So it's actually preferable to delete any annotation that you don't want and hide any model elements that you don't want. So just keep that in mind. We're going to work with annotation differently than model. So what I'm actually going to do is make a window selection here around the entire floor plan. Now that's a lot of stuff. I want to be careful. Don't press delete yet. Click the filter button, check none. You can see all these different categories. I'm going to check door tags and perhaps window tags and click OK. So now I've highlighted only the door and window tags and I'm going to press delete. Now I've only deleted them from this view, the power plan view. If I go back to the level 1 floor plan, notice that the door tags and the window tags are still here. Okay. So that's a really important consideration to keep in mind. Now you may be saying, well, why wouldn't I just hide them? Well, if you hide them in this other view and then somebody comes along later and tries to add that tag, like for example, let's say I hide the room tags. Okay. It works. But now somebody comes along later and they say, how come there aren't any room tags in here? And they try and add a room tag. Okay. You're going to get this warning. And it may not dawn on them right away that you've actually hidden that category. Annotation, you want to either add or remove it, and model elements, you either want to hide or show them. Okay, so I'm going to undo a couple times to get those tags to come back. Now, let's do one last thing. Visibility graphics is not just about hiding and showing. We can also use the command to actually customize the way things display. So maybe I'm looking at my power plan and I'm saying, well, it might be useful to know where the furniture is so that we can know where to install the outlets and so forth. So what I'm going to do is go back to VG one more time here in my power plan, scroll down, select the furniture, turn it back on. Now, of course, if I turn it back on, it's full bold intensity, and that might be a little overpowering. So why don't we instead either override the graphics, or in this case, I'm just going to check this little halftone button over here and click OK. And maybe that does the trick. So now we can see the furniture. We know where it is. We know where to install our fixtures, but it's just a little bit less intensity than it was in the other view. So those are just a few examples of where you might see visibility graphics being used on a regular basis. It's a really powerful command. It's one that folks use all the time. And by far, it's the preferable way to control visibility if and when you can. So start with object styles if possible, get that set up, but that's kind of a one-time thing. And then use visibility graphics almost exclusively if you can. Now, there's going to be times when you can't get away with visibility graphics, and we'll talk about some of those scenarios in the coming movies. Sometimes you spend a lot of time in visibility graphics dialog making lots of customizations, different modifications for a certain kind of floor plan, for example, like we talked about in the previous movie. We had a furniture plan that was different than power plan, so we set up each view exactly the way we want, and then we realized that we want similar settings in other kinds of floor plans. Now, I've only got a 2-story building here, but maybe I've got a 10-story building, and so I need a furniture plan and a power plan for all 10 stories. It's certainly possible for me to go into each of the other floors and replicate the same settings, but it would get kind of tedious to do that, and I probably wouldn't enjoy it very much. So Revit offers us a feature called view templates, and I'd like to look at that tool here in this movie. So a view template is just a really simple tool. It captures all of the settings that are applied to a particular view, gives it a name, and then you can take that collection of settings and apply it to other similar views. So in this file, I have my level 1 floor plan, which is my main floor plan, but I also have my level 1 furniture, which is a simplified version, doesn't show any of the electrical fixtures, and it doesn't have any annotation. And then the power plan does show the furniture, but it's halftone. So let's say that I wanted to replicate these settings and apply them up here on the level 2 furniture plan, which currently is displaying the power symbols, for example, and the power plan, which is showing the furniture full intensity. Now I realize that these are simple settings that we could easily replicate, but again, we're going to use this as an opportunity to talk about view templates. So I'm going to start with the level 1 furniture. What you do is you open the view whose settings you want to capture. Then you go to the view tab, and the view templates drop down will appear over here on the left. And what we're going to do is create a template from the current view. So I'll choose that command, and it will ask for a name, and I'll say typical furniture plan. That will display the view templates dialog where I can confirm all of my settings. Now, I'm focusing on visibility graphics settings, which is here in the middle. You can see VG overrides, and it has all the different tabs listed, model, annotation, and so on. And if I were to click the edit button next to that, it would just display the visibility graphics dialog. And what you would see here is that in my furniture plan, the electrical fixtures are turned off. So it captured that setting for me, right? But you can certainly verify it here. But in addition to that, it captures all the settings of this view, things like the scale and the level of detail. And you can see here, there's a very long list. Now, it's actually possible, if you want, to uncheck in the include column here certain items that you did not want to include. For example, if you didn't want to force the scale of all your furniture plans to 1 to 100, then you could uncheck this box. Now, in this case, I'm going to leave everything checked, and I'm just simply going to click OK. Now I'm going to do the same thing with the power plan. So I'm going to come over here to level 1 power. These are the settings that I like for level 1 power. So I'll go to view template, create a view template from the view, call it typical power plan, verify all my settings, and click OK. So now I've created 2 view templates. So now I want to apply those view templates. And there's actually 2 ways that we can do that. When I come up here to level 2, I'm going to apply it one way to the furniture plan and another way to the power plan. So let's start with the power plan. So I'm going to double click the level 2 power plan. And here I'm going to apply the template properties as sort of a one-time operation. And let me explain what I mean by that. If I go right back to the view templates dropdown, there is the apply template properties to the current view command. And when I choose that, it will display the apply view template dialog. You can see it's the same list of view templates, and I can simply choose my typical power plan view template and click OK. Now watch what happens to the furniture in the background when I do that. Notice that all the furniture goes to halftone. So it's a really simple operation, and I've now applied that change. Now, if I go to the furniture plan, the way I'm going to apply it here is going to be a little bit different. Make sure that nothing is selected on screen, and go look at your properties palette. It should say floor plan over here, and it should say level 2 furniture plan specifically. If we scroll down, you'll notice that in the identity data area, there is a view template option, and it currently says none. So I'm going to click that none button. That also displays the apply view template dialog, and I'll choose my typical furniture plan and click OK. Now, what's the difference? Well, it applied the settings as well. You can see that the view has changed and all the electrical fixtures have disappeared. Here's the big difference. If we make a change to the typical power plan view template, this view will not change. So I'm going to open up the level 2 power plan, go to my view templates dropdown, and this time choose manage view templates. I'm going to scroll down here, and I'm going to select the typical power plan, and I'm going to do something a little nonsensical here, just so that we can illustrate the point. And I'm going to click on VG overrides for model, scroll down, and locate the walls category and turn it off. Now, I can't imagine that you'd ever really want to do this, but let's just go ahead and have a little fun here. Let's click OK, and wait a minute, nothing happened. And the reason for that is because we actually just changed the view template, but we haven't yet applied it. So there would be a second step where I would have to reapply that typical power plan to this view, and then the walls would disappear. Now, as I said, that's kind of a nonsense thing. We really probably wouldn't want to do that. So I'm going to do Control Z to undo that. And in fact, I'm going to do Control Z a second time, and that should bring the walls back in that view template. Now let's go to the furniture plan instead. Up here on my quick access toolbar, you can see that I've got lots of floor plans open in the background. Now what I want to do is open just my 2 furniture plans and put them side by side. But if I tried to tile my windows right now, I would get lots of small windows. So right next to this switch windows dropdown is another icon called close hidden windows. And when you click that, it will close all of the windows that are behind the current window. So you can see now that I only have level 2 furniture open. And now I'm going to open up level 1 furniture, and then I'm going to tile these 2 windows. Now I'm going to click over here on the level 1 furniture side to activate it, scroll down in the properties, and notice that the view template is still set to none here. So let's also apply that one to the typical furniture plan. And so now you can see it's typical furniture plan here, and if I go to level 2, it's typical furniture plan here. Now, what does that do for us? Well, if I go back to view templates, manage view templates, and select the typical furniture plan, let's make a change. VG overrides for model. Let's select the furniture category, and then I'm going to go to the projection surface and override the patterns. So I'm going to click this override button right here, and maybe assign a nice crosshatch pattern right there. And if you want, you can even give it a color or something. And I'll click OK, OK again, and then one more time. And notice that, you might have to zoom in to see it, but notice that on both sides of the screen, the furniture is now all crosshatched. So that's the difference in the way that the view template is applied. So if your office standard calls for the graphical settings to kind of be enforced automatically, then you can apply view templates directly to the views, and then a change to the view template will change all usages of it throughout the model, even if you have that 10 or 20 story building. So that can be very powerful. The downside is if anybody wants to make a change to either of these views, they can't do it without modifying the view template. So if I went to VG in either of these views, notice that everything is grayed out. If I try to change the scale, it's all grayed out. The level of detail, the shading level, it's all grayed out. Now, there is a tool available that allows us to temporarily override the view template settings. And that's this little icon right here, temporary view properties. And I can enable that. It will put this purple border around the screen. And while this temporary mode is turned on, I could change the scale, or I could go to VG and I could hide some element, or really do whatever change I want to do. And it separates it from the view template. But as soon as you click this button and you say restore, it'll reset everything back again. So depending on which workflow you prefer, whether you like it to be permanently assigned to the views and a little bit more forceful, and then people have to use the temporary properties when they want to make changes while they're editing, that's one approach. Or you can take the approach that we did here on the power plan, where it's not permanently assigned, and then later, if you want to reapply the view template, you just simply repeat the steps to reapply it. So both are perfectly appropriate, and it really is a matter of preference and a matter of following whatever the Office standard for your firm happens to be. As your models become more complex, it can be difficult to see and edit certain elements from time to time. In the previous movie, we saw that we can use the visibility graphics command to hide elements at the category level. Sometimes, however, you simply need to hide elements temporarily, or you may want to hide individual elements in a certain view. So in this movie, we're going to look at ways that you can hide stuff. We're going to hide things temporarily using temporary hide isolate command, or we're going to hide things in a permanent fashion, but very specifically to certain objects not at the category level. So again, we're exploring our visibility settings, moving from the most global down to the most specific. And here in this movie, we're really getting focused on hiding individual elements. So let's start with an exploration of the temporary hide isolate command. This is a really useful and powerful command that you can use while you're working, just when stuff is in the way. So here's a really good example. Suppose I move my mouse around over here, and you can see that there's some foundation walls down here underneath the building. However, even though I can select them, it would be difficult to work on them because they're completely concealed by this topographic surface that we have out here in front, which is actually part of the link model. Well, with temporary hide, I can actually hide this element, go in, do my work that I need to do the foundations, and then when I'm done, I can restore the element. Now that's done with the little sunglasses icon right here. I've got the object selected. I'll simply choose hide element. You can see that because it was a link file, the entire thing disappears, topo, trees, and all. Now I could zoom in, and I have very easy access to these foundation walls to make whatever edits I need to make. When I'm done in this mode, I can simply click the sunglasses again and choose reset, and that will restore the site file. Let's look at another example. You'll notice that on the sunglasses here, there's actually several options. So suppose I select one of these columns here at the exterior on this little portico. Well, if I go to the sunglasses this time, I certainly could hide that element and it would hide the one column, but probably in this case, that's not necessarily what I need to do. But maybe I want to do something to the columns and I feel like not only is the roof in the way, but some of the other geometry is in the way. Well, this temporary command also has category level options. So I can actually, in addition to hiding, I can actually isolate. And what that will do is it will hide everything that's not a column. And so now I'm looking at only the columns in this view and I can make modifications to my columns. And then when I'm done, I could reset and everything comes back again. Now, of course, you can do the same thing with isolate element, and you can do the same thing with hide category, and those modes would work as well. So the temporary hide command is something that I use all the time while I'm working because you're always going to find a situation where there's something in your way and you just want to get it out of the way so that you can get your work done. Now I'm going to go over here to my level 1 floor plan, and let's look at another scenario where we might want to hide stuff, but this time I want to do it in a more permanent fashion. Now we've already discussed visibility graphics, and we've already seen that if there's something that we want to hide, that we could hide it there in VG. So for example, this section line right here, I was using just to draw my curtain wall, and I don't really want to keep that section line moving forward, but I'm not quite ready to delete it yet because I might want to come back later and make some modifications to the curtain wall. So what I'd really like to do is just kind of get it out of the way, just to hide it. Now, of course, if I use the temporary hide method that I just showed you, it would only be this work session. With temporary hide, it'll come back tomorrow when I reopen Revit. So I don't want to have to keep hiding that every day. So what I'm going to do instead is I'm going to look at a way that I can hide it permanently. Now, if I go up here to this little light bulb, I showed you this in the movie where we talked about visibility graphics. And you may recall that if we did hide category, that was the same as going into VG and unchecking the box. But notice the result that that had. That actually hid all of the section lines, which is probably a little bit more than I was looking for. So what I'm going to do here is undo, and then I'm going to select this section line again. You can see there's a shortcut for that, EH. Now that will hide just that section line, and all of the other section lines will remain. Here's another example. If we look over here, we've got this opening object. Now, for whatever reason, down here in the foundation plan, that opening object is showing through in the foundation plan. In addition to that, if you zoom out a little bit, you can see that that entire site file again with its topo surface is also showing here. Now, maybe I don't want to see either of those things here in this foundation plan. So I can select it, hide the element, and then I can select this, and hide that element. And in both cases, it just simply hides that object. It kind of gets it out of the way and allows me to do my work. Both of those are permanent hides, and they stay hidden until I tell them otherwise. Now, you may notice that the section is back on here. Another thing that's really important to understand about this permanent hide is, just like visibility graphics, it is view specific. So you would have to go into each view where you want to hide this section and hide it separately in that view. But of course, once you've done that, it will stay hidden until you unhide it. Now, how do you do that? How do we unhide stuff? Well, to unhide anything that's been previously hidden, you come down here to the view control bar and you click this small little light bulb icon, and it's labeled reveal hidden elements. When I click that, that takes me into a temporary mode. It puts the reveal hidden elements label up in the corner and highlights the screen in this pink border around the screen. Now notice that every element that's hidden also shows up in that pink color. So here's that opening object, here's the section line, and if we zoom out a little bit, we've also got the site plan. Now, if I wanted to restore that section line because I want to be able to work with it, all I have to do is select it, and then up here on the ribbon choose unhide element. And there is a shortcut for that as well, EU. When I close the hidden elements mode, either with this button here or by clicking the little light bulb a second time, it will go back to displaying the file as normal, and that border will go away. So those are some examples of where you might use either temporary hide isolate or the permanent element level hide. Both can be very valuable while you're working for various reasons. I like to use temporary hide isolate all the time while I'm working, just to kind of get things out of the way so I can get my work done and then restore. And then element hide is useful for those situations where, even though it's desirable to use visibility graphics would be a little bit too global and we need to be much more specific and just hide that particular element. Just use it with caution, because if you start hiding everything with element hide, it makes it very difficult for your other team members to kind of know that you did that and find the things that they're looking for. In this movie, I'm going to look at a completely different aspect of controlling what you see in your views in Revit and look at the crop region feature. The crop region feature is a border that will appear around your views. You can use it in plans, elevation sections, even 3D views, and then it's used to actually crop what you see in the view. So only the geometry within that border will display. So crop regions can be really helpful in helping us size our views in order to help enable them to fit on sheets of paper when it comes time to print. So I'm in a floor plan right now. What I'm going to do is do ZF to zoom to fit, and that will back me out to these elevation markers out here. Then I'm going to type ZO to zoom out 2 times. And as you can see, I could keep zooming out, and there really is no limit to that. Now, the reason I want to zoom out this far is because at the moment, this view does not have a crop region enabled. So if I came over here and drew a wall and placed it way out here, that wall would continue to display. If I zoomed out further and created another wall, that wall will continue to display. So in other words, there really is no extents to this view. It will just continue to expand and expand indefinitely. Now I'm going to cancel out of there and I'll delete this wall. Let me leave this one for the moment. And let me come over here to the properties palette, make sure that nothing is selected, and then you'll be seeing the properties of the floor plan itself. If I scroll down and locate the extents grouping, there's actually 3 checkboxes here, but let's talk about the first 2. The crop crop view checkbox and the crop region visible. Now, both of those actually have icons on the view control bar. So the crop view checkbox corresponds to this icon right here, which currently shows the little red X, and the crop region visible corresponds to this icon right here, which currently shows the little dim light bulb. So if you enable the crop region by checking this box, that will turn on the cropping feature. And then if you click this box, it will actually display that crop region. And if I apply both of those changes, you're now going to see this rectangle appear surrounding the floor plan. Now notice that on the top, bottom, and right-hand sides, it went just a little bit bigger than the elevation markers. But on the left-hand side, it also includes that wall that I just drew. So whatever geometry you have in the view when you enable the crop feature, it will just go a little bit larger than that geometry. But now if I go ahead and roll my wheel to zoom in here, we can select this crop region. And now that it's been enabled, you can actually start to stretch it in and it will begin to crop what you see in the view. So if I wanted to crop it in such a way that that wall that's off to the side no longer displays, I could just adjust those grips. Now I could actually adjust it so that it actually crops off a whole portion of the floor plan. And this could really be helpful if we were going to change the scale and make an enlarged floor plan view. Now, if we come back over to either the properties palette or the icons down here on the view control bar, with this crop region enabled, I can still hide it. So if I didn't want to see the rectangle, but I want to keep the view cropped, I can do that. Or I could actually disable the crop and notice that it goes back to displaying the entire floor plan. The crop feature is not limited to just floor plans. If I come over here and I open up the south elevation, I'm going to do that by just double clicking on the small triangle there. And then let's zoom out a little bit. Notice that this view is not showing us that wall off to the left side. That's because this view is actually currently cropped. You can also kind of see that because we're only seeing part of this tree over here and part of the topo surface with this bold line. Well, if I turn on the visibility of the crop rectangle, you can see that much more clearly. And then if you wanted to see the full tree or the wall over here, you could actually disable the crop by unchecking this and it would display the entire view again, complete with all the trees and that wall over there. Now, I don't really want to keep this wall, so I'm going to get rid of it. And then I'm going to go ahead and crop this view again, and then I'll actually hide it. Now, let me close this view and let's look at one more example. Let me open up this section. Now, here in this section, you can see that we've got the crop region visible. It's right there, and it's very clearly cropping down the part of the building that we're seeing in section to just that rectangle. Now, let's say that I wanted this to be a little bit closer cropped on just the stair. So I could pull these grips in and begin cropping away everything that's not part of the stair. However, because of the angle of the roof, I may find it difficult to actually remove that portion from the view here. So what I can actually do is when the crop region is selected, you'll notice that up here on the ribbon, there's an edit crop button, and I can click that, and that takes me into sketch mode. Now I can just simply draw a line, and I'll just make that roughly parallel to the window there. I'll use my trim and extend to a corner, clean that up, and finish. And now you can see that my crop region actually has an irregular shape. And in fact, you could even fine tune it further by just adjusting these grips or by going back to edit crop and adjusting the sketch. Now you can actually draw the crop directly that way when you create a view. So let's go back to the level 1 floor plan, and I'm going to zoom in over here in the middle of the plan. And let's say that I want to enlarge the reception area of this plan. I can go to the view tab, and there is a callout button right here. When I click the drop down, there's two options. You can make a rectangular callout, or you can sketch your callout and make an irregular shape. So I'm going to choose sketch callout, and I'm going to draw a line parallel to the corridor, come over here, turn a corner, go just in front of this doorway, come back over here, and then let me click finish. Now what that will do is actually create this boundary line here. It's even got a callout symbol here. Now I can take that callout symbol and select it, and then just drag it wherever I want it to go. And then if I right click and say go to view, it will open up that view, and as you can see, it created it with an irregular shaped crop region. So the crop region feature allows you to take any view and isolate what you're seeing to just a small crop down area. By default, the crop regions are rectangular, but by editing the sketch mode, you can actually create irregular shaped crop regions. In this movie, we're going to talk about the view range feature. The view range feature is a setting that belongs to all floor plans and determines what graphics we actually see in the floor plan. So view range corresponds to the concept of cutting through your building at a certain height and then looking down to generate a floor plan. So the view range dialog is going to have settings that allow us to determine what height we're cutting at and then how much of the plan we want to see. And actually, in the previous few movies, we talked about object styles, visibility graphics, and some other visibility commands, but really it all starts with view range. So when you're working in a floor plan view, the very first thing that Revit does is it actually cuts through your model and then consults those view range settings and decides which objects intersect the view range. And then based on the objects that it finds, that's when it then looks at the visibility graphics and the object styles and so on. So before it even gets to any of the settings we talked about in the previous movies, the objects have to actually be within the cut plane. And a really easy way to kind of prove that to you is we're looking at a first floor plan here, but notice that you don't see any of the geometry on the second floor plan. Well, hopefully it's fairly obvious why that is, because all of that information is above the view range for this floor plan. So let's dig in a little bit here and kind of try and understand how the view range works. And I'm going to do this in two parts. So in this movie, I'm going to focus on the primary view range, and in the next movie, we're going to look at some special features of the view range. So I'm going to scroll down here on my project browser and locate an elevation that I've created called Understanding View Range. And I'm going to double click and open that up. And what I've done here is, if we zoom in, is I've created some line work. These are just drafting lines that I've placed here on the view. Now I've placed them relative to the second floor plan, and they represent where the default values of the view range dialog come from. So by default, we're in this template that we started with, the default metric template, the cut plane is set at 1200 millimeters above the current level. So that's the most important aspect of the view range. And you can see this bold line I've drawn, it's cutting through these windows. So if we were looking at the second floor, we would expect to see this window and this window. Then there's another setting called above that defaults to 2300 above the level, and that defines a zone between here and here. And we're going to talk about that in a little more detail in the next movie. And then there's also a zone potentially between the level and down to something called depth, and that's also something we're going to look at in the next movie. So there's really three zones in the view range dialog. The one between cut plane and level is the primary range, then above and cut plane is a special range, and then below the level down to depth is another special range. Now these are just the default values, but we can actually change these to anything we want. I've got a fourth line up here that I've drawn at 3600 because in the upper portion of the building I have these three fixed windows. So what I'm going to do is we're going to go to the second floor plan right now, and we're going to adjust the cut plane, and instead of displaying these two windows, it'll show these three up above, and that should hopefully help us understand how the view range works. So let's scroll back up here on the project browser, double click the level 2 floor plan, and we're going to zoom in on that area that we were just looking at, which is these two windows right here. So at the moment, we have all the default view range settings. We're cutting at 1200, and therefore it's cutting through those two windows. The third window is in this general location right here, and it's way above our heads, so currently it's not displaying. Now we can get to the view range dialog on the properties palette. Make sure you don't have anything selected, and it should say floor plan over here, and specifically floor plan level 2 on your properties palette. Then you want to scroll down, And under the extents grouping, you'll see the view range button, and you just click this edit button right here. If you recall the diagram that I showed you just a moment ago, you can see those settings that we were talking about. The cut plane is set at 1200 above the current level, and the top of the range is set at 23. What we're going to do is increase this cut plane up to 3600, which I had illustrated in the diagram. Now, there's another important aspect to understand about view range. There's actually the 4 settings here, and they can't get out of order. So if I try and click OK, Revit will complain. And it's telling me that the top clip plane is below the cut plane, and it just doesn't like that. Now, the top can be equal to the cut, but it can't be below it. So you have to make it at least 3600, or you could make it higher than that. So I'll just make it 4000. Doesn't really matter for this example. When I press enter, that will click the OK button, and it will take me back to the floor plan. And notice that the 2 windows that were displayed are no longer displayed. They're down below. And then this third window is now displaying, like we saw over here back in this elevation. So we're now cutting through these 3 windows up here instead of these 2 windows right here. The trouble with doing that is, as you can see, if you investigate the rest of the floor plan, we're cutting so high now that we're not seeing any of the doors or the furniture or the other items that might occur in this floor plan. So what I'm going to do is actually go back to the view range, and I'm going to reset this cut plane back down to 1200. And that will restore everything to the way it was. And what I'm going to do instead is show you an alternative way that we could start to display those clerestory windows up above, if in fact that was something that we needed to do. And I'm going to do that with a feature called Plan Region. I've already got a plan region actually here in this floor plan right here, and it goes right up against this wall. So I'm going to have a little bit of a problem here if I try and overlap these 2 plan regions on top of one another. So I'm going to talk about this one in a moment, but for the time being, let me just grab this little grip and stretch it away from that wall. And then I'm going to come over here and go to the View tab, and then on the Plan Views dropdown, you can get to Plan Region. Now that'll take us to sketch mode. We've now seen several examples of sketch mode, and you can draw the plan region any shape you want, but I'm going to do a simple rectangle here surrounding that wall and those windows. I'll click finish, and that will display this little dashed box. But now over here on the ribbon, you can see that it has its own view range button. And when I click that, I can now take this, put it up at 3600, click OK, and you see that it will display those clerestory windows without changing the graphics of any of the other elements in this floor plan. So it's an isolated view range modification. Now, as I started to mention, if these 2 overlapped one another, that's where we're going to get into problems. So this is why I stretched this one back, because Revit won't allow us to have 2 plan regions overlapping one another. So I'm going to click cancel there. But I am going to zoom out and talk about why this one is here. So you can see this one here kind of surrounds the low roof. Now, if I select it and just delete it, you can see why I did that. Because the roof at 1200 was being cut through, and you were seeing, parts of the walls and everything down below, which would not really be that appropriate in this case. So when I do Control Z to undo here, you can see that the plan region comes back again, and if we select it and look at its view range, all I did was increase the cut height so that it would get up above the ridge of that low roof. So the primary view range settings, the most important setting is really the cut plane, and that cut plane setting determines which objects are actually going to display in any given floor plan. Whenever you need to override it, you can override it globally for the entire floor plan, but in many cases, it's actually more convenient to set up a plan region instead so that you can isolate the overrides to just small areas of the plan without changing the cut plane of the entire floor plan. In this movie, we're going to continue our exploration of the view range dialog, and I'm going to focus specifically on the 2 other zones within the view range. The first of which is the top of the view range, which occurs between the cut plane and what I've labeled above here, which is actually the top of the view range in the dialog. And also, we're going to look at the view depth, which occurs between the level and what I've labeled depth here on the screen. So let's get started by talking about the top of the view range first. And to do that, I'm going to go back to my level 1 floor plan. And because I'm going to be opening up a couple different windows here, I want to actually close that other elevation that I have open in the background right here. So I'm just going to click the close hidden windows right here, and that will close any of the other views that I have open. Then I'm going to zoom in on this small break room right here. And what I want to do is add a couple pieces of casework. So I'm going to come over to the architecture tab, and I'm going to click on the component tool, and I've preloaded in this upper cabinet right here. And I want you to take note particularly of the elevation that this item comes in at. By default, it's coming in at 1400 millimeters, and that is higher than where the cut plane occurs in this plan. Now this is a wall hosted element, so I have to highlight a wall, and I'm going to highlight this wall here, and I'm going to place 2 instances of that cabinetry. Click the modify tool to cancel out of there. Now, I want to look at those casework elements head on as well. Now, I could cut a section to do that, or I figure this is a good opportunity for us to talk about interior elevations. So I'm going to go to the View tab, click the Elevation button. You can create either building elevation or interior elevation, so make sure you're choosing interior elevation, and then just kind of move your mouse around inside the break room, and notice that this arrow is going to kind of sense the nearby walls. It's almost like a little magnet. So when the arrow is pointing to the wall at the right, just go ahead and click to place that elevation. Click your Modify tool to cancel, and then this piece right here, this little triangle piece, that's the actual elevation. And if you click on it, notice that the interior elevation automatically sizes itself to fit within the room, okay? And that's really neat. So if I deselect it and double-click the triangle, we can open that up. Now I want to tile these 2 windows. So I'm going to come over here and click the Window Tile button, or type WT, and then finally I will zoom and adjust both views so that I'm looking at the break room. Now, let's go back to talking about view range here. You may recall that the cut plane is at 1200. So let's draw a line here using Annotate and Detail line right here on the elevation. I'm going to press Escape once, and let's draw a second line right here, press Escape. I'll select this one, set it at 1200, and I'll select this one, adjust the grip down here, and set it at 2300. So this represents where our cut plane is, and this represents where our top of view range is. And notice that both of these cabinets occur above the cut plane, but below the top. Now, you may recall that when I talked about cut plane in the previous movie, I said in order for objects to display in plan, they had to intersect the cut plane or be below it. Well, these 2 objects clearly do neither of those things, but yet they continue to display here in the floor plan. So the rule that we're seeing here applies to just 3 specific categories. There's 3 types of elements that can display above the cut plane, but below that top. So in that top zone, they are windows, casework, and generic models. So if you have an object in one of those 3 categories and you place it in that zone, it will display in plan. And we're seeing that very clearly here with these 2 casework elements. Now, if I select one of these guys and come over here to its elevation parameter and change it, you can start to move it around, right? So let's say 2000. Notice that it will move up, and the top portion of the piece of casework is going outside of the top of the range, but it's still got some portion of it below. So the rule is if any part of the object intersects that zone, then it continues to display in plan. You can clearly see it over here. But if I take this and I raise it up above that 2300, so that it now goes above the top. Notice that it disappears here in plan. So as long as you keep it within this top of the view range, it will display in plan just fine. Now, I mentioned that there was two other categories as well. So here's a window over here, and if I come over to its sill height, it's clearly well within the primary range right now. What happens if I move that up to 1500? 1500 places it above the cut plane, and at first you might say, well, it disappeared, but notice that if I move my mouse over here, I can still select it. So the reason it disappeared is actually because the wall just happens to be in the way. So the wall is covering it up, but I am able to select that window still, and I could move it around, and of course I could set it back to its regular default sill height. If I did the same thing to the door and moved it to 1500, it will go outside the view range, and I will no longer be able to select it because the door is not one of those appropriate categories. So I'm going to do Control Z to undo. All right, I'm going to close the elevation here, and I'm going to open up the foundation plan, and I'm going to maximize it. And I'm going to do ZO just to zoom out a little bit. And what you'll notice here is that our interior elevation that we just drew is showing here in this foundation plan, and there's these two rectangle things over here that if I hover over them, interestingly enough, those are casework. Now, that's kind of peculiar. Well, let's try and investigate what's going on here. I'm going to select this section right here. I'm going to right click on it, and I'm going to choose Go to View. And let's zoom in a little bit down here. Now, the foundation, if I select it, scroll down here on its properties, you'll notice that the associated level for the foundation is bottom of footing, and that's right here at negative 1800. If you measured up 1200 from that, it would put it a couple hundred millimeters below level 1, maybe right about where my mouse is right now, and that's where the cut plane for that foundation is. But more importantly, if you measured up 2300 from that point, it would actually intersect through this furniture right about here, which means that it would catch the bottom of those casework elements and the bottom of that elevation view that we were seeing right here and right here. Furthermore, you may recall in a previous movie that we hid an element here in the foundation. So if I go to Reveal Hidden Elements, select that hidden element and restore it, and then toggle that view back off, if I highlight this element, notice that it's a generic model. And I just mentioned to you that there were three categories that could display in the above range. So this applies to every plan. So the reason we're seeing this, this, and this is because all of those things are intersecting the top of that view range. So all I have to do in this foundation is scroll down, find the view range, edit it, and change the top of that view range. I'm going to make it 1200 to match the cut plane because I don't really need to have a zone up above in my foundation plan. When I click OK, it makes all of those elements disappear. So this is an alternative to what we talked about in a previous movie of actually individually hiding all those elements. So if you just understand why the element displays, sometimes you can find a better solution. Now there's another problem with this foundation plan that I'd like to address, and that will allow us to talk about the final part of the view range dialog, that view depth setting. So if I edit the view range again, and we look here at the bottom of the dialog, we've got our view depth. Now at the moment, it's set to 0, which basically means it's turned off because it matches the bottom of the view range here. So what we're going to do here is we're actually going to lower the view depth setting low enough to capture the footings that should be displaying here in this foundation plan. So I'm going to try a setting of maybe negative 1000 millimeters. That should do the trick. Now when I click OK, you're going to see these lines appear, and in fact, those are the structural foundations. Now, typically you don't want to display structural foundations in solid lines like that. You prefer to display them dashed. Well, here's a really interesting property of what happens with that below view range. Any element that occurs in that zone between bottom and view depth uses a special line style to display it. That line style can be accessed here on the Manage tab under Additional Settings and Line Styles. When I get to this dialog, I expand lines, and I'm looking for the Beyond line style. Any line style that you see here on the list with the two angled brackets around the name, those are built into Revit. So those are sort of like permanent line styles that will always be there. And the function of Beyond is specifically for the purpose that we're talking about right now. It displays elements that occur in that bottom zone of the view range dialog. All I'm going to do is come over here and change the line pattern for this line style and change it to a dashed line. I'm going to click OK, and now you're going to see all of those footing lines display in dashed. So it's kind of an obscure little feature that if you didn't know it was there, it would be very difficult to understand where you needed to go there. So both things need to happen in order for this condition to take place. You need to lower your view depth, first of all. That actually enables the Beyond line style, and then you have to configure the Beyond line style to look the way you want it to look, in this case, a dashed line. So as you can see, the view range dialog is a very powerful dialog. Most objects are just going to interact with the cut plane, and that determines how they display. But in those special cases for objects above, like casework, windows, and generic models, you have the top of the view range. And for that special case for the stuff below, we have the view depth and that Beyond object line style. So far in this chapter, we've seen global object style settings and view-specific overrides at both the category and the object level. Sometimes none of these methods is sufficient to get just the right graphical treatment in a particular view or drawing. In such situations, we have the line work tool, our last line of defense, if you will. With this tool, we can actually modify the individual edges that make up an element and vary them as required. For example, we can make one side of a wall bolder, or we could change the roof overhang to a dashed line in certain areas of the plan. The line work tool can be just what you need to add that finishing touch to your work, but please remember to use it sparingly. So to show you a really simple example of using the line work tool, I'm going to zoom in on the reception area here in this level 1 floor plan. There's a balcony that runs along here and goes and connects with the stair. And it might be nice to see that balcony as a dashed edge up overhead. I'm going to use the line work tool to do that. Now, it would be possible to go to Annotate and use a detail line. Detail lines are view specific. They only show in the current view. You could draw it as a dashed line. It would work just fine. The problem is it wouldn't be associated with anything in the model necessarily. And if you made changes, it's a totally manual change and it might get out of sync. And it's just as easy to do it with the line work tool. And it's a little nicer because it's still a part of the live model. So the first thing that I need to do is actually know where I need that line to be, where that floor element is. And it's obviously not displaying because it's up over our head on the second floor. So what we can do is over here on the properties palette, we can scroll down and locate the underlay feature. I'm going to change the underlay from none to level 2. Now, when I do that, it will display a grayed out version of the second floor as an underlay to the first floor. Now, you'll see it's a little busy right now. There's multiple lines there because it's showing the edge of the floor and the railing because the current orientation is to look down. But I can change that to look up, make it more like a reflected ceiling plan. And then when I do, it's going to show just a single edge where the floor is. So now it's going to be a lot easier for me to know where to click when I move to the next step, which is to go to the Modify tab and use my line work tool. Keyboard shortcut for line work is LW. And this tool gives you a list of line styles to choose from, and you can choose any line style you want to override the existing line work. Well, we've got one right here called Overhead, which is designed exactly for the purpose we need here. It's just a dashed line to represent things over our head. So I'm going to choose that. And I'm going to click right on that edge. And you'll see it'll dash it in, and then I'll click on this edge, and then I'm going to zoom out slightly. And before I finish up with this command, I'm noticing that the edge of the roof is displaying here as well, and it might be nice to see that as an overhead line also. So I'll just simply click on the 4 edges that make up that roof, and then assuming that that's all the line work overrides that I want to apply, I can click the Modify tool to finish the command. Now I'm still seeing the underlay, so I'm done with the underlay. I don't want to see that anymore. So I'll just come over here to Properties and set it back to None. That's a really simple example of how you can take elements that otherwise would not display in this view and override them to display. Now notice that if I highlight here, that dashed line is actually the edge of the floor, and this dashed line is actually the edge of the roof. So you can select that element, and it's the live element. So just be careful with that because you'd be changing the roof or the floor in that case. So unlike using drafting lines, that's real live geometry. Now let's look at one more quick example. I'm going to scroll down here to my elevations and double click my south elevation. I'm going to zoom in over here, which is the portion of the building that's closest to me in this elevation view. Now I've got this big tree in the way, so I'm going to cheat a little bit. I'm going to tab in to this link file because that tree is actually in the Revit link. So I'm going to tab in there and grab just the tree. And then I'm going to go to the light bulb here and hide element. Now notice that doesn't hide any of the other trees. It only hides that one. Now, yes, that's a little bit of a cheat because I'm hiding that tree, but it's going to allow me to see this wall clearly. Now I'm going to go to the line work tool and change the line style from overhead to wide lines. And then I'm going to start touching the edges of the geometry that I want to make bold so that it stands out a little bit more starkly as being in the foreground. I picked all of those edges, but notice what happens when I pick this underside. You get these little grips on the ends, and you can actually stretch this back so that the effect of the line work tool is limited to just a portion of the edge. And then when I cancel out, now you can see we've got this nice bold line that goes around just that part of the elevation, making it appear like it's a little bit more in the foreground. So that's a really simple technique that we can do using the line work tool to give that drawing just that extra punch that it needs. You can use the line work tool anytime you want, but I typically try to wait until much later in the process when we're almost done with the presentation and we're ready to present the drawings, because as you continue to manipulate the model, sometimes the line work overrides can be a little fragile and you might have to reapply them. But keeping that in mind and using the tool sparingly, it can be just what you need to give your drawings that extra little graphical punch that you're looking for. In this movie, I want to talk about how you can create cutaway three-dimensional views of certain portions of your model. So we've talked about how we can create 3D views, and we've seen ways that we can cut sections and even create call-out views, and just all of these give us opportunities to study the model from different vantage points and at different sizes and scales. But sometimes it's just really helpful to get in and take a look at how things are shaping up in 3D, and you want to do that maybe with only a portion of the object. So you want to kind of isolate that 3D view into a certain area. If I go to the default 3D view button and kind of look at this, it's showing me the entire building. Now we can certainly start selecting objects and using the temporary hide isolate mode that we talked about in the previous movie to start hiding them so that we can get in and take a better look. But sometimes it's actually just a little bit easier to kind of create a permanent view that's cropped down to the area that we want. So just like we discussed the crop region for 2D views a little bit earlier in this chapter, 3D views actually have a feature called a section box. So if I look at the properties here of the 3D view and I scroll down, there's this section box feature right here. Now if I were to zoom all the way out and enable that section box, what you're going to see is it will make this giant box way off to the side here. Now let me just disable that again. Now I could select that box and there's little grips over here, and I could begin resizing it to start cropping down the model. Now that's the manual way to do it, and it's effective, but there's actually a faster way and an easier way to do this. So let me just disable that section box and start again. So the first thing I'm going to do is go back to my level 1 floor plan here, and I'm going to find a view that kind of represents the cropping that I'm after. So maybe I want to get a better look at the stair here. If I open up this stair section, you can see that it's cropped down to a small area. So perhaps I want to make my section box kind of match that section view. Now I'm going to scroll down here, and I'm going to start by expanding my 3D views, and I'm going to right click on the curly bracket 3D view there, and I'm going to choose rename, and I'm going to call this 3D stair cutaway and click OK. Now I'm going to double click and open that up, and of course it's still the default 3D view showing the entire model. The next step is to actually come over here to the view cube on the corner of the window and right click it. And then there's this orient to view option, and here you're going to see all of your other views. And you can actually orient to any of the views. Like for example, if you wanted a 3-dimensional version of your floor plan, you could actually choose one of the floor plans here, use the view cube to orbit it into 3D, and notice that I now have this cutaway version of a floor plan. Now we said we wanted a section for this, so let me right click again, go back to orient to view, go to sections, and I'll choose that section at stair. And that will reorient and spin it around. Let me use my view cube, and then I can kind of zoom in here. And this right here is that section box. So you can see that all that really did for us is crop the view to a section box that matched the extents of the view that we were working with, the section in this case. Now I can fine tune it, and if I want to kind of peel off that wall, I could drag that a little bit right there. And if I want to reduce the height a little bit to get rid of that little chunk of the roof there, I can drag it down there. And then I could even come down here and start enabling the shading mode and giving myself a better look at this thing. And then finally, if you want, you can even take this section box and use that hide in view feature that we talked about before and hide that box so that it's not quite as distracting. Now, if you later want to resize that crop region, just enable the reveal hidden elements mode that will redisplay the section box, and you can fine tune the cut. Like maybe I decide I want to see the whole stair in here. And then when you disable it, it will hide again, but now you've adjusted the view. So it's a very effective way for you to kind of go in and isolate a 3D view to just a very specific little area. But the key is really to make sure you create a duplicate view first. Now, what I did was I actually renamed the default 3D view. Now, I did that on purpose because you'll notice I don't have a default 3D view anymore. Okay, there's no more curly bracket 3D. Well, notice what happens if you click the birdhouse icon again. Revit will just create a new one. So if that default 3D view isn't there, it'll just create one. And if it is there, it'll open it up. So this is why anytime you want to create your own custom 3D view, it's important that you name it with a unique name. That way Revit doesn't try and take it over when you click the default 3D view icon. Now let's look at an alternative way that we can do essentially the same thing that we just did. That's actually slightly quicker. So I'm going to go back to level 1 floor plan, and maybe I want to take a look at this break room in 3D. So I'm going to make a window selection around the geometry there in that break room. Now you can fine tune the selection if you want and add and remove objects, but I'm just going to make that simple window selection. And right here on the view panel of the modify tab, you've got this icon here, section box with a keyboard shortcut of BX. And all I have to do is click that, and it will take me to the default 3D view, and it will crop down to the objects I have selected. Now let me take this item here and hide it. And then let's go ahead and use our view cube to zoom in on that and take a look at what we got. Now, it needs a little bit of fine tuning. So if I want to get a better look at what I'm seeing in here, here's your section box again, and I could just drag this down to maybe strip off the ceiling. That gives me the opportunity to kind of peer down in there. Do the same thing here, maybe to get rid of this front wall. And now I can kind of orbit around and see this little 3D view of the kitchen area. Maybe you want to shade it. And you might want to finish it off by coming down here. And remember what I said about naming. It would be a really good idea to rename this now, so that the next time somebody uses the default 3D view, it doesn't try and take this view over. So those are a couple ways that you can quickly make these little cutaway 3D views, and I find these exceedingly helpful when you're trying to check things in your model and make sure that everything is coordinated the way you expect, and make sure that objects are joining with one another and that you're getting all the proper relationships. So it can be a really, really handy tool and very quick and easy to make. Naturally, as you work in Revit, you'll be creating views for many different purposes. Early on, you'll probably be creating most of your views simply for the purpose of editing your model. So you'll create floor plans, elevations, and sections to help you build your geometry in your model. But eventually, you'll want to start creating views that have more to do with presenting your model and outputting your model to the various recipients who need to see it. So in this movie, I'd like to take a quick tour of some of the graphical display options that we have available to make the views in your model a little more graphically appealing. I'm just going to highlight a few of the settings and show you where the command is and some of my favorite features, and then you are welcome to explore on your own because the potential of this command is pretty wide open. So I've created a view here called 3D Level 1 Cutaway, and I just oriented to the first floor plan and then adjusted the section box to show a little bit more of the height and a little bit less of the width. So you can get to the graphic display options in two places. You can get there on the view tab. On the graphics panel, there's a small little icon right here. It's a dialog launcher. It's called Graphic Display Options. GD is the shortcut. You can get to it from this pop-up right here on the Visual Style pop-up on the View Control Bar. Graphical Display Options. Either one gets you into the command. So let's start with the actual visual styles themselves. Of course, wireframe is just going to show you everything without any surfaces at all. Hidden line is what we were seeing here. It's just sort of flat hidden line. Shaded will actually apply not only some color shading, but also you'll notice there's a little bit of tonality going on there. Compare that to consistent colors, which would just do flat colors throughout. Let me set it back to shaded here and click apply. If your video card supports it, smooth lines with anti-aliasing is a nice setting because if you look carefully at the edges now, it takes away some of the jaggies and it just sort of smooths them out, makes them look a little bit richer. Transparency. This is kind of an interesting setting and can have an interesting effect, but if you slide that setting over, it actually makes all the surfaces semi-transparent. Now I find this a little overpowering in a view like this, maybe not quite so successful, so I'm going to dial that back to 0, and let's click OK. An alternative is to actually select an individual element, and let's say I wanted to just make this one wall transparent. Well, I can do that by going to this paintbrush icon right here, override graphics in view. I'm going to override by element, and then you've got surface transparency here, and now I could kick that up a little bit, click OK, and that transparency will apply only to the selected element. So that's a way to do kind of the same thing, but in a more isolated area. So definitely something you might want to consider there. Let's go back to graphical display options. Now, silhouettes, I love the idea. I'm not so wild about the implementation. I'm going to choose wide lines from that dropdown and click apply. And what you'll notice is that it tries to apply the effect that you would do if you were kind of drawing this by hand. Like in other words, it finds all the edges that are kind of out in front of open space and it bolds them. And it's doing a really nice job like on this column right here where these two edges are bold and that one's a little bit lighter, but not so much down at the floor because the column is actually sitting on the floor. So you really wouldn't want to bold those edges. And when you look at this desk here, it kind of bolded everything. So it's a little bit overpowering there. It looks really nice on this column and looks nice on this edge of the roof, but really this edge of the roof is actually adjacent to a wall, so maybe not so much. Unfortunately, you can't tell it which edges to apply the effect to, so it's kind of all or nothing. So I'll leave that up to you to decide whether or not you want to use that. I'm going to set it back to none for now. Under shadows, we've got two different possible shadows. Now, I love ambient shadows. When I turn that on, you can see that it adds a little bit of shadowing, especially in the corners. It kind of pulls up the shadow there, kind of dirties up the model a little bit. If you combine that with a hidden line, I think it looks really terrific. It's almost like you hand sketched it and you just sort of shaded it in a little bit. Sometimes that's all I'll do. I'll just turn on a hidden line with ambient shadows and smooth anti-aliasing, and that's it. And then I print it out, and I think it makes a terrific presentation. You also have casted shadows. So if I check this box, it will actually cast the shadows as if there's a light source. Now, the lighting is actually controlled down here. Now, we're currently in session lighting, and there's a ton of settings in here. Like if you go to any one of these, you can actually set the location of the sun and the time of day. I'm just going to stick with lighting, and to vary the angle of the shadows, you could change those numbers there. However, you'll probably notice there's the shadow kind of floating down underneath the model. And if that looks a little weird to you, that's because the shadow is being cast on this level, the bottom of footing. So we can just turn that off, and when we do, it won't cast that bottom shadow anymore. So that probably looks a little nicer. You can control the intensity of the shadows here. So if I drop this slider down, they get a little bit lighter, and if I crank it up, they get a little bit darker and more intense. So a lot of different possibilities here as you start mixing and matching and combining the settings. Sketchy lines. When you enable sketchy lines, you have jitter and you have extension. And the way these work is it just sort of roughs up the model and the edges and makes it look a little bit more hand drawn. Now let me crank up the extension here, click apply, I'm going to OK, and then I'm going to zoom in over here and kind of show you. There's the extension. And of course the jitter is just the more rough form to the edges. Now you could of course crank up both the jitter and the extension, but I think that maybe is a little bit too much. So personally I like the more subtle effect of just maybe a 2 or 3 on those settings, but you can fine tune and experiment with it as much as you like. The next setting in there that I want to show, the final setting actually, is depth queuing, but I can't show you that in the 3D view. Depth queuing is for elevations. So I'm going to go to my south elevation view here and kind of take a look at this elevation. And what we can do with depth queuing is we can start to have the system fade the geometry as it recedes back from the elevation line. Anything that's closest to the elevation line will be the boldest, and anything that's furthest away will be kind of faded out. So let me go back to graphical display options, and I'm going to expand depth queuing and check the show depth button. Now, when I click apply, you're going to see very little change. The reason for that is if I click OK and I go back to the level 1 floor plan, here is our south elevation and it's being cut right here. And when we look at its properties on the properties palette, its far clip is not being clipped at all. So it's going off into infinity. So the problem is there's just not enough variation between this plane, which is closest to us, and this one, which is a little bit further back. Now that's further complicated by the fact that my elevation is actually being controlled by a scope box right now. So I'm going to take the scope box setting here and change it to none. That now allows me to click the clip option here and either clip it with or without a line. And then when I do, that gives me this back grip. If I left it assigned to the scope box, I would have to actually take the scope box and drag it in closer, and that would affect the other elevations. And so in this case, I think just separating it from the scope box is probably a better way to go. Now, you can actually move this closer to the building too to further compress. And what I'm doing is I'm compressing this distance between here and here so that when you go back to the south elevation, you should already start to see the effect taking place. Because when you go back to graphic display options and you look at depth queuing, these are really percentages. And so it's looking at the total depth of your elevation and then applying the effect across that depth. So you can clip it a little bit by, slowly dragging these kind of near and far, and that starts to compress those values, or you can tell it to not get as light or to not get as dark by dragging this and adjusting it, and it does have an effect on it. So play around with these settings, but you really need to get that depth right first, because that's where the whole thing is applied to initially, and then it kind of compresses from there. So as you can see, the potential in this graphic display options dialog is vast, and there's all sorts of possibilities here when you start combining the various settings with one another to get different sorts of graphical display options that you're looking for. So whether you're doing a presentation view or just a construction document elevation or something in between, the collection of settings that you have available in here should allow you to get a result that you're happy with.
Hey, what's going on, everybody? We're taking a look at how to show doors in a reflected ceiling plan. So in front of you, what you see is I have a reflected ceiling plan for my level 1. The first thing I need to do here is go to my visibility graphics over here in the properties panel, and I'm going to go down to view range under extents and click on edit. In here, I can go to set my cut plane. So I would go and change this cut plane. It defaults at 7'6". I want you to see what shows. So a lot of my doors are 7'4", then get cut out of this reflected ceiling plan. So I've modified this to 7'2", just to be able to see the frame of the door in that cut plane. And then from here, what I need to do is I need to hide the door swing and the thickness of the door panel. So that way just the cut is open on where the doors are located, but we're not really interested in seeing those door swings in a reflected ceiling plan. So you do the shortcut VV. So I'm literally out of all my commands hitting escape. And then I press the keyboard VV. And with VV pressed, I'm going to go down to doors and expand that, and you'll see I have unchecked panel and swing. I want you to see what happens when I apply that back on. So this is what's showing by default by cutting through my door, but in a reflected ceiling plan, I'm not interested in seeing the panel or the plan swing. I'm going to apply that and say OK. And now I have my reflected ceiling plan annotated with the doors done correctly. And if I want to go through and make sure that all my windows are done right, I can also make sure that those are all being shown at the correct height. And in this one, at this level, it's earth sheltered on one side, and so there's really no low windows in this one other than the curtain wall on the south side facing part of the structure. All right, don't forget to save and subscribe. I hope you enjoyed the video, and I will see you next time.
In this movie, we're going to add some rooms to our model. Now, I like to think of rooms as mainly a utility object, and what I mean by that is technically a room is part of your model. It actually represents the space that you occupy when you're in an enclosed space. But graphically, it doesn't display anything unless it's selected. So it's really not a graphical object. It's not an object that you would see in your drawings, but it holds lots of information. So it can hold the area of the space, the volume, the perimeter of the space, the occupancy information, the finish information, things like that. So it's a very important and useful object, but it's going to behave slightly different than all of the other model elements that we've looked at so far. To illustrate, let me go to the room command, which is here on the architecture tab on the room and area panel, and the button is right here. So you'll notice that there's this tag on placement button over here, and it should be on by default. But if for some reason yours is unchecked, it's not turned on, then just make sure you click it here and it'll be highlighted in this blue color. Now, if you move your mouse into the view window, you're going to see this light blue rectangle appear, and then a smaller rectangle with the word room above it. That's actually the tag. The blue rectangle with the X through it, that's the room. So what we're actually doing is creating two objects, a room and its tag. Now, if you were to click out here, you're not going to get a very useful room. Okay, let me go ahead and cancel out of the command, and you'll notice that there's an error message down here telling me that my room is not properly enclosed. Well, if I were to deselect, kind of click anywhere to dismiss that warning and to deselect the room, it looks like there's actually nothing there. But of course, I see a room tag, so I kind of know that there is something here. And if I move my mouse nearby, I can find the room and actually select it. So one of the features of rooms is that they're invisible until you actually select them. That's sort of their default behavior. So what I want to do here is do Control Z to start over again. I don't want to create that sort of orphaned room off to the side. What I'd rather do is go to my room command, make sure tag on placement is on, and I'd rather place it inside the space somewhere. So I'm going to start with this bedroom up here in the corner. Now, if I click, you can see that this time I don't get a warning and it fills the space of that bedroom. Now, as long as you move these into enclosed spaces, like this bedroom here, it will continue to do that same thing and flow into the available space. Notice also that the room tags will try and line up with one another. So if you just pay attention to that, you can actually get a nice, neat presentation when you place these. Now, if I were to come out to this space here, it's not going to work quite as well because that space, it's a living room, it's a dining room, it's a kitchen, and it's kind of all flowing together. So I don't really want one big room in all of that space. So I'm going to avoid that room, and I'm just going to click in any of these enclosed spaces, the walk-in closet, the two bathrooms, the small linen closet, these two small closets here, and the utility room. Now, I can certainly place them the way that I just did, one at a time. Okay, but I'm back now to this big open space here. So before I place this last space, what I really need to do is kind of carve this space up. So let me go over here to the modify command and cancel out of the command. All the rooms will become invisible again, but the room tags, of course, remain. Now, we could draw new walls to divide up the space, but that would be kind of silly. We don't want to change the architecture in order to accommodate the rooms. But what we have instead is a feature called a room separator. Now, a room separator is a kind of model line, and you just draw these anywhere that you want a boundary between two rooms. And you can see here on the draw panel that we can draw any shape we like, but I'm just going to stick with a simple straight line here, and I'll wall off this dining room right here, and then I'll kind of pull down to take care of that little hallway right there. Then I'll do this little space right here to wall off the kitchen, and then finally divide this space here to give me the living room and this little hallway. And I'll click cancel there. Now, going back to the room command, I could click one at a time in each of these spaces to create the remaining rooms. However, if I want, there's also this place rooms automatically command that I can use. And with a single click, it will just go in and create the remaining 8 rooms that were needed. Now, actually, it turns out that one of them I didn't need, which was this right here. That was a shaft space. So there's actually 2 disadvantages to the place rooms automatically. One is that it finds every enclosed space, like this one right here. And 2 is that you don't get any control over what order they're placed in. Now, I'm going to talk about placing rooms in a strategic order in a future movie. We're going to ignore that second concern for the time being. But in the meantime here, I'm just going to simply delete this room tag and then select its room and delete it. Now, when I do, Revit will alert me that the room still exists. And again, that's a feature that I'm going to talk about in a future movie. So for now, I'm just going to kind of ignore that. All right, so the next thing that I want to do is talk about the relationship between the room and its tag. So perhaps I come up here to this dining room, and if I start moving my mouse around, what you're going to see is that this little X appears through the middle of the tag. Now that X is actually the room. And you can see that by default, it's going right through the middle of the tag. Now, if I click on that X, it will allow me to select the room. And then if I look over here on the properties palette, you're going to see all of the information about this room. Now, contrast that to selecting the tag. When you select the tag, you're just selecting the symbol that's reporting information about that room. Now, it will highlight the boundary of the room that it belongs to, but if you're not sure, like if it's ambiguous in any way as to which room this tag belongs to, you can click this button right here, select host, and it will actually select the room for you. That also can be another easy way to select a room when it's difficult to get to it, like I had in this small space here. So for example, this closet, it might be difficult to select the room underneath, so I could start by selecting the tag and then click this button to say select host, and that would be an easy way to get that room. Now, you can actually move both the tag and that X. So if I select the tag, you're going to see this small little move cursor on the tag, and you can use that to drag the tag and relocate it. Now, notice that the X is still back where we left it, and that X can actually be relocated as well. So if you have a non-rectangular shaped room that's kind of an unusual shape, sometimes it's going to be more convenient if you move that X to a nicer area to make it easier to select. Because after a while, when you're working in these floor plans, you'll kind of remember where those X's are so that you can quickly select the rooms when you need to make modifications. Now, there's one thing that I really want to stress here. The room and the tag are 2 separate things. This room right here is the actual model object. The tag is nothing more than a piece of annotation that is linked to that model object. Now, the way I like to think of it is the tag is asking the room a question. So in this case, it's asking the room, what's your name and what's your number? So if I select this room right here, come over to my properties palette and look for the information. It says that it's room. I can change that to dining room. And it says the number is 13. Well, maybe I want the hallway to be 100. I want the living room to be 101. So maybe I want this one to be 102. When I apply those changes, notice that the tag updates. So it's really important to understand that it's actually the room that stores the data and the tag is just on the receiving end. In fact, you could actually delete the tag. Nothing will happen to the room. And if you come back here and choose this room tag and re-add it, it will already know what the name and number is because it just reads that information right off the tag. So the last thing I'm going to do is just sort of go through here and change all the names and numbers of all these rooms to make them a little bit more logical. So now that I've shown you the relationship between the room and the tag, let me show you a shortcut. It's actually possible for you to select the tag, and then if you look carefully at the two labels within the tag, they turn into that light blue color, and that usually indicates that it's editable in some way, just like temporary dimensions. And notice that I can click right on that label and modify it. So if I wanted to input the name and number directly in the tag, that is an option that I have available. As long as you understand that what you've actually just done is use the tag to modify the room. So if I deselect and I come back and select the room, scroll down over here on properties, notice that the name and number of the room matches what I input in the tag. So once again, the tag is on the receiving end, not on the driving end, but we can use it as a shortcut to rename and renumber the rooms. So at this point, I'm going to go in and just name and number all of my rooms. And when you're done naming and numbering, it might look something like this. Feel free to fine tune the position of any of the tags and line them up with one another, and then you can save the file to complete your work. So the first step in starting to track things like the square footage or labeling all your spaces, maybe assigning finishes, the first step to all of those tasks is to add the rooms and their associated tags. In the next several movies, we'll look at some other things that we can do with rooms to help managing the data within our project. In this movie, we're going to add a sequence of rooms to our commercial building layout, but we're going to do it a little bit more systematically than we did in the previous movie. You may recall in the previous movie that we added rooms to our 2-bedroom condo, and we sort of placed them randomly, both manually clicking room by room, and also we used the automatic room generation command to do it. And in both cases, we really didn't have a whole lot of control over the numbering of those rooms, which meant that we had to go back and actually select the rooms one at a time and renumber them all, which can get a little bit time consuming. So in this movie, I want to show you that if you just employ a little bit of strategy, you can actually get a much better result with the numbering of all of your rooms, and in the long run, save yourself a little bit of time and effort. So the first thing I want to do to get started is I'm going to make a slight visibility graphics modification. If we look at this plan here, you'll see that there are room separation lines here and here. And if you watch the previous movie, then you know that the room separation lines actually create sort of a virtual boundary between two areas in an open space. And it allows you to turn that into two rooms, where otherwise you'd have to build a wall there. Because these are the same as all the other geometry, it's a little difficult to see. So a trick that I usually like to do here is I'm going to select one of those, and I'm actually going to modify the graphics of that category. So right here on the ribbon, we have this little paintbrush icon. I'm going to expand that, and then I'm going to choose the override by category command. That's going to display this view graphics by category dialog. And all I'm going to do here is click the color button and choose some bright noticeable color, like this bright orange here, and click OK. Now you certainly could choose other settings as well, like a dash line pattern or heavier line weight, but I'm going to go with just the orange there and click OK. When I deselect that, notice that there's one here, here, and here, and they've all turned orange. So it's just a little bit easier to spot where the room separation lines are. Okay, now I'm ready to start adding the rooms. So I'm going to go to architecture, and once again, you might be tempted to click the room button and do the place automatically. But if I do that, it's going to create these 14 rooms, but when I close, notice that I have really no control over any of the numbering. It's all sort of random, and it started at a strange number, and I'm really not sure what it did. So I'm going to undo that. Okay, so what I'm going to do instead is I'm going to go to the room command. I'm not going to use place automatically, and I'm going to decide which room I want to be my first room. And the most obvious choice is this lobby right here. So I'm going to click to place that lobby. Then I'm going to cancel the command and take a look at what name and number it gave me. Now, obviously, I don't want to call this room, so I'll call it lobby. And then here's the key. Change the number right now to the number that you want it to be. How about 101? Now I'll zoom back out, and I'm going to add my next room. And what Revit does is it picks up wherever you left off. So when I click this room here, that one becomes 102. This one becomes 103. Let me cancel the command and zoom in so you can see that. There's 102. There's 103. So now my job is to just go in and place the rooms in the sequence that I want them to be in. So this will be 104. This one right here will be 105, 106, 107, 108, 109, 110, 111, 12, 13, and 14. So that takes care of all the numbering, and it was just a matter of thinking about where I want to click to place each room. Now it's just a matter of doing the naming. Well, here again, I can employ some strategy, and all of these rooms here, plus these two here, I want to have the same name, right? They're all just offices. So I'll go to filter, check none, choose rooms only, notice that it's 6. That highlights the 6 offices, and then I'll come over here to the properties palette and type in office. And that will change all 6 of those to the same thing. If I find the room here, hold my control key down and find the room here, I want both of those to be corridors. So as you can see, when you start having repetitive room names, it becomes much quicker to go in and modify those names if you select them in batches like this. Now you will have some unique rooms, so you can do each of those and complete the room naming for the first floor. Now the layout on the left-hand side of the second floor is largely similar to the layout on the first floor. So now what I want to do is go up to the second floor plan and again employ a little bit of strategy to make my job a little bit easier here. Now this particular floor plan, the furniture and the electrical fixtures are showing, so I'm going to hold the control key down and select one of each of those elements, go to the light bulb here and hide the category. That'll just make it a little bit easier for me to see what I'm doing. Now I want to add the rooms up here. But again, I want to show you that if I go to room and I place this corridor, for example, right here, cancel out and zoom in, Revit's not very smart about how it handles the second floor. It's just going to pick up wherever you left off on the first floor, 115 in this case. Here's all you have to do. Click in there, change that to 201. While you're here, give it a name. Now I'm going to zoom out, go back to the first floor, and I'm going to select all of the rooms that I want to copy from first floor to second floor. Again, I'll go to filter, check none, but this time I'm going to select both rooms and room tags. So all of those objects there, and I'll do this button right here, copy to clipboard, or you can press Control C. When I go up to the second floor, I could do Control V, but it won't be very precise, so I don't recommend that. Click the drop down instead on the paste button, and I'm going to choose paste aligned to the current view. When I do that, it will paste all the rooms in exactly the correct locations here on the second floor, and more importantly, notice that the sequence is now picked up from 201 this time. So the key to doing a multi-story layout where you have similar room layouts is to get the numbering and the naming the way you want on the first floor, and then on each subsequent floor, you have to add at least one room and rename and number it. But then you can copy and paste the rooms and tags from the other floors, and the numbering will automatically match the new pattern from the new floor that you're working on. But the naming, as you can see, will be copied and pasted from the floors below. So this will save you a tremendous amount of time and effort when you're adding rooms to a very large project. In this movie, I want to continue our exploration of room objects and dig a little bit deeper into the room bounding property. Now, we've already seen that walls are room bounding by default, and in cases where we don't have any boundary between the two rooms we want to create, we can create a room separation line, which is a room bounding model line. But there may be situations where you actually want to disable the room bounding feature. So let me show you an example right here. I'm going to zoom in on this bedroom area down here in the lower left-hand corner. Now, at the moment, if I kind of move my mouse around here and find the room right there, you can see that it's got this little notch taken out of it for the closet in the right-hand side of the room. Now, if I look over at the properties palette, it's about 14.8 meters squared. Now, let's say I wanted to think of the bedroom as both the bedroom and the closet. So I wanted to kind of ignore the fact that that was a separate space in there and not give it its own room. All I have to do is select these two walls, And then on the properties palette, if we look over here and scroll down a little bit, you'll see that there's a feature here called room bounding. It's as simple as unchecking that box, and when you apply the change, come back over here and select the bedroom, you can see that it now completely ignores the closet. And if you look at the area, it is now 16.4 meters squared. So that's a really simple situation where you might want to actually disable the room bounding feature. Now let's take a look at another example here up in this bathroom area here. Perhaps you want to do the same basic idea here in this room and kind of incorporate the linen closet into the master bath. Well, there's two things you want to be cautious of here. Here's the wall that separates those two spaces. So you say, okay, I know what to do now. I'll just uncheck the room bounding feature. But as soon as I do that, you're actually going to get an error message display on screen from Revit. And if you read the whole message, it's basically telling you that you now have two rooms in the same enclosed region. So what this means is we had the master bath right here, which now flows into the linen closet and into that little chase area. And if we come over here and select the tag for the linen closet and then click the select host button, you'll see that there's a second room that matches the exact same enclosed area of the first one. And so that's what the error message was telling us. Now, generally speaking, it's considered a bad idea to put two rooms in the same space. Now, to help me investigate this a little bit further and kind of understand what we have here before I try and remedy the situation, I'm going to deselect that, and we're going to come down here on the project browser, and we're going to open up this room schedule that I've provided here in the file. Now, we're going to talk about schedules in detail in a future movie, but for now, we're just going to work with the one that I've already provided here. Now, if we come down to this icon over here in the upper right-hand corner, it's labeled Restore Down. We can click that, and that will make this a floating window. I'm going to resize it a little bit and kind of put it up here in this corner, and then the floor plan, I'll just kind of position that as well, and maybe reduce the size and make a few adjustments here. And I just want to basically be able to see the schedule over here and that master bathroom and linen closet in the background. Now, notice that if I come over here into this little schedule and locate that master bathroom and click on it, it will actually highlight the corresponding room in the model. So that makes it even easier to select that particular space. And then if I locate the linen closet and do the same thing, it will highlight that room. Now, if you look in column C, the area column, you'll notice that 105 master bath is 5 meters squared. But if we click on 110 linen closet, it actually says redundant room. So that's another way that you can tell that you have two rooms on top of one another. So if somebody dismisses the error message but doesn't actually get rid of the offending room, you'll be able to spot it immediately on the schedule. And that's why, using a schedule can be really helpful here to troubleshoot situations like this. Now, I may be tempted to just say, okay, let's just delete the room then. I don't actually need it anymore if I'm going to have this larger room. Let me click over here into the floor plan. Notice that the linen closet is still selected, and I'll press my delete key. Now that will generate yet another warning from Revit. Now we've actually seen this warning before in an earlier movie when we had a room in this small chase space there, and I deleted that. The message says we've deleted a room from the model, but it still remains in the project. Now what does that mean? Well, to go back over here to the schedule, we can start to see what the problem is. Notice that that linen closet right here now says not placed. It's still there on the schedule, but it's saying it's not placed. And in fact, up here at the top of the schedule, we see that other room that was created when we did the automatic room command a couple movies ago, and it is also not placed. So the reason that they appear this way, there's a lot of special behaviors of rooms, but the reason they appear this way is because Revit is allowing for the possibility that you might want to create your program of rooms first before you even have any wall geometry, and then later place those rooms. So if you went to a client meeting and you got a lot of area requirements for the different spaces that were required for a project, and then you wanted to come over here to a room schedule, there's actually a button here where you can insert a data row. So I could click insert, and notice that down here at the bottom of the schedule, it's created room number 115 and called it room. And I'm just going to rename this test. And then it says that it's not placed. Well, now over here, I'm going to come over and just draw some walls just to have something. And then I'll divide this like that and divide this like that. I've got 3 not placed rooms. Watch what happens now when I go to the room command. By default, this drop down here on the options bar says new, meaning it's going to create a brand new room. But if you open that up, any of the rooms that are listed as not placed on your schedule will actually appear here, and you can select them and place them from this list. And when you do, if you watch the schedule, you'll notice that we no longer have any that say not placed. Now we do still have one that says not enclosed. I'm going to talk about that next, but all of the not placed rooms have now been filled in. Click modify to cancel the command. Anytime you delete rooms from a model view, like a floor plan, you'll get that warning in Revit that the rooms are still there, and then you'll see them still appear on the schedule as not placed. So to actually permanently delete a room for good, not have it appear in the schedule, you have to use this button right here on the rows panel. Now don't use this button. This would actually delete the entire column. If I do that, the whole number column goes away. Let me undo. It's this button right here to delete that room, and it will warn you, and I can do that for each of the non-placed rooms. And now they're permanently deleted from my model. So let's address this last one here, this not enclosed room. Where is that? So let me zoom out here. And as you can see, it's out here. Okay, so when I select it here, it highlights in the floor plan right there. And the problem with this, we already know how to solve. Because that's an outdoor space and there's no walls there, this is a railing, this is not actually walls, then it's not an enclosed room. Now, in some cases, maybe you don't care, because if you're not trying to calculate the area of the patio, then it might not be important. But assuming that you did want to calculate the area of the patio, it's as simple as adding some room separators that trace the shape of the patio. And I'm just going to draw that manually. And as soon as you do, that patio will fill in and give you the correct area. So managing your room bounding elements can be an important part of the design when you're working with your projects and working specifically with your rooms. In some cases, you might want to deliberately disable room bounding, like in the cases of these closets or small ancillary spaces. And of course, in other cases, you'll have to create room bounding elements using the room bounding line. But in any case where you create a room that's not enclosed or that's not placed in the model, the schedule is your tool where you can identify those rooms and also where you can remove them if they're no longer needed in the project, and where you can even create future rooms that you intend to place later. Tags are very common in architectural drawings. We typically add tags to rooms, to doors, windows and walls, and many other items. Tags often reference a designation on the schedule or on a detail where we can find out more information about the item in question. In Revit, the element, the tag, and the schedule are all linked together. The tag basically asks a question of the object to which it is attached and reports the result in the symbol on screen. The same designation is often included in a field in the schedule so that a cross-reference can be made. So in this movie, I'm going to add some tags to some of the more common elements in a floor plan view. Now it turns out I can add most tags using a single command. We can find that command on the quick access toolbar right here. It's called tag by category, has the shortcut TG, and you can also find it here on the annotate tab right there, tag by category. Once you click that command, all you need to do now is move your mouse around the screen, and it will highlight different kinds of objects and display different shape tags. So for the door, we're getting this little pillbox shape. For the window, we're getting this little hexagon. And for walls, we're getting this little diamond. Now, how do we know which items are eligible to be tagged? Well, here on the options bar, there's a tags button right here. And if we click that, it will show me all of the categories that can be tagged. And like we've seen in some other dialogues, we can actually filter this by discipline. So if we wanted to just limit this to architectural tags for the time being, I could uncheck the other disciplines. And you can see all of the different categories that are taggable listed here. And then over here in this loaded tags column, you'll see the ones that actually currently have a tag loaded. So we have a tag loaded for doors, for example. We have one for rooms. We've got those on screen already. We've got one down here for walls and another one for windows. Notice that we don't currently have a tag for specialty equipment, for example, and several other categories. So if you were to actually highlight a specialty equipment item, it would still highlight the item, but if you click it, Revit will alert you that you don't currently have a tag loaded and ask if it's okay that you load one. Now I can answer yes and go browse to my hard drive and find a tag, or in this case, I'm just going to click no because I don't actually want to tag that. So if there's a certain kind of object that you want to tag, you can either preload the tag ahead of time in the tags dialog, or you can just wait to be prompted. So let's go ahead and work with some of the tags that are already loaded, like for example, the door tag. So I'm going to click right on this door right here. Now, if I zoom in, you'll notice that it created that tag with a leader. It wouldn't be very common for door tags to have a leader. More often than not, they would be created without that. So right here on the options bar, we have that checkbox where we can disable the leader. And now when I click on these doors, they will simply tag without the leader. Now, if I cancel out of here for a moment and you take a look at the numbering, it might seem a little bit random. This was door number 13. This was 9, 10, 11. It's important to understand that the numbering for the doors has already taken place. A lot of times people misunderstand this and they think that when they're tagging, that's when they're assigning the numbers and that the numbering information is stored in the tag. Both of those things are not true. The numbering actually occurs at the time when you create the object. So this was the 9th door that I created and it was automatically numbered as door number 9. Now, if I select the door and I scroll down over here, we can see that here in the mark field. This is door number 9 and this one is door number 10 and this one is door number 11. This one that I haven't tagged yet is door number 12. So the number already exists. The mark already exists. And when you tag, the tag simply asks that object what its mark is. Now, if I go back to tag by category, and this time I click on some windows, and let's click on those 2 windows over here, and maybe a couple more over here, notice that these are all displaying the same number. Now, why is that? Okay, well, it turns out that these tags are asking a different question. So if I select this window, its mark is window number 9. This one is window number 7. This one's window number 8. So when I created those windows, they were each numbered in sequence, but that's not the question that the tag is asking. The question the tag is asking is, what is the type mark? Now, with any of these windows selected, if I open up the list, you may recall we could choose a different size. So what would happen if I chose a different size here? Well, not only does the window get slightly smaller, but notice that the designation changed as well. So it turns out that this designation is actually here in the edit type dialog. And if I scroll down, we can see that there's a type mark field, and this one that I just changed is door number 24. Meanwhile, if I cancel there and select one of the original windows, edit type, that window is window number 25. Now, what if I change that number and made it 35? When I click OK, it won't affect just the one that I have selected. It'll change this one and these 2 over here as well. So that's the difference between an instance property versus a type property with respect to the tags. So each tag is asking different questions. The room tag is asking name and number. So it's actually asking 2 questions. So let's go to tag by category again. And what if we started to tag some of the walls? Well, the first thing is notice that the wall tag butted right up against the wall doesn't quite look right. So actually that leader feature is going to be helpful if we decide to tag walls. And this is a little bit more common scenario that you might see in construction documents. So I'm going to go ahead and select some of these walls here. I'll just tag a few of them. And then notice that all of these tags are empty. Now, why is that? Well, it turns out that these tags are really asking the same question that the window tags were asking. They're asking the wall what its type mark is. And in this case, if we select one of the walls, go to edit type, scroll down and look at the type mark, you'll see that that field is currently empty. So if we input a designation, maybe something like A1 and click OK, you're going to see the tag fill in here and in all of these locations as well, because all of those walls are the same type. Now, these 2 didn't fill in because we haven't given that designation yet, and these are different type walls. So here's an alternative to fill in that designation. I can actually select the tag and click right on that small question mark and put in a designation. And when I press enter, it will alert me that I'm changing a type property and ask me if that's okay. I'll say yes. And notice that it fills in this designation here, but it also filled in this one here. So this wall and this wall are the same type, where the other walls were all a different type. So regardless of how you make the change, it's just important to understand that you're dealing with different properties in each case. Now, let me zoom out here a little bit and notice that I still have several doors that haven't been tagged. I have several windows that haven't been tagged. So I could go around with the tag by category and keep clicking on individual elements. And in a small floor plan like this, it might move pretty quickly. But there's actually a faster way to create a series of tags. Right next to tag by category is a command called tag all not tag. And what this command allows me to do is to tag all of the objects of a particular category in a single step. So when I open up this dialog, the first thing I want to do is make sure that at the top it says all objects in the current view. If you go into this dialog with something selected, so let me cancel that and select some objects here, and then go to annotate and tag all, notice it would say only the selected objects, but you can still change it to all objects in current view. Let me cancel again and just deselect, and then I'll do tag all, make sure it's all objects. The next thing you want to do is select which category you want to tag. So I'm going to choose the door tags. I don't want a leader, and I'm going to click OK. That will go through the floor plan, and any door that didn't already have a tag will now have a tag throughout the entire plan. So much faster than doing them manually. And we can repeat that for as many different tags as we want to create. In fact, you can do them without even leaving the dialog. I could click window tags and click apply, and that would add any missing window tags. They're actually down here off screen. I could click wall tags, add the leader, and click apply, and that would add any missing wall tags. And then when you're done, you can click OK. So however you choose to add the tags, either with tag by category or tag all, it's a really quick and easy process to go in and add all of these different tags to your plan, and then double check all the designations and make any changes you need to make. Now I want to show you one last change that I like to make here. I'm going to select this tag, and you see how it kind of just ends, that leader just sort of ends at that wall? I want to give that a little bit more graphical punch. So with the tag selected, not the wall, I'm going to edit type. So what I'm editing is the properties of the tag itself now. And notice that there's a leader arrowhead option, and I can open up this list and I can choose from any of the leaders that are available in this file. Now I like this one here called heavy end, and when I click OK, it just sort of puts a nice little bold end there on the end of that tag, and I think that makes it look a little bit nicer. Now the last thing I want to do is I'm going to right click with that tag selected, go to select all instances, and I'm going to say visible in the view. That's going to reach out and select every wall tag. And what you'll notice is that over here on the type selector, there are actually 2 different types for this wall tag. I'm going to choose this smaller size here, 8mm, and you see how all the tags get a little bit smaller, and I think I like that a little bit better. So you can feel free to do any other additional fine-tuning measures that you'd like to do, but adding tags is a critical part of any construction document set, and I hope you'll notice here that using the tools available in Revit makes really short work of that task. In this movie, I'm going to create a schedule view. Now, there's lots of different kinds of views in Revit, of course, and so far we've been working with plans, sections, and elevations. And these are all graphical views where Revit looks at your model, finds the objects that should be displayed, and then draws them graphically on screen using the standard architectural drafting conventions that we're familiar with. Well, when it generates a schedule, it does essentially the same thing. It looks at all the objects in the model, gathers up the ones that are required by the schedule, but instead of drawing them, it lists them out in a table that looks very much like a spreadsheet. And that tabular view we can then use to print out, to report, to query, and or to edit our model. So let's do a really simple schedule. In this case, I'm going to do a furniture schedule, and as you can see, I've got some furniture items here in my floor plan. And to create a schedule, we can go to one or two places. We can go to the View tab and click the Schedules drop down here and choose the Schedule and Quantities command, or you can right click here on the Schedules and Quantities branch on Project Browser and choose New Schedules and Quantities. It doesn't matter which way you do it, you're going to get to the same dialog either way. Now this dialog, like so many others that list out categories, does have a filter at the top, and at the moment I am filtering by just the architectural categories. I'll scroll down, I'll select the furniture category, it will suggest the name Furniture Schedule, which I'm happy with, and then I'll click OK. In this dialog, it will ask us to place one or more fields in our schedule. You have to have at least one field, but you can put as many as you need in the list here. So I'm just going to move through the list and decide which fields I want to include. And I'm again going to keep this fairly simple. I'll add the comments, the count, the family and type, and then finally the type mark. Now you can also double click the fields to put them in the list as opposed to clicking the add button. Now down here at the bottom, you can use these move up and move down buttons to reorganize the list. So let's put type mark first, then we'll go family and type, and we'll end with comments. So once you've got them in the order that you like, we can click OK, and that will display the schedule. Now I'd like to tile my schedule and my floor plan next to one another, but unfortunately I can't type WT when the schedule is active. So if you want to use your keyboard shortcuts, you have to restore this down, click on the floor plan to bring that to the front, and then you can type WT, and it will tile those two windows next to one another. Let me go ahead and adjust the zoom here slightly so that I can see the entire floor plan. And then over here in the schedule, I'm going to enlarge column B by dragging right between the two columns. I'm going to drag it wide enough that I can read all of the names in the family and type column. And I'm going to reduce the width of column C so that I can see everything comfortably there on that screen. Now, one of the advantages of tiling the two windows side by side like this is if you click on an item in the schedule, it will highlight the corresponding item in the floor plan. So I can kind of click through the schedule fairly quickly here and see where all the various objects are. Now, another advantage is I can actually select the item in the schedule as I've just shown you, but if I look over in the family and type column, notice that if I click here, this actually is a drop-down list. And that list corresponds to the same set of choices that we would have if we used the type selector back in the properties palette, which means that if I wanted to experiment with using a different size bed in this bedroom, I could actually choose the queen bed right here off the list. Now, if I'm satisfied with that, I could keep it, or I could just simply go back to the double bed and say, yeah, maybe I'll try that instead. Now, another thing that you can actually do is you can click and drag through multiple items. So in this case, down at the bottom of my schedule, I have all of my nightstands. So if I click and drag through all of those items, it selects all 4 nightstands. Now, unfortunately, I can't click here and begin modifying that nightstand because you can see it will drop the selection. So here's what you do instead. Drag through all 4 items. That makes your selection, and then click over here on the title bar of the floor plan to activate the floor plan. That will keep the selection active, and now you can come over here to the type selector to make a change. So perhaps I want to try this slightly larger nightstand in that place instead. Notice that the schedule will update accordingly. So it doesn't matter whether you make the edit in the schedule or in the floor plan, both sides are going to reflect the change because they can't get out of sync because it's the same model. These are just 2 different ways of looking at the model. Now, if you watch the movie on adding tags, we talked a lot about instance marks and type marks, and those were the values that were showing up in the tags. Over here on my project browser, I have a floor plan called Level 1 Furniture. I'm going to open that up, move it over here on top of the other floor plan, and resize it so that it covers it up. Now, notice that the nightstands are still selected, okay? But what I'm going to do here is come into one of my chairs. So I've got this Breuer chair right here, and I'm going to click right in that type mark field. And I'm not really too concerned as to which chair it is, but you can see that down here, it's one of the ones in the kitchen area. Well, I'm going to start typing in a designation that I want that chair to have. So I'm going to label this chair CH1. When I press enter, watch what happens. Revit will alert me that that change is a type change and it's going to apply to all instances of the Breuer chair. And if I click OK, you're going to actually see several fields here in the schedule fill in. And if you zoom in here on the floor plan, because I've already added furniture tags to this floor plan, all of those furniture tags are going to fill in with those designations. Now, just like we saw with other tags, I could click right here on this question mark. And if you have any difficulty highlighting the label, you can press the tab key and then click it again. And maybe this is going to be TB1 for table 1. When I press enter, it will also alert me that it's going to apply to multiple items potentially. And when I click yes, somewhere in this schedule, you're going to see TB1 fill in. So whether or not I make the change in the floor plan or in the schedule becomes irrelevant because both of them are going to update. Let's do one more example. CH2 for the Corbu chair. And you'll see that fill in both of those places. So it becomes a very convenient and easy way for you to keep track of the changes because as the schedule starts to fill in, you'll kind of know when you're finished. And you can also check your work using the tags in the floor plan. Now, we've got a very small floor plan here. It's pretty easy to see, but in some cases, if you're having a hard time finding a particular item in the schedule, what you can actually do when you click on it is if it's not immediately obvious where it is, there's this highlight in model button right here. Now, when I click that, it will find the item and actually zoom in on it for you. Now, assuming that you're happy with the view that it chose to do that, then you can simply close this box. If not, you can actually click the show button, and what it will do is switch to another view. In this case, it switched over to my furniture view, and continue to show it to me until I exhaust all the views. And then when you're happy with the selection, you can click close and continue with your work. So a schedule view is a pretty easy view to create. It's a tabular view of your model, but it's a live view of the model just like any graphical view is. You can make edits directly in the schedule. You can use the schedule to help you find and select objects, and any changes that you make in either view, graphical view or schedule view, will be reflected everywhere throughout the model. In this movie, I'm going to look at some options to configure my schedule and make it a little bit easier to read and make the information a little bit more valuable. So I'm going to focus on things like sorting and grouping the schedule and consolidating some of the information so there isn't quite so much redundancy in it. So I've got 2 views open on screen. I've got a floor plan, a furniture floor plan on the left side, and I've got my schedule view on the right, and you can see all of the different items listed in here. If we look in the type mark column, you can see here that there really isn't too much rhyme or reason to the order that any of these items are in. And in fact, there really isn't any. The schedule is currently being listed in the order that these items were created. So the flat screen TV at the top was the first item I created, and the nightstands at the bottom were the last items I created. So what we want to do here is maybe introduce a little bit more rational sort methodology to this schedule. So how are we going to do that? Well, the first thing I'm going to do is select the schedule to make that the active view. And then when you do that, if you look over at the properties palette, it will tell you that we're looking at the properties of the schedule itself. Now, if I scroll down a little bit, you'll see here under other that there are 5 entries here. Each one has an edit button next to it. And if you click the edit button next to any of these entries, it will display the schedule properties dialog and it will highlight that particular tab. So I click the edit button next to sorting and grouping, and I'm on the sorting and grouping tab. Now, everything's grayed out here because I don't have any sorting and grouping at the moment. But if I click this drop down list here under sort by, it's going to list out each of the fields that I've added to the schedule minus the count field. You can't sort on the count field. So I could choose any one of these fields to sort on. So I'm going to choose the type mark field. Now, let's assume that that's all I did. If I click OK, let's move this out of the way here so you can see it's all random right now. But if I click OK, notice that it now resorts it and it sorts it alphabetically. So that's definitely better. That helps things be a little bit more rational, but we can still improve that more. So let's go back to sorting and grouping and look at some of the other opportunities that we have. Below the sort by field, you have some checkboxes. And this one right here allows us to turn this field into a header. So let's see what that looks like. When I click OK, it will introduce an entry here above each line item in the schedule and kind of group them a little bit. Now, everything's still a little bit busy. So if I go back to sorting and grouping, we also have the opportunity to introduce a blank line here. And that will just sort of spread it out a little bit so that these groupings are a little bit more distinct from one another. And you can see that it's improving. We're getting a better look at the schedule. But of course, there's still more improvements that we could make. Now, one item that becomes immediately apparent is that this CH1 entry here, there's 10 redundant items sitting right below it. So we could probably do better. We could consolidate that and go to a single line item. So what I'm going to do is go back to sorting and grouping. And the way that we do that is we uncheck itemize every instance. So in that case, what it'll do is every line item in the schedule that's identical, it will collapse those down and watch the count column when I'm done here. When I click OK, it now gives me one line item for CH1 and says there's a quantity of 10 of those. Furthermore, if you actually click in that line item, look what happens back in the floor plan. So now that one line item entry represents 10 items, or 2 Corbu chairs, or this one dining table, or this double bed. Like each one has different quantity. Somewhere down here we had our nightstand. There it is. That's all 4 nightstands. So it's definitely improving. But now I still have a little bit of redundancy here. I have a header item, and then I have it listed again in the line item itself. So what can I do about that? Well, if I go back to sorting and grouping, one option is I could just remove the header. Now, when I do that, everything will get a little closer together, and this is fine. It reads pretty well, so that is certainly one option that you could do. The other option you could do is leave the header, and then click over here to the formatting tab, and you can take your type mark field and make it a hidden field. Now, when you make it a hidden field and you click OK, it'll remove that entire column there and only show the header. Now, it's important that you do it with the hidden field. Don't go to the Fields tab and remove the type mark. If you remove it, you'll no longer be able to sort on it. Okay, so it has to be included in the fields in order to sort, so that's why we make it hidden. Now, there's additional formatting that we can do. I'm going to go back to the sorting and grouping tab one more time, and you can actually introduce a grand total at the bottom of your schedule. So I'm going to check that box right there, and you can accept the name grand total, or you can actually type in something else if you want. I'm going to click OK, scroll down, and you'll see here that it says grand total, and there are 27 items. Now let's verify that quantity, right? So I'm going to come over here in the floor plan and drag a crossing window through all of the items in the floor plan and go to the filter dialog. Now, right here is the furniture category, and it only says 17. So hold on a minute. Why does this say 27 and this says 17? Well, if we kind of investigate this and move the filter out of the way, Revit's throwing us a little bit of a curveball here, because this table here and this table here are actually what we call nested families. So there's a table family that has chair families nested within it. So this item right here is actually 7 items. It's 1 table, 6 chairs. And this one is actually 5 items, 1 table, 4 chairs. So that accounts for some of the disparity in the count. Now, we're seeing 27 down here, but if we look at the furniture tags, this is much closer to the count. It says 26. Well, the last little curveball here is that at my TV, I have a TV stand and a TV, but I did not tag both items. I only tagged the TV. So the total is in fact correct, but it's always a good idea to verify. Now, there is additional formatting that we can do, but this time I'm going to do some of that formatting directly in the schedule itself. So if I click over here in the schedule, scroll up to the top of the list here, notice that the ribbon changes to a modify schedule and quantities, and there's several buttons available there. Now, we've got a count column here, and normally numerical columns are actually right justified instead of left justified. So I can actually click right here on the letter B and highlight that entire column. Now, if you look over in the floor plan, you'll notice that that actually selects all of the items in the schedule. Okay, so just be aware of that you currently have everything selected right now. Here on this appearance panel, I can do align horizontal, and I can change the alignment, and I'll choose right justified. Now, that actually did the entire column, including the header. If I click in just the header this time, I can go back to align center to make it match the other 2 headers. I can drag through multiple headers by just clicking and dragging in one motion, and then this font button will light up, and I could make those bold or italic or underline, or I could even change the font size or the font that I'm using. I'll just make them bold. So there's a couple different opportunities to do some formatting here. You could even click right in the header here and type in an entirely new name for this schedule. In the header, you can actually also do other things like change the shading, configure borders, and so on. So I encourage you to go ahead and play with some of those formatting options. Some of the formatting options will show directly in the schedule, like the bolding and the justification. Others won't show until you actually put the schedule on a sheet. Now, we're going to talk about sheets later in the course, so if you want to wait until that time to explore those, you can. So once you create your schedule, just keep in mind that it's going to be just a big, long, unformatted list to start with. So it's worth taking a few moments to go in and look for opportunities to sort it, to group it, and to change the formatting to make the overall presentation more legible and easier for people to use. Schedules often contain many simple text-based fields. Inputting values in such fields can be a tedious affair. Using key schedules can help. A key schedule is a schedule that allows us to create a name style complete with the values for several different text fields. You can use this key in your main schedule, and then choosing one of the predefined key styles from the list, Revit will input all of the other values designated by that key. Now, to demonstrate this feature, I'm working in a version of my condominium building which includes 3 stories and all of the condo units and rooms. So if I scroll through this list, you can see that there are several dozen room elements in this room finish schedule. Now, on the left-hand columns, we've got the names and numbers, and we've got some area column on the right, but in the middle of the schedule, everything is blank, and that's really where we need to focus our attention. So we want to look for a way to fill in the data in this schedule in as efficient a way as possible. Now, certainly, I could come in here and just begin typing. So for this bedroom here, I could say that the floor material is carpet and press tab, and the base material is wood and press tab, and maybe I want paint on the walls and I want drywall on the ceilings, and I'll press enter to accept that. You know, not so bad. Maybe this kitchen area has tile on the floor, and it also has wood base, and it's got paint as well. Well, notice what starts to happen when I start typing a value that I've already input in there. Revit will actually show me that value on a list, and I could actually just choose it right off the list instead of typing it over again. So that'll save a little bit of time. And then another option is if you actually just click there ahead of time, it'll build a little drop-down list from those values. So if I come over here to this hall and I start putting in hardwood, and then I go over here to another field, well, notice that now all 3 values that I've previously typed in this field are available here, and I could choose the one I want. So that speeds things up a little bit, but it's still going to take quite a while, even with that, to fill in all of these different values. So let's look for something that's a little bit more efficient. So a key schedule is a tool that's really going to help us here. I'm going to go to the View tab and click on the Schedule dropdown and choose Schedules and Quantities. From the new schedule dialog that appears, I'll set the category as rooms to match the schedule that I have in the background. Now, instead of scheduling building components, I'm going to schedule keys. I'm going to change the name of the schedule to Room Finish Style Schedule and change the key name to Room Finish Style. And I'll click OK. Now that key name will already be added to the schedule, but then here I'm going to see all the available text fields. Now I want to put the 4 finish fields in the schedule in the same order as they appear here in the background. So I'm going to choose floor finish and add it, base finish, wall finish, and then ceiling finish. I'll click OK, and that will create the new schedule. Now the schedule is currently empty. I haven't added any keys yet. I can add keys here on the Modify tab on the Rows panel by clicking this Insert Data Row button. And I'm actually going to do that 3 times. Now you can add as many keys as you want, but I'm just going to start with 3 here. I'm going to name the first key Bedrooms. I'm going to name the second key Living Areas, and I'm going to name the third key Public Spaces. So I've got those names, and now the next thing is to come over here and actually input the values. Notice that those same drop-down lists are available. So for my bedrooms, I can choose carpet, wood base, painted wall finish, and drywall ceilings. For my living areas, I can maybe choose hardwood, also wood base, also painted walls, and drywall finish. And perhaps for the public spaces, I'm going to use the tile and then a vinyl base. I'll just type it in, press tab, just to do something different. Let's put in wall covering and then acoustical tile ceiling. So it doesn't really matter what values you input, just as long as you kind of fill everything in. So now I have my completed key schedule. I'm ready to go back to my room finish schedule and start using it. So the way that I do that is I click over here and edit the fields button of this schedule. I'm going to select the field that is going to be before the one that I want to add. So I want to insert it right here after the room name. So I'm going to select the name field here, and notice that the room finish style appears over here in the available fields. When I add it, it will come in right beneath the room name. I'll click OK. So we now get a new column that has the word none next to it for all of the fields. But now what you can do is locate a room that you want to edit, click on this drop down, and notice the 3 keys that we input will be available on that list. So I'll choose bedrooms here, and it will fill in all of the other values for me. So I can do this for any bedroom that I see on the list, working my way through here, and it will input all the values. For some of these others, I could choose something from the list. Perhaps this south stair here could be our public spaces. Now you can see that that'll move fairly quickly, but again, let's remember that we have many entries to input. So we can do even better still. In the exercise file, I've actually created a copy of this room finish schedule. Now, creating a copy of a room finish schedule is just as easy as creating a copy of any view. You just right-click it and choose duplicate the view. So that's what I did here. Once I had that view, I went to edit fields and I removed the number field. The number field is what was making every room entry unique. Then over here on sorting and grouping, I turned off itemize every instance. When you do that, you now get 1 entry per room name. So now what happens is if I go to the fields in here and I select the name field and then insert my room finish style again right below it, click OK, you'll notice that I now get the room finish style again, just like we did in the other schedule. But now what I can actually do is open up the list here and choose one of my key styles, and it won't be applying to just a single coat closet. It's actually applying to several coat closets across the entire building. Now notice that some of these fields are blank. Be careful of the blank ones, because what that's actually telling us in Revit is that those fields are actually variable. Okay, that means some of them are using the room finish style and some are not. But I can easily open up the list here and just choose something that I want for those, and it will overwrite the values on all of them. So if I fill in a few of these, you can start to see that what will happen if I go back to the room finish style is not only is it filling in over here, but it's actually filling in across the entire schedule on all 3 floors of the building. So it'll still take a few moments to kind of go through here and rationalize and decide what we want each of these to be, but it will move much more quickly in this schedule, and all of the changes will be reflected over here. Now, as a final point, if you ever have a space that's unique that doesn't want to use a style, just leave it set to none, and then that's going to allow you to be able to come in here and type in whatever value you want. When it's assigned to a key, you can't type in the values. So set up your keys and apply them to all the common spaces, and then go back and fill in the unique spaces, and you will see that your schedule will be filled in no time. So a key schedule is a great way to manage large collections of repetitive data. You can use it for room finish schedules like we've done here, or door schedules, or hardware schedules, or just about any schedule that uses manually input text fields. In addition to all the information that we can include in schedules, such as name and count and size and all the other data, we can actually include images. Images can be either PNGs or TIFFs or JPEGs, and we can take those actual image files, whether they're a photograph or a sketch, and we can associate them with the objects. Then we can in turn add those images directly to our schedules, and they'll print out right alongside the schedule. I'm in a file that has a furniture schedule, and I've got a variety of furniture here, and perhaps I want to include some images with some of the items. Maybe this is something from the manufacturer's cut sheet, or maybe it's a photograph of the chair or something like that. So I'm going to focus just on the 2 chairs that I have, the Breuer chairs and the Corbu chairs for this example. If you select one of the items, what you'll notice is that over here on the properties palette, there is this image field right here. And if you click, there's a small little browse button, and you're able to actually go to this manage image dialog and actually add an image. Now I'm actually going to cancel that because I don't want to add them one at a time to each chair. So what I want to actually do is add them together to a group selection. Now the easiest way to do that is to come over here in the schedule and select that line item. So notice that when I select the Breuer chair, for example, it actually selects all 10 Breuer chairs. Now what I can do is click over here and actually click in the image field button, and I'm editing all 10 chairs at once. I'm going to click the add button here, and with the exercise files, I've included a couple PNG files. Now these are just sketches of the chairs, but you're welcome to go out to your web browser and search for any image that you'd like to use. So I'm going to open this up, and you can see it's a small illustration of that Breuer chair, and I'll click OK. Now the other way that we can do this is to actually add the image field to the schedule. So let's click over here in the schedule, and then I'm going to scroll down over here on properties and click the edit fields button. In the edit fields dialog, I'm going to select the image field. So I want to add that right above the comments here. So I'm actually going to select the count column, and it'll go below that but above comments, and let me click add, and there's the image field. If it comes in the wrong spot, you can just use move up or move down. Now when I click OK, you're going to see a new column appear here, and notice that the Breuer chair entry is already listed there for the Breuer chairs. So I'm going to click in the Corbu chair field. It'll highlight the 2 Corbu chairs over in the floor plan, but actually I've got the browse button right here. So without even switching to the floor plan, I can add the image directly from the schedule. I'll click add, I'll select the Corbu image file, click open, and it will bring in that illustration, and then I'll click OK. Now unfortunately, we only see the name of the image file in the schedule itself. So what we're going to need to do is actually add this schedule to a sheet before we actually see the image preview. So if I come over here, I've already provided a sheet on the project browser. So you can see here under the sheets branch, I've got A101 furniture. So I'm going to double click that to open it up, and then I'll maximize that view to fill the screen. Let's go ahead and zoom in here on the sheet. To add an item to the sheet is a simple drag and drop operation. So if I come over here and select my furniture schedule, I can drag it off the browser. Notice that I get a small little plus sign on my cursor. I'll let go, and then I'll click anywhere to place that schedule. I'll zoom in over here, and as you can see, those 2 images are now displaying here on the sheet. So if we printed out this sheet, it would print with the schedule complete with these 2 small image files. So if you ever want to include an image of the objects directly in your schedule, it's a simple matter of just adding the image field and then pointing that image field to a PNG or a TIFF or a JPEG, and it will print right alongside of the schedule when you print your sheets. Most architectural drawings need text at some point to annotate and explain things in the view. So in this movie, we're going to look at the text features available to us here in Revit. So I've got a simple elevation on screen. Doesn't really matter what view you're working in to add text, and I'll go to the annotate tab and click the text button. The text button is also on the quick access toolbar, or you can type TX, which is the keyboard shortcut. So you just simply click a point where you want the note to go and begin typing. When you're done typing, click next to the note in empty white space to complete it. If you're typing a note and you press enter, that will not complete the note. If you press escape, Revit will warn you and ask you, do you want to keep your changes to the note? Of course, if you said yes, then the note would remain, but if you say no, it will disappear. So the easiest thing to do if you're typing something is to just simply click next to it, and that will take care of the note. Now, you can use this small little control handle to move it, and this one to rotate it. If you drag it far enough, it'll actually flip around and stay right reading. So that's kind of an interesting feature using those control handles. I'm going to delete that note. Going back to this note here, I'm going to zoom in a little bit, and maybe I want to actually point that to something in the drawing. With the note selected, if you look at the leader panel, you've got a couple different choices for leaders, straight and curved, and they can be either on the left or the right. So I'm going to add a straight leader to the right side, grab this little grip control, point it to the parapet, and then adjust the elbow like so. And that elbow should align and stay nice and horizontal. Now let me go back to annotate and add another note. This time, I'm going to actually choose one of these options to add the note with a leader. So you can do a 1-segment, a 2-segment, or a curved leader. So I'll add it with a 2-segment leader, and the first point you click is now going to be the location of the arrowhead. So I'll point right to the soldier course, move out over here, and Revit will sense when it's near the elbow of the previous note, and I can click to line up, type in my note. When I click in empty space to complete the note, notice that the leaders will stay lined up and the note will jump off to the left. Now that's true despite the fact that I've got the alignment set to align left. So what aligned left means is within the note itself, it will align to the left. But notice here that actually had an impact now on the leader and it's no longer lined up. I'm going to undo that. Now, if you decided that you didn't want these notes to have their leaders lined up and instead you want the text to line up, you can simply select this stone parapet note, drag it over here until it snaps, and then take this grip and drag it until it snaps and line it up that way. So the choice is really up to you. Let's say that over here somewhere there was another item that needed the brick soldier course note. You can select the note and you can add additional leaders on either the left or the right. It's interesting that you can have multiple leaders on each side. Unfortunately, if you decide you want to remove this leader over here, they only can be removed in order they were created. So I have to remove that one, and then I could come back and add this one back again. So, a little bit of strategy here will be helpful. But now I can take this leader and point to this other brick soldier course, and that's a pretty nice feature. Now I'm going to add another note, and this time I'll do it without a leader, and I'm going to pick right on top of the existing brick here, type in what I want it to say, and click an empty white space to finish. Let's zoom in a little bit, maybe adjust it slightly, and notice that there's this white mask behind the note. So I'm going to come over here and click Edit Type to show you the setting that's controlling that. The background setting here can either be opaque or transparent. Now I think the opaque is more legible. That's what I'm going to leave it set to, and I'll click Apply there and OK. Now if I zoom back out a little bit and go back into Edit Type, these arrowheads are these open 30-degree arrows. That's also controlled here in the type properties. So if you want, you can choose a filled arrow, and there's a few different ones to choose from, and now all the arrowheads are this filled arrow instead. Up here it says that this is 2.5mm Arial. This is where that's being controlled, right here, the text size and of course the font. We'll talk about the tab size in a moment, but if you wanted to, you could actually make the entire text type bold or italic or underline. Well, what I'm going to do is actually reverse that, and I want to show you some features that we can do instead. Let me create a new note over here. I'm going to type a little bit more text this time. It's going to be a little bit of a longer note. So this note came in kind of long, and I've got to zoom out a little bit to find the grip on the other side. But the nice thing is I can just sort of drag this grip to change the width of the note, and everything will wrap accordingly in order to match that new width. Now let me zoom in on this note. If I double click into the note, I'm going to be in the text editor. Now I can select any part of the text, like this word right here, and I can make it italic, or this word and make it bold, or underline. This gives you a little bit more control in this editor than if you did it to the entire text type where it would apply to everything. I'm going to select this number 3 right here, and maybe that's a footnote. So you can actually add a subscript there. Now down here, I've got a list of items. So we can select all of those items and make it a bullet list or a numbered or alphabetic list. So let me set it back to number, and then you can see that it's doing 1 through 6 right now. Well, here's some sub items. If I click this increase indent, it will automatically make that a sub list and go to A and B and then renumber these accordingly. And I can do it again to make a sub list. And of course, at this point, I might want to change the wrapping so that that works a little bit better. The other thing I might want to do is adjust this amount of indent. To do that, I go back to edit type, and that's what the tab size controls. So right now it's 12.7mm. Maybe I change that to 6mm and click OK, and now this gets a little bit more compact. Whether or not you're doing simple construction notes with leaders that point to elements in the drawing window, or longer general notes that are paragraphs that have lists and indents, the text tools give you a lot of flexibility and a lot of control over the various documentation needs that you'll have within your projects. In this movie, we're going to look at dimensioning a floor plan. Now, we've looked at dimensions before, but largely we've focused on using dimensions as a tool to help us build our model, and they're very useful at doing that. But in this movie, I'd like to focus on using dimensions purely for annotation to help us document our design. I'm going to work in a floor plan, but all of these techniques would work equally well in elevations or sections. So let's just review the basics of laying out a dimension first. So what I'm going to do is zoom in over here on this side of the plan near these two offices, and I'm going to go up here to my quick access toolbar and click my aligned dimension tool. And remember, the shortcut for that is DI. Now, you may recall that to use the dimension tool, it's just a matter of clicking on 2 or more dimension references. So right now you can see it's highlighting the center of this wall, and then I'll come over here and it's highlighting the center of this wall. And then it's important to remember that you need to click in empty white space to complete the dimension. So I can click anywhere in the screen as long as there's no geometry underneath my cursor. Now, I see folks make this mistake a lot. They'll click on their first witness line, then they'll click on the second witness line, and then they'll come and they'll click again in exactly the same spot. And then they're a little puzzled by why the dimension is still active. It's like, okay, well, I want to dimension these 2 things, and I want to put it right there, and nothing happens. Well, you've got to remember that that last click has to be an empty white space, because otherwise what Revit's doing is it's adding and removing witness lines. So each time you click in the same spot, it's just adding a witness line, or if the witness line is already there, it's going to remove it. So we add our witness lines, at least 2, and then we click in empty white space to finish. So that's a very important step in the dimensioning process. Now, right now I'm dimensioning to the center lines of these dimensions, but if you want to, you can start at a center line. And then if I wanted to get the outside face of this wall, just simply move your mouse to the outside face of that wall and then press the tab key. It will tab through different edges that are available. And when it highlights the edge that you want, in this case, the outside edge, that's when you would click to create that witness line. And then again, remember to click in empty white space to finish, and it will place the dimension. Now, each of these dimensions I'm just using 2 points and creating single dimension strings. But it's important to understand that you can actually create a multiple dimension string using exactly the same procedure. So suppose I wanted to dimension these column grid lines. I can start with this one, click the first witness line, click the second witness line, and then just keep going to create a continuous string of dimensions. And again, the only thing to remember is that the final click needs to be out here in empty white space, and that will create the entire string of dimensions. So the process is pretty straightforward. You just simply click on the various witness lines you want and then place the dimension where you want it to go. Now, there are other options available to us when dimensioning. If you're going to dimension a lot of wall faces instead of a lot of wall centers, you can actually come over here and click this drop down and change what the preference is. So I can change the preference here to wall faces, and then when I zoom in, now it's highlighting faces instead of wall centers. Now you can always use your tab key to get back to the center if you need to, but it will just simply default to wall faces, and then I can place that dimension. Next to the drop down where we set wall faces or centers, there's a second drop down, and this one says individual references or entire walls. With individual references is convenient, and you get to select exactly which references you want, but sometimes this entire walls can be a lot more powerful. Now, when I choose that one, it's going to be a little bit different. Instead of picking the edges you wanted to mention, you actually just pick the wall you wanted to mention. So like, for example, if I select this wall out here and click, Revit will automatically figure out where the witness lines should be, in this case on either end of the wall, and then it's just up to me to place where I want the dimension to go. Now, that's not a terribly exciting dimension because it just did the length of the wall, but notice that right next to it, there's an options button. If I click that, I can start including things in that dimension string like the openings. And then you can tell it, do you want the centers of the openings or the widths? Now, I tend to prefer the widths, so I'm going to click OK, and maybe I'll do this wall down here. So I'm going to click it and move away from that wall and then click again, and boy, is that going to be a time saver. So instead of having to go and click each of these points to create those witness lines individually, with a single click, I get the entire string of dimensions. Pretty powerful stuff. Now, these two settings work together. So if this thing was still set to wall center lines and you click on another wall, notice that that witness line at the end is actually going to the center line of the wall instead of the face of the wall. So make sure you set both of these things to your preferences before you start to click. Let's zoom over to another area, maybe right over here, and look at some other settings in here. One of the options is intersecting walls. Now, if you choose that and you click this wall, in addition to giving you the openings, it's also going to find all of the walls that intersect this. Now, I personally think this is a little bit too busy, and I've got maybe a few too many witness lines. It's a little difficult to read all of this, but let's say for the sake of argument that this was the dimension you wanted. I'm going to click the modify tool to cancel out of here. To make this a little bit more legible, what you can actually do is click right on the dimension after it's created, and notice that there's a small little round dot beneath each piece of text. So you can actually click that and drag this text away from the dimension string, and it will add a leader that points back to it. So in all the places where it's a little bit illegible, you can just start to do that and kind of clean this up and make it easier to read. Now, another option is to go back to your dimensions. Again, click options. I'm going to turn off intersecting walls this time, but this time I'm going to turn on intersecting grids. So let's click OK here, and I'll pick this wall this time. Now that'll give me the wall, all the openings, and if I kind of pull it out over here, notice that it's also including each of the grid lines as a witness line. I tend to prefer that maybe a little bit better. Now I'm going to click modify here, and I'm going to select this equal dimension. Now remember, this is the one that we use to actually space the office walls. I don't really want that for construction documents, so I'm simply going to delete it. Now, if you still want the offices to maintain the constraint of equality, then click OK. If you no longer want the equality constraint, click unconstrained. Now remember, if you click OK and keep the constraint, you can always use the reveal constraint modes here to see that constraint at a later time. Now you can see that this dimension is actually covering up part of the grid line. You can actually select the dimension and just sort of drag it to make that whole thing a little bit more legible. So again, there's definitely some fine tuning that we can do. Now, let me look back over here at this dimension string that we created, and what about this wall over here? Well, unfortunately, when you use the entire walls option, you're only able to pick one wall at a time. But what you could do is actually select this dimension, and notice that any dimension you select, there'll be an edit witness lines button that will appear on the ribbon. You can click that button and then add and remove witness lines to your dimension string. So for example, if I came over here and clicked on an existing witness line that was already highlighted, it'll actually remove that witness line from the dimension. If I come over here and click on one that's not there, it will add that witness line to the dimension. And so I could add these points over here, including the outside face of the wall, and just remember to click an empty white space to finish, just like you would when you're creating the dimension in the first place. Now, we can adjust this dimension even after it's been created. For example, if for whatever reason you decided you wanted to break this dimension back into two strings again, instead of having it continuous all the way across, you can highlight one of the dimension segments, press your tab key, and it will reach right into that segment, select it, and press delete. And now this and this are two separate dimensions. Now actually I want to reverse that, so I'm going to do Control Z to undo. Another option is you can select the dimension and click directly on the text. Doing that will display the dimension text dialog. Now this dialog allows you to add modifiers in various fields around the dimension text, or even replace the value entirely with text. So suppose this length of this curtain wall was unknown and we wanted the contractor to verify it. We could click replace with text here, click in this field, and type VIF, and when I click OK, it would replace the number with those letters instead. Now what you can't do is put in a numerical value here. If you do, Revit will complain and tell you that numerical values are not allowed. So it's not going to let you fudge the value. You have to put in the real value. So I'm going to say use the correct value, but if I still want them to verify that, then what I can do is in one of these text fields here, I can add VIF, and I'll add it below and click OK, and it will display right there. Now, if you're working in a jurisdiction where you need to show dimensions in both imperial and metric units, what you can do is actually select the dimension string, go over here to edit type, scroll down, and you can see there's lots of options in the dimension type, and one of those options is alternate units. And if I click on that, I can choose from a variety of different alternate units, and I could choose decimal feet or feet and inches, and when I click OK, and then right above that, it says none, and I need to open up this dropdown and either input that unit to the right or below. So I'll choose below and click OK, and now you can see that I'm getting an imperial unit value beneath all of my metric unit values. So there's quite a few different features and settings that we can take advantage of in our dimensions, and if we zoom out here, nothing really makes a drawing start to feel more real than adding a few dimensions. So please feel free to go ahead and experiment with some of the tools that we've discussed here, and go ahead and start adding dimensions to this and some of the other views here in the project. As you continue the process of preparing a project for output, such as creating a construction document set, you're going to want to add more than just text and dimensions. Now, we've looked at dimensions and text in the previous movies, but there's all kinds of symbols that we might want to add to the various views in our project to begin annotating certain aspects of the design. So there are a few symbols already loaded here into this project, so let's start with those. If we go over here to the Annotate tab, we've got a symbol tool right here, and this just gives us access to a variety of generic annotation symbols that are available in the software. So I'm going to click on that, and if I open up the type selector over here, you're going to notice that we have a center line symbol and a north arrow. So let's start with the center line, and I'll just sort of place it up here in the upper portion of the plan, click the Modify tool, and zoom in on that general area to fine tune it. I can select that symbol, go to Rotate. I'll start with a vertical angle and snap it down here 90 degrees to rotate it 90 degrees, and then I'll just move it right over here next to this dimension line to indicate that that's the center line of the dimension. So pretty simple. Let me go ahead and type ZP to zoom previous, and then I'll zoom in over here on this location and add a north arrow. So I'll click the symbol tool again, go to the north arrow family, and there's actually two options here. So let me just pick the first one, north arrow 1. And when I move my cursor into the screen, you can see that it's got a small arrow. Now again, this is just a symbol, okay? It's just a graphical symbol. So I'm going to click anywhere on screen. Then I'm going to come back and select it after I cancel out of the command. Go to my rotate, start my angle vertically, and then just sort of rotate it in the direction of north. Now, this is just a symbol. It's not actually linked to the north direction. You would have to actually set up the north direction separately. Okay, now, those are the only two symbols that are actually loaded into the template to start with. Now, to access additional symbols, I'll just go to the Load Family button that's available here on the ribbon. That will take me out to my library, and I'll browse in my metric folder, and in there, I'll go into the annotations folder. And if you scroll through the list here, you'll see there are quite a few different symbols for you to choose from. So feel feel free to browse through those. What you can actually do is single click one of them, and then with the arrow keys on the keyboard, you can actually page through the various symbols that are available here on the list. Now, the one that I'm going to bring in is this graphic scale right here, and I'll open that up, and then I'll just simply place that on screen. Now, this particular one is established for a 1 to 100 scale, so you can kind of see that there, and it indicates those divisions. Now, on the subject of scale, all of the annotation objects that we've been adding are view-specific elements that respond to scale. So that includes dimensions, that includes text, and that includes symbols. So if I came down here and changed the scale from 1 to 100 to 1 to 50, what you're going to see is all of those annotation elements are going to adjust in size. So all the dimensions got smaller, the text, the symbols, and even the view indicators for sections and elevations. Now, you may still need to go in and zoom around and fine-tune some of these things, but if you decided that 1 to 50 was a more appropriate scale for this view, you can make that change knowing full well that all of the annotation will adjust accordingly. So feel free to continue adding additional symbols and browse out to the library and add others that you find there to finish up the presentation of this floor plan. If you'd like to add a legend to your project, perhaps one showing each kind of door or window that's used with an elevation view and some notes indicating its construction or function, there's no need to draw this completely manually. A legend view in Revit allows you to place a graphical representation of any family used in your project. You'll be able to control the scale and the level of detail, and you'll be able to insert it as either a plan or an elevation symbol. And the nice thing about the legend view is that these graphics are only representational, so they won't be included in any counts in your model, and they won't throw off any of your schedules or any output in reports. So to illustrate the legend view feature, I'm going to create a door types legend here in my project. Now, I can do that in one of two ways. I can scroll down here to the project browser and right-click the legends branch here on the project browser, or I can go over here to the view tab, click the legends drop-down, and choose legend right here. It doesn't matter which way you do it, it displays the same dialog either way. Now, I'm going to give it a name, door types, and then there's a scale drop down here, and it's suggesting a scale of 1 to 50, and I'm fine with that, so I'm simply going to click OK. Now, here on the project browser, if I expand legend, you'll see that there's my door types legend, and of course, here on the main screen, I have this big blank sheet now. You can draw anything you want on this legend view. This is basically a drafting view, and you can draw diagrams or symbols or anything like that. We're going to go over here to the Annotate tab and click the drop down here on the component button, and what we want to access is a legend component. Now, a legend component is a special two-dimensional symbol that represents one of the families within your project. Now, on the options bar is where we find all of the families listed, and as you can see, this is a very, very extensive list here. This lists out every family and type that you're currently using in this project. The first item I'm going to bring in is this single flush door, and notice that it comes in a floor plan representation by default. Well, right here, there's another drop down, and you can actually choose from two different elevations. So I'll choose a front elevation and place that one in. I'll go back to the drop down and choose the next door, and I'll just sort of place that one in and go to the next one, which is this double glass door, and then finally the curtain wall storefront door. Now, the curtain wall storefront door comes in a little odd because it's kind of small here. And the reason for that is because curtain wall doors conform to the shape of the curtain wall itself. So it doesn't actually have a built-in size. But fortunately, though, we have this host length feature right here, and we can input the size we want. So I'm going to try maybe 2100 millimeters, and that should get me within the ballpark. So let me go ahead and place that one in, and I'll click the modify tool to cancel out the command. Now, you can fine-tune the placement of these things and, sort of space them out a little bit. So I'll take this one and I'll sort of space it here, and they will even attempt to line up with one another. Or you can just go to your modify tab and use your align command. Now, once I've got the graphics placed in here, the next thing I can do is add any notes or dimensions that I want to include. So I'm going to go to my align dimension and dimension the size of this door. And you may not want to actually list the actual sizes. So what you could do, if you recall from the dimensions movie, is that we can actually replace the value with text. And so perhaps I want to write C plan for that indication. I could add some text beneath the legend symbol to label which door that is, and then I can repeat that for each of the other doors. And when you're finished, it might look something like this. Now, once you've got a legend, you can put it on a sheet just like any other view. Now, I've provided a sheet in this file called A601 Schedules and Legends. And when we open it up, you can see it already contains a door and window schedule. And you can see those door and window schedules right here if you'd like to take a look. And all I have to do is take my door types legend, drag it from project browser. A small plus sign will appear on my cursor. I'll let go. And then I just click somewhere on the sheet in order to place that view. And if we zoom in here, you can see that there it is right there, complete with the title bar. And that's all there is to adding a legend. In this and the next few movies, we're going to look at the detailing process in Revit. Details are an integral part of any architectural documentation package. However, one of the challenges in working in building information modeling and software like Revit is that there's always this temptation to overmodel everything. In other words, it's theoretically possible to add items like flashing, fasteners, bolts, and screws directly to your model. However, typically such items would only be shown in large-scale views, and in smaller views, they'd actually kind of get in the way. So we want to resist the temptation to model such elements. There's actually little payoff to model them, and you often pay a high price in diminished computer performance. For such items, we continue to rely on traditional detailed drawings. This has always been the case in architectural communication, and Revit offers a full complement of tools to facilitate the detailing process and does so in a way that maximizes the potential of both the live 3D model and the large-scale detail embellishments that we'll place on top. So to get us started, we're going to create a detail callout, and that's going to give us the underlying 3D view. And I like to call this the hybrid detailing process. It's hybrid because we're going to start with an underlay from the model, but then we're going to layer on top some 2D detail embellishments to further enhance and communicate the detail. So in this case, I'm going to illustrate the process by creating a stair landing detail. So I'm starting in my section at stair view, and the first thing that I need to do is create an enlarged callout. Now you may recall that we've looked at callouts in the previous movie, and if we go to the view tab, we've got our callout button right here. Now in this case, a simple rectangular callout is all I need, so I'll choose that option, and I will drag two opposite corners to indicate the rectangle that I want. It will create the callout symbol, complete with the callout bubble over here, and if you look on the project browser, it will create a new view called section at stair callout 1. Now I'm going to select that, and we can either right click and choose rename, or you can actually just press the F2 key on your keyboard to get to the rename dialog. And I'm going to rename this as stair landing detail. Now I can double click it here to open it up, or I can right click back on the callout in the drawing. So once I'm here, you can see it's created this cropped down version of that stair section, and it's set the scale to 1 to 50. Now let's start off by talking about this crop region a little bit. We've discussed crop regions in previous movies, but we focused then on just two of the settings of the crop region. We talked about the crop region and the crop region visible. And if you recall, come over here to the properties palette and scroll down to the extents area, and we have these two checkboxes right here, crop the view and crop region visible, and those correspond to these two icons here, crop and hide and show the crop region. So of course, if we hide the crop region, it disappears, and that box unchecks right there. If we show it, the box checks again and it comes back. And then of course, if we chose do not crop the view, it would uncheck it there, and we would be back to seeing the entire section. So of course, we don't want to do that, so we're going to go ahead and crop the view again. Now, the other thing to understand about this crop is this inner rectangle here is actually what's cropping the model. And if I take these little grips and fine tune what the crop is centered on, and you can see that we can make those adjustments here, it's actually changing the shape not only here in the callout view, it's actually changing the shape here in the stair section as well. Those two are one and the same. So you can edit that shape in either location. Now, notice that there's this additional rectangle out here that's a dashed line. That's actually called an annotation crop. And you can see that that is toggled on as well. What is the annotation crop exactly? Well, in order to talk about the annotation crop, let me deselect it and add a piece of annotation. So I'll just add a simple piece of text, and then I'll click away from it to add that text. And then I'm going to cancel out of the command, select the text, and using the little move cursor, I'm going to start to move it. And you'll notice that at some point it will disappear. So I'm going to move it way over here and it vanishes. So why is that? Well, if I go back to the crop region and select it, this dashed line here indicates where annotation can occur. And any annotation that falls outside of that dashed rectangle becomes invisible. If I take this little grip here and start to stretch it out, at some point I'll make that large enough that it will begin to show the text again. So one way that you can deal with the annotation crop is to simply enlarge it large enough to include all of your notes and 2D annotations. Another option, of course, is to just scroll down over here on the project browser and turn it off. Now, in my opinion, the annotation crop is useful for floor plans and elevations that have annotation on two sides of a match line, but for details, I don't really find it that useful. So I like to turn it off for my detail views. Now, looking at the text and comparing it to the detail and seeing the amount of detail that I'm trying to show, I'm thinking that the 1 to 50 scale is probably not adequate. So what I'm going to do here is come down and adjust the scale, and I'm going to choose a scale more like maybe 1 to 10. Now, obviously that adjusts everything and the text gets significantly smaller. So let's just take this note and I'll move it in a little bit closer, and I'll just place it here for now. We're going to use that later. Then I'll go ahead and zoom in on this entire detail. There's one more fine-tune adjustment I want to make to this view before we start adding detail components, and that is you'll notice here in the background that I'm actually seeing some of the curtain wall mullions. Now those are behind the stair. I want to focus my attention on the stair itself for this detail, so I don't want those distracting elements in the background. If we look over here on the properties palette for the view and you scroll down, what you'll notice is that beneath all these crop settings that we were just talking about, there's a far clip setting, and there's far clip offset and far clip settings. Notice that the far clip settings actually has two choices. It's got independent and same as parent view. Now it's currently set to same as parent view. So what I want to do is actually change that to independent. When it's set to same as parent view, it's just like the section that it came from, and it's seeing all the way beyond to that curtain wall. Well, now that I've made it independent, I can actually click in the far clip offset field and just put in a smaller number. Now I'm just going to take a guess here and maybe try 1500 and press enter. When I apply that, you'll see that that actually removes all the information from beyond. Now it actually looks like it's actually cutting through the stair now, so even part of the railing beyond has disappeared. But I think that's okay, so I'm going to leave it like that. Now keep in mind you can always adjust this later if you realize that you need to see that railing. So the first step of creating a hybrid detail is creating the view that you want to work on top of. In this case, we created a callout view from another section, enlarged the scale, adjusted its settings so that it was more optimal for the process of adding detail. And in the next several movies, we'll begin adding the detail components on top to flesh out the detail. In this movie, we'll take the next step in creating our hybrid detail and begin using some 2D detail components. 2D detail components are special families that are two-dimensional but represent model elements. So they're full-size elements that represent real things, and they're drawn to a great deal of detail. However, they only show in the view that they're created. So this is a great way for us to manage file size and performance by not modeling all the little parts and pieces that wouldn't give much benefit to an overall model, but instead we can create these two-dimensional versions of them that can help embellish these detail views that we're creating, and they only occur in that view that we're creating. So it's a much more efficient and manageable system. So I'm going to start off creating a few 2D detail components. I'm going to start with a couple that are already loaded here in this file, and then we'll look at loading some in from the library. Now, if we go to the Annotate tab, we've got our detail component drop down here, and we want to use the first button on the list there, the detail component button. Now, if I open up my type selector here, you can see that there are a few items loaded. There's a brick and a beam, and I'm going to start with this really simple item here called a break line. Now, the break line is really just a graphic embellishment that we can use as a finishing touch really to the detail. All we're going to do here is tap the space bar to rotate that 90 degrees, and then I'm going to kind of click a point maybe right about, let me zoom in a touch, maybe right about there. Now, what you'll notice if I cancel out of here is that that object actually has a built-in mask to it. The mask kind of behaves like a piece of whiteout, and you see how it actually covers up the detail underneath. So what I want to do is kind of make that start off in the location where I want it, and then using these grip controls here, I can actually stretch it to make it a little bit longer. And I'm going to stretch it the full height of the detail here. And when I deselect it, notice that it will cover up that detail there. Now, if I come down to the bottom of the screen and hide the crop region, all we see is this break line, and it's masking out the part of the detail that we don't want to see. Now, we could do it on the other side as well, but since the other side kind of ends naturally, we don't really need to do that. Now, if I went back to the original section at stair, it's important to notice that it does not include that break line. So these detail components are view-specific elements, and they're only going to show in the view that I place them in. Let's go ahead and add another one. This next one is a steel channel. So if I scroll down here on the properties palette, I've got a steel channel item right here, 250 by 45. I'll move over here into the view, and I want it in this general location, but for now, I'm just going to kind of place it randomly on screen, and we'll kind of fine-tune the position of it later. So what I want to do right now is just sort of get all my parts and pieces in place, and then I'll kind of move them around where they need to go. Now, at this point, I don't have any of the other components that I need, so I'm going to load in a couple. So I'm going to use my load family button right here, and that'll take me out to my library. I'm going to go to my metric folder. And in the metric folder, we have a detail items folder. Now, the folders in here are named by the CSI master spec division numbers. Now, if you're familiar with master spec, then this should be a pretty comfortable organization for you. If you're not familiar with it, then you can just sort of browse in and out of the folders and kind of get familiar with the organization. What's really helpful is there's a description in the folder name, so you can kind of ignore the division number if you're not familiar with those and just sort of focus on those division names. So I'm going to go into this metals folder, division 5, and then in there, I'm going to go into this metal fabrications folder. In there, there's a single folder called metal stairs, and then finally, there's 3 families in there. Now, what I usually like to do is select the first family and then use the arrows on my keyboard to page through the others and look at the previews over there on the right-hand side. Now, it's actually this first family that I want to use here, a steel pan stair in section. So I'll go ahead and open that up, and then when that comes in on my cursor, you can see that it's coming in from the nosing. Now, you can actually snap these items to other items in your model. So I'm going to snap it to the surface of this tread here in the live model, but I'm not going to try and snap it to the nosing because where I actually want to position it is from the back rather than the front. So I'll just go ahead and click to place that in. Then I'm going to click the modify tool to cancel it, and I'm going to select it, and let me zoom in a little bit closer. And using my move tool, I want to snap right to this endpoint back here And then I want to move over here and snap that right to that edge of the stair. So you can kind of see that it'll kind of bump out a little bit here and bump out a little bit there. And we'll adjust that a little bit more shortly. So I need one more component, and I'm going to go back to the 2D detail component tool, and I'll click on load family again. And the trouble is here that if I go into my metric library and under detail items, metals, and structural metal framing, we have the structural steel folder, but unfortunately in the metric files, all we have are section versions of the various families. And I actually need an angle here, but I don't need it in section. I want it in elevation. So what I'm going to do here is go back up to the Imperial library, and I'll go into there to detail items, metals, structural steel framing, and then here you'll notice that they actually have section side and top. So for this one, I'm just going to use the Imperial version of the angle shape inside, and I'll click open. Now this will display a type catalog, and when we loaded some doors in an earlier movie, we saw a type catalog, and you may recall that a type catalog is just a way of allowing you to load in just some of the types in the family instead of all of them. Because if you look at this list here, you can see it's quite extensive, and if we loaded all of these types, it would just become way too unwieldy. Now you could select a single item, you could hold the control key down and select multiple items, or you could hold the shift key and select a group of items. In this case, we really only need one, and it's down here towards the bottom. So I'm going to scroll down, and the one that I'm looking for is actually right here at the bottom of the list. It's L2x2 by 1/8. So I'm going to open that up and click OK. Now, this will actually prompt me to click to enter a start point. So this is a different kind of detail component than we've seen before. This is actually what we call a line-based detail component. So I'm going to click my first point down here and then start moving my mouse, and you can see that it's drawing this linear object. So I just want to make sure I'm drawing it nice and horizontal, and then I'll drag out the length that I want. Now, I think about 150 millimeters is all I need here. So I'll just type 150 and press enter, and then I'll click my modify tool to cancel. So if I zoom in slightly, you can see that this is just an angle object, but kind of looking at it in elevation instead of in section. Now I'll just sort of move that over here and get ready to position it. So now I have all my components and pieces ready to go, and in the next movie, we'll begin assembling all of these parts and pieces into our final detail. In this movie, we're going to use the array feature, which is a powerful copy command. What makes array special is that it's actually a parametric array. Now, what we typically mean by parametric is anything where the original parameters used to create the object remain available for us to manipulate at a later time. And so if we have a parametric array, then what we're saying is all of the original parameters used to establish the array, the multiple copy basically, those parameters remain available, and we'll be able to adjust them afterwards as the design needs dictate. So where we're going to actually use the array is to duplicate this detail item that represents a single stair tread and make multiple copies moving down the stair. So I'll select the detail component to get started, and then on the modify tab of the ribbon, I'll click the array button. The shortcut for that is AR. Now you may notice that this dash box appears around the object that I've selected for the array, and that kind of looks similar to what we saw when we were working with groups in a previous chapter. Well, in fact, it is a group because if you look here on the options bar, the group and associate feature is turned on, and that's actually what makes the array parametric. Now, before that, you see two little icons, linear and radial. So it's actually possible to array along curve or straight line, but in this case, we want to do a straight line, so I'm going to leave it set to linear. We do want the group and associate, and as you can see, we're going to need 3 treads. So I'm going to type in 3 right here. Now over here, you can either do second or last. I want to make sure that I choose second. Second means that you know the distance between the first and the second item. Last means that you know the total length of the entire array, and you want to fit all the items in between. So in this case, because we know the sizes of each tread and riser, second is more appropriate. Now we don't want constrain because that would force us to move along only horizontal and vertical. And in this case, we want to move along the diagonal. Now, the thing about the array is the next point I click on screen will become the start point of the array. So I want to make sure that focus is actually in the drawing window. So an easy way to do that is actually use the wheel on your mouse and just kind of click and drag slightly, and that will ensure that the focus is there without accidentally clicking the start point. Now I want to zoom in slightly, and I'm going to use 2 points on the stair. And I can actually use any 2 points that I want. So it'll be a little bit easier to select the point between here and here than it would be back here. So I'm going to use this as the start point of my array, and then this point right here as the end point of my array. And when I click that and zoom back out, you'll see that it creates 3 copies of that stair tread. And down here, we get this small temporary dimension that currently displays the number 3 as an active dimension. Now, if I change that to 2 and press enter, now I only have 2 treads. If I went to 6 and press enter, you can see that I'll get 6 of them, but they go off screen. So let me change this and change it back to 3. So 3 should do the trick for us right here. Now I'm going to click anywhere on screen to deselect that and then zoom in, and you can see that that completes my array. Now, what we mean by parametric is more than just changing the quantity. Of course, at any time, you can select one of these grouped elements and then look for that dimension and change the quantity. So that's one aspect of being a grouped and associated parametric array. The other aspect is that if we move these around, notice that they're all moving together by the same amount. So that's the other aspect of being a parametrically grouped array. So I'm going to undo that to snap them back again. Now, what I want to do is make a modification to that group element. You may notice here that the shape of this tread doesn't quite match. Like if we zoom in here, this thing here should really fit into that notch, and they slightly overlap, and it's slightly too tall. Well, here's one of the benefits of working on a hybrid detail. If you come over here, you can actually click the live stair in the background. When I have that stair selected, I can come over here to the properties palette and take note of the actual sizes of the riser height and the tread depth. So what you're going to want to do is take note of those sizes and perhaps write them down. So you can see that my riser height is currently 166.7 millimeters and my tread depth is 275 millimeters. Now we're going to need those values in a moment. So what I'm going to do next is select any one of the grouped elements, and it doesn't matter which one I pick because they're all tied together. Up here on the ribbon, I'll choose Edit Group. That will dim out the rest of the drawing window and put me in the group edit mode. Now I'm going to select the individual instance of that steel pan detail item and come over here to the properties palette and choose Edit Type. Now, do you remember the values that you wrote down? This is where we're going to input those values. So right here for the rise, I'm going to put in 166.7. And for the tread, for the run, I'm going to put in 275. Now, when I click OK, that will adjust the size of this item. And if I zoom in, you can see that it adjusted to the left. So I'm going to go to my move command here and just move it and snap it right back to there. And then when I click finish here, it will adjust all of the grouped items and make them all match. So you can see now that they kind of fit nicely together, almost like a little puzzle piece right there. That's all we need to do to make the adjustment, and that's the benefit of using the group and associate feature. Now let's look at one more example of that. I actually need this little angle to support each of these treads on both ends. So I'm going to select the first grouped item this time, go to Edit Group, and click over here on this Add to Group button. And I'm going to click on that angle element. Now, when I do that, it adds it into the group, and then I will click the Finish button button here to complete that modification. Now, of course, when I do that, the angle will appear in all 3 instances of the group, but it's not really in the correct place. So let's go ahead and modify it one more time. Edit group. I'll select this angle, go to my move command, snap to a good useful point, and then snap again to another useful point. That puts it in a more appropriate location, and I'll finish it one more time. And notice that all 3 instances of the group will update to match. Now, if you look over here, you'll notice that our grouped elements are actually sitting on top of our break line. Detail components have stacking order, which means that they can cover each other up. So all I need to do here is, since I created my break line first and my treads last, the treads are sitting on top. But if I select my break line, I can use the arrange buttons here and tell it to come to front, and then it will now cover up the component underneath. So as you can see, the array feature is an extremely powerful way to make multiple copies, because all of the parameters that you build into the array remain live and editable as long as you have that group and associate feature turned on. And you can go back anytime and make adjustments to any part of the array and have the changes propagate across all the instances. It makes it very easy for you to make design changes as you're moving forward. In this movie, we'll look at filled and masking regions. Filled and masking regions are two-dimensional shapes that you apply to your drafting views to help you either cover up underlying geometry or further articulate certain parts of the drawing. Like any other detail component, they are view-specific and two-dimensional, and we can draw them in any view that we like. Now, if you've been following along in the detailing process throughout the other movies in this chapter, then you've already actually seen some examples of filled and masking regions. This break line component that we have over here actually incorporates a masking region. So the reason it's able to cover up the underlying geometry is because there's a mask in there. And I like to think of masks as basically just like a piece of whiteout. There's a filled region incorporated into this stair tread detail that we have here, and it's using that stipple pattern there to represent a concrete filled pan. So that's an example of a filled region, as is this shape right here that's making up the steel shape. The crosshatch that you see in there is also a filled region. Now, certainly we can use filled and masking regions inside of 2D detail component families, but that's not the only place they can be used. We can actually draw them directly on top of our detail. So let's do that now. If I look at the stair here, it's giving us some geometry we need, but there's still some artifacts that we haven't covered up yet that don't quite accurately display the stair the way we want. Particularly these vertical riser lines right here and some of the other line work we might not want to have shown in this detail. Now the trouble is we can't just hide the stair. If I go to temporary hide and hide it, you can see that it actually hides way too much. So what we're going to do instead is just use a masking region to cover up the parts of the stair that we don't want to see. So over here on the annotate tab, on the region dropdown, I'll click the masking region tool, and you have all of the standard draw shapes, of course, and then there's a dropdown here for the different line styles. Now I'm going to trace the stringer here. So I'm going to start with a medium line. That seems like it would do a decent line weight to kind of convey that without it becoming too overpowering. So I'll do medium lines here, and then we could draw the edges manually, but I'm going to try the pick lines because I actually want to follow the stringer directly here and here. Now you'll notice that they do have the little lock icon, so it actually is possible to sketch your drawing to the underlying geometry, and in some cases that can be valuable if you anticipate the design changing, the detail can try and keep up. In my experience, that can sometimes cause errors to occur when constraints aren't satisfied, and it can be confusing to know exactly where those are. So I don't think it's that hard to come back to the detail later and make adjustments, but it really is a matter of preference. So in this case, I'm not going to lock them, but you can feel free to do that if you wish. Now I'm going to also trace this line here, and then continuing with medium lines, I'm going to draw a vertical line outside over here, and I'm not really concerned what the length is because I'm going to clean it up in a moment, but I just want it outside of the crop region, so a little bit larger than the crop region. Now for the final line that I'm going to draw, I'm going to actually use a special line style right here called invisible lines. Now invisible lines is exactly what it sounds like. It won't render that edge at all, so the mask will just sort of end without any visible edge to it. So I'm just going to start right at this endpoint and just pull it straight up vertically like so, and then I'll escape out of there. Now I'm going to come over here to the trim and extend command and just sort of clean up. So I'm going to trim those two together, these two together, and these two together. And when I finish, this is the shape of my mask. Now, all the sides around here are going to be rendered in medium lines, but this one is going to be invisible. So let me click finish here. So with the region still selected, it's semi-transparent, but as soon as I deselect it, you'll see that it's actually covering up everything underneath. Now, of course, it's covering up a little bit too much right now. We'll address that in just a second, but let me point out, if I zoom in slightly, that the edges here do use that medium line style that we asked for. And then, of course, this edge right here is an invisible edge, and so the mask just sort of ends there. Let me zoom back out slightly. So to address the fact that the mask is covering up everything, let's talk about the fact that 2D elements actually have stacking order. Pretty easy to fix this problem. If you look up at the modify tab, you'll notice that there's an arrange panel, and we can bring to back, send to front, those kind of things. So any of the 2D elements can be shuffled around with respect to the other 2D elements. So all I have to do here is click the send to back button, and when I deselect, that mask now drops behind all of the other 2D elements. Notice that the 3D geometry always remains in the back. So sometimes folks misunderstand this, and it's really important that we emphasize that the 3D geometry is always behind the 2D geometry, and so the stacking order just applies to other 2D elements. Now I've covered up a few items over here that perhaps might not be desirable, so let's deal with that next. Turns out that I'm going to add a filled region across here anyway, so that'll solve the problem. So a filled region is very similar to a masking region. I'm going to choose the filled region command, puts me in sketch mode, and we're going to address this one in virtually the same way that we did the filled region. We're going to use our pick lines. Let's choose a line style, and I'm going to start with medium lines, and I'll do the top edge here. I'll do this edge over here, and the top of this piece of steel. Now you're probably noticing that I favor using pick lines and then using the trim command to clean it up. You certainly could draw these edges manually if you prefer. Now I'm going to zoom in over here, and I need to get all these little edges on the inside of that stair nosing, but I want to change line styles for that. I don't want the medium lines to overpower the other detail component on top here, so I'll do a thin lines, and I want this little short line right there, this one here, here, and here. And it looks like I got the wrong line style, so let me just fix that. I'm going to select these. The green color was a giveaway here. I meant to choose thin lines. There we go. That's a little bit better. Okay, so let's go to our trim and extend here, and I'm going to select this small little vertical line here, and then extend it to this one, and the line is too short error. This is one of my favorite non-solvable Revit errors. Okay, so unfortunately I'm going to have to click cancel here and try something else. I'm not really sure why Revit thinks it's too short when I trim it, and it doesn't think it's too short when it's standing all by itself. But anyway, let's just take this little grip here and do it that way instead. So sometimes there's more than one way to solve the problem. I will use trim here and here, and then I will do my previous zoom and do trim here to here and here to here. So of course, like most sketch objects, you have to have an enclosed shape in order to finish. Let's click finish, and the default hatch pattern is just this vertical hatch pattern, which obviously is not what we want here. I mean, maybe it is, but I think we want something a little bit more suitable. So if I come over here to the type selector here and see what other fill patterns we have available. Now what I really want is a stipple pattern that matches those stair nosings, and I'm not seeing one here on the list. So what I'm going to do is choose edit type right here and then duplicate. And so what I'm actually duplicating is the filled region type, and I'll just call this concrete fill. And click OK. And then you can see that the properties are very simple. You've got a fill pattern and a color and so forth. And I'll just click right here, and there's a small browse button, and I'm going to choose this sand fill pattern. I'll click OK. I'm going to leave the color white, the pen weight 1, and the background opaque. I'll click OK again, and now I have that sand pattern applied, and it looks more like concrete. So at this point, the graphical portions of the detail are largely finished. All that really remains is adding maybe some notes and dimensions, and we've talked about that in previous movies. So when you're done, your final detail might look something like this. This chapter is devoted to the family editor. Now, the family editor is a very large topic that could easily take up an entire course. In fact, we have a course here in the lynda.com library called Revit Architecture, the family editor. So in this chapter, we're just going to cover the high-level basics, and we're going to build a really simple parametric family. But if you want to learn more about the family editor, I do highly encourage you to check out that other course after you're finished here. So let's start with just a quick look at the basics of the family editor, just so you kind of have yourself in the right mindset. When we talk about the family editor, what I'm specifically talking about here is we're going to create a model family. So it's going to be a model element that we're going to create, and we're going to make it a parametric family. So that means that some of the next steps that I'm going to outline to you may not apply if you're creating either a non-model family or if you're creating a family that doesn't need to be flexible. Assuming that we're going to make a flexible model family, here's the basic steps. The first and most important is to choose a template. A template establishes sort of the underlying rules and parameters for the family, things like its category and its overall behaviors. Next, we introduce reference planes. Now, in the project environment, we've been using levels and grids to kind of give form and structure to our project. In the family editor, you use reference planes for this purpose, and they achieve essentially the same thing. They help define the overall dimensions and form and scale of the family. Next, we add dimensions to those reference planes, and the purpose of those dimensions is that we use them to add parameters and constraints. Now, I like to group parameters and constraints together into what I call adding the smarts to the family. So when you're making a flexible family, when you're making a parametric family and you want it to be able to adjust, we want the length to be adjustable or the width or so on. Those are called parameters. If we want to lock in a relationship so that people can't change it, that's a constraint. So we're going to look at both of those. And then after we've done all of that framework, it's time to build the geometry. So there's actually quite a bit that happens before we create any geometry in the family. And then the absolute most important part of working in the family editor is to flex, and flex often. Now, flex is just Revit's term for test it out and make sure it's not going to break. So if you flex on a regular basis, if you test out your family on a regular basis, you can troubleshoot many of the errors before they become a problem and create a highly functional family. So in this movie, we're going to start building our custom piece of family content, and it all starts with choosing a good template. Now, there's a couple ways that you can access the family templates. Since I'm looking at the recent files screen, I actually have a link right here where I could create a new family. But if you're already in a project, or if you're not looking at the recent file screen, you can also go to the application menu, highlight new, and then slide over here to family. Either one will get you to the same place. It will display the new family select template dialog. I'm going to back up one step and jump into this folder where my metric templates are located. And let's talk a little bit about the templates that are provided here. You'll notice that the name of the template indicates the kind of object. So the first and most important thing that the template is doing is actually establishing what kind of family you're creating, what category, in other words, it's assigned to. So this very first option here is a baluster, and we have casework, we have columns. And what I usually like to do is just sort of start at the top and then use the arrow key on my keyboard, and you can just start paging through these and watch the preview over there. And you'll see that each one of these templates actually starts with some different stuff in it. If you get serious about working in the family editor, you're going to want to actually open up different templates and kind of explore around, and you'll be surprised what you can learn just by what default geometry and settings are included in these different templates. Now, in our case, we're going to create a piece of furniture. Specifically, we're going to create a pool table. So I'm going to select the furniture template for that purpose. Now, before I open this up and dismiss the dialog, I do want to point out one other really important thing that the template is assigning for you. If I look right above furniture here to these electrical equipment templates, notice that there's a few different versions of the electrical fixture. We have electrical fixture here, which is just a freestanding electrical fixture, and we also have electrical fixture wall-based and ceiling-based. Now, from our explorations to this point, we've seen the difference between freestanding families and hosted families. So doors and windows required a wall host, and light fixtures required a ceiling host, and then many of our other components we could just place freestanding in space. Furniture is typically a freestanding element, so you're able to just place it anywhere you like. But sometimes you're going to be creating families that are hosted. So just keep that in mind, because that limitation is one of the few things in Revit that you can't change your mind on later. So if you choose a hosted template, anything that says based at the end of the name, that decision is not reversible later. Pretty much every other decision you make in the family editor you can probably change, but that one is pretty important. So in this case, we avoid it because we're doing furniture and there's only one template. It's not hosted, but I did want to just point that out to you. So let me go ahead and click open here, and that will load up that template. So we're looking at a blank screen. Now there's actually 4 windows that opened with this template. So the very next thing I'm going to do is type WT for window tile, and then everything's kind of off screen there. So I'll do ZA, which is the shortcut for zoom all, and you see it will zoom all 4 windows to fit. Now the only window that doesn't seem like it reacted was the 3D view, and we're just going to have to wait until we get some geometry before that window will start showing us any information. But this is usually a nice basic setup to have here when you're working in the family editor, is to go ahead and tile the windows. As you can see in the top left corner, I have a floor plan. It's called reference level. Down at the bottom, I have a front and a left elevation, and then over in the right hand corner, I have the 3D view. And this is going to make it really helpful while we're working, because you'll be able to see your progress in each of the views as you work. Now, the last thing that I want to do in this movie is just save the file. So I'm going to go up to the application menu here, and I'll choose save. And because we haven't actually given this file a name yet, it's actually going to perform a save as. So I'm just going to put this in my chapter 13 folder. Now, something I like to do when I'm working on family content is I actually like to add a little version number at the end of the name. So in this case, I'm going to call it pool table _ V1. Now, the reason I like to do that is you might go a certain level and then realize you want to try something else. And by having different versions along the way, you can experiment, and then you can always go back to a previous version if you decide you don't like the experiment you did. So certainly optional to do that, but I'm going to recommend that we do that here. So I'm going to do pool table V1, and then over here, there's an options button. And if you click that, there's a few options that you might want to configure. First of all, there's the number of backups. Now, by default, it's choosing 3, and that's perfectly fine if you want 3 backups. But I think for family content, we don't really need 3 backups. 1 is suitable. So I'm just going to choose 1 there. Then down here, if you want, you can actually choose one of your views to generate the thumbnail preview from. And it's usually nice if that's the 3D view. And then anytime somebody selects this item in a browse window, it'll show a 3D version of our little pool table. Then I can click OK here. So I'll click OK, and I'll click save. Our file is now created and ready to go. So in the next several movies, we'll start going through the various steps to build our pool table family. In this movie, we'll begin adding the underlying framework to our pool table family. And we're going to use reference planes, constraints, and parameters to achieve this. Now, reference planes provide the form and the structure for your family. And the default template that we started with came with 2 reference planes. So we have this one right here, which is called center front back, and it's pinned. And this one right here, which is called center left right, and it's also pinned. The reason that those are pinned is because they mark where the insertion point of this family is. And so it's a pretty good idea to keep those pinned to the center. What I want to do is go to create and create some new reference planes. I'm going to make 4 total. I'm going to go to the reference plane button here on the create panel, and make sure you're choosing reference plane, not reference line. They're not all the same thing. And I'll click above and to the right of the horizontal reference plane and draw horizontally straight across. A temporary dimension will appear, and I'll just set that to 600 as a starting value. And then I'm going to click above the one that I just drew and pull straight down, running parallel to the vertical one at the center. And for this one, I'll put in 1200 as a starting value, and then I'll click the modify tool to cancel. Now I'm going to zoom in slightly, stretch the length of this one just a little bit so that they overlap one another, and then I'll take each of these and mirror them around the center. So I'm doing mirror pick axis and picking the center axis. And then let me just kind of pan slightly to clean up the screen. You saw that these in the middle had names. You can select reference planes that you create, click right on this little click to name control here, and give it a name. So I'm going to call this one right edge. I'll call this one left edge, back edge, and front edge. It's a good idea to get in the habit of naming your reference planes. It just kind of keeps everything straight while you're working. The next thing I need is to apply some rules to these reference planes, because right now I can pick this reference plane up and I can move it anywhere I want. So let me undo that. So I don't want to be able to do that. I want it to move a little bit more logically. We do this with dimensions. So I'm going to go over here to my dimension command, my align dimension, or you can type DI. And I want 4 dimensions total. One that goes from the left to the center to the right. Another one that goes from left to right as an overall, skips the center. And then the same 2 in the opposite direction, here and here. Now I'll cancel out of the command and I'll zoom in to try and get a better look, but the numbers are really small. So what you can actually do is just change the scale of the view here to something larger. So I'm going to go to 1 to 50 to make these numbers a little bit easier to read. The 1200 dimension, I actually want that to always be the same on both sides. So I'm going to toggle on the equality. And I'm going to do the same thing for this one. So now what happens is if I were to move one of these reference planes, it'll move the other one the equal and opposite amount. Let me undo that. The way I want these dimensions to behave is I want those to be driven by parameters. To apply a parameter to a dimension, you use the label option up on the ribbon. So notice here it says label dimension. There are no labels currently available, so I need to create one. So I'm going to click this button right here to create a parameter. And I'll call this length. Now you can make it a type or an instance. You may recall that type parameters, if you change one, they change everywhere throughout the model. Instance parameters, each object has its own individual value. Well, since we're building a pool table, they come in standard sizes. I think a type parameter makes the most amount of sense. Now I'm going to click here where it says edit tooltip. This is optional, but I think it's a nice feature. I'm going to delete all of that text and I'm going to type in overall length of the pool table. Now I'm going to select all of that, Control C to copy it to my clipboard, click OK, OK again. Let's select the 1200 dimension now, add a parameter for it, call it width, leave it a type parameter, and edit its tooltip. Now I'll select all the text and do Control V, and I'll just change the word length to width and click OK. So I'll show you where those tooltips appear in just a moment. But let's click OK out of here, and you can now see that if you deselect everything, both dimensions have a label in front of them telling you what the value is. Now what we want to do, it's very important that we test all this out and make sure it's working. And the way that you do that is on the ribbon, on the properties panel, you're looking for the family types dialog. Now, if I click family types, that takes me to a dialog that shows me the 2 parameters that I just created and any types that might be in this family. Let's start by flexing each of these values. Now, flex just simply means we're going to try a different value and test it out and make sure it's working correctly. So here for the length, I'm going to try 2000 and click apply. And you'll see that the length adjusts. So we're happy with that. Let's put it back to 2400 and let's try 1000 for the width. Click apply, and that's working. So let's put that back to 1200. If everything flexed the way that you expected it to, congratulations, you've just created your first parametric family. Pool tables come in standard sizes, so you might consult a cut sheet to get this correct. And what I want to do is I don't want to have to change these values every time. So if you look up at the top of this window, it says type name, and it's currently grayed out. Now, every family has a category, family, and a type. The category here is furniture, because that's the template we started with. The name of the family in this case is ref planes, but it's whatever name you give this file. And the type we don't have yet. So there's a small icon right here that I can click to create a new type. And for now, I'm just going to call this large and click OK. This is going to be my larger size pool table. Now I'm looking at a cut sheet and it's in imperial units. So there's a really neat trick that you can do here. You could do the math and try and figure out how much 88 inches is in millimeters, or you can just simply do this. Type 88 inches. The inch symbol is right next to your enter key. You hold the shift key down to get it. When I click somewhere else, notice that Revit will do the math for me automatically. And the width of this pool table is 44 inches. You need to put the inch symbol. If you just do 44, it'll think you mean 44 millimeters. But if you put 44 inches, then it will do the math. When I click apply, it will reduce the size of that slightly, and it's going to use the metric equivalents of those imperial sizes. Let's create another type here, call it small. Change the length. The small size is 78 inches and 39 inches. I'm putting the numbers in the reverse order that they're listed on my cut sheet. So you might accidentally put the wrong number in the wrong place. So one of the things you can do is with this parameter selected, you can come down here and rearrange it on the list. So if I want to put the width first to match the cut sheet, I can just rearrange it that way. The other thing that I said that we would look at is if you hover over any of these parameters, notice that the name of the parameter is there, and right below it, you get that tooltip that you typed in. So if anybody's unclear on what they're supposed to put in this value, if you give them the tooltip, it makes it a little bit easier to understand what we're supposed to do here. Now, the real benefit of having 2 types is this. If you want to flex, it's as simple as opening up the type list, choosing the other size, and clicking apply, and it will adjust the family for you. So when I just choose the 2 different sizes, you can see it adjusting back on screen. So let me click OK here. And as you can see, creating reference planes gives us the overall structure of our family, but it's really the dimensions and the parameters that drive those reference planes. So we can create dimensions that are constrained, such as our equal, or we can create them that are driven by parameters, and then that gives us the flexibility to put in real life sizes and flex our family to any size we need. So now that we have our reference planes and our constraints and parameters and everything is flexing properly, it's time to start adding some geometry. So we're going to add a couple objects here to start creating the surface of our pool table. So I'm working in a file that is called adding solids, and I've added a couple reference planes in the front elevation. And what I've done is I've placed each of them with a dimension, and I've locked that dimension. So here you can see those 2 dimensions are locked. And the reason I did that is because the heights of the pool table are fixed, and there's really no reason to make those parameters. So anytime you have a dimension that is not going to flex, you can simply add a dimension and lock it. Okay, so let's start in the floor plan view. Just click anywhere in the floor plan view to activate it. Click the Create tab, and then I'll click Extrusion. So the extrusion I want to create is just a simple rectangular shape. What you do is you sketch out the shape here in sketch mode, and then when you finish, it'll give it a thickness. It's a really simple form. So I'm going to snap to the reference planes here, and then diagonally across to the reference planes here, and I'm going to close each of these 4 padlocks. Then I will click Finish to complete the shape. So you're going to see this box appear in the plan in the 2 elevations. To see it here in 3D, we just click over in the 3D view, find the little corner of the view cube up near the top, and click it, and it will zoom right in on that box. Then I can hold the Shift key down and drag the wheel if I want to spin it around, like so. You'll notice that the box is sitting right on the floor. Let's go ahead and select the box again in the plan view and take a look at the properties on the properties palette. There's a work plane property, and it's currently set to reference level. That's why it's sitting down here on the floor. Well, on the ribbon, you have an edit work plane button, and if you click that, you can change the work plane to any reference plane that's parallel to the existing work plane. So I can choose from these named work planes. That's the reason that I gave these work planes names, and choose underside. And when I do, that box will jump up to the underside reference plane location. To change the thickness, all I have to do is click in the elevation view, grab this little triangular extrusion shape handle at the top, stretch it down until it snaps to that reference plane, and then I'll lock it just to make sure that it stays there. Now we've got the plane surface up at the correct height. I'm going to click back into the floor plan, and I want to add another solid object for the rail that goes all the way around the pool table. This object might get in my way. So it's a really good idea to select the object, go to the sunglasses, and hide that element. Now, of course, this is temporary hide, so the object is still there in the other views, but I'm just hiding it in the plan view so that I can get to the reference planes. The best practice recommendation is whenever you build solid geometry, you should always try and reference the geometry to reference planes, not other geometry. Now, there are exceptions to that rule, of course, but for now, I'd like you to just kind of adopt that rule and try really hard to build all of your geometry relative to reference planes. So let's go back to create. And the other thing that I want to do here is I want to build that rail at the correct height this time. I don't want to build it on the floor and move it. So here in the elevation view, this reference plane is called playing surface. That's where I want to build this thing. So I'm going to click back in the floor plan, and on the create tab, I'll click the set work plane button. And this allows me to choose from a list of all my named reference planes, and I'm going to choose the playing surface reference plane and click OK. And now that's the active work plane, so that when we start creating our next piece of solid geometry, it'll go right to that correct location. The object I'm going to create this time is called a sweep. So a solid sweep, you sketch a path, and then you take a sketch shape and you move it along that path. Let's start with the path. So here's the sketch path button, and we'll start with a rectangle. But before you start to click, over here we have an offset. And I want to offset this profile by 75 millimeters. So I'm going to type in 75 right there. Now, when I click the insertion point of these two reference planes and start to draw, you'll see the shape is actually offset 75 millimeters away. Now, if yours is going to the inside, like this, you can just tap your space bar to flip it to the outside. So just make sure it's going to the outside and then click the opposite corner. I'll click the modify tool to finish that. I'll zoom in on one of the corners, and I'm going to choose the line option here and draw a little chamfered corner right there. Cancel out of there, go to the trim command, trim this to this, and this to this. And now I want to repeat that at all four corners. And when you're done, it should look something like this. Click the finish button right here, and the color of the path will change from magenta to black. That's how you know you're done. And then over here in the 3D view, notice this small little cross symbol that appears right here. That's the work plane of the profile that we're going to move along this sweep path. So locate a view that's looking right at that work plane, such as the left elevation right here, and let's zoom in on that location. Now you can sketch your profile shape, or you can load it in from a pre-created profile. Now we can create 2D profile families where you draw out the shape and save it, and then you can use them in multiple families. That's what I've actually done for us here. So up here on the sweep panel, there is a load profile button. And if we click that, you will find a rail family with the exercise files. I'll open that up and then load it in. Once you load it in, it will show on this drop down right here, and I'll choose rail, and then you'll see it appear right there. Now you can actually select this and move it anywhere you want. I'm going to undo that. I want to move it a little more precisely, so I'm going to use my align command. I'll select this reference plane as my alignment edge, and then that edge right there, and that will move the rail into the correct location, and then I will click finish to create the sweep. And if you zoom in here in 3D, you can see it's sweeping that solid form all the way around the edge of the pool table. So whatever form you're creating within the family editor, it's usually just a process of breaking down the overall object you need into a series of solids and sweeps and blends and other objects. So you can use the various create tools that we have on the create tab and assemble them together to create the overall 3D form. When you're building 3D geometry for your family content, you're going to use a combination of solids and voids. Now, we've already seen some solids, and they just create actual physical geometry. What we use voids for is to actually carve away from the solid geometry to make more complicated shapes. So if we look at our create panel, we actually have on the forms panel here, we have a voids dropdown, and it lists all 5 of the same shapes that we had for solids, but we can create them as voids. So in this example, I'm going to work in my floor plan, and I'll enlarge it a little bit larger here, zoom in, and like we did in a previous movie, I want to select my solid forms here and use my temporary hide and hide both of these elements. The reason I want to do that is because the void that I'm going to create, I want to build it directly to these reference planes, so it just makes it easier to do that if I get the solids out of the way temporarily. So the next thing I'm going to do is go back to create, click on void forms, and I want to create a simple void extrusion. I'm going to create the 6 pockets around the pool table, and for this example, I'm just going to use simple circles, even though in a real pool table, the pocket shape is slightly different than that, but for our purposes here, a circle will work just fine. Now, I'm going to start right at the intersection of these 2 reference planes here, and I'm going to drag that out slightly, click on the radius dimension that appears, and I'm going to make that 50. Then I'm going to create a second one right here, and also make that 50, and then I'll cancel out of the command. So now what I want to do is move these circles to shift them in slightly. So I'm going to select both of them to start off with, go to the move command, pick any start point, start moving in the down direction, and I'm going to type in 32. Then I'm going to select only this one, and move it again, the same amount, but I'm going to move it to the right this time, 32. Now with that one selected, I'll go to mirror pick axis and mirror it around the center point here, and then I'll deselect, select all 3 of these, mirror pick axis again, and mirror it around this point here. So I've now created 6 circles that are going to represent my pockets. Now if I stretch this window back down again, and look over here in the 3D, you'll notice that everything is sitting on the floor. So again, we have that work plane issue that we had in a previous movie. Well, let me go ahead and finish this extrusion and create the object, and then we'll talk about how we can actually change the work plane after the fact. Now notice that what we've got down here is, if you deselect it, they're these sort of yellow glass objects. Okay, so that's how a void object looks when it's deselected. What I'm going to do is select that void object, and notice that on the ribbon, we have this edit work plane button, and I'm able to take this and change the work plane after the object's been created. So I'm going to choose that playing surface work plane, and that will move those void objects up to the surface of the playing table. Now let me go ahead and enlarge my 3D view a little bit here so we can zoom in and see. And what you'll notice right now is that the 2 shapes are not interacting with one another. Had I built the voids directly on the playing surface, when you click the finish edit mode, it would have automatically cut away from the sweep. But in this case, we're going to have to do the cut manually. So all I'm going to do is come over here to modify, click the cut tool, I'll select the sweep, and then I'll select the void. Now when you do, it applies the void to the sweep and cuts away from it, and the void disappears. So the only time you're going to see the void in that yellow transparent glass is when it's not applied to anything. Now I want to repeat the steps by selecting the extrusion next, and then picking on the same void object. And if you move your mouse around, you'll find it, and you can apply it to more than one object. Now if you zoom in, you won't really see any effect from doing that, and that's because the void object is actually too short. So all I have to do here is I'm going to zoom in one of my elevation views, is move your mouse around and find the void. You might have to use your tab. There it is right there. Click on it, and then use that small grip control handle at the bottom to stretch it down and snap it to that reference plane, and I'll go ahead and lock that. And then when you deselect the void, it will cut all the way through the playing surface there. And so now you can see we've created our pockets around the edges of the table. So a void form is created from the same 5 shapes that we can create solid forms from, but the difference is we use it to actually carve away from solid geometry instead of adding to it. So our playing surface is coming along nicely, but our pool table needs some sort of means of support. So unless we've invented an anti-gravity device, we're going to need to put some legs underneath here. Now you could use really any kind of form that you wanted to create the legs, but just to do something that we haven't done yet, I'm going to use a blend for this. Now like most of the geometry that we've created, we're going to want to establish some reference planes and maybe some dimensions and constraints before we build the geometry. So the blend legs will certainly be no exception. Now to give myself a little bit more room to work, I'm going to maximize my floor plan view and zoom it to fit. I just typed ZF. And then I am going to hide some of this geometry. So because it's been joined with voids, you might have to do this more than once. So just keep selecting the elements and hiding them until you've got only the reference planes like that. Okay, so now I'm going to add some new reference planes. So I'm going to go to create and choose my reference plane button here. And I'm going to create a horizontal one in here that I'm going to set at 75 millimeters away from the edge. And then another one here that I'm going to set at 150 from the edge. And then one more right here that I'm going to make 300 off of the first one. So I'm going to take this reference plane here and mirror it like so. And then I'll take both of these and mirror them over here. So I've defined kind of a rectangle in here and in here that's where the two legs will be. And I've established those reference planes to determine those locations. Now, if I went to family types and flexed this family, what you're going to see is all those new reference planes are going to stay right where they are, and they're going to completely ignore the rest of the family. So of course, what I want to do next is apply some logic to the positions of those reference planes so that they flex along with the family. So I'm back to the large type, and I can do that again with just some dimensions. Now I'm just going to dimension from here to here. And for this example, I'm just going to lock these. Now it is possible that you could make these parameters if they needed to be, but in this case, I think locking is more than appropriate. How do you make that decision when you're building your own family content? Well, what I usually like to tell people to do is, if you're looking at a product catalog and building an object that's pre-manufactured, if the object comes in more than one variation from the factory, then you should make it a parameter. But if the object only comes one way, then go ahead and lock the dimension. So in this case, I'm assuming that when we buy this pool table, the legs only come one way, and so we don't get an option for that. And so that's why I feel comfortable going ahead and locking those dimensions. Okay, so now we're ready to build the blend form. So I'm going to go over here to the create panel, and I'll click on blend. Now, building a blend is almost exactly the same as building an extrusion. The only difference is it has a bottom and a top. So it actually blends from one shape to another as it extrudes between its height. So by default, we're building the bottom first. And what I'm going to do is choose my rectangle command here. I'm going to set an offset for that rectangle of 50 millimeters. And I'm going to click right at the intersection of those two new reference planes that I just drew and start to draw this way. And you'll notice that it's actually making it larger than that rectangle. I want it smaller. So I'm going to tap my space bar to shift it to the inside. And then I'll click at that intersection right there. So that gives me the base of my blend. Now on the modify tab, I'll click this edit top button, and that will shift me to the top of the blend. I'll do another rectangle, but this time I don't want it to offset, so I'll set that back to 0. However, what I do want to do is check this box right here to give it a radius at the corners. Now it's defaulting to 1,000 millimeters, which is way too large for this example. I'm going to set it to just 50, and then I'll come over here and click my first point at the intersection of the two reference planes, and my second point at the opposite corner. And when I click, what you'll see is, if I zoom in here, that Revit rounds off the corners of that rectangle. Now I'm going to go ahead and lock this on all 4 sides. I'll click the modify tool, and I'll click finish to complete the blend. Now I'm going to come over here and click the restore down icon at the top of the screen to go back to my 4 tiled windows and look over here at my 3D view. And as you'll see, my blend is a little bit too short. So all I need to do to fix that is something that we've done before. I'm going to click over here into the front view, and using this little control handle here, I'm going to drag it up until it snaps to the reference plane. Now look at my status bar. This is very important. On the status bar, it says nearest to reference planes. If it says solid geometry, then you'd want to use the tab key, but I want to make sure that I'm snapping it to the reference plane and locking it. So it's always better whenever possible to build your geometry relative to the reference planes rather than to other geometry. Now there's always exceptions to that rule in any rule, but in general, building to the reference planes is a much smarter course of action. So now that I've got the one leg here, I'll keep it selected, and I'll go to the mirror command, and I'll mirror it over to the other side. So that completes the legs for our pool table, and our pool table is ready for some final finishing touches. So our pool table is nearly complete, but it could use a few finishing touches to complete it. I'd like to look at adding a couple materials, maybe add some accessories, and then of course the real test of any family is to load it into a project and really test it out. So the first thing I'd like to do is apply a material to the surface of the pool table. We're looking for that really recognizable green felt that you see on many pool tables here. So I'm going to go into my 3D view here. I'll zoom in just a touch, and I'm going to select that pool table surface, that extrusion that we created for the pool table surface. And there's going to be a couple steps. The first step is I want to assign a material parameter to that surface. So if we come over here to the properties palette, you're going to see some different settings over here. And next to material, it actually would be possible for you to click right here where it says by category and assign a material directly. Now you could certainly do that if you were only ever going to use green felt and never anything else. But sometimes pool tables use different color felt. So if you want to keep it flexible so that the end user could actually change the kind of felt they're using, click this small little icon right here. It's a small little button, and it's called Associate Family Parameter. So now when I click that, it will display the Associate Family Parameter dialog, and we don't currently have a material parameter in this file. You can see that none is the only choice. So I'm going to come down here and click Add Parameter, and I'm going to call this Playing Surface Material. Now, of course, you can edit the tooltip if you want to, but for now, I'm just going to click OK and then OK again. Now, if you deselect the object, it might be a little disappointing because you're like, well, that didn't really do anything. Well, all we've really done is allowed for the possibility now of assigning material to that surface. So the next step that we have to do is actually create the material that we want to assign and then assign it to that surface. So what I'm going to do is do both of those things here in the Family Types dialog. So I'm going to go to Family Types, and you'll now see that we have a new parameter called Playing Surface Material, and it's currently set to by category. So I'll click in the by category field here, and there's a small browse button, and that will load up the material browser. So here, I'm going to create a brand new material to apply to that surface. So I'm going to take the default material that's here, and I'm just going to right click it and choose Duplicate. I'll give that a name of green felt. Now, there's 2 sets of settings that we want to configure here. We've got settings on the graphics tab, and we've got settings on the appearance tab. Now, we've discussed this in previous movies, but it's worth repeating here. The graphics tab is used to determine what occurs in shading, surface patterns, and cut patterns. So this is going to occur in plan views, elevation sections, 3D views that use either hidden line or shaded display. If you use realistic display or do a rendering, it's going to use the settings on appearance. So if you want to make this material the most flexible it can be, you should really configure both sets of settings. So what I'm going to do is jump right over here to appearance, something that you really want to be cautious of. Right now at the top of the window here, it says it's using a default appearance asset. It's really a good idea to either duplicate this asset, which is what I'm going to do, or actually replace it with one from the library. Now, I'm pretty sure that we don't have a green felt in the library, so duplicating is what I chose to do here. And then I'm going to come over here under information, and instead of the name default 2, I'm going to rename that to green felt, just to give it a more descriptive name. Now I'm going to come down here for the color swatch and click on that and just choose a greenish color that I want to use. Now you can choose one of the preset ones, or you can dial in your own color over here. And then that's really all I need to do for this example. I'm going to go back to graphics, and there's this handy checkbox right here that allows me to make the shading material for this material match the appearance material, so that whether I go to shading or realistic, they're going to use that same green color. And you'll see the icon will update over here. So this is a pretty simple material. There's lots of other settings we could add. We could load in texture maps. We could do bump map. There's all sorts of things we could do, but all we needed was the green color. So I'm going to click OK on that. That's now assigned the green felt to the playing surface, and I'll come down here and click Apply, and you'll see that appear in the 3D view. Now, if I open up my type selector and choose my small table, notice it goes back to by category. So all I need to do now is click the browse button, select green felt again, and click OK, and then apply, and my pool table will get a little smaller, but it will still keep using the green felt material. So now all that remains is for us to add some accessories to this table, and I provided a family with those items for you. Now you can bring one family into another family, and Revit refers to this as nested families. So I'm simply going to go to the Create tab and use the same component button that we've used in the project. Now when you click the component button, Revit will alert you that there are no component families currently loaded and ask you if it's okay to load one. So I'll say yes. I'll browse to the Chapter 13 folder, and I'm going to choose this family right here called Cues and Balls. I'll click Open. And I'm going to work here in the 3D view. This is a special kind of family that's what we call a face-based family. And you can see that the message says click on an instance or face to place the family. Okay, so if I move my mouse on the surfaces of this pool table, it will sense all of the faces. Now it would be kind of silly to place it on a face like this. So the most logical face is the surface of the pool table. Now you'll notice the orientation is wrong. I can just tap the space bar to rotate it. So I'll go ahead and rotate that around, click a point to place the object, and then I'll click my modify tool to cancel out. So that completes our pool table family, complete with balls and cues. And now all that remains is for us to load it into a project and see how it's shaping up in a project environment. Now, if I look at my switch windows here, I've got the condo building loaded in the background. So I'm going to load it into that project file. If you're done working with the family, you can use the load into project and close. If you're not sure if you're done, you might want to come back later and make adjustments. You can choose the load into project instead. So in this case, I'll choose load into project just in case we need to come back and make any modifications. Now, when I load it over, it's loading into this large 3D view here. That's probably not the best view for me to use. So let me maximize my condominium here. And I'm going to double click the level 1 floor plan. And I've got a small rec room over here in this location. And we're going to place the pool table in that area right there. So I'm going to go back to my component button. There's my pool table on the properties palette. Notice that if I open up the type selector, I have my large and small sizes. You can choose whichever one you like, and then come over here and place it in. Now, that's what it looks like in plan view. Looks pretty good, but it might be nice to see this in 3D as well. So I'm going to go to my drop down next to my 3D view, click the camera button. I'll come over here and stand next to the door and click, and then I'll drag beyond the back wall right here, and that will show us the pool table here in 3D. Maybe change to a shaded view so that we can see our nice green felt. You can even adjust the zoom or hold your shift key down and orbit around a little bit if you want to make adjustments, but that gives you a pretty good idea that your family is working and it fits nicely in the space. If you want to, you can select it and try the other size. You can see it gets a little bit larger and everything appears to be working. So once you've completed a family and added any little details to it that you need, material parameters and nested accessories, all that remains is to load it into a project and test it out. It's a really important final step, but hopefully when you do, everything's going to behave exactly the way you expect, and then all that remains is for you to congratulate yourself on the job well done. When you're ready to share the work that you've done in Revit with outside recipients, one of the most common ways to do that is to print out a set of documents. Now you can actually print from any view in Revit. We could just simply go up to the application menu and go to print, but a more professional presentation will be accommodated by adding some sheets. So if you look over here at your project browser, there is a sheets branch on the browser, and I've added some basic sheets to this file. And here in this movie, we're going to look at some of the features of those sheets, and we're also going to look at how we can add additional sheets to the list as well. So let me start with the very first sheet that we see here. If you'll notice, there's a small plus sign next to it. If I expand that out, you're going to see that it says floor plan level 1 beneath that. Now that's actually the view that I have here on screen. So what that's telling me is if I double click this A101 floor plan sheet, it actually already has that level 1 floor plan inserted on it. And so if I kind of zoom in here, you can see that it looks exactly the same, and it's kept up nicely with all the changes that we've been making. And one thing that we want to point out here, though, is if I zoom in a little bit more closely, you'll notice that this section head over here and this elevation marker over here actually have information input into them. And I'm going to focus on the section markers for the moment. So if I just pan over a little bit to see some of the other section markers, this one says 1 on A301, and then there's one over here that says 2 on A301, and then you'll notice that this one is still empty. Both of those that are filled in say A301. So let's take a look at that sheet right here. And if I expand that, you can see that it confirms that both of those sections that we're looking at there are actually already placed on this sheet. Let's go ahead and double click that sheet, and you can see them inserted here. So the way that this works is when you add a view to a sheet, Revit just simply numbers each view that you add, and then it's able to go back and populate those callout references with the correct number and sheet reference. So this is very powerful because in traditional CAD drafting, we had to do all this work manually, and it's quite a tedious process. But here in Revit, it will take care of all of those things for you. Now, if you add views, it automatically numbers them. If you remove views, it automatically adjusts the numbers. So if I take this section right here and I press the delete key, that removes it from the view. It's no longer here indented beneath this sheet. And if I go back to the A101 sheet and look over here, notice that this callout is no longer filled in. Now I'm going to do Control Z to undo that, and that will restore the reference and place the view back on the sheet where it was. Now, if I go back to that section sheet, there's still some room over here on the sheet, and I have other sections here in this file. So perhaps I want to add some of these other sections to this view as well. So let's take a look at this section at stair here. Now, to add a view to a sheet, there's actually two ways that you can do it. So one way is to just simply drag it right from Project Browser. So I'm going to select section at stair, start to drag it out of the Project Browser. You'll notice a small little plus sign appear on my cursor. I'll let go. The view will appear as a small rectangle attached to my cursor, and I'll be able to move over and place it anywhere that I want. Now, notice that it does try and line up the title bars, or it'll actually try and line up the views themselves. Now, I think in this case, it makes more sense to line up the view itself, and then I'll adjust the title bar as a separate step. So I'm going to get it to line up here with this other view, and I'm going to click, and then, if we zoom in, notice that it automatically assigned that to detail number 3 on this view. Now, if you deselect it, I'll zoom back out a little bit here. If you grab the view itself, click on it and drag, it moves both the view and the title bar. Let me undo that. But if you want to move just the title bar, you can click directly on the title bar and then drag it, and then notice it will line up with the neighboring one, and that's how I can make sure that both the geometry lines up with the other views and the title bars line up to make a nice, neat presentation. Now, this was detail 3 on A301. So if I go back to my floor plan sheet, and we pan back over here, notice that it fills in that reference for me automatically. So just simply by adding a view to a sheet, Revit will automatically take care of all the cross references. That's very powerful and very, very useful. Now, what if my team decided that after I've placed this section on the sheet that we'd actually like to renumber things? Perhaps I'd like it to go, instead of going top to down 1, 2, and then back to 3, maybe they want to go across the top first 1, 2, and then come down to 3. Well, I can certainly do that, and I do that over on the properties palette. So I'm going to select this view, and then over on the properties palette, here's the detail number. Now, the trouble is you can't just type in 2 here, because if you do, it will tell you that that detail number is already in use. So you have to do sort of a little workaround here. I'm going to select this one, and I'm going to set that to detail 4. Now that number wasn't taken, so it allows me to do it. That freed up detail number 2, so now I can change this one to detail 2, and then I can come back and select this one and make it detail 3. So it takes an extra step, and it's a little bit of workaround, but it does the trick. So you definitely can have control over the numbering of the various views. So that's working with some of the existing sheets that are already here, and you're welcome to open up some of the other sheets. You can see that I've got elevations placed on sheets, and I've got 2 floor plan sheets. But if we scroll back up here to my project browser, I still have quite a few floor plans that are not on sheets yet. So I might want to add some additional sheets to the set. So that's real easy to do. I can scroll down over here and right-click directly on the sheets branch, and then choose the new sheet option. Any title blocks that are loaded in the file will be listed here. In my case, I only have the one called A1 metric, but if you wanted to load additional title blocks, you could just click this load button here and load in an Office standard title blocks. That's perfectly fine to do, but I'm just going to accept the default here and click OK. That will create a blank sheet complete with the title block. And if I zoom in over here on the title block area, you'll see that it went to sheet 502. So the last sheet that I created in the set was 501, and Revit just remembers that and picks up the numbering from there. Now maybe I'm going to add my power plan to this sheet. So I might want to actually renumber it. Now the two ways that you could do that is to either come over here to the browser, right click it and choose rename. That would give you name and number, or it's actually possible to click directly on the title block and then activate the text and rename and renumber it directly on the sheet itself. So perhaps this wants to be P101 because it's a power sheet. Maybe I want to list myself as the author. Maybe I have another individual as the checker, and there's a date right here. Maybe I want to make an adjustment to that we're actually going to issue the project a little bit early, so I'm going to set that date like so. Right here, unnamed, that's the name of the sheet, and I can call this Power Plans. And you'll see it update immediately over here on the project browser. So it doesn't matter which place you do it, whether you right click in the browser or whether you do it here. I'm going to click anywhere in empty space and I'm going to type ZF to zoom to fit. So now I want to add a view to this sheet. The one thing I want to point out is I changed the date right over there. So before I add a view to the sheet, let me go back to one of my existing sheets, zoom to fit, then zoom in over here. Notice that the date updated across the entire project. So some of the properties that you fill in here are global properties like the project number and the date. Drawn by and checked by, you can see did not change because those are unique sheet by sheet. All right, let me do zoom to fit again, return to my power plan, and let's go ahead and add the view to the sheet now. Now I've already shown you that we can drag and drop, so we could certainly scroll back up here, locate my level 1 power plan, drag it over. There is another way that you can do it if you prefer. You can go to the view tab, and then here on the sheet composition panel, there's an icon right here to place view. You just click that, it will list out all the views that are available. You select it here, you click add to sheet view, and then you place where you want it to go. So it's as simple as that. So those are the two ways that you can add views to your sheet. Now, one last thing that you might want to do is once you've started building a collection of sheets, it might be good to have a sheet index. To do that, that's actually a special kind of schedule. So like other schedules, you can right click here to get to it, or you can just use the schedule drop down here, and you want to choose sheet list. So I'm going to scroll down, and maybe I want the sheet number, the sheet name, and perhaps the issue date. Okay, real simple. I'll click OK, and it populates a nice list of all the sheets for me. You'll notice that they're not in any particular order here, so I'm going to go to sorting and grouping, and I'm going to sort by sheet number and click OK. That will reorganize the list, and then I'm going to scroll back down and decide what sheet I want to place this index on. Now, a lot of times you'll have a cover sheet. I don't actually have a cover sheet in this project, so I'm just going to go ahead and add it to the floor plan sheet here. Scroll back up on the browser, locate the sheet list. It's under schedules, drag it, and drop it on the view, and I'll place it right over here. I'll zoom in, and you can use these small little grip controls here to enlarge the fields so that they don't word wrap, like so, and that's our sheet list. Now, anytime you drag a schedule to a sheet, if it's a really long schedule and you run out of room and it doesn't fit comfortably on the sheet, they have this small little split icon right here that you can click on, and that will actually split it into more than one column. If you change your mind about that and you want to put it back together again as a single column, you just use this control right here and you drag it on top of itself, and it will heal back up. So when you're ready to start making a formal presentation of drawings in your set, sheets are the best way to do that. You can create a collection of sheets, drag and drop the views on those sheets, complete with a sheet index, and then package up the whole set and get it ready for printing. In this movie, we're going to talk about adding sheets from placeholder sheets. So this is just an alternative way of adding sheets than the one that we looked at in the previous movie. I'm in a copy of my condominium building here, and there's no sheets yet in this project. I'm looking at an empty sheet list as a consequence. What I want to do here is begin adding sheets, but I can actually do that directly in the sheet list instead of doing the right click over here like we did in the previous movie. So all we have to do is actually come up here to this rows panel in the sheet list and click insert data row. Now that will create the first sheet and suggesting the name A101. And if I'm happy with that, I can accept that. And then I, of course, can come over here and begin typing in whatever I want the name of this sheet to be. Now, when I insert the next row, it'll just go to A102, A103, and so on. Now, I might want to be a little bit strategic about this. I have 3 floor plans. I have a roof. So, if I want to, I might want to insert 3 or 4 different floor plan sheets. I can just come over here and from this drop down, I can just choose the previous name that I typed in, or if I start to type it, it will actually show me previous ones that I've typed and I can select it that way. However I do this, right, I can get those in there. When I insert the next one, it's going to go to 105. So if I wanted my elevations to maybe be 201, that's when I would want to change this. And this is very common, like we've seen in other numbered elements in Revit. Revit just numbers sequentially, 1, 2, 3, 4. And so just like we saw with rooms or with doors or any other numbered element, if you want to restart the sequence, just make sure you stop and do that before you get carried away. So it might be tempting to click insert data row a bunch of times, but then you're going to have a whole bunch of sheets that you have to rename. So I'm going to insert it again, and maybe 2 elevation sheets is all I need. Then, perhaps I want a 301 sheet for sections, and you can just kind of go through the list here, adding the ones that you want. And I'll skip right to a schedule sheet. Okay, so you're welcome to add additional sheets to the list if you want to. Another thing that you can actually do is you can go back to fields, and you can add other fields to this sheet list and fill those in as well. So if I wanted to add the drawn by field and click OK, currently it's going to say author for all of those, but I could fill in my initials. And then, of course, for all of these now, I could just choose it off the list. And what will happen is when I create those sheets in a few moments, they will already have the author information filled in. So the sheet list can really be a powerful tool to help you actually speed up the process of creating all these sheets and filling in all the data that you need. So now that we've got our sheet list and we've got these entries on the list, if you scroll down here and look at the browser, we still don't have any sheets yet. That list is still empty. So how do we actually get sheets from the sheet list now into the project browser? I'm going to right click again and go to new sheet. And this time when the new sheet dialog displays, notice that down here under placeholder sheets, all of the ones that I've just input into the sheet list are available. You can actually click and drag through this whole list and create all of those sheets in a single step. So I'm going to click OK. And then if we expand the sheets branch here, I now have all of my sheets and they're all empty, but they're all ready to receive views. So A101 is open. And just like we saw in the previous movie, I can drag a floor plan onto that sheet, kind of click to place it where I want it to go, just about makes it on the sheet there. Do the same thing for other sheets, level 2, level 3, and so on. Click, drag it. Now this one came in a little bit larger, so let's zoom out and investigate what the problem is here. Notice that the elevation symbols are way far away from the building. So what I'm going to do is actually just drag this so that the building itself fits on the sheet. And you can actually use the arrow keys on your keyboard to nudge it a little bit at a time to kind of get it to fit. And you can see that if I adjust those elevation markers, I can get everything to fit in there. There's a couple ways I could do that. I certainly could go back to the level 2 floor plan here, open it up and do it here, but I might not know how much to move those elevation markers without the sheet in the background for context. So there's actually a really handy tool that we can take advantage of. If I go back to the 102 sheet, click right on the viewport. I'm going to right click and choose activate view. That kind of grays out the sheet, and now I'm literally working in the level 2 floor plan. Now what you want to do is be really careful here. There's actually 2 things. There's an elevation symbol and the view itself. So do a crossing window to make sure you're getting both of them. And then you could nudge one step at a time with the arrow on your keyboard. If you hold the shift key down and then nudge, it goes 10 steps at a time. So what I'm going to do is nudge it over, and then maybe nudge it back 1 or 2. Do the same thing over here. Shift nudge a couple times, then maybe back a few. Shift nudge a couple times, then maybe back a few. Now in this case, it's right on top of the section marker, so I'll just nudge it over to the side a little bit. And then the final one right here, shift nudge, back it up, pull it over, fine tune like that. Now all I have to do is right click and deactivate the view. And now you can see that the viewport fits much more nicely on the sheet. Now, the title bar is still floating out here. In the previous movie, we saw that if you move the viewport, it moves both pieces. I'll undo that. But if you grab just the title bar and drag it, you can move it independently. Now, here's the interesting thing. To move the title bar, you drag it independently. But to resize it, you actually have to go back to the viewport again. So if I click on the viewport, that puts a little grip here on the end of the title bar, and then I can shorten it up like that. That's just to keep you on your toes. Let me do zoom to fit here, and that completes the setup of the sheet. Now, one last thing. If I activate view again, notice these orange lines here that are visible because of the room separation lines. If you see something on screen in your Revit view, it will print as a rule in Revit. There's very few exceptions to that. There's one or two elements that won't, but in this case, that's a model line and it will print. So if you don't want to print orange lines when you print your set, tab into that, select it, then come up here, go to the light bulb and choose hide category. That will hide all of those. Then I can right click again and deactivate the view, and now the sheet is ready to print. So a nice little check to do before you actually finalize and click print is to just look for those little things that you may or may not want to see. So this gives you an alternative way to create sheets. You can very quickly set up a whole list of sheets on your sheet list, and then using those placeholder sheets, you can create your whole collection of sheets and then just drag and drop the views and fine tune them. In this movie, we're going to look at the guide grid feature. The guide grid feature is designed to help you line up multiple views across different sheets. Now, when we were setting up the sheets for this project, you may recall that on the section sheet, we had multiple sheets, and it was pretty easy to get alignment between two different views on the same sheet. So if I just sort of move this out of the way, when I'm moving it, Revit tries to snap to that nearby geometry and get those views lined up. So it's pretty easy to do that. But what about if you have a similar view on a different sheet and you want it to fall in, roughly the same spot on the sheet of paper? That makes for a more professional presentation. So for example, here's my first floor plan, and then over here on the sheet A111, my first floor reflected ceiling plan. And if I tile these two next to one another, you can kind of see that there's a much bigger gap here to the edge of the sheet than there is over here. Now, you could take this and you could start to eyeball it and maybe get it close, but a lot of times folks want that to be exact. So let's look at the guide grid feature as a way to help us do that. So I'm going to maximize the floor plan back up again and go ahead and start setting up my guide grid. So if I come over here to the view tab on the sheet composition panel, there's a guide grid icon right here, and I'll click that. That will display the assign guide grid dialog, and currently there are no guide grids yet in this project. So I'm just going to give this one a name, and I'm going to call it floor plans. Now you can call it anything you want, but because I'm going to use this one to line up my various floor plans, that seems like a pretty good name. Now this really overpowering blue graph paper will appear on the sheet. This is the guide grid. Now you may recall in a previous movie I talked about things that plot and things that don't plot. So the one thing I do want to mention is that even though this grid here that I can select is very overpowering, if we printed right now, it wouldn't print. So this is one of the few objects in Revit that actually does not print. Now I tend to like to actually expand this grid a little bit just so that it's not quite so overpowering. If you've got it selected, and you can do that out by the edges here, you can come over here on the properties palette and you can input a different value for the grid spacing. So right now it's defaulting 25 millimeters, and maybe I'll do about 4 times that. So I'm going to put in 100. When I apply that, you see that now the grid spacing gets a little bit further apart and it's not quite as distracting anymore. Now, of course, that's completely optional. You don't actually have to do that. But I think an even more useful thing to do is to resize the grid itself. So notice that there are actually little control handles at the sides of the grid. What I'm going to do is stretch this down so that it's really narrow, and then again, so that it's only showing me a single grid intersection. Now notice that you can pick this thing up and move it around. So I'm going to kind of move it roughly nearby my existing floor plan here. And then assuming that I'm happy with the position of my floor plan and I want to make my reflected ceiling plan match it, then what I can do is zoom in right over here, and you can use your move command and snap intersections on the guide grid to intersections of the datum elements in your floor plans. So grids are eligible, reference planes are eligible, and levels are eligible. So guide grids can snap to any of those datum elements. So I'm going to keep this selected, go to the move command, start at this intersection right here, and then I'm going to move over and snap it to this grid intersection right here, grid A4. So I've moved that guide grid into position in that location, and now I'm going to do zoom to fit. So now here's where we can use that guide grid to help us line up the other sheets. I'm going to go to the A111 sheet and open it up. And if I look over here on the properties palette, as long as nothing's selected here, it says sheet at the top and it tells me I'm in my reflected ceiling plan sheet. I'm going to scroll down, and here's my guide grid feature. It currently says none. If I open up this list, floor plans is now available on the list. And when I choose that, notice where the guide grid appears. It appears in exactly the same spot that it did on the first floor plan sheet. So now I'll zoom in again in that general location. And this time, instead of moving the guide grid, I'm going to move the viewport. So I'm going to click anywhere in the viewport to select it. Okay, you can confirm that it's selected over here because it says viewport on the properties palette. Click my move command, start my move right at the intersection of grids A and 4. And then snap it right to that intersection right there. If you're having any trouble getting it, type SI for snap to intersection, and that should give it to you, and it will move right over. Zoom to fit, and now that reflected ceiling plan is lined up perfectly with the floor plan on the other sheet. Now you can repeat this process for all of your floor plan sheets. Now you don't actually have to turn off the guide grid at all. You can leave it turned on if you want to, or if you've decided that you no longer want to see it, you can just come over here and set it back to none. That does not change the orientation of the floor plan at all. It just simply hides the guide grid. So using guide grids, you can take a bunch of similar views on different sheets and get them all lined up with one another and make for a nice professional presentation. Occasionally when you're working on your projects in Revit, you'll need to share data from your project with an outside recipient who does not use Revit. Often that recipient might be a user using AutoCAD or perhaps even some other CAD program. So in this movie, I'd like to look at the process of exporting views from Revit to the AutoCAD file format. Now you can actually export directly from views or from sheets. In this case, I'm looking at a floor plan sheet, and what I'm going to do is go up to the application menu and scroll down to the export item right here. If you hover over it for a moment, it will expand out a menu of choices, and then you can slide over here to CAD formats, and then that will fly out one more time. And these are the formats that we can export to: DWG, DXF, DGN, or even ACES stat files, which are 3D files. That wouldn't be a good choice for my current view because it's a 2D view, but if I wanted to export a 3D file, I would just go to a 3D view first, and then I could export that. So for this example, I'm going to choose DWG, and when I do, it will display the DWG export dialog. Now it'll show you a preview of the current view that you're in this case, my floor plan sheet. If you only wanted to export the current sheet, you could go right to next and continue. But I want to show you a few of the options in this dialog before doing that. The first option that I want to show you is it's actually possible to export more than one view at a time. So over here under export, we have this drop-down list, and if we open that up, there's two choices: the current view and sheet or in-session view and sheet set. Now if I change to in-session, that actually creates a second drop-down, and then if I open that one, you can see I have lots of choices. So if I wanted to export certain views, I could choose this option. This would filter just for the sheets. This would show me all of the sheets, and this would show me everything. So I'm going to come down to this one here, sheets in model, and what that's going to do is it's actually display all of the sheets that are on the sheets branch of my project browser. And then you could check whichever ones that you wanted. So let's say that I wanted both the first and the second floor. So I'm going to check those two boxes right there, A101 and A102. Now it's actually possible to come down here and click this button and save that set. Okay, now this says save set and close. So that would actually allow you to save the set, close the dialog, and then you can come back in again to export out. I'm going to skip that step for now. Before I go to next and start the export, let's talk about the settings that we're exporting. How will Revit choose to export the data in your Revit model? Well, it turns out that there's a whole bunch of settings that we can configure. So if you look up here at the top of the dialog, there's the select export setup dropdown, and you might have more than one choice here if you've actually saved some. And then there's a small browse button right here that allows you to modify the setup. And as I said, there are lots of choices in here. Now, we're not going to go through every last setting in here. I'm just going to highlight a few of the more popular ones. Now, by far, the thing that your recipient is probably most concerned with is this very first tab here called layers. Everything in an AutoCAD file is organized into layers. Revit will take all of the various categories of objects in your Revit model, and it will map them to certain layers in AutoCAD. Now, there are some pre-built-in standards here that you can choose from. So the default one in my list is the American Institute of Architects standard. So all of the layers down here match that AIA standard. But there's also other standards for different jurisdictions around the world. So for example, if I wanted to use the British standard 1192, I could choose it off the list. It will warn me that I'm going to replace all the settings, and I could say yes. And now all the layer names, if I go ahead and widen this out a little bit, now all the layer names would match the British standard instead of the AIA. So you can go ahead and choose whichever standard here that you like. I'm going to set mine back to AIA and click yes here. Now, in addition to that, if you want to customize it further, you can actually scroll through this list, select any item you like, and actually type in your own layer name. In addition to that, you can type in your own color ID. If you're familiar with AutoCAD, you know that often the color ID has an impact on the output of the drawing. You know, it might control the line weights, or it might control other aspects of the printing. So these can be pretty important settings. I'm not going to change any of the settings here, but if you have an office standard that you need to adhere to, then it might take you some time to go through this list and get everything configured properly. Okay, so let's move on to some of the other tabs here. We've got similar settings for nearly every kind of object in the Revit model. So what sort of lines do you want to use? Well, all our different line patterns are listed here, and you can let Revit automatically generate the line types in AutoCAD, or you can actually map them to predefined ones. The same thing with the hatch patterns. The same thing with fonts and text styles. With colors, you can either use the default AutoCAD color index, which is just 255 colors, or you can set it to true colors and let it just use all the colors in the rainbow. For solids, if you're exporting 3D views, it can either create mesh files or solid files. So talk to your recipient, find out which one they prefer. Obviously, units and coordinates can be important, right? So I'm exporting in millimeters, but if my recipient is using a different unit, I might want to change that. And then here, we talked briefly about shared coordinates in one of the earlier movies, but often it can be important to set this to shared before you export. Otherwise, when the user tries to insert these files into their own projects, they might not line up properly. So usually choosing shared here is the better choice. And then finally, on general, there's a few different settings, like we can mark certain layers as non-plotting. You can choose to hide certain kinds of objects from the Revit model, things like reference planes and unreferenced view tags. And you can even tell it to take the rooms and export those as polylines. I'll choose a few of those options, and then finally, what file format do you want to export this to? So the current AutoCAD file format 2013 is chosen by default, but if your recipient's using an older version, you can choose that there. Now, if you want to preserve these settings as a new named setup, you can use the icons down here to do that, or you can just simply click OK, and it will change the default settings. That's what I'm going to do in this case. I'm going to click next here, and there's one more really neat setting that I want to point out to you. Because I'm exporting sheets, there's a checkbox that's available right here that says export the views on the sheets as linked external references. So what Revit's going to actually do, in my case, this particular sheet has one viewport and one sheet. So I'll actually get two AutoCAD DWG files, one for the title block and one for the floor plan viewport, and it will XREF the floor plan viewport into the title block. Let me click OK. I'm just going to save it in the Chapter 14 folder. Let me click OK here and let it do that export. So when the export is complete, if you have a copy of AutoCAD, you can actually go out to that folder and open up the files and take a look. I'm just going to show you the files in a folder here and show you what it created. Revit created, as you can see, a couple different DWG files. So here's the A101 sheet file, as I mentioned, and then this is the file that's being XREF'd onto that sheet. So you can see for each sheet I exported, I actually got two DWGs. Here's my 102, and here's the XREF'd 102 as well. It also exports these PCP files, which sometimes people need to get plotting correctly, but often those files can be discarded. So if you ever need to export your Revit file to other file formats, Revit does support many popular formats like DWG, like DGN, and you can export it on a view-by-view basis. Take some time to go through that export setup dialog because, as you saw, there are plenty of settings in there that you can customize the way the output is generated. So at some point in every project, you're going to be ready to print something out, maybe on paper or as a digital plot. Revit certainly can print out anything you like, and we can print from any kind of view. We can print from the views on the project browser, or we can print from the sheets. Now, we've already talked a few times in this chapter about how printing from sheets is a more professional presentation. That's the way I'm going to demonstrate it here, but feel free to print from any view that's convenient. So the first thing you might want to do before you print is zoom in and just kind of look around and make sure everything is to your liking so that you can save yourself the grief of having to reprint something. I'm happy with what I see, and it's time to print. So I'm going to go to the application menu, and I'm going to come down here and go to the print option, and that will display three sub-options over here. Now, in reverse order, we can use this to get to the print setup dialog. That won't actually print anything. It'll just change the settings, and I'll show you that in just a few moments. Print preview, of course, is a handy command because even though you're viewing things on screen here and you're saying, yeah, I think everything's okay, a print preview will be a little bit more accurate because it'll show you exactly what the printer's going to see. The print dialog actually gives you access to all of that stuff. So really, if we just go to print dialog, we can get to the other two all from one place. Now, the first thing you're going to want to do is set up what printer you want to choose. Now, naturally, the list of printers that I have on my system are going to vary greatly from whatever you have on your system. So for this exercise, just feel free to choose whatever device you like here. So I'm going to choose this laser printer that I have right here, and that will potentially adjust some of the other settings in the dialog. So you always want to start with that. Now, this button here accesses printer-specific settings. I'm not going to click that because, as I said, my printer is different than your printer, but in your own system, you might want to click that and look at whatever printer-specific settings you have. Let's take a look down here. The reason that I zoomed in the view in the background is to talk about the print range options. So let me move this out of the way as best as we can, and then let's talk about the three options that are here. Current window would actually print the entire sheet. It would print out to the extents. Visible portion of the current window would only print what you see actually in my viewport. So there's a difference there. So because I've zoomed in, it would only print that portion. So if you ever want to print just a small area of your file, zoom in first before you go to the print dialog. And if I click a print preview button right here, you're going to see what I mean. You see how it's zoomed in on just that area? If I close and I go back to print, and this time choose current window and do preview, you see how it does the entire sheet. Now, instead of closing, I can actually click print here, and it'll get me back in the print dialog without my having to go back to it manually. The option you're more likely to want to choose is this one, selected views and sheets. What's really nice about this is you can click the select button here. That will display a dialog, and every view and sheet in your project will be listed here, which is sometimes a really long list. Now, in the previous movie, I exported 2 sheets to DWG, and Revit's actually remembering that session right here, so you can see how they're still selected. Now, if that was a set of views that I'm going to print on a regular basis, I could actually click Save As and give it a name, and then it will appear here on this list. Now, another thing you can do is you can filter the list here by either views or sheets. So if I uncheck views, it will show me only the sheets. Then I'm going to do check all, and I'm going to do Save As again, and maybe I want to call this the permit set. So now, if I go ahead and check the box here again, let me do check none. So at the moment you can see nothing is selected. Now I could choose plans, and it would only check those two, or I could choose permit set, and it would go in and select all the sheets. So if you've got different configurations of sheets that you want to print for different purposes, just make sure to give them nice descriptive names. Let me go ahead and OK out of there. So at that point, it's got permit set chosen here, and that means it's actually going to print all of those sheets. Now, remember I said we could get to both the preview and the page setup from this dialog. Well, we've already done preview. Here's page setup. So I'm going to click that, and it will display the print setup dialog. And once again, this setup is tied to the device you choose. So I can't stress enough how important it is to make sure you choose your device up there first. All right, so many of these settings are self-explanatory. We don't have to go through all of them, but you have your different page sizes and the source for that and portrait or landscape. Those are all standard printer settings. Here, you can either center the print on the available paper, or you can choose offset from center with either the printer limit or user-defined margin. All I can recommend here is just do some test prints and see what you need to do. So sometimes when you choose one option or the other, it crops off a little bit on the edges. You'll have to do a few test prints to find out what the optimal setting is in order to work best with your printer. Whenever you get the settings in this dialog configured to your liking, you can do save as over here and give them a name. So if you spend some time figuring out those offsets, you're not going to have to do that every time. You'll be able to save it. As far as the zoom goes, fit to page is just going to fit the available sheet of paper, which means it's not going to be to scale. So if you want to print to scale, you want to choose zoom and 100%. If you want to print a half size set, you're going to choose zoom and 50%. So there's different things you can put in there. As far as hidden line views and appearance, you can experiment with some of these different settings here. We can force all the colors to black lines, for example, and we can use high, medium, and low quality. Some of these settings matter more when you're in 3D, like vector or raster processing. So again, just do some experiments on your own equipment and see what gives you the best results. What I want to talk about is these settings down here under options. If you're printing out your set, this first option here says view links in blue. That's like this little section head over here. If you wanted to actually print that section head in blue, you can check that. If you leave it unchecked, it'll print in black like everything else. All of these 4 items here, this one, that say hide, those are pretty much the only elements in Revit that we would consider non-plot. So I often get the question from new Revit users where they say, is that going to print? And the answer to that question is usually, do you see it? And if the answer is yes, then the answer is yes, it's going to print. So in general terms, anything that's visible on screen when you click print is going to print unless it happens to be one of these 4 items. Now, most of these we've talked about elsewhere in the course. So we talked about reference planes, work planes, for example. So if you have reference planes, we most recently discussed those in the family editor, they won't print if that box is checked. We didn't really discuss scope boxes, but if you have a scope box and you check this box, it won't print. We've certainly talked about crop boundaries quite a bit. And so if you leave that checked, even if they're displayed on screen, they won't print. So sometimes we hid the crop box, but you can actually check that box and you don't have to worry about it. This is an interesting one here. If you remember the movies where we talked about detailing and we brought in a masking region, sometimes the mask actually covers up part of a thick line. So if this is unchecked, it won't do that. So the thick line will always take precedence over the mask, even if the mask is touching right against it. If you check this, then the mask can actually cover up part of the line. It doesn't look so nice. So in my opinion, this should always be unchecked. And then finally, if for whatever reason you have trouble printing halftone, you can tell your printer to force it to thin lines. So these are all some very specific types of settings. But the one that I skipped here is my favorite: hide unreferenced view tags. So you notice over here that there's A301 in the section marker. That's a referenced view tag. But if I look over here in the break room, there's this elevation symbol right here that we created, and it doesn't have any sheet indication in it. That is an unreferenced view tag. So what that means is that view is not yet on a sheet. So if you print that view tag, your contractor might call you up and say, hey, I've got an elevation marker here, but I don't see the elevation in the set. So if you check this box, it will automatically hide those that aren't referenced, so that you're not basically telling people that there's an elevation or a section in some place where they can't find it. So that's a really handy feature that I like a lot. Now remember I said if it's visible on screen, it's going to print. Remember these orange lines right here? That's a room separation line. So if I click OK here, and then I'm going to go back to current window for just a second and click preview. Oops, I still had current window selected. So let me do visible portion of current window and do preview. You notice how those orange lines are showing up? So unfortunately, I can't fix that in the plot dialog. I would have to actually close out of the plot dialog, go into that view, and do hide in view. But do notice that the break room symbol here is not showing. So that's what I'm talking about, is that unless it explicitly says hide this object, it won't hide, it will print. Okay, so at this point, assuming that you have all the settings the way you want, so I'm back to my permit set, I've got all my setup the way I want, at this point you could go ahead and click OK and print out the set. So if you've chosen PDF up here, it will create a PDF. If you've chosen a physical plotter, it'll create a bunch of paper plots. And you can go ahead and check it out and see if you're satisfied with the results. In my case, I'm simply going to click close because we've sufficiently explored all the different plot settings that we need, and that's all I really needed to do there. So there's going to come a time when you're ready to print, and when you do, you can see that the Revit print dialog is fairly straightforward. Most of the settings are what you would expect from other programs that you've likely printed on in Windows, and there are a few that are unique to Revit. So just do a few experiments, run a couple test plots, and you'll be good to go.
What's going on, guys? Vulcan Architect here, and in today's video we are going to be talking about project browser organization inside of Revit. So when it comes to working on larger projects inside of Revit, it can be really difficult to locate views when you have a lot of them. So when you have a few hundred views, it can be really difficult to kind of scroll through the menus and locate the view that you're looking for. So because of this, we can actually organize our project browsers in order to kind of accommodate our workflow and our organization of the project. So I'm just going to be showing you how to do this inside of Revit. Now before I jump into this video, I would like to ask you to check out my website, vulcanarchitect.com. I'm going to link it up just below this video in the description, and then also up in the cards above. This is my website where I upload my Revit courses, where I take the extra time to go slowly step by step and cover all of the important yet complex Revit topics. I've got over 130 hours of content, and I'm adding more each month. Also there you can find some of my customized Revit templates. You can find some really high quality Revit families, as well as a plugin, so make sure to check it out. And also before we get started, make sure to like this video. It helps me out a lot, and also make sure to subscribe. Not only will that make it so that you don't miss the next video, but also it does make the LPAC happy, and let's be honest, that's why we're all here. Okay, so now without any further ado, let's jump straight into Revit. Now here I actually have a specific project that I want to show you, because here we have kind of a very nice organization of the project browser. Now this is like the example project that's included in my structural, concrete, and reinforcement template for Revit, and you get this organization out of the box. So let me just show you how this works here. If you want to get this template, you can find it by clicking on the card above. Okay, so now here you can see that the project browser is divided into multiple levels here. So first we have 3D level 1 and level 2. Now basically this organization is set up in such a way where you have all of these structural elements, and then you want to categorize them by each level, and then for 3D views we just have this 3D. So basically, for example, for level 1, then we have that defined into formwork, which is kind of all the structural elements, and then reinforcement, which is rebar plans. And then here you have, for example, floors and walls, and we're going down into each kind of construction or structural element, because usually all of these kind of require their own sheets and views. So for example, here you have all of the views for the columns, all of the views for walls, and so on. So for example, if you're working on a project here, you would say, okay, I want to reinforce a beam. I would basically go here, okay, where's that beam? Is it on level 2? Okay, let's go to level 2. You want to reinforce it, so that's reinforcement. Open that up. Okay, so we're into beams, and then we open that up, and then we have all of the views for beam reinforcement on level 2. So this is a really useful approach because it kind of minimizes the time for searching for the kind of project views. Also, another trick you can use is you can right click here, and then you can go to search, and then you can actually type in anything that you want, and it's basically going to give you kind of results here. So that's just another feature that you might be interested in. But I'm just going to cancel out of this, and now I'm actually going to be showing you how to organize this, how to set this up. So let's close this project up, and then here I have my basic single-family home here, and let's set up the views for this. You can see here we have many views, and they have kind of the basic organization, but it is very disorganized in this case because I want to emphasize detailing for this particular project. So I'm going to be devising a project browser organization for detailing. So let me show you how that works. The first thing that we have to do is we have to add parameters which Revit is going to use in order to characterize these or organize these views. So when it comes to these parameters, they're basically going to be parameters that appear here in the view instance properties. So for example, this is the 3D view, and then here we have just a set of parameters that go along with this project. Now you can pretty much use these parameters in order to organize your views. Actually, out of the box, Revit here, let me show you. Right click, project browser organization. Here, for example, you can organize by discipline or by phase. So what this basically means is that Revit, let me see. Okay, Revit is going to use, for example, the phasing parameters in order to organize the views. Or by discipline, it's going to use this discipline parameter to organize the views. So you have that option, but I think what is much better is to have your own parameters which you can use. So in this case, as I said, I want to use detailing. So let me show you the approach for that. To create these parameters, they're going to be project parameters. So you need to go here to the Manage tab. Then you want to go to Project Parameters, and then you just add a parameter here. So this is going to be a simple project parameter. The name is going to be the, let's call it the View Detail Level. Now, I could use the detail level that's available in the properties, but actually I want all of my views to have kind of the defined level of detail, but I still want to have them kind of categorized differently. So I'm creating this custom parameter. I'm going to leave it as an instance parameter, and then for the type of parameter, I'm just going to use text. Now, also, you want to define the categories here. So views is obviously one of them, so check that. But also what you can check here is sheets and schedules, because you can use the same type of organization that you're using for views for your sheets and your schedules. So that's useful as well. So this is the first one, the view detail level. Let's click OK. So we have that one. Let's add another one. So this one is going to be called the view type. Okay, again, instance parameter is going to be a text parameter. The discipline can be common. It's perfectly fine. And then just make sure to check views, sheets, and schedules. Sheets and schedules. Okay. So now once we have these two parameters, if I click OK and exit out of this, now you'll see that for each of our views, here we're going to have, let's see. Okay, so here we have the view detail level and the view type. So these parameters can now be used in order to categorize these views. So what we want to do next is go here to the views, right click, and go to browser organization. And then, as I said, we have these kind of options. The first one is all. This is kind of the default one that you're going to see all the time. But then we have these additional ones which you can use as well. Now in this case, I want to create a new one. So let's call this one my detailing browser. Okay, click OK. And now here we have an option for setting up the filtering, or in this case, I want to concentrate on grouping and sorting. So I want to group these by our view detail level parameter first, and then I want to group it by view type parameter second. So as I said, we already have the type parameter, and we already have the detail level parameter. So that's why I've added view in the name, so I can kind of differentiate those parameters. So that's just something to keep in mind. So anyways, here I have kind of set these two up, and then I'm simply going to click OK. Click, make sure to check that one, and then hit apply. Okay, and then your project browser is going to look like this. Now at this point, you might be thinking, oh no, I've messed up my project browser. I only have these question marks here, and then I have all of the views kind of bunched up below. And that's okay. That's usually how it starts, because Revit still doesn't know which view belongs where. So now it's time for us to categorize these views. So for example, I can go here to elevations. I can select all of them by selecting the first one, hold the shift key, select the last one, and then here in the properties, for all of these, I can say that the view detail level, so this is going to be our main model, and then you want to hit enter, and then view type, this is going to be elevation. And then make sure to hit enter as well. So always when you enter something here, you want to hit enter after that. Then we hit apply, and now what will happen is here below this, now we have our main model, and then here we have elevation views. See? Now, for example, I can go here into sections. So these two sections are going to be our kind of main sections. So if I open this one up, as you can see, it's a main section. This one as well. It's not really a detailing section. So I'm just going to select those two, and then go here. So this is going to be our main model. So we just click there. It appears in the drop menu, and this is going to be sections. Again, hit enter, and then hit apply, and now here we have those sections. And then we can just continue like this. So for example, here we have some additional views. So let's go through floor plans now. So floor plan 00, this one, roof level, top of foundation, site plan, and then the ceiling plans as well. So all of these are going to be under, let's see, so that's going to be main model, and then this is going to be floor plans or plan views. Okay, make sure to hit enter, and then hit apply. Okay, so here we have those plan views. And then we can just continue like that. So for example, as I said, this is going to emphasize detailing. And if I open up here, you can see I have this 3D detail of a roof. I have this drafting view of the roof drain. I also have this call out again of the roof. So what I can do now is just select this one, and then also the roof drain, for example. And then I can go for those. Those are not going to be the main model. These are going to be detailing. Hit enter, and then this is going to be roof. So these are roof details, and then I want to hit apply. So now here we have detailing, and then we have the roof details, and then we have the main model, and there we have all of the main views. And then I can just continue like that. So let's see, what else do we have here? We can close these up. Okay, so we have this 3D view. So this is kind of the main view, this one as well. So I can select those two. Again, these are going to be main model, and then they're going to be 3D. Again, hit enter, hit apply, and now it just goes under the main model. Then we have this exploded diagram. Again, that's a main model, 3D. Okay, apply. Now we have this foundation detail. Here again, we have foundation, and this is foundation. So all three of these are foundation details. So this is going to go under detailing, and then here, foundation. Hit enter, hit apply, and now here we have detailing, and that goes into foundation or roof, and then we have the rest of the views here. And finally, we have this rendering, so I can go with perhaps main model and 3D for that, hit apply, and now we're done with our project browser organization. You can see we have it now kind of split into detailing and into the main model, and then here the detailing goes kind of through the elements, the foundation, the roof, and then we can go and just continue like that. And then for the main model there, we have all of our main views, and we can search for those there. So we have developed now a completely new approach to creating our browser organization. Now you might think, okay, it takes a lot of time to set this up, and that is true. Now what I've seen, what they do in kind of bigger offices is usually they would connect this with the view templates. So if you don't know what view templates are, I have an entire video on that, so I'm going to include that just up in the cards above to check it out. But basically here, if I select any view, so for example this foundation, let's use this one for example. Okay, so for foundation, if I go here to view template, I can assign different view templates. So you would usually have like a detailing template, and then for that template, what you'll see is that here you will have these two parameters, the detail level and the view type. So you would basically assign a view template, which is going to give you all of the kind of important view parameters for that view, which is going to be kind of the scale, the VG settings or overrides, the detail level, the shadows, everything like that. And then with that, you would assign the detail level and the view type. So through that, or basically kind of the parameters that define your project browser. So in that way, you would kind of make this process a lot shorter because it's done alongside with setting up the view template, so it's done automatically. So that's just something to keep in mind. But there you go. That's basically how you have your whole kind of project browser organization set up. Now, if you want to get this model, this project file, it is going to be available on my Patreon. So I'm going to include a link to that in the description below this video, and then also up in the cards above. Thank you for watching, guys. Make sure to check out my website, balkanarchitect.com, for more Revit courses. There I have over 120 hours of content, and I'm adding more each week. Make sure to subscribe for more videos, and also I've added a video over there that might interest you as well.